between what you said, the 25 people in the paper. I think now the today version of that is you look at like, I'm sure there's a Gemini 3 contributors list that will come out. There's already
2,500.
There's like 2,500 people, and then I'm sure people are
conservatively.
Yeah, I'm sure people are thinking there's no way that 2,500 people contributed to actually, but they did, which is crazy, and it is fascinating to see like how large scale some of these problems are now.
Yeah, it is. And I think it is important for us, and that's one of the great things about Google. There are so many people who are amazing experts in their areas. We benefit from that. Like Google has this full stack approach, right? Like we benefit from that. So you have experts at every layer, from like data centers to chips to like networking to how to run these things at scale, right? It comes to state, again, going on this like engineering mindset, it comes to state that these things are not separable, right? Like when we design a model, we design it knowing what hardware it's going to run on, and we design the next hardware knowing where the models will probably go. But this is beautiful, right? Like, I mean, but coordinating this, yes, of course, you have thousands of people working together and contributing, and I think we need to recognize it, and that's a beautiful thing. That's great.
Yeah, it's not easy to pull off. One of the interesting threads is around back to this sort of like DeepMind legacy, sort of doing all these different scientific approaches and like trying to solve these really interesting problems. And today, where we actually like sort of know that this technology works in a bunch of capacities, and we truly just need to keep scaling it up, and obviously there's innovation that's required to keep doing that. But I'm curious like how you think about DeepMind sort of in today's era balancing, purely doing scientific exploration versus like we're just trying to scale up Gemini. And maybe we can use my favorite example for you, which is Gemini diffusion, as a sort of like an example of like that decision making come to life in some capacity.
Like that is the most critical thing, right? Like finding that balance is really important. Even now, when people ask me like what is the biggest risk for Gemini, and of course I think about this a lot. The biggest risk for Gemini is running out of innovation, because I really don't believe that like we figured out the recipe and like we're just going to execute from here. I don't believe in that. If our goal is to build intelligence, and we're going to do that, of course, like with the users, with the products, but the problems out there are very challenging. Like our goal is still very challenging, and it's out there, and I don't feel like we have the recipe figured out that it's just scaling up or executing. It is innovation that is going to enable that. And innovation, you can think about it as at different scales or at different tangential directions to what you have right now. Like of course, like we have Gemini models, and inside the Gemini project, we explore a lot. Like we explore new architectures, we explore new ideas, we explore different ways of doing things. We have to do that. We continue to do that, and that's where all the innovation comes from. But like also at the same time, I think DeepMind or Google DeepMind as a whole doing a lot more exploration. I think it is very critical for us. Like we have to do those things because like again, like there might be some things that like the Gemini project itself might be too constraining to explore some things. So like I think the best thing that we can do is both in Google DeepMind, also in Google Research, right? Like we will explore all sorts of ideas, and we will bring those ideas in, because at the end of the day, Gemini is not the architecture, right? Gemini is the goal that you want to achieve. The goal that you want to achieve is the intelligence, and you want to do it with your products enabling all of Google to really run on this AI engine. In a way, it doesn't matter what particular architecture it is. We have something currently, and we have ways of evolving through that, and we will evolve through that. And the engine of that will be innovation. It will always be innovation. So finding that balance or finding opportunities of doing that in different ways, I think is very critical.
Yeah, I have a parallel question to that, which is at I/O, I sat down with Sergey and I made the comment to him that sort of and I personally felt this at I/O, which is you bring all these people together to launch these models and have this innovation. You sort of like feel the warmth of humanity as you do that, which is really interesting. And I was referencing this because of, I was sitting next to you also listening to them, and I sort of was feeling your warmth, and I mean this very personally, because I think this translates into like how DeepMind sort of as a whole operates. I think like Demis has this as well, where it's like this deep scientific roots, but also it's just like people who are like nice and friendly and kind. And there is something interesting where like I don't know how much people appreciate like how much that culture matters and like how it manifests. I'm curious, like as you think about like helping sort of shape and run this, how that manifests for you.
Like first of all, like I mean, thank you very much. You're embarrassing. But like I think it is important to be. I believe in the team that we have, and I believe in giving people, like trusting people, giving people the opportunity, and that team aspect is important. And I think like this is something that, at least to my part, I can say I've learned through working at DeepMind as well. Like because like we were a small team, and of course like it's like you build that trust there, and then like how you maintain that as you grow. I think it is important to have this environment where people feel like okay, like we really care about like, solving the challenging technical scientific problem that makes an impact, that matters for real world. And I think that is still what we are doing, right? Like Gemini, as I said, is about that. Like building intelligence is a highly technical, challenging scientific problem. We have to approach it with that way. We have to approach it with that humility as well, right? Like we have to always question ourselves. Like hopefully the team feels like that too, and I'm like that's why I always keep saying I'm really proud of the team that they work together amazingly well. Like we were just talking upstairs at the micro kitchen today. Like I mean, I said to them, yes, it's tiring, yes, it's hard, yes, we're all exhausted, but this is what it is. Like we don't have a perfect structure for this. Everyone's coming together and working together and like supporting each other. It is hard, but like what makes it fun and enjoyable, and also like what makes you tackle really hard problems is, I think, to a big extent, like having the right team together, working together. The burden is, the way I see it, is more like be clear about the potential of the technology that we have. Yeah. I can't definitely say that 20 years from now it's the exact same LLM architecture. I'm sure it won't be, right? So I think pushing for new exploration is the right thing to do. As we talked about, like GDM as a whole, together with Google Research, we have to be doing with the academic research community. Like as a whole, we have to push many different directions. I think that's perfectly fine. Like what is right, what is wrong is like I don't think that it's the important conversation. I think like the capabilities and the demonstrations of those capabilities in real world is the real thing that should speak for itself.
Yeah, I have one last question, which is, and I'm curious to have your reflection on this as well. I feel like for me personally, like my first year and a half plus at Google felt like, which I really liked actually, this like Google underdog story to a certain extent, which despite all the infrastructure advantage and all that, like for me personally showing like working.
When did you join?
April 2024.
2024.
Yeah. So like and also like the AI Studio context, so like we were building this product and like
right.
sort of,
oh yes, now I remember.
We had no users, we had 30,000 users, we had no revenue, we had sort of very early in the Gemini model lifecycle. And I think fast forward to today, and like it's obviously not like I was getting a bunch of pings earlier as sort of the last couple of days as this model has been rolling out. And from folks across the ecosystem, I'm sure you got a bunch of these as well, people like I think they're finally realizing that like this is happening. But I'm curious from your perspective, like what did you feel that, like again, I had belief, that's why I joined Google, that like we were going to get to this point, but like did you feel that underdogness too? And I'm curious like how you think the team will manifest with the team as we turn that corner.
I definitely did, even before that, because like when LLMs really like became apparent that they're really powerful, right? Like I felt like very honestly, I felt like we were the frontier AI lab, right? Like in DeepMind, but also at the same time I felt like okay, like there's something that we haven't invested as much as we should have as researchers, and that's a big learning for me as well, right? Like that's why I'm always very careful about like we need to cast a wide net. That's really important. That exploration is important. It's not about this architecture, that architecture. And I've been very open with the team that when we started taking LLMs a lot more seriously and starting with like with the Gemini program like 2.5 years ago, I think we've been always, and I've been very honest with the team that like we are nowhere near what is state of the art here. Like we don't know how to do a lot of things. There are a lot of things we know how to do, but like we are not at that level yet, and it's a catch up. And it has been a catch up for a long while. I feel like nowadays we are at that leadership group. I feel really good and positive about the pace that we are operating at. We're in a good sort of rhythm. We have a good dynamic. We have a good rhythm. But like yeah, we have been catching up. You have to be honest with yourself, right? Like when you're catching up, you're catching up. You have to see what others are doing and like learn what you can learn. But you have to innovate for yourself, and that's what we did. And that's what I feel like it's a good underdog story in a sense in that way, right? Like we innovated for ourselves, and like we found our own solutions, both like technology-wise, model-wise, process-wise, and how we run. Right? And it's unique to us, right? Like we run together with all of Google. Like look at like what we are doing. It's a very different scale. I never saw these things as like sometimes people also say, oh, Google is big and it is hard. I see that as like we can turn it into our advantage because we have unique things that we can do. So like I'm quite pleased where we are. But we have to learn through and innovate through that. That's a good way to achieve what we have achieved right now. And like there's a lot more to do, right? Like I mean, I feel like we are sort of just catching up. We're just getting there. There's always comparisons, but our goal is to build intelligence, right? Like we want to do that. We want to do it the right way, and that's where we are putting all our minds, all our innovation that way.
Yeah, I feel like the next 6 months are going to be probably just as exciting as the last 6 months and maybe the 6 months before that. Thank you for taking the time to sit down. This was a ton of fun. I hope we get to sit down again before I/O next year, which feels like forever, but it is going to sneak up. And I'm sure there's going to be meetings like next week that are like I/O 2026 planning to make everything happen. So thank you for taking the time. Congrats again to you and the DeepMind team and everyone on the model research team for making Gemini 3, Nano Banana Pro, everything else happen.
Yeah, thank you very much. It's been amazing having this conversation. It's an amazing journey as well, and glad to have all the team, but also like sharing with you as well. It's great. Thank you very much for inviting me.
We got a special little gift. Thank you to congratulate you and the team for making this happen.
Oh, nice. Thank you very much. Very much on point.
1520 low club. First model, right? 1501
yeah,
for
first model. Very kind. Thank you very much.
How it feels like Gemini is this through line across literally every single one of our products.
To see it all come together, it is really special. I was just reflecting in the last couple of weeks. I think we've pretty much been shipping something every day, and so it's a great feeling.
The Nano Banana Pro moment. I'm sure you spend much time playing with the model. People are going crazy with it, which is awesome.
To me, it showed how much latent creativity people have. People are going to express themselves, and we're giving them the tools to do it the way they're thinking it in their head.
And it empowers me. Like I feel like I've actually become more creative in like the way I think about the world because of these tools.
I think in about 5 years, we'll be having reckless excitement about quantum, hopefully, like we're having with AI today.
Hey everyone, welcome back to Release Notes. My name is Lenny. I'm on the Google DeepMind team. Today we're joined by Sundar Pichai, who's the CEO of Google and Alphabet, and we're sitting here in Mountain View. Gemini 3 has rolled out, Nano Banana Pro has rolled out, and the reception's been super positive. So I feel like you want to sort of frame the moment of this progress to get to today where we sort of have state-of-the-art models across not actually just Gemini and Nano Banana Pro, but VO and some of the other music models and stuff like that across the board. It's like more and more SOTA the longer the time goes on. So yeah, you want to frame that moment for us?
First of all, great to be here. It's been a phenomenal week, I would say. You know, when you're working on stuff inside, you kind of visualize the moment when you can actually put it all out. And when you work on products, there's nothing more exciting than that, and that's what this week is. But I think it's based on a foundation over many, many years and of all the deep investments we built. And it was always clear to me. You could see the pace at which we were making progress. But to see it all come together, it is really special. I was just reflecting in the last couple of weeks. I think we've pretty much been shipping something every day, and so it's a great feeling.
It is. Yeah, I remember back to you and I were talking probably a year and a half ago, and I was complaining about something. I'm sure I was complaining about something, and you were like, something to the effect of like pushing me to sort of see this long-term perspective. And I'm curious, like I think obviously to me the story of like getting to this moment that we're in now with state-of-the-art models and all this infrastructure to scale up Gemini across Google, like is this long-term perspective. And I think especially in this hyper-competitive moment, like what are you like how are you keeping that long-term perspective? And like because it feels so much like a rat race right now in some sense to like keep hill climbing 1% on all these leaderboards, but obviously that long-term perspective is super helpful.
No, I think I've always I always force myself. You're obviously in the moment. We work in an industry where you move fast, you want to iterate fast, and I really enjoy that. But being able to pull back and making this long-term bets and being very focused over that time period on a long-term bet, I think it's always super important to do, I think. Obviously, in 2016, I wanted the whole company to be AI first. A lot of what prompted that moment was 2012 was Google Brain, the famous cat paper, which had breakthrough in image classification. 2014, we brought Google DeepMind in. January 2016 was the AlphaGo moment. And now many people will notice in May 2016, we announced our first TPU.
Yeah.
So it was clear to me in 2016, seeing all that, we are about to go through another platform shift. And that was the bet on a full stack bet on setting up Google to be an AI first company. And since then, we have been making a lot of progress. There's so many breakthroughs coming from Google, including Transformer. We were putting in our products in BERT and MUM and making search better, launch Google Photos and so on. But obviously with the generative AI moment, I realized the window was even bigger. Like, that people were ready to use the technology at scale, consumers, developers, and so on. So how do you respond to a moment like that? And, for us, it was about, we kicked off Gemini as a project and across Google Brain and Google DeepMind. And as part of that, then deciding to bring the teams together as Google DeepMind, we really ramped up our investments in our infrastructure, data centers, TPUs, GPUs, and so on. It is then, getting the company to more a faster cadence, right? You now have the technology, and once the GDM team started shipping Gemini, and you can talk about the series of Gemini milestones we worked through, and it's been great to have you for a lot of the journey, driving it too. And now, how do you make sure you manifest it in all our products? There are many products which touch billions of users, right? How do you get search to iterate with the power of all these models can do? And so that's been the journey. But you can step back and understand that framework, and it's so exciting because for the first time, in your full stack approach, each layer when it innovates, it flows through all the way on the top.
This is why I tell people about pre-training. I'm like, the fact that pre-training for DeepMind is working so well in the Gemini models, it's like post-training in RL is like this accelerant of the underlying capability. And I feel like our infrastructure is a similar story.
Yeah, absolutely. You make your infrastructure better. You make the models better. Pre-training, post-training, test time compute, where have you? Or how do you take those capabilities and then manifest it in products, right? How does Nano Banana show up in your products? Generative UI in search with AI mode, right? So you're expressing it at all these layers, and not to mention being able to take that and give it to developers who are then innovating on top, right? And that's what creates this multiplicative effect, and it's always incredibly thrilling to watch. but always had this long-term vision of how we can do it. Some of this took time because we have a full stack approach. When we had to respond to this Gen AI moment, like we were short on capacity. So when we had to invest to ramp up all these things to get it to the scale. So you had a fixed cost around it. So if you were on the outside, it looked like we were quiet or we were behind, but we were putting all the building blocks in place and then executing on top of it. We're on the other side now, right? And which is what you can see the pace at which teams are moving forward.
Yeah, it's been incredible to see this. You mentioned this like Gemini showing up in all of our products, and I think I was talking to Josh and Tulsi about this and Corey about this. I feel like the challenge for some of these launches now is sim shipping, and maybe not even from a product perspective, but capacity and the sort of how do you make sure that the models show up really well across all these different product experiences. I feel like it's introduced a new, like we've almost, Corey made the comment something to the effect of like we figured out how to do the models, and obviously there's more that we need to do, but like deploying them across all of Google's product surfaces is extremely hard, and it gets me to this. And I sort of had this realization at I/O this year of, and I want to gut check this with you because I don't maybe you have a different perspective, but historically, like other than maybe your Gaia or your Google account, there wasn't this through line across like this whole suite of different products that Google has, everything from Cloud to Waymo to Search to everything else to Gmail. And now it feels like Gemini is this through line across literally every single one of our products, which is just such a, it feels like there's something magic there that is happening. I don't know what your reaction is to that.
I think Gemini, I know it's a good observation. I think Gemini to me is like a much more, it's a very clear manifestation of what is the AI first strategy.
Yeah.
Because now you have something tangible like Gemini, which people can understand. And Gemini, you're right, improves everything from search to YouTube to Cloud to Waymo. What I loved about the Gemini 3 launch, you talked about sim shipping. We shipped it across many of our products. But it was fascinating for me to see, on X, it could be Copilot or Replit or Figma, people all coming together, they're also sim shipping.
Yeah.
Right. And to me, that's innovation at scale. Right. It's not just us. It's other companies in the world. It's been extraordinary to see.
Yeah, it's awesome. One of the other threads, and obviously the Nano Banana Pro moment, I'm sure you spend much time playing with the model. The people are going crazy with it, which is awesome.
I have to keep asking, did we improve the productivity of the world? or is it a net progress or not? The infographics seem amazing.
They do.
And I think as we move beyond the fun stage, I just saw on X, I think Ben Bajarin had tweeted this infographic of his core weave analysis. So, it actually made me look through that thing to try and understand it. One of the things PowerPoint many years ago unleashed is people kept making more and more slides. Like now, it's so much information and it kept expanding. Like maybe with Nano Banana Pro, we're back to a phase by which you can kind of compress it and give it to the world in a more digestible way.
Yeah, that was going to be exactly where I was going. Like there's something, I've historically been personally skeptical about like how useful a lot of the Gen Media models would be for the world. Like, obviously it's useful from an entertainment perspective, but it felt like Nano Banana Pro crossed the chasm specifically with infographics and actually grounding with Google Search in that of like actually like I believe I can see very clearly how this is part of Google's mission of like organizing the world's information and actually making it universally accessible to people with those infographics. Like it blew me away. Like it was so interesting. And I feel like it's a great reminder of like we're going to see those use cases. And I think the Nano Banana team, if I remember correctly from one of the pieces of content we were doing, they're like, yeah, we weren't even like, it's not like they were trying to make infographics work really well. It just happened as the model got really good and text rendering capabilities improved so much, which is fascinating.
Fascinating. The other thing that shows me is how much latent creativity is there in the world.
Yeah.
So one of the other beautiful things we're witnessing is I think like people are going to express themselves and we're giving them the tools to do it the way they're thinking it in their head. Right. And so I think if otherwise we've been constrained by the tools in front of people. We may not have realized it, but we're creating more and more expressive tools. And they're more and more accessible to, more and more people. And so watching that, it's incredible to see as well.
Yeah, I've got another question about that in a second, but one of, I'll give Tulsi credit for this. Tulsi had suggested when we were talking yesterday to ask you about this, because she was curious, what sort of like, as you see these launches happen in these like large tentpole moments for Google, what is your success barometer for these moments? Is it like the reception online? Is it like, what does the adoption look like on day one? Or like, how are you measuring, like, is this thing actually moving the needle for Google?
Look, I'm pretty active on launch day, trying to understand what's working. I'm looking for feedback. Both, an example, I'm on X, trying to understand, like, see as people, average users, how they're experiencing the product. I probably ping people back saying, look, there's a valid point, we should address it. So in some sense, I'm looking at that trying to assess it. It's clear to me teams internally are using Gemini itself to kind of collate. We have great dashboards. And so I try to take in across a variety of sources. I'm one of those people, I need to feel it firsthand, right?
Yep.
So I get reports, but I'm out there trying to understand how people are using it, what they're posting, right? And, and I think that is important. But I walk over to some people who all have these big screens with multiple dashboards, looking at QPS and, understanding how the usage is, worry about capacity. But all that gives you a real sense of what people are doing, saying. But that's how I do it. It's a combination of monitoring stuff online, talking to people, walking around, sitting down with people. I want to get, particularly the first day, it really helps me get a sense of what's working, what's not working well.
Yeah, I feel like you can feel the excitement in the office right now too.
I can't walk out anywhere without some version of some banana.
I don't know who did that, but kudos to the events or facilities team for somehow bringing 100,000 bananas into this building and making it happen. The exciting part is this is just sort of the first chapter or the first page of the Gemini 3 chapter. We don't have Flash yet. We don't have any of our other sort of models in the 3.0 category. We shipped Gemini 2.5 Pro, and actually as I was looking at a bunch of the benchmarks, like even 2.5 Pro is not SOTA on everything. Obviously competitors have caught up, but even 2.5 Pro right now is still like best in class at a bunch of capabilities and sort of taking it a step farther with 3 Pro now.
2.5 Pro was Google I/O.
Yeah,
and you could sense that it was a big step up. I think one way I feel great is, and Demis, Corey, and team, the GDM team is on a good cadence, right? So we are kind of every 6 months or so pushing that frontier, and it gets harder, right? Because you're right. 2.5 Pro is a very good model. So to kind of clearly take a meaningful leap from that, I think it's hard, but that's what that's what makes it exciting progress. I know you're always excited about Flash, which is working on and is coming. You're excited about Flash because it allows you to serve more people.
Yeah.
And in that parade of frontier, it really makes a difference. So I'm excited for 3.0 Flash. I think it's going to be a very, very good model. Might be our best one yet, right? And we'll see. What's great is teams are internally, our pre-training teams are thinking about the next version. And so this culture of, relentlessly innovating and shipping, I think makes this moment special. And, definitely feels like there's going to be a lot of exciting progress going back to the full stack at all layers of the stack as we go into 2026.
Yeah, I have a goofy question because Josh sort of inspired me with his goofy answer about launch day rituals.
With his dry Cheerios?
With his dry Cheerios, which is weird. And I need to keep putting Josh on blast because I think it's funny and it's...
I'm like, next time I see Josh, I'm going to be walking around with a carton of milk to
help him so that he doesn't have to eat dry Cheerios anymore. Do you have any weird, interesting launch day rituals, or is it just trying to make it through the day?
Oh, yeah, it's, my normally, in the morning ritual, I almost always have is I kind of pick up and catch up on what's happening in the world.
Yeah.
I consume. In fact, I don't even check like Google email because the way I think about it is if something interesting has happened about Google, it'll be there in the news anyway. So I kind of like try to step back and take in the news. That's what I do. So launch ritual becomes our products, and when we're in the news. So trying to understand to your earlier question about how it's work. So that's my main routine, and I kind of try on launch days to have a bit of a less structured day, so that I can go spend it time. I love walking to the teams which worked on the products, maybe seeing them, seeing how they feel about what they shipped. So that engagement to me matters a lot. Yeah. So.
Yeah. I have another sort of question along this line, which is I have an interesting observation. I think Demis and others have talked about this maybe internally, but there's this micro kitchen inside of the Gradient Canopy office where a lot of the sort of action is happening from a DeepMind perspective. And every time I'm there, it makes, obviously Google is big and huge and global, and there's all this stuff happening. The MK, that blue MK makes Google feel small to me. And I'm curious if there's like something interesting there, which is like how it feels small and intimate. And I'm curious how you.
Oh, it so reminds me of early Google. Obviously, I go there quite often, and it could be, you have Sergey there, and you have people like Jeff and Sanjay, pair program still, and they're making their espressos. Nothing encapsulates our culture better than watching the precision with which people make their espressos in that micro kitchen, right? I would never dare make an espresso there, right? I know a lot about how to make good espresso, but I feel a bit intimidated, amongst that group. But Noam is there, Korai, Oriol. Just last week alone, walking around, it's very dense in talent. People are constantly people are visiting. There's a very great exchange of ideas. And so I love that. Kind of reminds me of how the company used to be in our early days. Some of our serving team, Emma and people are there, and that's where when I mentioned I'll probably go look at the QPS. It's I'm hovering over these people's screens trying to understand what's going on. So it's definitely a favorite part of I think how the company works.
Yeah, my Google feature request is we need to somehow remake these MKs across all the PAs or something like that. I don't know how that happens.
I mean, there are there are other teams which have versions of these, and it really helps pull people back into the office because you realize the value for when you're there. That exchange of ideas. You can still go back and have focused time wherever you're working, but that moment really helps a lot, I think.
Yeah. A lot of this AI story that you've talked about so far has been like us making these really, really long-term investments and sort of setting the company up for success like 10 years ago. And I'm curious how you think about like right now, or obviously, and the bets are right. Like Claude has worked out really well. Waymo's worked out really well. Quantum hopefully will work out really well. Just announced a bunch of other the quantum stuff goes over my head, but I keep vibe coding experiences to try to understand what they're talking about.
It was one of the ways in which I was like testing. Asking Gemini 3 to help understand a layer deeper on these topics, which is fascinating.
Yeah, it brings anything to life, which I'm happy we went with that tagline. But how do you think about like is it just like infrastructure that's like this next 10-year bet, or like do we know AI is the thing, so that's what all the eggs are in that basket now, or like I'm curious how you think about like what do the next future-facing 10 years look like, and we're making the bets now to set ourselves up for that next layer of success.
Oh, look, I think it's always important, right? Going 10 years back, it was a bet on AI, in a deep way, in a full stack way. It was a bet on saying we're going to build other big new businesses, diversifying the company. Bet on YouTube, betting on cloud. Google was as cloud native as a company you can never imagine, but we weren't fully providing it outside. So that was a deep, big scale bet on cloud. And Waymo, these things take time. Waymo's a long bet, and I think we are now seeing the inflection point around Waymo. There's always these future bets, right? Quantum computing is an amazing bet. I think in about 5 years, we'll be having breathless excitement about quantum, hopefully, like we're having with AI today. But I'm constantly thinking in that time frame. One example of this is Project Suncatcher, 2 weeks ago, where we announced we're going to build data centers in space. Obviously, it's a moonshot. Some of it looks crazy today. But when you truly step back and envision the amount of compute you're going to need, it starts making sense. And it's a matter of time. And so how do you make progress on that? You work back and have 27 milestones and get underway. So in 2027, hopefully we'll have some TPU somewhere in space. Maybe we'll meet a Tesla Roadster, which is going around there too. So it'll be fun. But that's an example of the kind of long-term projects you want to undertake and do. Isomorphic with AlphaFold and Wing with drone delivery. We are hooking up exciting work on robotics. So you take that long-term view and keep making progress.
When I saw TPUs going to space, I pinged Demis and I said we should fund a moon rover and put Gemini on device and then have it sort of explore the moon. It'd be a great marketing campaign, even if it's not scientifically super useful. So
who knows? Maybe the project is underway somewhere.
Yeah, I'm sure it is. You mentioned this right before, which is the capabilities continuing to go up, sort of like raising the floor for everyone to go and be creative. And I actually personally feel this way. Like I don't feel super like artistically creative by default, and yet I can like tackle these tasks that historically I would have had to have done. And it empowers me. Like I feel like I've actually become more creative in like the way I think about the world because of these tools and like not being worried about not being able to do something. I think vibe coding is this like massive one, and there's this like moment where this force that is like one of the most economically powerful things in history, which is creating software and being able to code, is now in reach of so many more people. And I'm curious how you obviously you do vibe code sometimes. I'm curious how you've been thinking about that moment of like AI builders being able to more than just like traditional software engineers be able to build stuff.
What an exciting moment. It's almost like how the internet, suddenly blogs appeared. Many more people became writers, if you will, right? And what YouTube did, many more people became creators. And you can feel that happening on the coding side. Even within Google, there's a sharp increase in a set of people who have submitted their first CLs, right? And it's because of these tools are making it more accessible, right? Maybe you're a product marketing person, you have an idea. In the past, you would have to describe it. Now, maybe you're kind of vibe coding it a little bit and showing it to people. So you can tangibly see that, come to work. I was just speaking with someone on my team who doesn't code, but was trying to teach his son Spanish conjugation and just one-shotted in Gemini 3 animated HTML page to describe this to his son. See, when you hear stories like that, and that person is in our comms team, right? So you can kind of see how people are beginning to do things. And so it's very, very promising. The limited time I have, I played around with it. It's almost like, just not just vibe coding, but just these IDEs now. It's making coding so much more enjoyable, right? Like, of course, I'm not working on large code bases where you have to really get it right. The security has to be there. So, those people should weigh in. But I definitely feel things are getting more approachable. It's getting exciting again. And the amazing thing is it's only going to get better. There's something I always used to tell about Waymo whenever people talk to me about it is, remember, this is the worst Waymo we'll ever drive, right? It'll only get better.
Yeah.
So version of all these tools which we're doing, whiteboarding with Gemini 3 in AI Studio, it's both amazing to see and it's the worst it'll ever be.
Yeah.
Right. Both are simultaneously true. And so, I mean, in a sense, that you're going to see a lot of progress ahead. So I think it's definitely an exciting time, and can't wait to see what people out there in the world come up with it.
Yeah, it is awesome. I think my last question is like, what's next? What can we be excited for? Lots of cool things in the pipeline, but anything top of mind?
I think some folks need some sleep. I probably, hopefully the team, so the teams, all of us, get a bit of rest. But look, I think I'm excited for the Gemini roadmap. I'm excited at how it's coming through all our products. We're also shipping new things, right? I love Flow. I've been playing around with Flow, Notebook LM. It has a passionate, growing community, and it's amazing, seeing journalists like work on it, people doing their PhDs, like really doing all the research in it. So there's a lot more to come.
I'm excited. Thank you, Sundar, for sitting down, and thank you everyone for watching Release Notes. We'll see you in the next episode.
Okay, so we have a special emergency podcast episode today about the launch of Gemini 3.
Yes, Kevin, hotly awaited, much discussed among AI nerds here in Silicon Valley. We are finally about to get our hands on the genuine article.
Yeah, so normally we wouldn't break our Friday publication schedule to publish a special episode just about a new model coming out from one of the big AI companies. They're releasing models all the time. But there are a couple reasons that we thought it was worth doing this week to talk about this model, Gemini 3 in particular. The first is that we got some time with Demis Hassabis and Josh Woodward, two of the leading AI executives at Google. Demis, of course, is the CEO of Google DeepMind, which is their in-house AI lab. And Josh Woodward is the VP of the Gemini team and some other stuff there at Google. So we were excited to talk to them and ask them about this big new model release. But I think there are a couple other reasons we were interested in doing this as well.
Yeah, I mean, one big thing, Kevin, is just that maybe more than other model releases, this one seems to have the attention of Google's competitors. We're hearing a lot of whispers from folks who work at other AI labs that, it seems like Gemini 3 has managed to figure some things out in a way that may be bad for their businesses.
And I think around the AI industry, there's sort of this feeling that Google, which kind of struggled in AI for a couple of years there, they had the launch of Bard and the first versions of Gemini, which had some issues. And I think they were seen as sort of catching up to the state of the art. And now I think the question is like, is this them sort of returning to the top of the AI leaderboard? Is this them taking their crown back? So we'll get into all that with Demis and Josh. But let's just talk, Casey, about what we know about Gemini 3. They held a briefing early this week and told us a little bit about the new model and what it can do. So what did we learn about Gemini 3?
Yeah, well, so in terms of what it can do, which is always the most interesting to me, Google shared a few different things. One, in addition to saying all the things you expect, like it's better at coding and it's better at vibe coding, it also is going to do some new things around generating interfaces for you when you ask it a question. So nowadays, you ask most chatbots a question, it'll spit back an answer in text. Maybe it shows you an image. According to the Google folks, Gemini 3 is just going to start building custom interfaces for you. So they showed an example where somebody wanted to learn about Vincent van Gogh, the painter, and Gemini 3 just sort of like coded up an interactive tutorial that had all sorts of like images and interactive elements. They showed another example that involved building a mortgage calculator for buying a home over $1 million, which is the lowest amount of money that anyone at Google can imagine spending on a home. So these are the kinds of things that you can expect to find in Gemini 3, Kevin.
Yeah, so I would say the theme of the briefing and of the materials that Google shared ahead of the Gemini 3 launch was this is just kind of better than their last model, Gemini 2.5 Pro, in basically all respects. Some of the benchmarks that caught my attention, one was this benchmark test called Humanity's Last Exam, which is sort of a very hard interdisciplinary exam that consists of a bunch of questions like basically a graduate student or PhD level. And their previous model, Gemini 2.5 Pro, got about a 21.6% on that test, and Gemini 3 Pro gets a 37.5% on that test. That's basically the story of all of these benchmarks. They gave more than a dozen examples of various benchmarks where the new model just beats the old one handily. And to a lot of people, I think that may not matter. Most people who are using Google's AI products are probably not out there trying to solve like novel problems in physics. But their basic pitch for this is just like, this is a state-of-the-art model. Anything that you could do with ChatGPT or Claude or even the older versions of Gemini, you can do better with Gemini 3 Pro.
They also talked about testing what they're calling the Gemini agent, which is going to be able to do one thing in particular that I've been waiting for somebody to do forever, which is look through your inbox, understand its contents, propose replies, kind of organize like emails together, and really sort of help you get your inbox under control in a way that I personally have never been able to. So we basically only saw a few animated GIFs about that, but that will definitely be one of the first things that I try when I get my hands on Gemini 3.
Yeah, and they are not, we should say, rolling this out to everyone right away. It's going to be available this week for users in the Gemini app and also in the AI mode, which is sort of the tab off to the side of the main Google search engine. It will also be available for developers in various products, but they're not sort of saying when this will come to things like the Gemini integrations in Google Docs or Gmail, these very popular things that are used by billions of people a day. But I thought it was interesting that they had brought this model to Google Search, albeit in this AI mode that's not sort of the main search bar. That to me suggests that they feel like they can serve this model cheaply enough to make it potentially something that billions of people could use, and that would not melt their servers and incur billions of dollars of costs.
Yeah, so far they say that the usage keeps going up for AI overviews, and every quarter they continue to make more money, so it seems to be working out for them. Not working out for the rest of the web, but it's working out well for Google.
Yeah, but I think that's like obviously Google's big advantage here over their competitors is that, they have products that are used by billions of people a day, and they can kind of shove Gemini 3 into those products over time and just get more and more usage and get more data and use that to improve their models. So
yeah, because why we always tell students when they ask us for advice, step 1, build an illegal monopoly.
Yes. And speaking of students, the other notable announcement that Google is making this week is that they are giving all US college students a year of free access to a paid version of Gemini, which is, I think, a smart move. I feel a little gross about it, like essentially telling students, hey, why don't you use this to maybe do some of your homework, maybe help you with your exams. We'll give you the first hit for free.
Yeah, I was also struck during the briefing that we had this morning that I believe 3 different people used the phrase learn anything. This seems like it's become a very prominent plank of Google's messaging, is they're presenting Gemini as a learning tool, which maybe is just sort of a euphemism for a do your homework tool. I don't know.
Yes. Okay, so that is what we know about Gemini 3. We will be doing our own testing and reviewing of Gemini 3 once it is fully out on Tuesday. But for now, we wanted to just kind of give you the basics and also bring you our interview with Demis Hassabis and Josh Woodward of Google DeepMind. And before we get to that, we should obviously make our AI disclosures. I work for the New York Times company, which is suing OpenAI and Microsoft over the training of large language models.
And my boyfriend works in the product.
Demis and Josh, welcome to Hard Fork.
Thank you.
So 2 years ago, Sundar Pichai told us that Bard, rest in peace, was a souped-up Civic that was in a race with more powerful cars. What kind of car is Gemini 3?
That's a good one. Demis, you want to take it?
Well, I hope it's a bit faster than a Honda Civic. I don't really think of it in terms of cars. Maybe it's one of those cool drag racers.
Yeah. So people are really excited about this model. We have been hearing from folks that have been sort of really testing it. Obviously, you guys have shown off a lot of the benchmarks, very impressive. What can Gemini do on a concrete level that previous AI models couldn't?
Well, I'll jump in maybe a couple of things that stand out. One, we're starting to see this model really excel on reasoning and being able to think many steps at the same time. Sometimes models in the past would lose their train of thought, lose track. This one's way better at that. The other thing you'll see tomorrow as well is all kinds of new generative interfaces. This is our best model yet at being able to create new types of interfaces. It gives people really a custom sort of design, sort of answer to their questions. And then maybe the third thing I would say is we've put a lot of investment in coding itself. And so a lot of the coding examples, you'll see some new products coming out, like Google Anti-Gravity, will also kind of showcase that.
There's been some discussion that for average users, the chat use case can feel solved, that sort of average users of products like Gemini kind of almost can't even think of a question to ask it that will generate something that feels meaningfully different from what they were able to get in the last model. To what extent does that feel true to you in Gemini 3? And to what extent do you think average folks are really going to notice a difference?
Yeah, one of the things I guess we're seeing in some of the testing, and Demis, feel free to chime in too, is I think these are really, for us, this is a model that it's more concise, it's more expressive, it starts to present information in a way that's much easier to understand. And I think for most people, that's going to be a big immediate effect. And then I think what starts to get interesting is how these models start to interact with other types of information. So we talk a lot about how students are going to be able to learn with this model, or even how this model can connect to other types of data you might have in other Google products with your permission. These are the ways I think we're starting to show kind of it's going beyond just the standard text kind of Q&A back and forth.
Yeah, I think I'd add to that, just like, its general reliability on things is incredibly, you'll notice that when you use it. I think also we work quite hard on persona, which we call internally, like the style of it. I think it's more succinct, I think it's more to the point, it's helpful. I feel like it's got a better style about it. I find it more pleasant to brainstorm with and use. And then I think, I think there are various things where there's almost a step change. I feel like it's crossed a sort of threshold of usefulness on things like vibe coding. I've been getting back into my games programming. I'm gonna set myself some projects over Christmas on that because I feel like it's actually got to a point where it's incredibly useful and capable on front end and things like this that perhaps previous versions weren't so good at.
Demis, the last time we had you on the show in May, you said that you think we're 5 to 10 years away from AGI and that there might be a few significant breakthroughs needed between here and there. Has Gemini 3 and observing how good it is changed any of those timelines, or does it incorporate any of those breakthroughs that you thought would be necessary?
No, I think it's sort of dead on track if you see what I mean. We're really happy with its progress. I think it's an absolutely amazing model and it's right on track of what I was expecting and the trajectory we've been on actually for the last couple of years since the beginning of Gemini, which I think has been the fastest progress of anybody in the industry. And I think we're going to continue doing that trajectory. We expect that to continue. But on top of that, I still think there'll be one or two more things that are required to really get the consistency across the board that you'd expect from a general intelligence, and also improvements still on reasoning, on memory, and perhaps things like world model ideas that you also know we're working on with Simmer and Genie. They all build on top of Gemini, but extend it in various ways. And I think some of those ideas are going to be required as well to fully solve physical intelligence and things like that. So I'm both are true. I'm really happy with the progress of Gemini 3. I think people are going to be pretty pleasantly surprised. But it's on track of what we were expecting the progress to be. And I think that means still 5 to 10 years with one or two more perhaps breakthroughs required.
You mentioned Gemini 3's style. There's been a lot of discussion recently about AI companions, the relationships people are developing with them. How do you think about Gemini 3's personality and what kind of relationship you want users to have with it?
I would say in the app itself, Casey, we're really interested in kind of, we see it on the team a lot as almost like a tool, where it's something you're using to kind of work through and kind of cut through your day. And so whether it's kind of helping on different types of questions you have or helping you create things, that's really where we see it really kind of excelling and kind of the direction we want to see it. I think if you zoom out, if you look at Gemini or some of our other projects like Notebook LM or Flow, we're really kind of trying to think through how does AI really be this superpower, kind of super tool in your toolbox that you can use, whether it's for writing or researching or creating films or whatnot. And so that's really more where we're focused. I think over time, we're really interested on the team to be able to track things like how many tasks did we help you complete in your day. That's a new type of metric that I think we get excited about, and sort of a way that the original sort of Google search worked. You would come to it, you would sort of try to get an answer or sent to a page and sort of move on from there.
Well, that all sounds very good and responsible, but I'm wondering about all the viral engagement you're leaving on the table by not making this thing an erotic companion. Big oversight.
No comment.
Some of your competitors have been very nervous in the days and weeks leading up to Gemini 3. I think they've started hearing the same rumblings that we have about this model being quite good, and maybe the narrative shifting from sort of Google playing catch up in AI to now sort of being on top of the race, or at least in a leadership position there. Do you feel like Google is ahead in the AI race right now?
Look, it's as you guys know very well, it's a ferocious, competitive environment, probably the most competitive there's ever been. So one can never, it's almost really the only important thing is your rate of progress right from where you are, and that's what we're focusing on, and we're very happy about that. I mean, I don't really see it as a sort of like, we're back in the lead or something like that. We've always pioneered the research part of this. I think it's like getting into our groove in making sure that downstream reflected in all of our products. And I think we're really getting into our stride there. I think you saw that actually last I/O, I would say. And we're getting better at that, like with GDM being sort of the engine room of Google. And of course, there's a Gemini app, there's Notebook LM, these AI first products, but there's also powering up all these amazing existing Google products, whether that's Maps, YouTube, Android, search, of course, with AI first features, and actually in some cases reimagining things from an AI first perspective with, often Gemini under the hood. And that's going amazingly well. I think we're only midway through that evolution, but it's very exciting to see how, much value and excitement our users are getting when they see each of those new features. And, for example, Workspace and Gmail and so on. There's almost endless possibilities there. So we're really excited about that, as well as all of these AI first products that we're also imagining and prototyping.
We had a historian on the show last week who was using an unreleased Google model in AI Studio, and it had sort of blown his mind with how it was able to transcribe these very old documents and reason correctly about, what kind of, what was the measurements of the sugar in this sort of 1800s fur trade in Canada. Do you think you can tell us once and for all, was this man using Gemini 3?
Not sure about that one.
Okay.
I will say the model is, though, quite amazing at making these connections. And I don't know if the historian was using kind of photos of old documents or diaries or whatnot.
Yes, that's what he was doing.
Yeah,
okay, it's very good at this. And someone like me who has pretty poor handwriting, you can take a page of notes and it'll kind of take that and run with it with no problem, no sweat. So.
You mentioned that on this call that you're going to be integrating this into search in the AI mode that sort of is a side tab on the main Google search engine. Does that mean that you found a way to serve this model more efficiently and cheaply than previous models?
I think we're always on the cutting. I feel like the thing we do really well, apart from the overall performance of our models and getting better and better at that, is the efficiency of our models and the distillation techniques and many other techniques that we sort of created and pioneered that we're now putting to use. Obviously, it's necessary for us because we have extreme use cases of things like AI overviews and others that we have to serve billions of users. And then, of course, some of our cloud enterprise customers really appreciate that efficiency, cost efficiency too. So we've always tried to be on this Pareto frontier of cost to performance, and wherever you want to be on that frontier, if you value performance most or if you value cost the most, then there'll be one of the models in the model family for you. So, of course, course, we're only announcing Pro today, but we are also working on the other family of models for the 3.0 era. So you'll see a lot more about that pretty soon.
It seems like every time we see the release of a new frontier model, we get to revisit the discussion about scaling laws. And are we beginning to see diminishing returns? And I can predict a few Twitter accounts that will probably have something to say about this over the next few days. So I thought I would just sort of ask you, before we have that discourse, how are you guys thinking about that in relation to Gemini 3?
Yeah, we're very happy with the progress Gemini 3 represents over 2.5. So I would say, sort of actually referencing what we discussed earlier, that the progress is basically what we were expecting and on track, and we're really pleased with it. But that's not to say that it's like there is some kind of diminishing returns. People, when they hear diminishing returns, they think of is it zero or exponential, right? But there's also in between. So they can be diminishing. It's not like going to like exponentially double with every era, but it's not. But it's still well worth doing, right? And extremely good return on that investment. So I think we're in that era. And then, as I said, my suspicion is, although we'll see, is that still one or two more breakthroughs are required, research breakthroughs are required to get all the way to AGI. But in the meantime, you're going to obviously need as scale the possible versions of these foundation models, multimodal foundation models that we're building today, and still seeing great progress on.
Which of the many benchmarks that you showed off today do you feel like is going to matter most to the average user?
Oh, that's a good question. I think most people don't look at the benchmarks as closely as we do, but the benchmarks are always a proxy, right? So you look at something like cracking the 1500 ELO on LM Arena. That's great, but what really matters is kind of user satisfaction in the products too. And I think what's been encouraging to us is these are still moving in the same direction. They're good proxies for each other. And so ultimately, I think we'll put out all the benchmarks, and we're very proud of them, and they represent amazing progress. But you also have to be able to translate that into product experiences that matter. And so we try to do both with every one of these releases.
Any new dangerous capabilities or safety concerns that come with the increased power of the model?
I think, well, we've taken quite a long time on this model because it's frontier and has some new capabilities, and it's very capable, as you can see from the benchmarks. And as Josh said, we don't we make sure to not over-index internally on those benchmarks. They're just a proxy for overall performance, and that's why we care about them across the board, and then ultimately how our users experience them. But we spend a lot of time on testing, safety testing, all the different dimensions with the safety institutes, and also external testers that we work with as well, of course doing a ton of internal testing. So I would say this is our most thoroughly tested model so far.
Do you want to mention any of those sort of new capabilities that popped up, whether or not it was for a safety thing? Was there something in there where you thought, okay, yeah, we definitely need to make sure we're sending this to a bunch of
well, look, it's just making sure we've worked really hard on things like tool call usage and function calling and these kinds of things. Obviously, they're super important for coding capabilities, and developers want that and so on, and it's very important in general for reasoning. But it also makes them more capable for riskier things too, like cyber. So we have to be sort of doubly cautious as we improve those dimensions for all the good use cases, that we're continually checking on all those kinds of measures that they can't be misused.
Are we in an AI bubble?
I think it's too binary a question, I would say. I think, my view on this is just strictly my opinion, is that there are some parts of the AI industry that are probably in a bubble. If you look at like seed investment rounds being multi-$10 billion rounds with basically nothing, it seems, there's talented teams, but it seems like that might be the first signs of some kind of bubble. On the other hand, I think there's a lot of amazing work and value to, at least from our perspective, that we see that not only are there all the new product areas, so Gemini app, Notebook LM, but thinking more forward, robotics, gaming. There's incredible uses of, and not just Gemini, but some of the other models, Genie. You can imagine my old games playing background. I'm itching to think about what could be done there. And drug discovery, we're doing isomorphic and Waymo, and so there's all these new greenfield areas. They're going to take a while to mature into massive multi-$100 billion businesses, but I think there's actually potential for half a dozen to a dozen there that I think Alphabet will be involved with, which I'm really excited about. But also immediate returns. We got, of course, the engine room. This is the engine room part of Google, where we're pushing this into all of these incredible, multi-billion user products that people use every day. And there's just almost, we have so many ideas. It's just about execution. Like, how would you reorganize workspace around that? Android, YouTube. There's just so much potential there, and I think a lot of that will also bring in near-term revenue and direct returns, while we're also investing in the future. Not to speak of cloud revenue and TPUs and all of that, which I think is also going to be huge. So I feel really good about where we are as Alphabet, whether or not there's a bubble or not. I think our job is to be winning in both cases. Right? If there's no bubble and things carry on, then we're going to take advantage of that opportunity. But if there is some sort of bubble and there's a retrenchment, I think we'll also be best placed to take advantage of that scenario as well.
All right, let's imagine it's Thanksgiving coming up, and it's the Bay Area, and one of our listeners, changes the subject from politics, which is upsetting everyone, to AI, give people something to be excited about. And someone say, hey, I heard Gemini 3 just came out. Like, what can it actually do? What's the example that you would have our listeners show their friends, whether it's on their phone or their laptop, to be, get a load of this and say Thanksgiving? Yeah,
I don't know if it'll say Thanksgiving, but it could probably provide some laughs. Our imagery models in Gemini are still best in the world. So what I would say, grab your phone, can be, iPhone, Android, doesn't matter, pull it out, you can take a selfie, put yourself in it and edit it. People are still doing that at huge amounts, and it's great fun. And then I think you can then show off any kind of other capabilities in the new Gemini 3 alongside it. But this is what we're seeing, people kind of coming for a lot of these interesting use cases and then starting to try other parts of the app too.
You heard it here. Nano Banana will save Thanksgiving dinner. Gentlemen, thank you. It's great to talk, and thanks for making the time.
Thanks for having us.
All good. Thank you all.
The spatial intelligence work I've been thinking about in the past few years is truly a continuation of my entire career's focus in computer vision and visual intelligence. Why did I emphasize on spatial is because we've come to a point in our technology that the level of sophistication and profound capabilities of this technology is no longer at the level of staring at an image or even understanding simple videos. It is deeply perceptual spatial, and also connects to robotics, it connects to embodied AI as well as ambient AI.
Welcome to the podcast. In this episode, I had the honor of talking again to Fei-Fei Li, a pioneer in artificial intelligence and computer vision. I had Fei-Fei on the podcast a few years ago, and I invite you all to go listen to that episode. I'll put a link at the end of this video. We'll explore her insights on world models and the importance of spatial intelligence, crucial elements for creating AI that truly understands and interacts with the world around us. While large language models are amazing, much, if not most, of human knowledge is not captured in text. And to reach a more general artificial intelligence, models need to experience the world firsthand, or at least through video. We talk about her startup World Labs and their first product, Marble, which generates incredible, complex 3D spaces from the model's internal representations of the world. Plus, she tells us her guilty pleasure, watching her favorite TV show on airplanes. And you probably won't be surprised what that show is. Stay tuned for an enlightening conversation.
I'm Fei-Fei Li. I'll be joining the podcast of Ion AI and discussing spatial intelligence and world models. Come and join us.
Build the future of multi-agent software with Agency. That's AGNTCY. Now an open source Linux Foundation project, Agency is building the Internet of Agents, a collaborative layer where AI agents can discover, connect, and work across any framework. All the pieces engineers need to deploy multi-agent systems now belong to everyone who builds on Agency, including robust identity and access management before interacting. Seamless protocol for scalable Dell technology, more than AI spec Agency DC, your new model, which is amazing, that generates sort of consistent and persistent 3D worlds that the viewer can move through. I want to talk more about why you're focusing on world models on spatial intelligence, why that is necessary to go beyond learning in language, and how your approach differs from LeCun's. So can you talk first of all about, did the world model work emerge from your work on ambient intelligence, or has this been a parallel track?
The spatial intelligence work I've been thinking about in the past few years is truly a continuation of my entire career's focus in computer vision and visual intelligence, right? And why did I emphasize on spatial is because we've come to a point in our technology that the level of sophistication and profound capabilities of this technology is no longer at the level of staring at an image or even simple understanding simple videos. It is deeply, deeply perceptual spatial, and also connects to robotics, connects to embodied AI as well as ambient AI. So from this point of view, it's a continuation really of just my entire career in computer vision and AI.
And the importance of spatial intelligence, and I've talked about this, I've had this podcast for a while, human knowledge, language models learn from human knowledge encoded in text, but that's a very finite subset of human knowledge, and as you pointed out, many people pointed out, humans learn a lot from interacting in the world without language. So it's important, we're going to move beyond the current LLMs, as amazing as they are, that we develop models that have more direct experience of the world, learn more directly from the world. Your approach has been, well, certainly with Marble, to take the internal representations of the world that the model learns and create an external visual reality with those. LeCun's approach is to create internal representations from direct experience or video input that allows a model to learn physical laws of motion and things like that. Is there a parallel between that? Are the two approaches complementary, or are they overlapping?
So first of all, I actually would not pit myself against Young or vice versa, because I think we're on on this continuum of intellectual just approaches to spatial intelligence and world modeling. So if you probably read my recent long essay that I called Manifesto of Spatial Intelligence, and there I was very clear. I actually think both implicit representation and eventually some level of explicit representation, especially in the output layer, are both probably needed if we are considering a universal, omnipotent world model eventually. And they both play roles. For example, our current world model in Worklab's Marble does explicitly output 3D representation, but within the model there is actually also implicit representation, along with the explicit output. So it is eventually, I think we need both, to be honest. And also, in terms of the input modality, yes, learning from videos is very important. The whole world is a continuous input of lots of frames. But the whole world to intelligent or just to animals is not just watching passively. It's also, an embodied experience of movements, of interaction, of tactile experience, of sound, of smell, and also just forces, physical forces of and temperature and all this, right? So I think it's deeply multimodal. And if you even look at, of course, Marble as a model is just the first step, but in our tech piece that we released just a few days ago, we were pretty clear that we believe in multimodality as a learning paradigm as well as an input paradigm. So so I think there's a lot of intellectual discussions on this. It also shows the excitement in the early days of this model. So I would not say that we have finished exploring exactly the model architecture, the representation, and all that.
In your world model, the inputs are primarily videos, and then the model builds an internal representation of the world?
Not quite. If you experience Marble, our world model, our inputs are generally pretty multimodal. You can do a pure text, you can do 1 to multiple images, you can do videos, and you can also input coarse 3D layouts, like boxes or voxels. So it's multimodal, and I think we're going to deepen that as we go.
And is the ambition beyond, it's a fantastic product with many applications, is the ambition to build a system, and when I said that the input is video, but to build a system that can learn from direct experience, whether it's through video or some other modality, but it's not learning through a secondary medium like text.
Yes, I think world model is about learning about the world, and the world is very multimodal. And whether it's machines or animals, we are multisensory as well. So the learning is through sensing, and the sensing has different modalities. So text is one form. Again, this is where we depart from animals, because most animals don't learn through sophisticated language, but humans do. But our today's AI's world model will learn from a lot of language input as well as other modality, but it's not squeezed through only language.
Yeah, and one of the limitations of LLMs is that the model parameters are fixed after training, so the models don't learn continuously. There's a certain amount of learning at test time inference. Is that something that you're tackling with world models? Because presumably a world model is learning as it encounters new environments.
Yeah, the continuous learning paradigm is definitely a very, very important one, especially for living beings. That's how we do it. And even there is online learning versus offline learning. So in the current form of our world model, we are still more in the batch or offline learning mode. But we're definitely open to continuous, especially eventually online learning modality.
Yeah, and how would that? It wouldn't be a very different architecture. It would simply be a matter of engineering. Is that right?
Well, I would be open-minded. Yes, I think it's going to be a mixture of both. Obviously, good engineering, good fine-tuning online learning can already happen, but maybe there will be a new architecture.
Yeah. Can you talk about the real-time frame model, which underlies Marble and your work with world models?
Yeah. So you're referring to a tech blog that we also put out a couple of weeks ago that specifically double-clicks on our real-time frame model. Worklab is a very research-heavy organization. We also care about product, but so much of our work right now in this stage is model first. So we're definitely looking at how we can push forward spatial intelligence. And this particular line of work, which definitely connects to Marble, is really focusing on how we can achieve frame-based generation with as much geometric consistency and permanency as we can. Because some of the early work in frame-based generation, you lose that permanency as you move forward. But in this particular case, we try to really balance and also do it in a compute-efficient way during inference, which in this case we achieve through a single weight 100 in inference time. We don't really know. Some other frame-based models, they don't tell us how many chips they use during their inference time. So we have a hypothesis. It's a quite a number, but we don't know that information to compare ourselves.
Yeah, and in your manifesto, I think you called it, you talk about the need for a universal task function.
A universal what function?
Universal task function.
Oh yes, yeah.
Analogous to the next token prediction in language models. Does RTFM does have a prediction element to it? What are you talking about when you say universal task function beyond what the predictive element of RTFM?
Well, so one of the biggest breakthrough of Gen AI is really this discovery of the objective function of next token prediction, right? Because it really is such a beautiful formulation because language is in this kind of sequential, you can tokenize language in this kind of sequential representation, and your learning function of next token prediction is precisely what you need during inference, which is as you generate language, whether humans generate or computers generate, it really is putting token after token forward. So having an objective function that is 100% aligned with the actual eventual task that is supposed to achieve or carry out is just great because it makes the optimization just on target. In computer vision or in world modeling, it's not as simple, because if you look at our relationship with language, it really is just to speak it or to generate it. But there's no language in nature that you're staring at it. I mean, eventually you learn to read, but that's because it's already generated. So, but there's, your relationship with the language is deeply generative. It literally is a generated thing by humans. But the relationship with the world is so much more multimodal, I would say, right? There is a world out there for you to observe, for you to interpret, for you to reason with it, for you to eventually interact with it. But there's also a mind's eye that can formulate different versions of reality as well as imagination, and also allow you to also generate the story, the imagined world, or so it's much more complex. So what is the task that defines, or the objective function that defines a universal function that we can use that is as powerful as next token prediction? It's actually a really profound question, because is it 3D reconstruction? Just some people actually would argue that the universal task for world modeling could be that it's just be able to 3D reconstruct the world, because if that is the objective function, and if we achieve that, a lot of things will fall naturally out of it. But that is, you could also argue, I don't think so, because most animal brain don't necessarily do precise 3D reconstruction. Like it's not clear a tiger or a person actually can reconstruct the world, yet we're such powerful, visually intelligent, spatially intelligent beings. So maybe that's not necessarily the right task. And then is it the next frame prediction as a way to, as if it's the next token prediction? Well, there's some power to that, right? Like, first of all, there's a lot of training data for this. And second is that it in order to predict the next frame, you have to learn the structure of the world, because worlds are not white noise. So there's a lot of structure that connects one frame to the other. And if you do it well, maybe that is the right universal task or objective function. But maybe it is also unsatisfying because you treat the world as 2D, and the world is not 2D. It's so do you really force the representation, collapse it in a very unsatisfying way? And also, even if you can say if you manage to do it perfectly, 3D is implicit. That's true, but it's also very wasteful, because with the 3D structure, there's actually a lot more information that you don't have to lose in the way that frame-based prediction might. So there's a lot of there's still a lot of exploration on that.
RTFM. And I have to ask you, was that a joke, naming an RTFM?
It was a brilliant play with the. I did not invent this. One of our researchers is really brilliant in naming, right? Like, as you know, I don't know how much we're allowed to say those words here.
I'll say it. Yeah, read the fucking manual. Let's see the acronym. Yeah.
Every computer scientist knows that, so we find that really fun to just play with that name.
Yeah. But RTFM is predicting the next frame, right? That's and
with training consistency.
Yes, and that's what's interesting about the internal representation that the model learns. I mean, sitting here, I'm looking at my computer screen. I know what the other side of the computer screen looks like, even though I can't see it, and there's an internal representation in my mind of that. And your model does that. I mean, that's why you can move around objects even though it's a 3D representation on a 2D screen, but you can move around, see the other side of things. So the model has an internal representation of the 3D object, even if its current view is can't see the backside of something. And that really interests me. That's essentially what you're talking about when you say spatial intelligence, understanding that 3D world. Does that learning include things like the physical laws of nature? I mean, does it understand that you can't walk through a solid object, or that I think on one of the podcasts I saw you on, somebody was talking about using this for people with fear of heights. So you could look over the edge of something. But if you create a physical representation, I mean an explicit representation of a cliff, let's say, and you move the point of view of the agent or the viewer over that cliff, will it know that it's no longer standing on solid ground, or will it float in space?
Yeah, so what you are describing is both physical and semantic, to be honest. Like, of course, falling off a cliff is very much dependent on the law of gravity and all that, but the fact that going through a wall, it's very much material based and semantics based, right? Solid object versus non-solid object. So RTFM as a current model right now is not focusing on the physics yet. Most of the physics, to be honest, coming out of the Gen AI models are statistics. If you look at, for example, a lot of these Gen video models where you do see water running and trees moving, that is not based on a Newtonian law of forces and masses. It's really based on, I've seen plenty of movements of water and leaves in this particular way, and I'm just going to follow that statistical pattern. So we have to be a little careful. Right now, World Labs is still focusing on generating and exploring static worlds. We are going to explore dynamic, and there, a lot of that will be statistical learning. I don't think any of today's AI, language AI or pixel AI, has the capability to abstract at a different level and deduce physics, like at the level of a Newtonian law out of it. Everything we've seen is statistical based physics and physical and dynamical learning. We could, on the other hand, put these worlds into physics engines, and these engines have the laws of physics, and they eventually, these physics engines, game engines, and also world generation, eventually they're going to combine into neural engines. I don't even know, maybe we should call them neurospatial engines or something like that. I think that we are moving towards that direction, but it's still early days, right?
Yeah. And I didn't mean to put you against Jan. What I was driving at is it seems like you're focused on explicit representations coming out of an abstract and internal representation. Jan is just focused on the internal representation and learning, and that's where the learning takes place. And it just seemed to me that they would marry beautifully.
That's a possibility. Like I said, like you already repeated, we are exploring both. The explicit output is actually a very deliberate approach because we want to be useful for people. We want to be useful for people who are creating, who are simulating, who are designing. And if you look at today's industry, whether you're creating VFX effects, or you're creating games, or you're designing interiors, or you're simulating for robots or autonomous vehicles, or industry digital twins, or whatever you're doing, it's very 3D, right? So there's entire industry after industry that's very much 3D in the workflow of 3D, and we want to be absolutely useful for people and businesses to use these models.
And the reason I brought up continuous learning, right now, the model understands depth of field and other sort of spatial properties. What is the learning that is implicit in the model that the model has that allows it to generate that explicit representation? I mean, because the ultimate goal is to build a model that presumably can learn over time. I mean, I'm sure you and everybody else. I mean, I imagine it having a model that maybe it's on a robot, or maybe it's maybe it's attached to it's getting data from a video camera that moves around in the world, but that eventually learns not only the scene that it's seeing, but understands the physicality of the space, and eventually then you marry that with language, and you've got a really powerful intelligence. Is that something that you think about? And that would require continual learning. That it's not a finite data set that you're feeding the model. That the model is continuously learning from its interaction in the world.
Yeah, definitely. Especially as one comes close to a use case, especially if the use case requires continuous learning. There are many ways of continuous learning, right? Like in language model, we see that taking into context itself is continuous learning, right? Like having the context as memory, so it helps inference. And then of course there is other methods of online learning, of fine tuning. So continuous learning is a term that can encompass multiple ways of doing it. And I think in spatial intelligence, especially like you said, some of these use cases, whether it's robots in personal or in customized situations, or artists with particular styles, creators with particular styles, these will all eventually push the technology to be able to be more responsive in whichever time horizon that the use case requires it to be. Some are real time, some are maybe just more segmented in the time horizon point of view. So it depends.
Build the future of multi-agent software with Agency. That's AGNTCY. Now an open source Linux foundation. Act need to deploy on Agency. Ensures everything. Seamless performance for Dead Hat next generation code. Spec Agency.c on this way shop, as I recall, in New Jersey, and in a very short period of time. And you're moving very quickly now. Do you have any sense of where you'll be in 5 years with this technology? Will you have some physics engine built into the model, or will you have the ability to learn in longer time frames and build up richer internal representations that the model can begin to understand the physical world?
Yes, I actually think it's not, as a scientist, it's very hard for me to give a prediction in terms of precise time, because some part of the technology has moved much faster than I thought, some are much slower than I thought. But I think that is very much a very good goal. And also, it's 5 years is kind of a fair guesstimate. I don't know if it will be faster, but it's a better guesstimate than 50 years in my mind, or 5 months.
Can you talk a little bit about why you think spatial intelligence is the next frontier? I mean, we've already said that human knowledge is contained in text is only a subset of all human knowledge, and while it's very rich, you can't expect an AI model to understand the world simply through text. Can you talk about why that's important, and how Marble and World Labs relates to that larger goal?
Yeah, so I think fundamentally, technology should help people. In the meantime, understanding the science of intelligence itself is the most fascinating, audacious, ambitious scientific quest I can think of myself, and it's a quest of 21st century. Both of these, whether you're fascinated by the curiosity of the science or you're motivated by using technology to help people, it points to one fact, is that so much of our intelligence and so much of our intelligence at work goes beyond language, right? It's I kind of lightheartedly say that you cannot use language to put down the fire. And in my manifesto, I described examples, whether it's the spatial reasoning deduction of DNA double helix structure, or a first responder putting down fire in a rapidly evolving situation with a team of coworkers. A lot of this goes beyond language. So it is obvious, both in terms of use case point of view as well as in terms of a scientific quest, that we should try our best to unlock how to develop spatial intelligence technology that takes us to the next level. So that's really the 30,000 feet view that describes how I'm motivated by this dual purpose of scientific discovery as well as making useful tools for people. And then we can dive deeper into, for example, being useful, like we alluded to a little bit earlier, whether you're talking about creativity or simulation or design or immersive experiences or education or healthcare or manufacturing. There's just so much that you could do with spatial intelligence. I'm very excited that so many people who are thinking about education and immersive learning and immersive experiences are telling me that Marble, our first release of the model, is inspiring them to think how to use it for immersive experiences, to make learning more interactive and fun. And that's just so natural, because pre-verbal children learn entirely through immersive experience. And even today, as grown-ups, our life, right? Like, so much of our life is immersed in this world, and involves, of course, it involves speaking and writing and reading, but it involves doing and interacting and enjoying and all that. So it's so natural.
Yeah, I mean, one of the things that has struck everybody is that this Marble, I'm not sure it's Marble or the itself or the RTFM, the generation of next frame in a moving through a space, is that it's running on one H100 GPU. And I've heard you in other talks refer to experiencing the multiverse, which everyone was very excited about until they realized how much computation it was going to take and how expensive it is. Do you really think that this is a step toward creating worlds for education, for example, because you've been able to reduce the computational load?
Not just that. First of all, I really believe at the inference front, we will be speeding up, we will be more efficient, and we'll be also better, bigger, higher quality, longer, experiences. All this, that is the trend of technology. I really do. Things are moving fast. I also do believe in multiverse experience. Humanity as far as we know, the entire history of humanity, our world experience is in one world, and it's literally physically this Earth, right? Okay, a handful of human beings have gone onto the moon, but that's about it. And that is the one shared 3D space. And we build civilization, we live our lives, we do everything in it. But with the digital revolution, digital explosion, we are moving part of our lives in digital world, and there is also a lot of crossover. This is not, I don't want to paint a dystopian picture of we have abandoned our physical world, nor am I going to paint a utopian, total hyperbolic utopian world of everybody wear a headset and never even enjoy and look at our beautiful real world, and that's the fullest of life. I would reject both notions, but both pragmatically speaking, as well as just projecting to the exciting future, the digital world is boundless, it's unlimited, and it gives us so much more dimension and experiences that our physical world will not allow us. For example, we already talked about learning. I would love to have learned chemistry in a much more interactive and immersive way, because I remember my college chemistry class has so much to do with arranging molecules, understanding the parities and the asymmetry of the molecular structure. Man, I wish I could just experience that in an immersive way. I would love for creators to creators, I meet these creators, I realize in their mind's eye, they simultaneousher every given moment, they have so many ways to tell their story. There's so much in their head, but they're rate limited by tools. If you use Unreal Engine, it's going to take weeks, hours after hours to express one world in your head. And whether you're making a fantastical musical production or you are, designing the bedroom for your newborn child, so many of these moments, if we allow people to use the digital universe as much as the physical world to experiment, to iterate, to communicate, to create, it's just so much more fun. And also, our digital age is also helping us to break the physical boundaries of labor, right? Like we're looking at robots that can be teleoperated. I can also totally imagine creators collaborate across the globe through embodied robotic arms or whatever form factor, and through the digital space, so that they can both work in the physical world as well as work in the digital world. And movies, right? Movies will completely change. Right now it's passive experience as much as it's beautiful, but we're going to change the way we get entertained. So all this requires multiverse.
And in teleportation or the teleoperated robots, you could there's a lot of talk of mining rare earths on asteroids and stuff. You don't need to physically be there if you can operate a robot remotely that's in those spaces. What you're talking about is, again, creating explicit representations of 3D space that people can experience. How much in your models does the model itself understand the spaces that it's internalizing before it explicitly projects them? I mean, and that's, again, one thing that I think about more than the productization or practical uses of this, is working toward an AI that truly understands the world, doesn't just have a representation of 3D space, that really understands not only the laws of physics, but what it's seeing and maybe the values or the usefulness of what it sees and ways that it could manipulate the physical world. And how much of that understanding do you think is there, and what needs to happen for the models to really understand the world?
Yeah, okay, great question. So this word understanding is a very profound word. When AI understands something, it just fundamentally is different from how humans understand it. Partially because we're very different beings, right? Humans has a level of consciousness and self-awareness in an embodied body. For example, when we understand something, when we understand my friend is really happy, it's not just an abstract understanding my friend is happy. You actually have chemical reactions in your body that releases happy hormones or whatever chemicals that your heartbeat might increase, your mood might. So that level of understanding is very different from an abstract AI agent that has the capability of correctly assign meaning and link meaning to each other. For example, in Marble, our model product, you can actually go to advanced mode of world generation, and in this advanced mode, it allows you to edit. You can take a preview of the world and say, I don't like this couch being pink, change it to blue, and it changes it to blue. Does it understand at the level of blue couch and the word change? It does, because without that understanding, it wouldn't change the couch to the blue couch. Does it understand it that the same way you and I understand it, including everything about this couch, including every useful or not even useful information of the couch? Does it have a memory of the couch? Does it, take the concept of couch to affordance, to many other things? No, it doesn't. As a model, it's limited to allowing you to, do whatever it's necessary the model needs to do, which is to create a space that has the couch that looks blue. So I think, the answer to your question is, I do think AI understands, but let's not mistake that understanding from a anthropomorphic human level understanding.
Yeah, and in fact, whatever understanding there is, when you tell it to swap a red couch for a blue couch, that's semantic. That's semantic understanding. It's not understanding at the level of light and hitting a retina and knowing and having a concept of blueness as opposed to redness. I saw your talk with Peter Diamandis and Eric Schmidt in Saudi Arabia, and I think you were wonderful in that, much more grounded than some of the questions or even Eric's views. But one of the things that struck me is that there was a brief discussion about the potential for AI to be creative or to help in scientific research, and the analogy that is given, if there had been AI and before someone like Einstein's relativity theory, or I can't remember the other one that was referenced, could AI reason to that discovery? What's missing for AI to be creative? I'm not talking about creative in the arts. I'm talking about in scientific reasoning. It seems to me that should be within reach. I mean, again, with no time frame, but that seems just intuitively something that should be possible.
Yeah, that's a great question. I would think we're closer to AI deducing double helix structure than AI formulating special relativity. Partially because, we already have seen a lot of great work in protein folding. Partly because deducing double helix structure is still, the representation is more grounded in space and geometry, whereas the formulation of special relativity is on an abstract layer that is not just expressed in unlimited amount of words. That's just not how it works, right? Everything we see in physics, from Newtonian law to quantum, we abstract it to a causal level, that the relationship of the world, the concept, whether it's mass or it's force, or is abstracted at a level that is just no longer pure statistical pattern generation. Like language can be very statistical. 3D worlds or 2D world, doesn't matter. It can be very statistical. Dynamics can be very statistical, but the causal abstraction of forces and masses and magnetism and all this are not purely statistical. It is very profoundly causal and abstract. So I'm more in the pontification mode than answering your question mode. I think Eric and I on stage were saying, we've got plenty of celestial body data, movement data in the world now. Just aggregate all the satellite data and all that. Give it to today's AI. Can it come up with Newtonian law of motion?
See, yeah, and actually, I found that was the other example I was trying to think of. Relativity, yeah, there's no physical system that you can observe, at least in day-to-day life, that would lead to that deduction or inference. But with the data of the movement of celestial objects, I'm not sure. Just again, intuitively, I'm a journalist. It seems that maybe not today's AI systems, but that an artificial intelligence could deduce the laws of motion if given the data and given the time to think. Why do you think it would not be able to deduce those laws?
When we say those laws are deduced, Newton has to abstract concepts like forces and mass and acceleration and fundamental constants. Those are at an abstract level that I have not yet to see today's AI can take that whatever vast amount of data and abstract representational variables or relationships at that level. It's there isn't much evidence yet. I don't know everything that's going on in AI, so I'm happy to be proven wrong. I just haven't heard any work that has done that level of abstraction. And in the architecture of a transformer model, I don't see where that abstraction can come from yet. So that's why I'm questioning that.
Yeah. It just from my sense, you're building these abstract internal representations, and as that knowledge accrues, I don't see why an AI model wouldn't be able to apply the rules of knowledge.
I'm not saying AI shouldn't or shouldn't try, but it probably takes more progress in our fundamental architecture of our algorithms.
Yeah, and that was something I wanted to ask. I mean, you use transformers in your models, and I've been talking to people about post-transformer architectures. We're certainly not at a breakthrough, but we started talking about this predictive function, universal task function, as you called it. Do you have an expectation that there will be that kind of a breakthrough, a new architecture that will unlock some of these capabilities?
I do think we will have architectural breakthroughs. I do not think transformer is the last invention of AI. In the grand scheme of things, humanity hasn't been around for that long compared to the entire history of the universe we know of. But in the short history of thousands of years, we have never stopped innovating. So I do not think transformer is the last algorithm architecture of AI.
In one of the conversations or something you wrote, I saw that you were talking about the history of your research, and that at one time you felt if you could get an AI system to label or caption images, that would have been the pinnacle of your career. And of course, you've blown past that. What do you imagine as the crowning achievement of your future career today?
I do think unlocking spatial intelligence, creating a model that really connects perception to reasoning, spatial reasoning, seeing to doing, including planning, and imagining to creation, would be incredible. A model that can do all three of that.
I have a couple of silly questions I'm going to ask you. What's your favorite food, or one of your favorite foods? I'm just curious. I mean, you were born and spent some of your early years in China. Is it Chinese food? Is it,
So I'm married to an Italian, and he's a phenomenal cook, in addition of being a phenomenal AI scientist. So I love Italian. And in our family, when we are being nonpartisan, we love Japanese food.
Not these days, yeah. That's yeah. And then what's your guilty pleasure? You read romance novels on the plane, or binge watch?
Yeah, that's a great question. First of all, I don't have too much leisure time because what I do is so much fun, but I do have a guilty pleasure. I don't think I've ever told anybody. If I'm really tired in a plane, I watch Big Bang Theory. I love that show. And I graduated from Caltech. I was a physics major. Everything of that show, I just identify so much with the people there. It's my, I don't binge watch because it depends on the duration of the flight, but that's my if I'm totally exhausted, I watch that.
Yeah, and you get the jokes, right?
Oh God, I can tell you I love every single jokes and every single character, the nerds in the show.
Welcome back to Google DeepMind podcast with me, your host.
A lot of people call you the godmother of AI. The work you did actually was the spark that brought us out of AI winter.
In the middle of 2015, middle of 2016, some tech companies avoid using the word AI because they were not sure if AI was a dirty word. 2017-ish was the beginning of companies calling themselves AI companies.
There's this line, I think this was when you were presenting to Congress. There's nothing artificial about AI. It's inspired by people, it's created by people, and most importantly, it impacts people.
It's not like I think AI will have no impact on jobs or people. In fact, I believe that whatever AI does, currently or in the future, is up to us. It's up to the people. I do believe technology is a net positive for humanity, but I think every technology is a double-edged sword. If we're not doing the right thing as a society, as individuals, we can screw this up as well.
You have this breakthrough insight of just, okay, we can train machines to think like humans, but it's just missing the data that humans have to learn as a child.
I chose to look at artificial intelligence through the lens of visual intelligence because humans are deeply visual animals. We need to train machines with as much information as possible on images of objects. But objects are very, very difficult to learn. A single object can have infinite possibilities that is shown on an image. In order to train computers with tens and thousands of object concepts, you really need to show it millions of examples.
Today, my guest is Dr. Fei-Fei Li, who's known as the godmother of AI. Fei-Fei has been responsible for and at the center of many of the biggest breakthroughs that sparked the AI revolution that we're currently living through. She spearheaded the creation of ImageNet, which was basically her realizing that AI needed a ton of clean labeled data to get smarter. And that data set became the breakthrough that led to the current approach to building and scaling AI models. She was chief AI scientist at Google Cloud, which is where some of the biggest early technology breakthroughs emerged from. She was director at SAIL, Stanford's Artificial Intelligence Lab, where many of the biggest AI minds came out of. She's also co-creator of Stanford's Human-Centered AI Institute, which is playing a vital role in the direction that AI is taking. She's also been on the board of Twitter. She was named one of Time's 100 most influential people in AI. She's also on the United Nations Advisory Board. I could go on. In our conversation, Fei-Fei shares a brief history of how we got to today in the world of AI, including this mind-blowing reminder that 9 to 10 years ago, calling yourself an AI company was basically a death knell for your brand because no one believed that AI was actually going to work. Today, it's completely different. Every company is an AI company. We also chat about her take on how she sees AI impacting humanity in the future, how far current technologies will take us, why she's so passionate about building a world model, and what exactly world models are, and most exciting of all, the launch of the world's first large world model, Marble, which just came out. As this podcast comes out, anyone can go play with this at marble.worldlabs.ai. It's insane. Definitely check it out. Fei-Fei is incredible and way too under the radar for the impact that she's had on the world. So I'm really excited to have her on and to spread her wisdom with more people. A huge thank you to Ben Horowitz and Condoleezza Rice for suggesting topics for this conversation. If you enjoy this podcast, don't forget to subscribe and follow it in your favorite podcasting app or YouTube. With that, I bring you Dr. Fei-Fei Li after a short word from our sponsors. This episode is brought to you by Figma, makers of Figma Make. When I was a PM at Airbnb, I still remember when Figma came out and how much it improved how we operated as a team. Suddenly, I could involve my whole team in the design process, give feedback on design concepts really quickly, and it just made the whole product development process so much more fun. But Figma never felt like it was for me. It was great for giving feedback and designs, but as a builder, I wanted to make stuff. That's why Figma built Figma Make. With just a few prompts, you can make any idea or design into a fully functional prototype or app that anyone can iterate on and validate with customers. Figma Make is a different kind of vibe coding tool. Because it's all in Figma, you can use your team's existing design building blocks, making it easy to create outputs that look good and feel real and are connected to how your team builds. Stop spending so much time telling people about your product vision and instead show it to them. Make code-backed prototypes and apps fast with Figma Make. Check it out at figma.com/Lenny. Did you know that I have a whole team that helps me with my podcast and with my newsletter? I want everyone on that team to be super happy and thrive in their roles. JustWorks knows that your employees are more than just your employees. They're your people. My team is spread out across Colorado, Australia, Nepal, West Africa, and San Francisco. My life would be so incredibly complicated to hire people internationally, to pay people on time and in their local currencies, and to answer their HR questions 24/7. But with JustWorks, it's super easy. Whether you're setting up your own automated payroll, offering premium benefits, or hiring internationally, JustWorks offers simple software and 24/7 human support from small business experts for you and your people. They do your human resources right so that you can do right by your people. JustWorks for your people. Fei-Fei, thank you so much for being here and welcome to the podcast.
I'm excited to be here, Lenny.
I'm even more excited to have you here. It is such a treat to get to chat with you. There's so much that I want to talk about. You've been at the center of this AI explosion that we're seeing right now for so long. We're going to talk about a bunch of the history that I think a lot of people don't even know about how this whole thing started. But let me first read a quote from Wired about you just so people get a sense. And in the intro, I'll share all of the other epic things you've done, but I think this is a good way to just set context. Fei-Fei is one of a tiny group of scientists, a group perhaps small enough to fit around a kitchen table, who are responsible for AI's recent remarkable advances. A lot of people call you the godmother of AI. And unlike a lot of AI leaders, you're an AI optimist. You don't think AI is going to replace us. You don't think it's going to take all our jobs. You don't think it's going to kill us. So I thought it'd be fun to start there. Just what's your perspective on how AI is going to impact humanity over time?
Yeah, okay, so Lenny, let me be very clear. I'm not a utopian. So it's not like I think AI will have no impact on jobs or people. In fact, I'm a humanist. I believe that whatever AI does currently or in the future is up to us. It's up to the people. So I do believe technology is a net positive for humanity. If you look at the long course of civilization, I think fundamentally we're an innovative species that if you look at from written record thousands of years ago to now, humans just kept innovating ourselves and innovating our tools. And with that, we make lives better, we make work better, we build civilization. And I do believe AI is part of that. So that's where the optimism comes from. But I think every technology is a double-edged sword. And if we're not doing the right thing as a species, as a society, as communities, as individuals, we can screw this up as well.
There's a line, I think this was when you were presenting to Congress. There's nothing artificial about AI. It's inspired by people, it's created by people, and most importantly, it impacts people. Another question there, but what a great line.
Yeah, I feel pretty deeply. I started working in AI 2.5 decades ago, and I've been having students for the past 2 decades. And almost every student who graduates, I find them, when they graduate from my lab, that your field is called artificial intelligence, but there's nothing artificial about it.
Coming back to the point you just made about how it's kind of up to us about where this all goes, what is it you think we need to get right? How do we set things on a path? I know this is a very difficult question to answer, but just what's your advice? What do you think we should?
Yeah, like how many hours do we have?
How do we align AI? There we go.
Yeah, so I think people should be responsible individuals. No matter what we do. This is what we teach our children, and this is what we need to do as grown-ups as well, no matter which part of the AI development or AI deployment or AI application you are participating in. And most likely many of us, especially as technologists, we're in multiple points. We should act like responsible individuals and care about this, actually care a lot about this. I think everybody today should care about AI because it is going to impact your individual life. It is going to impact your community. It's going to impact the society and the future generation. And caring about it as a responsible person is the first but also the most important step.
Okay, so let me actually take a step back and kind of go to the beginning of AI. Most people started hearing and caring about AI, is what it's called today. Just like, I don't know, a few years ago when ChatGPT came out, maybe it was like 3 years ago.
3 years ago, almost 1 more month, 3 years ago.
Wow, okay, and that was ChatGPT coming out? Is that a milestone? You have mine? Okay, cool. That's exactly how I saw it. But very few people know there was a long history of people working on it. It was called machine learning back then, and there's other terms, and now it's just everything's AI. And there's kind of like a long period of just a lot of people working on it, and then there's this, what people refer to as the AI winter, where people just gave up. Almost most people did, and just, okay, this idea isn't going anywhere. And then the work you did actually was essentially the spark that brought us out of AI winter and is directly responsible for the world we're in now. Just AI is all we talk about, as you just said. It's going to impact everything we do. So I thought it'd be really interesting to hear from you, just kind of like the brief history of what the world was like before ImageNet, then just the work you did to create ImageNet, why that was so important, and then just what happened after.
It is for me hard to keep in mind that AI is so new for everybody. When I lived my entire professional life in AI, there's a part of me that it's so satisfying to see a personal curiosity that I started barely out of teenagehood and now has become a transformative force of our civilization. It generally is a civilizational level technology. So that journey is about 30 years or 20 plus years, and it's just very satisfying. So where did it all start? Well, I'm not even the first generation AI researcher. The first generation really dates back to the 50s and 60s, and Alan Turing was ahead of his time in the 40s by daring humanity with the question, is there thinking machines, right? And of course, he has a specific way of testing this concept of thinking machine, which is a conversational chatbot, which to his standard, we now have a thinking machine. But that was just a more anecdotal inspiration. The field really began in the 50s when computer scientists came together and look at how we can use computer programs and algorithms to build these programs that can do things that have been only capable by human cognition. So, and that was the beginning, and the founding fathers, the Dartmouth workshop in the 1956, we have Professor John McCarthy, who later came to Stanford, who coined the term artificial intelligence. And between the 50s, 60s, 70s, and 80s, it was the early days of AI exploration, and we had logic systems, we had expert systems, we also had early exploration of neural network. And then it came to around the late 80s, the 90s, and the very beginning of the 21st century. That stretch, about 20 years, is actually the beginning of machine learning, is the marriage between computer programming and statistical learning. And that marriage brought a very, very critical concept into AI, which is that purely rule-based program is not going to account for the vast amount of cognitive capabilities that we imagine computers can do. So we have to use machines to learn the patterns. Once the machines can learn the patterns, it has a hope to do more things. For example, if you give it 3 cats, the hope is not just for the machines to recognize these 3 cats. The hope is the machines can recognize the 4th cat, the 5th cat, the 6th cat, and all the other cats. And that's a learning ability that is fundamental to humans and many animals. And we as a field realize we need machine learning. So that was up till the beginning of the 21st century. I entered the field of AI literally in the year of 2000. That's when my PhD began at Caltech. And so I was one of the first generation machine learning researchers. And we were already studying this concept of machine learning, especially neural network. I remember that was one of my first courses at Caltech. It's called neural network. But it was very painful. It was still smack in the middle of the so-called AI winter, meaning the public didn't look at this too much. There wasn't that much funding. But there was also a lot of ideas flowing around. And I think 2 things happened to myself that brought my own career so close to the birth of modern AI is that I chose to look at artificial intelligence through the lens of visual intelligence because humans are deeply visual animals. We can talk a little more later, but so much of our intelligence is built upon visual, perceptual, spatial understanding, not just language per se. I think they're complementary. So I chose to look at visual intelligence, and my PhD and my early professor years, my students and I are very committed to a North Star problem, which is solving the problem of object recognition, because it's a building block for the perceptual world, right? We go around the world interpreting, reasoning, and interacting with it more or less at the object level. We don't interact with the world at the molecular level. We don't interact with the world as we sometimes do, but we rarely. For example, if you want to lift a teapot, you don't say, okay, the teapot is made of 100 pieces of porcelain, and let me work on these 100 pieces. You look at it as one object and interact with it. So object is really important. So I was among the first researchers to identify this as a North Star problem. But I think what happened is that as a student of AI and then a researcher of AI, I was working on all kinds of mathematical models, including neural network, including Bayesian network, including many models. And there was one singular pain point, is that these models don't have data to be trained on. And as a field, we were so focusing on these models, but it dawned on me that human learning, as well as evolution, is actually a big data learning process. Humans learn with so much experience, constantly. And evolution, if you look at time, animals evolve with just experience in the world. So I think my student and I conjectured that a very critically overlooked ingredient of bringing AI to life is big data. And then we began this image project in 2006, 2007. We were very ambitious. We wanted to get the entire internet image data on context. Now, granted, internet was a lot smaller than today, so I felt like that ambition was not too crazy. Now it's totally delusional to a couple of graduate students and a professor can do this. But and that's what we did. We curated very carefully 15 million images on the internet, created a taxonomy of 22,000 concepts, borrowing other researchers' work, like linguists' work on WordNet, and it's a particular way of dictionarying words. And we combined that into ImageNet, and we open sourced that to the research community. We held an annual ImageNet challenge to encourage everybody to participate in this. We continue to do our own research, but 2012 was the moment that many people think was the beginning of the deep learning or birth of modern AI, because a group of Toronto researchers led by Professor Jeff Hinton participated in ImageNet challenge, used the ImageNet big data and 2 GPUs from NVIDIA, and created successfully the first neural network algorithm that it didn't totally solve, but made a huge progress towards solving the problem of object recognition. And that combination of the trio technology, big data, neural network, and GPU, was kind of the golden recipe for modern AI. And then fast forward the public moment of AI, which is the ChatGPT moment. If you look at the ingredients of what brought ChatGPT to the world, technically it still used these 3 ingredients. Now it's internet scale data, mostly texts, is a much more complex neural network architecture than 2012, but it's still neural network, and a lot more GPUs, but it's still GPUs. So these 3 ingredients are still at the core of modern AI.
Incredible. I've never heard that full story before. I love that it was 2 GPUs was the first. I love it.
Yeah.
And now it's, I don't know, hundreds of thousands, right? That are orders of magnitudes more powerful.
Yep.
And those 2 GPUs they were like gaming GPUs. They just went to like the game store, right? That people use for playing games. As you said, this continues to be in a large way the way models get smarter. Some of the fastest growing companies in the world right now, I've had them all mostly on the podcast, Mercor and Surge and Scale. Like they do this, they continue to do this for labs, just give them more and more labeled data of the things they're most excited about.
I remember Alex Wang from Scale, very early days. I probably still has his emails when he was starting Scale. He was very kind. He keeps sending me emails about how ImageNet inspired Scale. I was very pleased to see that.
One of my other favorite takeaways from what you just shared is just such an example of high agency and just doing things. That's kind of a meme on Twitter. Just you can just do things. You're just like, okay, this is probably necessary to move AI. And it's called machine learning back then, right? Was that the term most people used?
I think it was interchangeably. It's true. Like I do remember the companies, the tech companies. I'm not going to name names, but I was in a conversation in one of the early days. I think it is in the middle of 2015, middle of 2016. Some tech companies avoid using the word AI because they were not sure if AI was a dirty word. And I remember I was actually encouraging everybody to use the word AI because to me that is one of the most audacious questions humanity has ever asked in our quest for science and technology, and I feel very proud of this term. But yes, at the beginning some people were not sure.
What year was that roughly when AI was
2016. I think that was the changing. Like some people start calling it AI, but I think if you look at the Silicon Valley tech companies, if you trace their marketing term, I think 2017-ish was the beginning of companies calling themselves AI companies.
That's incredible. Just how the world has changed.
Yes.
Now you can't not call yourself an AI company.
I know.
Just 9-ish years later.
Yeah.
Oh man. Okay. Is there anything else around the history, that early history that you think people don't know, that you think is important before we chat about where you think things are going and the work that you're doing?
I think as all histories, I'm keenly aware that I am recognized for being part of the history, but there are so many heroes and so many researchers. We're talking about generations of researchers. There, in my own world, there are so many people who have inspired me, which I talk about in my book. But I do feel our culture, especially Silicon Valley, tends to assign achievements to a single person. Well, while I think it has value, but it's just to be remembered. AI is a field of, at this point, 70 years old, and we have gone through many generations. No one could have gotten here by themselves.
Okay, so let me ask you this question. It feels like we're always on this precipice of AGI, this kind of vague term people throw around. AGI is coming, it's going to take over everything. What's your take on how far you think we might be from AGI? Do you think we're going to get there on the current trajectory? Do you think we need more breakthroughs? Do you think the current approach will get us there?
Yeah, this is a very interesting term, Lenny. I don't know if anyone has ever defined AGI. There are many different definitions, including, some kind of superpower for machines, all the way to machines can become economically viable agent in a society. In other words, making salaries to live. Is that the definition of AGI? As a scientist, I take science very seriously, and I entered the field because I was inspired by this audacious question of, can machines think and do things in the way that humans can do? For me, that's always the North Star of AI. And from that point of view, I don't know what's the difference between AI and AGI. I think we've done very well in achieving parts of the goal, including conversational AI, but I don't think we have completely conquered all the goals of AI. And I think our founding fathers, Alan Turing, I wonder if Alan Turing is around today and you ask him to contrast AI versus AGI, he might just shrug and said, well, I asked the same question back in 1940s. So I don't want to get onto a rabbit hole of defining AI versus AGI. I feel AGI is more a marketing term than a scientific term. As a scientist and technologist, AI is my North Star, is my field's North Star, and I'm happy people call it whatever name they want to call it.
So let me ask you maybe this way. Like you described, it's kind of these components that from ImageNet and AlexNet kind of took us to where we're today. GPUs, essentially data, labeled data, just like the algorithm of the model. There's also just the transformer, feels like an important step in that trajectory. Do you feel like those are the same components that'll get us to, 10 times smarter model, something that's like life-changing for the entire world? Or do you think we need more breakthroughs? I know we're going to talk about world models, which I think is a component of this, but is there anything else that you think is like, oh, this will apply to or okay, this will take us, just need more data, more compute, more GPUs?
Oh no, I definitely think we need more innovations. I think scaling laws of more data, more GPUs, and bigger current model architecture there's still a lot to be done there, but I absolutely think we need to innovate more. There's not a single deeply scientific discipline in human history that has arrived at a place that says we're done innovating. And AI is one of the, if not the youngest discipline in human civilization in terms of science and technology. We're still scratching the surface. For example, like I said, we're going to segue into world models. Today, you take a model and run it through a video of a couple of office rooms and ask the model to count the number of chairs. And this is something a toddler could do, or maybe a elementary school kid could do. And AI could not do that, right? So there's just so much AI today could not do. Then let alone thinking about how did, someone like Isaac Newton look at the movements of the celestial bodies and derive an equation or a set of equations that governs the movement of all bodies. That level of creativity, extrapolation, abstraction, we have no way of enabling AI to do that today. And then let's look at emotional intelligence. If you look at a student coming to a teacher's office and have a conversation about motivation, passion, what to learn, what's the problem that's really bothering you. That conversation, as powerful as today's conversational bots are, you don't get that level of emotional cognitive intelligence from today's AI. So there's a lot we can do better. And I do not believe we're done innovating.
Demis had this really interesting interview recently from DeepMind/Google, where someone asked him just like, what do you think, how far are we from AGI? What does it look like when we're through there? He had a really interesting way of approaching it is, if we were to give the most cutting edge model all of the information until the end of the 20th century, see if it could come up with all the breakthroughs Einstein had. And so far, we're nowhere near that.
No, we're not. In fact, it's even worse. Let's give AI all the data, including modern instruments data of celestial bodies, which Newton did not have, and give it to that. And just ask AI to create the 17th century set of equations on the laws of bodily movements. Today's AI cannot do that.
All right, we're ways away. So okay, so let's talk about world models. This is, to me, this is just another really amazing example of you being ahead of where people end up. So you were way ahead on, okay, we just need a lot of clean data for AI and neural networks to learn. You've been talking about this idea of world models for a long time. You started a company to build, essentially there's language models. This is a different thing. This is a world model. We'll talk about what that is. And now, as I was preparing for this, Elon's like talking about world models, Jensen's talking about world models. I know Google's working on this stuff. You've been at this for a long time, and you actually just launched something that's we're going to talk about right before this podcast airs. Talk about what is a world model, why is it so important?
I'm very excited to see that more and more people are talking about world models, like Elon, like Jensen. I have been thinking about really how to push AI forward all my life, right? And the large language models that came out of the research world and then OpenAI and all this for the past few years were extremely inspiring, even for a researcher like me. I remembered when GPT-2 came out, and that was in, I think, late 2020. I was co-director, I still am, but I was at that time full-time co-director of Stanford's Human-Centered AI Institute. And I remember it was, the public was not aware of the power of the large language model yet, but as researchers, we were seeing it. We're seeing the future. And I had pretty long conversations with my natural language processing colleagues like Percy Liang and Chris Manning. We were talking about how critical this technology is going to be. And the Stanford AI Institute, Human-Centered AI Institute, HAI, was the first one to establish a full research center on foundation model. We were, Percy Liang and many researchers led the first academic paper on foundation model. So it was just very inspiring for me. So of course, I come from the world of visual intelligence. And I was just thinking there's so much we can push forward on beyond language, because humans have used our sense of spatial intelligence and world understanding to do so many things, and they are beyond language. Think about a very chaotic first responder scene, whether it's fire or some traffic accident or some natural disaster. And if you immerse yourself in those scenes and think about how people organize themselves to rescue people, to stop further disasters, to put down fires, to a lot of that is movements, is spontaneous understanding of objects, worlds, human situational awareness. Language is part of that, but a lot of those situations, language cannot get you to put down a fire. So what is that? I was thinking a lot. In the meantime, I was doing a lot of robotics research, and it dawned on me that the linchpin of connecting the additional intelligence, in addition to language, and connecting embodied AI, which are robotics, connecting visual intelligence is the sense of spatial intelligence about understanding the world. And that's when, I think in 2024, I gave a TED talk about spatial intelligence and world models, and I start formulating this idea back in 2022 based on my robotics and computer vision research. And then one thing that was really clear to me is that I really want to work with the brightest technologists and move as fast as possible to bring this technology to life. And that's when we founded this company called World Labs. And you can see the word world is in the title of our company because we believe so much in world modeling and spatial intelligence.
People are so used to just chatbots, and that's a large language model. The simple way to understand world models, you basically describe a scene, and it generates an infinitely explorable world. We'll link to the thing you launched, which we'll talk about, but just is that a simple way to understand?
That's part of it, Lenny. I think a simple way to understand a world model is that this model can allow anyone to create any worlds in their mind's eye by prompting, whether it's an image or a sentence, and also be able to interact in this world, whether you're browsing and walking or picking objects up or changing things, as well as to reason within this world. For example, if the agent consuming this output of the world model is a robot, they should be able to plan its path and help to, tidy the kitchen, for example. So world model is a foundation that you can use to reason, to interact, and to create worlds.
Great, yeah. So robots feel like that's potentially the next big focus for AI researchers and just like the impact on the world. And what you're saying here is this is a key missing piece of making robots actually work in the real world, understanding how the world works.
Yeah, well, first of all, I do think there's more than robots. That's exciting. But I agree with everything you just said. I think world modeling and spatial intelligence is a key missing piece of embodied AI. I also think let's not underestimate that humans are embodied agents and humans can be augmented by AI's intelligence. Just like today, humans are language animals, but we're very much augmented by AI when helping us to, do language tasks, including software engineering. I think that we shouldn't underestimate, or maybe we tend not to talk about how humans as an embodied agents can actually benefit so much from world models and spatial intelligent models as well as robots can.
So the big unlocks here, robots, which a huge deal. If this works out, I imagine each of us has robots doing a bunch of stuff for us, goes into, they help us with disasters, things like that. Games obviously is a really cool example, just like infinitely playable games that you just invent out of your head. And then creativity feels like just like being fun, having fun, being creative, thinking of wild new worlds and environments.
And also design. Humans design from machines to buildings to homes, and also scientific discovery, right? There's so much, I like to use the example of the discovery of the structure of DNA. If you look at one of the most important pieces in DNA's discovery history is the X-ray diffraction photo that was captured by Rosalind Franklin. And it was a flat 2D photo of a structure that looks like a cross with diffractions. You can Google those photos. But with that 2D flat photo, humans, especially two important humans, James Watson and Francis Crick, in addition to their other information, was able to reason in 3D space and deduce a highly three-dimensional double helix structure of the DNA. And that structure cannot possibly be 2D. You cannot think in 2D and deduce that structure. You have to think in 3D spatial, use the human spatial intelligence. So I think even in scientific discovery, spatial intelligence or AI-assisted spatial intelligence is critical.
This is such an example of, I think it was Chris Dixon that had this line that the next big thing is going to start off feeling like a toy. When ChatGPT just came out, I remember Sam Altman just tweeted, here's a cool thing we're playing with, check it out. Now it's the fastest growing product in all of history, changed the world.
Yeah.
And it's oftentimes the things that just look like, okay, this is cool. That's fun to play with and end up changing the world most.
Yeah.
This episode is brought to you by Cinch, the customer communications cloud. Here's the thing about digital customer communication. You need them to reach businesses. Messaging teams need to know SMS, name, and logins. Plus, U.S. carriers messages around the U.S. market. INC loves what you're doing. A big fan of yours. They're investors, I believe in.
Yeah, we've known each other for many years. But yes,
Okay,
right
cool.
now they are investors of Worklabs.
Amazing. Okay, so I asked him what I should ask you about, and he suggested I ask you, why is the bitter lesson alone not likely to work for robots? So first of all, just explain what the bitter lesson was in the history of AI, and then just why that won't get us to where we want to be with robots.
So, well, first of all, there are many bitter lessons. But the bitter lessons everybody refers to is a paper written by Richard Sutton, who won the Turing Award recently. And he does a lot of reinforcement learning. And Richard has said, right, if you look at the history, especially the algorithmic development of AI, it turns out simpler model with a ton of data always win at the end of the day, instead of the more complex model with less data. I mean, that was actually, this paper came years after ImageNet. That to me was not bitter, it was a sweet lesson. That's why I built ImageNet, because I believe that big data plays that role. So why can bitter lesson work in robotics alone? Well, first of all, I think we need to give credit to where we are today. Robotics is very much in the early days of experimentation. It's not, the research is not nearly as mature as, say, language models. So many people are still experimenting with different algorithms, and some of those algorithms are driven by big data. So I do think big data will continue to play a role in robotics. And but what is hard for robotics? There are a couple of things. One is that it's harder to get data. It's a lot harder to get data. You can say, well, there's web data. This is where the latest robotics research is using web videos. And I think web videos do play a role. But if you think about what made language model work, as someone who does computer vision and spatial intelligence and robotics, I'm very jealous of my colleagues in language, because they had this perfect setup where their training data are in words, eventually tokens, and then they produce a model that outputs words. So you have this perfect alignment between what you hope to get, which we call objective function, and what your training data looks like. But robotics is different. Even spatial intelligence is different. You hope to get actions out of robots, but your training data lacks actions in 3D worlds. And that's what robots have to do, right? Actions in 3D worlds. So you have to find different ways to fit what do they call a square in a round hole. That what we have is tons of web videos. So then we have to start talking about adding, supplementing data such as teleoperation data or synthetic data, so that the robots are trained with this hypothesis of bitter lesson, which is large amount of data. I think there's still hope, because even what we are doing in world modeling will really unlock a lot of this information for robots. But I think we have to be careful, because we're at the early days of this, and bitter lesson is still to be tested, because we haven't fully figured out the data for. Another part of the bitter lesson of robotics I think we should be so realistic about is, again, compared to language models or even spatial models, robots are physical systems. So robots are closer to self-driving cars than a large language model. And that's very important to recognize. That means that in order for robots to work, we not only need brains, we also need the physical body, we also need application scenarios. And if you look at the history of self-driving car, my colleague Sebastian Thrun took Stanford's car to win the first DARPA challenge in 2006 or 2005. It's 20 years since that prototype of a self-driving car being able to drive 130 miles in the Nevada desert to today's Waymo and on the street of San Francisco. And we're not even done yet. There's still a lot. So that's a 20-year journey. And self-driving cars are much simpler robots. They're just metal boxes running on 2D surfaces. And the goal is not to touch anything. Robot is 3D things running in 3D world. And the goal is to touch things. So the journey is going to be, there's many aspects, elements. And of course, one could say, well, the self-driving car early algorithm were pre-deep learning era. So deep learning is accelerating the brains. And I think that's true. That's why I'm in robotics. That's why I'm in spatial intelligence. And I'm excited by it. But in the meantime, the car industry is very mature. And productizing also involves the mature use cases, supply chains, the hardware. So I think it's a very interesting time to work in these problems. But it's true, Ben is right. We might still be subject to a number of bitter lessons.
Doing this work, do you ever just feel off for the way the brain works and is able to do all of this for us? Just the complexity, just to get a machine to just walk around and not hit things and fall, does it just give you more respect for what we've already got?
Totally. We operate on about 20 watts. That's dimmer than any light bulb in the room I'm in right now. And yet we can do so much. So I think actually, the more I work in AI, the more I respect humans.
Let's talk about this product you just launched called Marble, a very cute name. Talk about what this is, why this is important. I've been playing with it. It's incredible. We'll link to it for folks to check it out. What is Marble?
Yeah, I'm very excited. So first of all, Marble is one of the first products that Worklabs has rolled out. Worklabs is a foundation frontier model company. We are founded by 4 co-founders who have deep technical history. My co-founders, Dustin Johnson, Christoph Lassner, and Ben Mildenhall. We all come from the research field of AI, computer graphics, computer vision. And we believe that spatial intelligence and world modeling is as important, if not more, to language models and complementary to language models. So we wanted to seize this opportunity to create a deep tech research lab that can connect the dots between frontier models with products. So Marble is an app that's built upon our frontier models. We've spent a year and plus building the world's first generative model that can output genuinely 3D worlds. That's a very, very hard problem. And it was a very hard process. And we have a team of founding team of incredible technologists from incredible teams. And then around just a month or two ago, we saw the first time that we can just prompt with a sentence and an image and multiple images and create worlds that we can just navigate in. If you put it on Goggle, which we have an option to let you do that, you can even walk around, right? So it was, even though we've been building this for quite a while, it was still just all inspiring. And we wanted to get into the hands of people who need it. And then we know that so many creators, designers, people who are thinking about robotic simulation, people who are thinking about different use cases of navigable, interactable, immersive worlds, game developers will find this useful. So we developed Marble as a first step. It's again, still very early, but it's the world's first model doing this, and it's the world's first product that allows people to just prompt. We call it prompt to worlds.
Well, I've been playing around with it. It is insane. Like you just have a little Shire world where you just infinitely walk around Middle Earth, basically, and there's no one there yet. But it's insane. You just go anywhere. There's like dystopian world. I'm just looking at all these examples.
Yes.
And my favorite part, actually, I don't know if there's a feature or bug. You can see like the dots of the world before it actually renders with all the textures, and I just love to like you get a glimpse into what is going on with this model. Basically,
that is so cool to hear, because this is where, as a researcher, I'm learning, because the dots that lead you into the world was an intentional feature visualization. It is not part of the model. It's the model actually just generates the world.
Okay.
But we were trying to find a way to guide people into the world, and a number of engineers worked on different versions, but we converged on the dot. And so many people, you're not the only one, told us how delightful that experience is. And it was really satisfying for us to hear that this intentional visualization feature, that's not just the big hardcore model, actually has delighted our users.
Wow, so you add that to make it more like to have humans understand what's going on more, more delightful. Wow, that is hilarious. It makes me think about LLMs in the way it's not the same thing, but they talk about what they're thinking and what they're doing.
Yes, it is.
It also makes me think about just the Matrix. Like it's exactly the Matrix experience. I don't know if that was your inspiration.
Well, like I said, a number of engineers worked on that. It could be their inspiration.
It's in their subconscious.
Yeah.
Okay, so just for folks that may want to play around with this, maybe use it. What are some applications today that folks can start using today? What's your goal with this launch?
Yeah, so we do believe that world modeling is very horizontal, but we're already seeing some really exciting use cases. Virtual production for movies, because what they need are 3D worlds that they can align with the camera. So when the actors are acting on it, they can position the camera and shoot the segments really well. And we're already seeing incredible use. In fact, I don't know if you have seen our launch video showing Marble. It was produced by a virtual production company. We collaborated with Sony, and they used Marble scenes to shoot those videos. So we were collaborating with those technical artists and directors, and they were saying this has cut our production time by 40x. In fact, it has
40x.
to. Yes, in fact, it has to, because we only had 1 month to work on this project, and there were so many things they were trying to shoot. So using Marble really, really significantly accelerated the production of virtual production for VFX and movies. That's one use cases. We are already seeing our users taking our Marble scene and taking the mesh export and putting games, whether it's games on VR or games, just fun games that they have developed. We have had we're showing an example of robotic simulation, because when I'm still a researcher doing robotic training. One of the biggest pain points is to create synthetic data for training robots. And this synthetic data needs to be very diverse. They need to come from different environments with different objects to manipulate. And one path to it is to ask computers to simulate. Otherwise, humans have to, build every single asset for robots. That's just going to take a lot longer. So we already have researchers reaching out and wanting to use Marble to create those synthetic environments. We also have unexpected user outreach in terms of how they want to use Marble. For example, a psychologist team called us to use Marble to do psychology research. It turned out some of the psychiatric patients they study, they need to understand how their brain responds to different immersive scenes of different features. For example, messy scenes or clean scenes or whatever you name it. And it's very hard for researchers to get their hands on these kind of immersive scenes, and it will take them too long and too much budget to create. And Marble is a really almost instantaneous way of getting so many of these experimental environments into their hands. So we're seeing multiple use cases at this point, but the VFX, the game developers, the simulation developers, as well as designers are very excited.
This is very much the way things work in AI. I've had other AI leaders on the podcast, and it's always like, put things out there early as soon as you can to discover where the big use cases are. The head of ChatGPT told me how when they first put out ChatGPT, he was just scanning TikTok to see how people were using it and all the things they were talking about, and that's what convinced them where to lean in and help them see how people actually want to use it. I love this last use case of like for therapy. I'm just imagining like heights, people dealing with heights or snakes or spiders, which
it's amazing. A friend of mine last night literally called me and talked about his height scare and asked me if Marble should be used. That's amazing. You went straight there.
That's because I'm mentioning all the like exposure therapy stuff. Like this could be so good for that. That is so cool. Okay, so I should have asked you this before, but I think there's going to be a question of just how does this differ from things like VO3 and other video generation models? It's pretty clear to me, but I think it might be helpful just to explain how it's different from all the video AI tools people have seen.
Worklog's thesis is that spatial intelligence is fundamentally very important, and spatial intelligence is not just it's not just about videos. In fact, the world is not passively watching videos passing by, right? I love Plato has the allegory of the cave analogy to describe vision. He said that imagine a prisoner tied on his chair, not very humane, but in a cave, watching a full life theater in front of him, but the actual live theater that actors are acting is behind his back. It was just lit so that the projection of the action is on a wall of the cave. And then the task of this prisoner is to figure out what's going on. It's a pretty extreme example, but it really shows, it describes what vision is about, is that to make sense of the 3D world or 4D world out of 2D. So spatial intelligence to me is deeper than only creating that flat 2D world. Spatial intelligence to me is the ability to create, reason, interact, make sense of deeply spatial world, whether it's 2D or 3D or 4D, including dynamics and all that. So Worklab is focusing on that. And of course, the ability to create videos per se could be part of this. And in fact, just a couple of weeks ago, we rolled out the world's first real-time demoable real-time video generation on a single H100 GPU. So we part of our technology includes that. But I think Marble is very different because we really want creators, designers, developers to have in their hands a model that can give them worlds with 3D structure so they can use it for their work. And that's why Marble is so different.
The way I see it is it's a platform for a ton of opportunity to do stuff. As you describe, videos are just like, here's a one video that's very fun and cool, and that's it, and you move on.
By the way, in Marble, we could allow people to export in video form. So you could actually, like you said, you go into a world. So let's say it's a Hobbit cave. You can actually, especially as a creator, you have such a specific way of moving the camera in a trajectory in the director's mind, right? And then you can export that from Marble into a video.
What does it take to create something like this? Just like how big is the team? How many GPUs you working? Like anything you can share there. I don't know how much of this is private information, but just what does it take to create something like this that you've launched here?
It takes a lot of brain power. So we just talk about 20 watts per brain. It's so from that point of view, it's a small number, but it's actually incredible. It's a 500 million years of evolution to give us those power. We have a team of 30-ish people now, and we are predominantly researchers and research engineers, and but we also have designers and product. We actually really believe that we want to create a company that's anchored in the deep tech of spatial intelligence, but we are actually building serious products. So we have this integration of R&D and productization, and of course we use a ton of GPUs. That makes Jensen happy to hear.
Well, congrats on the launch. I know it's a huge milestone. I know it took a ton of work. So I just want to say congrats to you and your team. Let me talk about your founder journey for a moment. So you're a founder of this company. You started how many years ago? A couple years ago? 2-3 years ago?
A year ago.
A year ago.
Plus.
A year? Okay.
18 months, yeah.
Okay. What's something you wish you knew before you started this that you wish you could whisper into the ear of 18 months ago?
Well, I continue to wish I know the future of technology. I think actually that's one of our founding advantage is that we see the future earlier in general than most people. But still, man, this is so exciting and so amazing that what's unknown and what's coming. But I know the reason you're asking me this question is not about the future of technology. You're probably more, look, I did not start a company of this scale at 20-year-old. So, I started a dry cleaner when I was 19, but that's a little smaller scale. And then I, founded Google Cloud AI, and then I founded an institute at Stanford, but those are different beasts. I did feel I was a little more prepared as a founder of the grinding journey that I compared to maybe the 20-year-old founders. But I'm surprised and it puts me into paranoia sometimes that how intensely competitive AI landscape is from the model, the technology itself, as well as talents. And, when I founded the company, we did not have these incredible stories of how much certain talents would cost, So these are things that continue to surprise me and I have to be very alert about.
So the competition you're talking about is, the competition for talent, the speed at which how things are moving.
Yeah.
Yeah. You mentioned this point that I want to come back to, that if you just look over the course of your career, you were at all the major collections of humans that led to so many of the breakthroughs that are happening today. Obviously, we talk about ImageNet, also just SAIL at Stanford is where a lot of the work happened. At Google Cloud, which a lot of the breakthroughs happened. What brought you to those places? For people looking for how to advance in their career, be at the center of the future, just is there a through line there of just what pulled you from place to place and pulled you to those groups that might be helpful for people to hear?
Yeah, this is actually a great question, Lenny, because I do think about it. And obviously, we talked about it's curiosity and passion that brought me to AI. That is more a scientific North Star, right? I did not care if AI was a thing or not. So that was one part. But how did I end up choosing in the particular places I work in, including starting Worklabs, is I think I'm very grateful to myself or maybe to my parents' genes. I'm an intellectually very fearless person. And I have to say, when I hire young people, I look for that because I think that's a very important quality if one wants to make a difference, is that when you want to make a difference, you have to accept that you're creating something new or you're diving into something new. People haven't done that. And if you have that self-awareness, you almost have to allow yourself to be fearless and to be courageous. So when I, for example, came to Stanford, in the world of academia, I was very close to this thing called tenure, which is, have the job forever at Princeton. But I chose to come to Stanford because I love Princeton. It's my alma mater. It's just at that moment, there are people who are so amazing at Stanford, and the Silicon Valley ecosystem was so amazing that I was okay to take a risk of restarting my tenure clock. Going to becoming the first female director of SAIL, I was actually, relatively speaking, a very young faculty at that time. And I wanted to do that because I care about that community. I didn't spend too much time thinking about all the failure cases. Obviously, I was very lucky that the more senior faculty supported me, but I just wanted to make a difference. And then going to Google was similar. I wanted to work with people like Jeff Dean, Jeff Hinton, and all these incredible Demis, the incredible people. So the same with Worklabs. I have this passion, and I also believe that people with the same mission can do incredible things. So that's how it guided my through line. I don't overthink of all possible things that can go wrong, because that's just too many.
I feel like that's an important element. This is not focusing on the downside, focusing more on the people, the mission, what gets you excited, what do you think?
I do want to say one thing to all the young talents in AI, the engineers, the researchers out there, because some of you apply to World Labs. I feel very privileged you considered World Labs. I do find many of the young people today think about every single aspect of an equation when they decide on jobs. At some point, maybe that's the way they want to do it. But sometimes I do want to encourage young people to focus on what's important, because I find myself constantly in mentoring mode when I talk to job candidates, not necessarily recruiting or not recruiting, but just in mentoring mode when I see an incredible young talent who is over-focusing on every minute dimension and aspect of considering a job, when maybe the most important thing is, where's your passion? Do you align with the mission? Do you believe and have faith in this team? And just focus on the impact and you can make the kind of work and team you can work with.
Yeah, it's tough for people in the AI space now. There's so much at them, so much new, so much happening, so much FOMO.
That's true.
I could see the stress, and so I think that advice is really important. Just like what will actually make you feel fulfilled in what you're doing, not just where's the fastest growing company, who's going to win. I don't know. I want to make sure I ask you about the work you're doing today at Stanford at the HAI, Human Centered AI Institute. What are you doing there? I know this is a thing you do on the side still.
So yes, HAI, Human Centered AI Institute, was co-founded by me and a group of faculty like Professor John H. Mendy, Professor James Landy, Professor Chris Manning back in 2018. I was actually finishing my last sabbatical at Google. And it was a very, very important decision for me, because I could have stayed in industry, but my time at Google taught me one thing, is AI is going to be a civilizational technology. And it dawned on me how important this is to humanity, to the point that I actually wrote a piece in New York Times that year, 2018, to talk about the need for a guiding framework to develop and to apply AI. And that framework has to be anchored in human benevolence, is human-centeredness. And I felt that Stanford, one of the world's top university in the heart of Silicon Valley, that gave birth to important companies from NVIDIA to Google, should be a thought leader to create this human-centered AI framework and to actually embody that in our research, education, and policy and in the ecosystem work. So I founded HAI. After fast forward, after 6-7 years, it has become the world's largest AI institute that does human-centered research, education, ecosystem outreach, and policy impact. It involves hundreds of faculty across all 8 schools at Stanford, from medicine to education to sustainability to business to engineering to humanities to law. And we support researchers, especially at the interdisciplinary area, from digital economy to legal studies to political science to discovery of new drugs to new algorithms to that's beyond transformers. We also actually put a very strong focus on policy, because when we started HAI, I realized that Silicon Valley did not talk to Washington, D.C. or Brussels or other parts of the world. And given how important this technology is, we need to bring everybody on board. So we created multiple programs, from Congressional Bootcamp to AI Index report to policy briefing. And we especially participated in policy making, including advocating for a national AI research cloud bill that was passed in the first Trump administration, and participating in state-level regulatory AI discussions. So there's a lot we did, and I continue to be one of the leaders, even though I'm much less involved operationally, because I care not only we create this technology, but we use it in the right way.
Wow, I was not aware of all that other work you were doing. As you're talking, I was reminded Charlie Munger had this quote: "Take a simple idea and take it very seriously." I feel like you've done that in so many different ways and stayed with it, and it's unbelievable the impact that you've had in so many ways over the years. I'm going to skip the lightning round, and I'm just going to ask you one last question. Is there anything else that you wanted to share? Anything else you want to leave listeners with?
I'm very excited by AI, Lenny. I want to answer one question that when I travel around the world, everybody asks me, is that if I'm a musician, if I'm a teacher, middle school teacher, if I'm a nurse, if I'm an accountant, if I'm a farmer, do I have a role in AI, or is AI just going to take over my life or my work? And I think this is the most important question of AI. And I find that in Silicon Valley, we tend not to speak heart to heart with people like us, and not like us in Silicon Valley, but like all of us. We tend to just toss around words like infinite productivity or infinite leisure time or infinite power or whatever. But at the end of the day, AI is about people. And when people ask me that question, it's a resounding yes. Everybody has a role in AI. It depends on what you do and what you want, but no technology should take away human dignity. And the human dignity and agency should be at the heart of the development, the deployment, as well as the governance of every technology. So if you are a young artist and your passion is storytelling, embrace AI as a tool. In fact, embrace Marvel. I hope it becomes a tool for you, because the way you tell your story is unique, and the world still needs it. But how you tell your story, how do you use the most incredible tool to tell your story in the most unique way, is important. And that voice needs to be heard. If you're a farmer near retirement, AI still matters, because you're a citizen. You can participate in your community. You should have a voice in how AI is used, how AI is applied. You work with people that you can encourage all of you to use AI to make life easier for you. If you're a nurse, I hope you know that, at least in my career, I have worked so much in healthcare research because I feel our healthcare workers should be greatly augmented and helped by AI technology, whether it's smart cameras to feed more information or robotic assistance, because our nurses are overworked, over-fatigued, and as our society ages, we need more help for people to be taken care of. So AI can play that role. So I just want to say that it's so important that even a technologist like me are sincere about that everybody has a role in AI.
What a beautiful way to end it. Such a tie back to where we started about how it's up to us and taking individual responsibility for what AI will do in our lives. Final question, where can folks find Marble? Where can they go? Maybe try to join World Labs if they want to. What's the website? Where do people go?
Well, World Labs website is www.worldlabs.ai, and you can find our research progress there. We have technical blogs. You can find Marble the product there. You can sign in there. You can find our job posts link there. You can we're in San Francisco. We love to work with the world's best talents.
Amazing. Feifei, thank you so much for being here.
Thank you, Lenny.
Bye, everyone. Thank you so much for listening. If you found this valuable, you can subscribe to the show on Apple Podcasts, Spotify, or your favorite podcast app. Also, please consider giving us a rating or leaving a review, as that really helps other listeners find the podcast. You can find all past episodes or learn more about the show at lennyspodcast.com. See you in the next episode.
All right. So I can't wait to retire and actually make React.
You know what's crazy? That all of this is real.
Yeah.
Don't you think so?
Pretty much.
Like all this AI stuff and all this Bay Area. Yeah, that it's happening. Like, isn't it straight out of science fiction?
Yeah. Another thing that's crazy is like how normal this slow takeoff feels. The idea that we'd be investing 1% of GDP in AI, like I feel like it felt like a bigger deal. You know, but right now it just feels like
And you get used to things pretty fast.
like it felt like a bigger deal, you know. But right now, it just feels like
you get used to things pretty fast. Turns out, yeah. But also, it's kind of like it's abstract. Like, what does it mean? What it means that you see it in the news.
Yeah.
That such and such company announced such and such dollar amount.
Right.
That's all you see.
Right.
It's not really felt in any other way so far.
Yeah. Should we actually begin here? I think this is an interesting discussion.
Sure.
I think your point about, well, from the average person's point of view, nothing is that different will continue being true even into the singularity.
No, I don't think so.
Okay, interesting.
So the thing which I was referring to, not feeling different, is, okay, so such and such company announced some difficult to comprehend dollar amount of investment.
Right.
I don't think anyone knows what to do with that.
Yeah.
But I think that the impact of AI is going to be felt. AI is going to be diffused through the economy. There's a very strong economic force for this. And I think the impact is going to be felt very strongly.
When do you expect that impact? I think the models seem smarter than their economic impact would imply.
Yeah, this is one of the
always maintain your React or Angular or whatever code one day.
Recording in progress.
Everyone. Good morning, good evening. I think for most of you it's evening.
Yes, it's 9 p.m. now.
Ah, fellow in Japan, JST.
Yep.
Let me know in the thread where you were saying hello from. I'm in New York, so it's still early. I woke up at 6 a.m. this morning. But
what's up?
That's
good to hear.
Good.
Thanks
We
for
were just
coming.
saying,
Good.
yeah, it's been a while. We'll just wait maybe another minute or so or two for other folks to join. And I just told Jason I'm out of practice with Zoom. So, Washington, D.C., 7 a.m. Yes, from the US. It's so early for us. Appreciate you.
Early, folks.
Hi, folks in India. Good evening. Hello from China. What's the time in China? It's definitely late in Japan. So really, really appreciate everybody for staying late. And of course, thank you to Jason. Super excited to have you. Let me see. I think I should be able to admit more people. Admit all. Hello, everyone who just joined. I see Terrence. Hello.
Hello.
Hello, hello. Good to see you. Yeah, likewise. Good afternoon from Spain. I love it. So it seems like we have,
morning, afternoon, evening.
Yeah, all over the world. Amazing. Good to see you all. We'll give folks maybe another minute. Let me see. So we have started recording, so Jason is thankfully is open to recording. So we're going to have this later on YouTube as well for folks who can join. And let's see. Hello, folks in Japan. Yes, Jason is calling from Japan. And is there a way to automatically allow folks to join without me having to manually approve them? More. All right. Okay, so I think I approved everybody. So they should automatically trickle in. Cool. All right, let's get started. It's
Awesome.
5 past. I'm so excited to have you all, and thank you so much, Jason, for joining us today. We're excited to have you. It's been a while. We're going to hear today about Claude skills from Markdown to production AI. And Jason prepared a little bit of content for us, but please feel free, like throughout the presentation, drop your questions in the chat. We really want this to be as interactive as possible, and then we'll do some Q&A and chat after the presentation. A few things about Jason. He's been like such an amazing MLT member for years and years. He earned his PhD in math. He was doing so many things contributing to open science and open source at MLT, from I remember MLT Init, where we had our journal club, to our math sessions, to really cool talks. If you're interested on YouTube, there's a bunch from the MLT Init sessions that I mentioned, to starting your career in AI and going from zero to AI engineer. You're currently an AI solutions architect in Japan, but you're also an entrepreneur. So you started your own company, which is super excited. Even another topic, I think, for another time, maybe to learn from you. But yeah, super excited to have you, and I'll pass it on to you.
Thanks, Susanna. Thanks for the invite, and thanks everyone for having me here. Good morning, good afternoon, and good evening. So today we're talking about cloud skills, but this is not going to be a feature talk or feature walkthrough. I'll be talking more about the 2 skills I've built that has helped some people around me. Let me start by showing a problem that you've experienced yourself, for sure. The context engineering problem. So we just keep re-explaining the same context over and over again, right? Whenever we use any of these LLMs, use our coding standards, that will be like 5,000, 8,000 tokens, follow a process, something process, 3,000, 5,000 tokens, check our brand lines from 2,000 to 8,000 tokens, maybe. Like, how many times have you described yourself, your company, or your project to ChatGPT or Claude, right? Like, we do that a lot. So it's just wasting tokens, because we repeatedly do it, time and consistency. And also, the more sophisticated the flows get, the worse this problem just becomes. So naturally, there has been solutions for this. Let's have a look. So what we've tried so far, system prompts, the OG, mostly used for tone settings, wasn't it? This gave rise with the term prompt engineering. This was the only way we can control the kind of chat that we can get. That's why it was mostly for tone or for character, but it's quite limited and not reusable. And conversation scope is very good in the scope, but outside of it, it's not. Now, a better version, an upgrade that was given to us, are projects and GPTs. So these are better because you can store context, upload documents, but they're platform locked. So you can't take your cloud project and use it in an API. You cannot share your GPT structure across any platforms. Basically, where you build it, it's just there, right? And then we increased our capabilities by tool use. Prominently, the MCP is very helpful. It can do many sophisticated things. It connects to external systems, but it's token heavy and it requires infrastructure. And so this is where skills are different, because skills are very simple. Skills are just markdown files. That's it. Simple text files. Claude reads them when it needs them. But and this it's powerful precisely because of that, because it's simple, right? So instead of repeating ourselves, rebuilding context every conversation, or setting up infrastructure, you just write an MD file, literally skill.md once. And then that basically captures your expertise, your process, your standards, and Claude just loads it dynamically. Okay, so how does it work? Skills use what's called what they call progressive disclosure architecture. So what it means is that metadata is always loaded. So it costs you 50 tokens to have a skill active. That's the cost. This is like having an index card that says, I'm here and this is how you use me, right? Like this first part. So Claude looks at the request, scans the available skills, and decides which ones are relevant. Now, after that, the full instructions only loaded when triggered. So it's up to Claude or up to how you put your description. And of course, Claude, it takes two, right? On if your skill will be triggered or not. So the instructions have the full set of the markdown files, which you can include resources. So to avoid having a very lengthy skill.md, you can actually have references and examples and templates, folders within the same directory of your skill.md that if Claude reads your skill.md, it knows how to increase its capabilities based on what you're doing. Okay, so here's the interesting part if we check the numbers, numbers in terms of tokens, right? Because that's the cost. That's the limiting factor, isn't it? The context limit. So we need to be frugal with this. So if we take the max of 50 tokens, right? 500 skills would be 25K tokens. And 5 MCP servers, given that an MCP server would average to be 5,000 tokens, would also be 25K tokens, right? So here are some examples of so you'd say, oh, this is unfair comparison. Not quite. MCP servers would have, you're probably familiar. Given an MCP server, there are a number of tools, right? So here are some examples. Google Drive MCP has 15 tools, 5K tokens to load. Slack, 12 tools, 4K. GitHub, 15 tools, 5,000 tokens. So it's still in it's a very different order of tools compared to skills, right? So essentially, we can say we had 100x more capabilities for the same cost, which is huge. It's a huge win. Now I'm gonna go ahead and go to the first skill that literally, by the way, literally the first skill, Claude skill I've built. So the story behind this is that before skills arrive, it's been like a half a month or that we entered a hackathon. It's a Chrome extension hackathon with my Vibe coding community. So we were Vibe coding Chrome AI extension. So what's good about this? It's powered by GPT Nano, meaning you can do LLM stuff without internet because it's on your browser. That's why it's cool. That's why we decided to join and okay, let's make something, right? So without skills, because there was no skill back then when we started, we run into a lot of problems that Vibe coders would be familiar with. There would be outdated API knowledge that by the way, I used Codex, I used Cloud Code, I use every different kinds of models and VS Code, and yeah, no one knows, right? Because they have outdated API knowledge. It was expected. I was just testing. So the reason for this is older training data cutoff, of course. So there's been multiple failed attempts because the LLMs are using deprecated APIs. We spend a lot of time debugging these errors and then have something running. right? And then, so in the middle of that, after we finished like a couple of extension, and then skills drop. I was like, okay, after reading the docs of skills, maybe, maybe I'll be successful to create a skill that can one-shot this, because it was a pain, right? Like, you would say, oh, tokens are cheap. Yeah, but if you are vibe coding a lot, you would want to actually one-shot things that you would consistently create, wouldn't you? So I thought, okay, cool. I'm gonna try to create a skill um, for this specific task, right? Will it be successful? Um, so the skills, the MD, I put the some a lot of notes. Basically, the strategy I did is we have a running code, right? We have a running example already. I not backtrack, reverse engineer that into creating a skill for that, essentially. So kind of vibe coding still the making of the skill, if yeah, that makes sense. And so this skill would have the latest on-device AI APIs. And when we tested, as I would show in the next video, it successfully one-shots the very start. Like, that's what we want. We don't want to one-shot the complete end, right? But I do want to one-shot the very start. I don't want something that is not running at least the very basic capability. Like, I want to, so, okay, let's go to the uh, I'm basically talking a lot now. Let's go to the video. So what I want to say here is that from hours of trial and error, we have a working extension in minutes, because it takes several minutes to run the. Okay, so here is the actual Chrome extension skill, the part that I showed earlier. And let's fast forward it a bit. Here's the manifest configuration. Bunch of things that we reverse engineer that we put there so that it will be successful, at least at the very start. Because if you succeed to at least run something, you will succeed into making it complex, right? Succeeding into something simple leads to something, succeeding into more complex stuff. So that's why it was important for me for it to succeed one shot. Okay, so this is the Claude CLI. Yeah. And you can literally say list all skills and it would show all the skills. So this is me verifying that my installation of the skill is there, right? So you can see there, Chrome AI extension. That's our skill. It was there. Okay, now here's my prompt. Create a Chrome AI extension that reads a page and generates answers to user questions, which is automatically highlight. Okay, I made it slightly complicated, but I really just want to test the prompt API. So I wanted to get something from the page and analyze something, right? And so the thing below, it says Chrome AI extension skill is running. Okay, good. So that means you would always know if your skill is being used. You're not like guessing, oh, is it using my skill or not? It's written there. And then fast forward. Okay, now this is the full process. It finished, right? Finished. So you'll see on the left side panel all the files that was created, and I just literally use it, right? This is the very first time it will be used. So I just put, can we use Cloud Code? Just for it. Let's keep it playing. It thinks a bit, right? Again, this is running in the browser. I don't need the internet for this to happen. Okay, it works. One shot, right? So it achieved my goal. I was happy. But I'm also curious because it's an MD file, right? Any model can read an MD file. So codex, read my MD file. So I just say use and then the path of my skill to create. And then I just copy paste the exact same prompt and then waited a few minutes. And okay, let's just play this. Wait a few minutes. Run out of file. So this is the version, okay? The P. This is the version of codex. Can we use code? Let's ask. Okay, there's an answer, right? Still one shot. Just by referring the path of the MD. Cool. You might notice the difference. Okay, this doesn't have more like better design. I think because so the skills, as I said, right? Claude knows how to read the skills and then read the layers. Like if there is path there for designs and stuff, it will read it. But I think Codex just didn't do that, and so it was plain. But yeah, no complaints. It still worked, right? Okay, so that was my very first Claude skill. And so next is for recruiting workflow, recruitment. That's like the most profitable business in Japan. So many recruiting companies here. So it wasn't difficult to find or befriend some people who has their recruiting firms and discuss something about recruitment and AI. So this is part of some things that I've tried with them. Traditional process, you have a recruiter, they receive the job description and they would source on LinkedIn. They're the ones spamming you. 4 to 6 hours for just checking people, resume screening 2 to 3 hours, and then they make some reports, which one would they actually proceed. It's tough work. 7 to 11 hours per role, right? Skills that I've developed for this is we'll do automated LinkedIn sourcing. The candidate evaluation scoring it's just something to put some numbers there. Yeah, you can change that anytime. Executive reports at the end also will be created because as long as you have the text, right? This is what we mean by like just make full use of your context of your text. So overall would be like for less than an hour, depending on how many people you want to source, because scraping is not that fast. Okay, the input. So what is the input for this workflow? I copy pasted this time this position in Anthropic, went to their site, copy pasted. You can see on the left side says pasted there. That's it. And then I prompted it to use the skill to find 10 candidates for the JD. It even understood JD, huh? As job description. Anyway, yeah. And so that's the input. That's it, right? The number of candidates and the JD. And so then now it starts working. So behind the scenes, what is happening? Behind the scenes, part of my skill in the documentation is that I want them to parse the JD, make some criteria, blah blah blah. Some of the things that I know. So this is actually good for technical stuff because I've known a lot about software engineering, and we can relate words which are relevant but not obvious. And so I put that knowledge in the skill. And the magic here is that DeepMind, and also the test that I want to see here is that, can I teach this skill? Because I know skills can use tools, right? MCP is a tool. So will it succeed in using Bright Data MCP? Remember, one MCP, multiple tools, right? And so there are specific tools that I want for this search. And so I put them there. It extracts candidate profiles and experience, scores candidates, as I said, generates structured Excel report and rankings, and provides hiring recommendations. And so here is the output. So the output is the, Claude artifact, the one that's typically on the right. Well, funny enough, it was recommending me, right? Which is, okay, cool, flattered. Maybe for AI solutions architect. I think also because, well, my LinkedIn literally says enterprise AI solutions architect, so that made me an attractive candidate. So executive summary, top recommendations. There are 10 people here, right? I can show you the actual thread later. This is the scoring rubric and key qualifications, which are all freshly scraped from my LinkedIn profile, because some of these are updated, not old, recently, a few months probably, or even last month. Yeah. So why does this matter? Why is skill something cool? Well, because knowledge decay is constant, right? APIs change, frameworks evolve, best practice update. The gap between model, when a model was trained and what we need today keeps growing. So traditional approaches force us to either repeat context every time. This is what we do anyway. Hit context limits, right? Hitting context limits is pretty annoying. And so we've all been there. So skills solve this slightly different, and I think it's a good way. It's a cost-effective way as a solution, right? It packages your expertise at once, whether it's an API specification, your coding standards, whatever the domain you work with, right? Whatever you know, it applies. You can apply it everywhere, as you can see with my experiment with for it using Codex. And then when things change, well, you update your skill, right? You know where to go. Update your skill, which is Git version, right? You can version it. You can just literally put your skill as a Git, and you can track the changes, which is quite valuable. So your knowledge becomes portable, reusable, and maintainable. So, yeah, this is why it's cool. And before we end, so this is something that I've been thinking, like, this idea I've been thinking for even before the official naming of context engineering, which I think this has a lot of overlap with that. But this is just from my daily experience of using AI. And I think some of the things that I put in the pillars here are still not here, aren't they? So number one, nothing you tell the AI should be wasted. I think memory kind of solves that for applications like ChatGPT and Claude, right? They have memory, but other systems should have memory as well if they don't still have, right? So that's something that I think is important. Context should evolve, not reset. I think this is not there yet, isn't it? Because context, what we know now is that if we reach context limit, Anthropic called it compaction, and they would Literally
Hi,
summarize.
my name is
When
Otto,
you
and in this
summarize
video,
things,
we're going to discuss
I mean,
agent
it
skills.
works sometimes,
Agents
but if
today are
you
pretty
are
intelligent,
working on
but
a
they don't
huge
always
code base
have
and
the
you
domain
suddenly
expertise you need
summarize,
for real work.
yeah,
And skills help solve this. You can think of skills as organized folders that package
three is
expertise
definitely not
that Claude
here,
can
right?
automatically
Because
invoke when relevant to the task at hand. And most importantly,
not
these skills are portable
reusable. You
across Claude
cannot
Code, the
even,
API, as well as Claude.ai. And the way skills work
correct me if
is
I'm
at startup,
wrong,
only the name and
can
description
you
of every
even
installed
like
skill is loaded in the
refer
system
to your
prompt. This is going to consume about 30 to 50
I
tokens
don't
per skill and make Claude aware of the skill's existence. Then, when a user
They're
prompt
not
matches a skill's
yeah.
description, Claude is going to
Retrieval
dynamically
should
load
be
the full skill.md
frictionless.
file into context. And finally, if the skill references other files or scripts, they are also
Using
progressively loaded
user
and run as
control
needed.
status.
This progressive disclosure allows you to install many different
I don't
skills
remember
to perform
what.
complex tasks without loading your context window. But let's see how skills fit in with the other Claude features. While skills teach Claude how to do specialized tasks, Claude.md files tell Claude about the specific project, things like your tech stack, coding conventions, and repo structure. Claude.md files live alongside your code in the repository. The Claude.md file may see things like we use Next.js and Tailwind, but skills on the other hand are portable expertise that work across any project. So a front-end design skill can teach Claude your typography standards, animation patterns, and layout conventions, and activate automatically when building UI components. MCP servers, on the other hand, provide universal integration, a single protocol that connects Claude to external context sources like GitHub,
Thank you
Linear,
so
Postgres, and many
much,
others. MCP connects to data.
Jason.
Skills teach Claude what to do with
To
it. So
everyone
an
in the
MCP server
chat,
may give
please
Claude
feel
access to
free
your
to
database, but a
drop
database query
your
skill can teach
questions
Claude
or
your
raise
query
your
optimization
hands. I'm
patterns.
happy to
Finally,
unmute.
sub-agents are specialized AI assistants with fixed
I do
roles.
have a
Each
bunch
sub-agent
of
has its own
questions
context window,
while
custom
we
prompt, and specific tool
for
permissions.
more.
Skills provide portable expertise that any agent can use. So your
First
front-end
of
developer
all,
sub-agent can use a
pretty
component pattern
interesting,
skill.
right?
Your UI
That
reviewer sub-agent, on the other hand, can use a
codecs
design
can
system skill, but
just
both can load and use the
as
same accessibility
easily,
standard skill.
right,
And the best
take
part
that
is these
MD
capabilities are
file,
designed to
take
work
the
together.
skill,
Claude.md files
and
sets the
just
foundation,
produce the
MCP servers
same
connect the
thing.
data, sub-agents
Even though
specialize
I
in their
do
roles. The
admit
skills
that
bring the expertise, make a
the
specific
design
security best
was
practices, or
nicer
sharing your data analysis.
with
Yeah,
Claude
yeah.
skills.
Yeah, it's very different. There's some gradient at least in the
Yeah.
in the blood, yeah.
But seems like it's something very general that can be used like across the board. And you also mentioned like a bunch of great benefits. I loved, by the way, the kind of comparison, right, to how you would have done it before and what is kind of the approach now and why it is better. Have you
Yeah.
seen like what are the actual practical drawbacks here? It seems like it's efficient, it's cheap, it worked one shot. You said it's portable, you can version it. Is that the way to build software moving forward, or are there still things where you say, okay, this needs to be optimized, or I don't know, for instance, like how debugging was. I know sometimes when you're vibe coding stuff, like debugging becomes a nightmare as kind of the
Yeah.
code base gets larger and larger, you kind of lose track of things.
Absolutely. Yeah. That happens because it just pops up, right? So you would know that it doesn't do something, everything is superficial. You would know it's in the high level, you basically a tester, right? That would be the feel. You're creator and the tester, but since you did not code it inside, it's yeah. I'm just lost. Aside aside from the very basic structure of the code base, for example, typical Next.js code base, like kind of would know like where would the if there's some LLM calls that are part of the vibe coding, like I would quickly know where they are and would edit them. But it's also as efficient to just tell them to change the prompt, the vibe code the prompt anyway. It's very yeah. I think the standards will change a lot.
Yeah, it looks like this is changing a lot, or vibe coding in general changes
Yeah.
a lot, but it does come with drawbacks, I think.
For skills, what would be drawback for skills?
Yeah, I'm curious.
Yeah, they're very. I mean, 500 skills. That's probably so much to handle. Probably.
Yeah.
Because okay, maybe because a skill would be successful if it's quite focused. And so to create complex tasks, you would have plenty of those focused things, right? But then there's the problem of an orchestrator to actually do all that. I haven't had the experience of actually using all multiple skills to achieve something, because the two examples I've shown, I'm literally using just one skill to achieve something. I'm still not mixing skills like in the middle. I'm not sure how consistent is that. Like if there's a certain use case that requires of these multiple skills working in order. Yeah, I don't know. I can
Working
only
together.
tell. Yeah. I can only say about this stuff that I've actually tried.
Yeah, but even within a skill, you have multiple tasks, right? And multiple functions, like the LinkedIn that you showed. That is pretty complex, right?
Yeah, actually, yeah. Yeah, it does. But I think because it's simple in the sense that it's step by step. Maybe I think if we the like I put here, I think it's less complex in the sense that these things will be done in order. I think if not, it probably would be more difficult to create this skill. But because what I want can be created in order, I think that's probably why it made it successful. But because literally everything in this step is just essentially the bulk of what I wrote in that skill.
And I see we have one comment by Joshua saying that skills are limited for hierarchical structure, and if the agent needs some more control structure in how it works. Mayank, I did ask to unmute if you want to ask a question.
This one?
Oh, yeah. Oh, yeah, that's very cool.
Yeah, so actually, before seeing this skill creator, I thought it would be an important skill. So I actually tried to create a skill creator, but it was there. And it works, but a couple of iterations to actually have the skill that you want. Well, I mean, one shouldn't complain, right? but it works. This skill creator thing. I think
Yeah.
Recording stopped.
Yeah. Yeah, I think for brands and designs, this actually is very useful. I really like the branding, because I've been making with the Vibe Code community, making a lot of websites, and the designs we've already been doing it with markdowns, like recording our designs there, but having it to be activated when you want it, because it's a skill, is pretty convenient because before Skill, what we would do is that we would refer our brand markdown file. But with Skills, and I think this activation feature, probably every provider would do this, right? Because it just works. Like, I mean, it already works if you just refer the path, right? So why not make it something like Skill? So I'm guessing they're cooking something up that would be very similar to Skills activation. I mean, yeah.
Yeah, that's pretty cool. There's front end design,
Yeah.
canvas design.
Oh, these ones are literally just one MD, huh? I think where are the file builders? Document skills. This one. Yeah. I checked this and I was happy because okay, makes sense. And actually these are the ones that I'm using anyway. Like
Oh.
PyPDF. Yeah, this is why I got curious, right? Because I'm doing this, especially for this one, for no, sorry, not Excel, PowerPoint. Because I did a project with PowerPoint, and it was actually tough to find a working library. And yeah, they're using the same. And so I was like, oh, okay, so I did not miss a library, the library to use if I want to have an like AI and PowerPoint. So where's that? Uh-huh. Maybe this one. HTML to PPTX. Oh no, this is HTML to PPTX. There's Python actually for anyway, it's somewhere here.
That's awesome.
Yeah.
That's a cool repository for sure. Jason, is your Chrome extension is it open source? Did you mention it's like was it part of a hackathon?
No, the part of the hackathons are outputs. Yes, we wait. Let me go to my GitHub Vibe coders. I think
There, yeah.
Yeah, this one.
Oh, cool. Awesome. I wonder how, like, this is awesome. I wonder,
It's
like,
public.
how, yeah, that's cool. I definitely, maybe we can drop the link in the chat.
Yeah, I'll drop the
I
link in the chat.
wonder, like, how, because I think what you showed was this would be still local, right? I wonder, and this should be, at least from what I've seen in your presentation, should be fairly straightforward to build, right? With like, I don't know, 80, 90% time reduction. I wonder how much of a lift it is to actually package this up as like, you know, like you did with your startup, like becoming an actual app for people to use, like a production piece.
Right?
Or the LinkedIn, even better. I can totally see like so many people wanting this, like hiring managers, recruiters, company founders.
Let's talk about that.
Yeah.
Yeah, I'm definitely want to push this forward. Yeah, I'm showing something. Yeah.
Yeah, this is awesome for sure. I also, oh yeah, thanks for sharing the link. And then Mayank made a good recommendation. Simon Willison is, yeah, great blog. And he has a blog post on Claude skills, but he also has, like, it's a wealth of really, really great blog posts. So I highly recommend this. Cool. And Jason, what would you say was the learning curve here? Or let's say a machine learning engineer.
Skills?
Yeah, who's familiar with the general flow.
Not much. It's more of articulation. It's really your articulation and your how good are you with iteration. Like everything
Mm-hmm.
now is just iteration, right? Like I can do it in 1, I can do it in 2, right? That's the skill now.
Yeah.
Yeah, it's like this is like going back to here. I could have made this if this wasn't here.
Mm-hmm.
This because as I said, right, the reason I check this is because I want to verify whether the libraries I use are the updated or the most useful ones or the most the one that works the best, things like that.
Yeah.
And because I know those, would have packaged them here, but they're already here, right? And this makes sense. So as an engineer, knowing certain things like for example this libraries to use,
Mm-hmm.
APIs to use, frameworks, probably frameworks too much, maybe not framework. Um, yeah, every niche skill that one knows, and you can imagine a specific task that you can trigger consistently, and it will do it. Like for example, how do you trigger something with documents? It's easy. You say, make me a PDF document. That's the trigger. Make me an Excel file, right? It's very
Mm-hmm.
clear. So and as an engineer, if you've done that before because you had a project, because you would know the library, so you can recreate this. So for anything like that, I think yeah. So I'm only talking about engineers, but I think anyone now, because in order to make this, wait, let me see if I can find it. In order to make a skill, there's the skill creator. Literally, there's the skill creator. You can talk to Claude and ask it to make you a skill, right?
Mm-hmm.
The best thing if you have code or if you have references is to put them already, and then it would work. Your iteration would be shorter. Now if you're non-technical and you have very specific knowledge that you can describe, that's the value, right? That's the
Mm-hmm.
like a process, for example, right? Like a process that you can describe very cleanly, and if it's hierarchical, then it will be successful for that specific skill. So I think it's literally for everyone. Like I don't see anyone having so much advantage here, especially if they want to like iterate. It's a back and forth anyway. So you can
Yeah.
start definitely with a skill creator. Just use it until it works, and then go outside and then reverse engineer what
Mm-hmm.
yeah.
But that's almost the business logic. It seems like to me, if I think back, Jason, around 10 years
Mm.
ago when we started in machine learning, now kind of of course, we still need to know how machine learning works, but it seems like
Yeah.
here, the core skill that you need is still, and even when we think about vibe coding and other things,
Yeah.
right? The software engineering foundations and the skills of putting it all together, making sense of it, deploying things, right? Is still probably central. Not so much maybe that you know calculus and how backprop works, but
Yeah.
more
Yeah.
how do you deploy this and what are the software engineering foundation fundamental skills that you need to make this work? Seems like to
Yeah.
me.
Yeah, it's really more of is it the answer to your problem, whatever that problem is, right?
Yeah,
It
true.
doesn't need to be technical. Yeah, it's just a problem. Don't label it technical, non-tech. It's a problem and there's a solution, right?
Yeah.
And how fast, I think brilliant people are the ones who can just relate a solution to a problem. Then that's it. That's how I would describe what's going now.
Yeah. Mark, do you want to unmute yourself and ask a
Yeah,
question?
I've been waiting for a chance to get in.
Hi, Mark.
Hi. Okay, Jason, hi. Magandang gabi.
Oh, magandang gabi.
Thank you for
Bye.
the presentation. So my question is, the way since I haven't used Cloud at all in terms
Mhm.
of code and skills, so the way I understood your explanation is skills is basically just us pre-loading the necessary data to the AI model before we can use it, so we can reduce the tokens that it will use.
Yeah.
Is my understanding correct?
Yeah, that's correct. Yeah. like, yeah, like going back to this one, right? Document skills, making a PDF, for example. Or you want to modify this, for example. Actually, let's make like a business case here, right? You're always making specific PDFs, for example. For someone, you can have them here redesign this skills, because this is for general. The codes here are for making the PDFs, right? But what you modify this, you literally just get this folder, dump it in an appropriate place. It depends, actually. It depends if you're using CLI, it's a different place. If you're using Claude, let me show you. If you're using Claude, you dump it. Oh, by the way, this is the full thing. The other candidates are here. If you're using Claude, you dump it where? Capabilities. Yeah, here. See? It's active. My recruitment pipeline automation. So I just zip it and then just dump it here after I created it. So same with anything that you want to create, you modify it. For example, the ones that on the examples, you zip them and then just dump them here. And after you dump them there, actually, Claude would, the first message that Claude would say something like this. And you just need to click it. So they know when you put a skill and they are ready to, they made this for you. Hey, Claude, I just added whatever the name of your skill. Can you make something amazing with it? So the truth is, it failed, actually. It failed here. So it just stops. And so I was like, okay, damn it. I'm just going to continue anyway. That's why my sentence here was weird, right? You notice that? Like, why would he start with how about to use? I mean, this is why it's weird, because I was just continuing this conversation after I literally dropped the recruitment pipeline automation skill. So yeah, that's how you would create your own skill and test it on Claude Desktop or Claude CLI.
Thank you for the explanation. So basically, skills, we can use skills for scalability too, huh?
In a sense, yeah. Yeah, multiple instances using this. Yeah, in a sense.
Okay, thank you for the answers.
Salamat, Mark.
Salamat din.
Mark, any other questions? Makes me definitely want to try this out. I'm off this week. I think I dropped it in the chat. I joined like a Hugging Face hackathon on MCP.
Yeah.
I'm super interested in just giving this a try to see how well it would do and kind of the stuff that I'm building. Oh yeah, super interesting.
Oh yeah, let me know. Might join you with that hackathon.
Oh yeah, I mean, if folks are interested, I think it's today is the 27th. I think it's 3 more days open. It's basically you can choose like either like building MCPs or using MCPs and building or building an MCP server or using some sort of MCP tools and building applications. So it's kind of fun, kind of interesting to dabble a little bit around that. I know some of you guys have mentioned in the chat you're already kind of deep into MCP stuff, and Jason, you probably as well. But yeah, it's a fun little hackathon. I say it's a fun little hackathon. Seems like 5,000 people signed up. So
It's not so little.
there's a little bit of competition.
Yeah.
But yeah, Ali, right. It's the Hugging Face MCP birthday. And it's like in collaboration with Anthropic. So that's why it kind of fits our theme today. Cool. And then I do see a question. How do I attend future demo sessions, Jason? I did drop in the chat your own community, right, Jason? Your vibe coding community, if people are
In
interested
the
in
Philippines, yeah,
joining.
yeah. And this
Yeah.
is my LinkedIn. You can connect with me on LinkedIn. You can. I made it QR, so it's easy for everyone to just take a picture and add
Awesome.
me to
I
the
also
QR.
yeah, also dropped both links in the chat, and I also dropped like a few more links. I hope this is gonna work, but let's see. Wait. Yes, this should work. So there's one of your talks already on YouTube if anybody's interested in hearing more about your AI journey, even though it's, it's been a while. So I think your
Yeah.
AI journey kind of evolved a lot since then, which
Yeah.
is also excited. And yeah, thanks Matthew for sharing the hackathon link for folks who want to join. Obviously Hugging Face is known for like lots of open source stuff, so that's pretty cool. There's also a so this talk is recorded and I'll upload it to YouTube afterwards. And then we already scheduled our next MLT talk. If you're interested, it's going to be with Robert Lange, who is one of the co-founders of Sakana AI, based in Tokyo, with David Ha as his co-founder. So that's going to be super interesting. They've also developed some fun and cool open source stuff and open science stuff. And yeah, connect with Jason. And yeah, if we don't have any other questions, I did drop the Discord link. So if you guys want to chat further, share your experience, share your whatever you've been building with us, or if you have more questions for Jason,
If you have
please
more
do.
questions, you can. If you join the Discord, you can just ping me there.
Awesome. Very cool. All right. Thank you so much, Jason, again. That
Thank you,
was
everyone.
awesome. Really enjoyed it. Great demos. And yeah, thanks everybody for joining from all over the world, and have a great rest of your day. If you're celebrating Thanksgiving, happy Thanksgiving. And good night for Japan and India and others. And I'll see you soon.
Thanks, guys.
See you, everyone.
very confusing things about the models right now. How to reconcile the fact that they are doing so well on evals. And you look at the evals and you go, those are pretty hard evals.
Right.
They're doing so well. But the economic impact seems to be dramatically behind.
Yes.
And it's almost like it's very difficult to make sense of how can the model, on the one hand, do these amazing things, and on the other hand, like repeat itself twice in some situation in kind of an example would be, let's say you use vibe coding to do something, and you go to some place and then you get a bug. And then you tell the model, can you please fix the bug?
Yeah.
And the model says, oh my God, you're so right, I have a bug, let me go fix that. And it introduces a second bug.
Yeah.
And then you tell you have this new, the second bug.
Right.
And it tells you, oh my God, how could I have done it? You're so right again. And brings back the first bug.
Yeah.
And you can alternate between those.
Yeah.
And it's like, how is that possible?
Yeah.
It's like, I'm not sure. But it does suggest that something strange is going on. I have two possible explanations. So here, this is the more kind of a whimsical explanation, is that maybe RL training makes the models a little bit too single-minded and narrowly focused, a little bit too, I don't know, unaware, even though it also makes them aware in some other ways. And because of this, they can't do basic things. But there is another explanation, which is back when people were doing pre-training, the question of what data to train on was answered, because that answer was everything.
Yeah.
When you do pre-training, you need all the data. So you don't have to think it's going to be this data or that data.
Yeah.
But when people do RL training, they don't need to think. They say, okay, we want to have this kind of RL training for this thing and that kind of RL training for that thing. And from what I hear, all the companies have teams that just produce new RL environments and just add it to the training mix. And the question is, what are those? There are so many degrees of freedom. There's such a huge variety of RL environments you could produce. And one thing you could do, and I think that's something that is done inadvertently, is that people take inspiration from the evals. You say, hey, I would love our model to do really well when you release it. I want the evals to do great. What would be RL training that could help on this task, right? I think that is something that happens, and I think it could explain a lot of what's going on. If you combine this with generalization of the models actually being inadequate, that has the potential to explain a lot of what we are seeing, this disconnect between eval performance and actual real world performance, which is something that we don't today exactly even understand what you mean by that.
I like this idea that the real reward hacking is the human researchers who are too focused on the evals. I think there's two ways to understand or to try to think about what you just pointed out. One is, look, if it's the case that simply by becoming superhuman at a coding competition, a model will not automatically become more caseful and exercise better judgment about how to improve your code base. Well, then you should expand the suite of environments such that you're not just testing it on having the best performance in coding competition. It should also be able to make the best kind of application for X thing or Y thing or Z thing. And another, maybe this is what you're hinting at, is to say, why should it be the case in the first place that becoming superhuman at coding competitions doesn't make you a more caseful programmer more generally? Maybe the thing to do is not to keep stacking up the amount of environments and the diversity of environments to figure out an approach which lets you learn from one environment and improve your performance on something else.
So I have an analogy, a human analogy, which might be helpful. So even the case, let's take the case of competitive programming since you mentioned that. And suppose you have two students. One of them decided they want to be the best competitive programmer, so they will practice 10,000 hours for that domain. Yeah. They will solve all the problems, memorize all the proof techniques, and be very, be very skilled at quickly and correctly implementing all the algorithms. And by doing so, they became the best, one of the best. Student number two thought, oh, competitive programming is cool. Maybe they practice for 100 hours, much less, and they also did really well. Which one do you think is going to do better in their career later on?
The second.
Right? And I think that's basically what's going on. The models are much more like the first student, but even more, because then we say, okay, so the model should be good at competitive programming. So let's get every single competitive programming problem ever, and then let's do some data augmentation so we have even more competitive programming problems, and we train on that. And so now you got this great competitive programmer. And with this analogy, I think it's more intuitive. I think it's more intuitive with this analogy that, yeah, okay, so if it's so well trained, okay, it's like all the different algorithms and all the different proof techniques are like right at its fingertips. And it's more intuitive that with this level of preparation, it would not necessarily generalize to other things.
But then what is the analogy for what the second student is doing before they do the 100 hours of fine-tuning?
I think it's like they have it. I think it's the it factor.
Yeah.
Right? And like I know, like when I was an undergrad, I remember there was a student like this that studied with me. So I know it exists.
Yeah. I think it's interesting to distinguish it from whatever pre-training does. So one way to understand what you just said about we don't have to choose the data in pre-training is to say, actually, it's not dissimilar to the 10,000 hours of practice. It's just that you get that 10,000 hours of practice for free because it's already somewhere in the pre-training distribution. But it's like, maybe you're suggesting actually, there's actually not that much generalization in pre-training. There's just so much data in pre-training. But it's like, it's not necessarily generalizing better than RL.
Like the main strength of pre-training is that there is A, so much of it.
Yeah.
And B, you don't have to think hard about what data to put into pre-training. And it's a very kind of natural data, and it does include in it a lot of what people do, people's thoughts, and a lot of the features. It's like the whole world as projected by people onto text.
Yeah.
And pre-training tries to capture that using a huge amount of data. The pre-training is very difficult to reason about because it's so hard to understand the manner in which the model relies on pre-training data. And whenever the model makes a mistake, could it be because something by chance is not as supported by the pre-training data? Support by pre-training is maybe a loose term. I don't know if I can add anything more useful on this, but I don't think there's a human analog to pre-training.
Here's analogies that people have proposed for what the human analogy to pre-training is, and I'm curious to get your thoughts on why they're potentially wrong. One is to think about the first 18 or 15 or 13 years of a person's life when they aren't necessarily economically productive, but they are doing something that is making them understand the world better and so forth. And the other is to think about evolution as doing some kind of search for 3 billion years, which then results in a human lifetime instance. And then I'm curious if you think either of these are actually analogous to pre-training, or how would you think about at least what lifetime human learning is like, if not pre-training?
I think there are some similarities between both of these two pre-training, and pre-training tries to play the role of both of these. But I think there are some big differences as well. The amount of pre-training data is very, very staggering.
Yes.
And somehow a human being, after even 15 years with a tiny fraction of the pre-training data, they know much less. But whatever they do know, they know much more deeply somehow. And the mistakes, like already at that age, you would not make mistakes that RAIs make. There is another thing. You might say, could it be something like evolution? And the answer is maybe. But in this case, I think evolution might actually have an edge. Like there is this, I remember reading about this case where that one thing that neuroscientists do, or rather one way in which neuroscientists can learn about the brain is by studying people with brain damage to different parts of the brain. And some people have the most strange symptoms you could imagine. It's actually really, really interesting. And there was one case that comes to mind that's relevant. I read about this person who had some kind of brain damage that took out, I think a stroke or an accident, that took out his emotional processing. So he stopped feeling any emotion. And as a result of that, he still remained very articulate and he could solve little puzzles, and on tests he seemed to be just fine. But he felt no emotion. He didn't feel sad. He didn't feel angry. He didn't feel animated. And he became somehow extremely bad at making any decisions at all. It would take him hours to decide on which socks to wear, and he would make very bad financial decisions. And that's very... What does it say about the role of our built-in emotions in making us like a viable agent, essentially? And I guess to connect to your question about pre-training, it's like maybe if you're good enough at like getting everything out of pre-training, you could get that as well. But that's the kind of thing which seems, well, it may or may not be possible to get that from pre-training.
What is that? Clearly not just directly emotion. It seems like some almost value function like thing, which is telling you which decision to be, like whether end reward for any decision should be. And you think that doesn't sort of implicitly come from?
I think it could. I'm just saying it's not 100% obvious.
Yeah. But what is that? Like, how do you think about emotions? What is the ML analogy for emotions?
It should be some kind of a value function thing.
Yeah.
But I don't think there's a great ML analogy because right now value functions don't play a very prominent role in the things people do.
It might be worth defining for the audience what a value function is if you want to do that.
I mean, certainly. I'll be very happy to do that. Right. So when people do reinforcement learning, the way reinforcement learning is done right now, how do people train those agents? So you have a neural net and you give it a problem. And then you tell the model to go solve it. The model takes maybe thousands, hundreds of thousands of actions or thoughts or something, and then it produces a solution. Solution is graded. And then the score is used to provide a training signal for every single action in your trajectory.
Mm-hmm.
So that means that if you're doing something that goes for a long time, if you're training a task that takes a long time to solve, you will do no learning at all until you come up with a proposed solution. That's how reinforcement learning is done naively. That's how O1, R1 ostensibly are done. The value function says something like, okay, look, maybe I could sometimes, not always, could tell you if you're doing well or badly. The notion of a value function is more useful in some domains than others. For example, when you play chess and you lose a piece, I messed up. You don't need to play the whole game to know that what I just did was bad, and therefore whatever preceded it was also bad. So the value function lets you short circuit the wait until the very end. Like let's suppose that you started to pursue some kind of let's suppose that you are doing some kind of a math thing or programming thing, and you're trying to explore a particular solution direction. And after 1,000 steps of thinking, you conclude that this direction is unpromising. As soon as you conclude this, you could already get a reward signal 1,000 time steps previously when you decided to pursue down this path. You say, oh, next time I shouldn't pursue this path in a similar situation, long before you actually came up with a proposed solution.
This was in the DeepSeek R1 paper, is that the space of trajectories is so wide that maybe it's hard to learn a mapping from an intermediate trajectory and value. And also given that, in coding, for example, you'll have the wrong idea, then you'll go back, then you'll change something.
This sounds like such lack of faith in deep learning.
Yeah.
Like, I mean, sure, it might be difficult, but nothing deep learning can do.
Yeah.
So my expectation is that like value functions should be useful, and I fully expect that they will be used in the future, if not already. What was I alluding to with the person whose emotional center got damaged is more that maybe what it suggests is that the value function of humans is modulated by emotions in some important way that's hard-coded by evolution. And maybe that is important for people to be effective in the world.
That's the thing I was actually planning on asking you. There's something really interesting about emotions of the value function, which is that it's impressive that they have this much utility while still being rather simple to understand.
So I have two responses. I do agree that compared to the kind of things that we learn and the things that you're talking about, the kind of guys you're talking about, emotions are relatively simple. They might even be so simple that maybe you could map them out in a human understandable way. I think it would be cool to do. In terms of utility, though, I think there is a thing where, there is this complexity robustness trade-off, where complex things can be very useful, but simple things are very useful in very broad range of situations. And so I think what one way to interpret what we're seeing is that we've got these emotions that essentially evolved mostly from our mammal ancestors, and then fine-tuned a little bit while we were hominids, just a bit. We do have like a decent amount of social emotions, though, which mammals may lack, but they're not very sophisticated. And because they're not sophisticated, they serve us so well in this very different world compared to the one that we've been living in. Actually, they also make mistakes. For example, our emotions, well, I don't know, does hunger count as an emotion? It's debatable, but I think, for example, our intuitive feeling of hunger is not succeeding in guiding us correctly in this world with an abundance of food.
Yeah. People have been talking about scaling data, scaling parameters, scaling compute. Is there a more general way to think about scaling? What are the other scaling axes?
So here's a perspective. Here's a perspective I think might be true. So the way ML used to work is that people would just tinker with stuff and try to get interesting results. That's what's been going on in the past. Then the scaling insight arrived, right? Scaling laws, GPT-3. And suddenly everyone realized we should scale. And it's just this is an example of how language affects thought. Scaling is just one word, but it's such a powerful word because it informs people what to do. They say, okay, let's try to scale things. And so you say, okay, so what are we scaling? And pre-training was a thing to scale. It was a particular scaling recipe.
Yes.
The big breakthrough of pre-training is the realization that this recipe is good. So you say, hey, if you mix some compute with some data into a neural net of a certain size, you will get results, and you will know that it will be better if you just scale the recipe up. And this is also great. Companies love this because it gives you a very low-risk way of investing your resources, right? It's much harder to invest your resources in research. Compare that. If you're a researcher, you need to have go force researchers and research and come up with something versus get more data, get more compute, you'll get something from pre-training. And indeed, it looks like based on various things some people say on Twitter, maybe it appears that Gemini have found a way to get more out of pre-training. At some point, though, pre-training will run out of data. The data is very clearly finite. And so then, okay, what do you do next? Either you do some kind of a souped-up pre-training, different recipe from the one you've done before, or you're doing RL, or maybe something else. But now that compute is big. Compute is not very big. In some sense, we are back to the age of research. So maybe here's another way to put it. Up until 2020, from 2012 to 2020, it was the age of research.
Now, from 2020 to 2025, it was the age of scaling, or maybe plus minus, let's say, every those years, because people say this is amazing, you guys scale more, keep scaling, the one word, scaling. But now the scale is so big, like, is the belief really that, oh, it's so big, but if you had 100x more, everything would be so different? Like, it would be different for sure. But like, is the belief that if you just 100x the scale, everything would be transformed? I don't think it's true. So it's back to the stage of research again, just to be computers. That's a very interesting way to put it. But let me ask you the question you just posed then. What are we scaling, and what would it mean to have a recipe? Because I guess I'm not aware of a very clean relationship that almost looks like a law of physics, which existed in pre-training as a power law between data or computer parameters and loss. What is the kind of relationship we should be seeking, and how should we think about what this new recipe might look like?
So we've already witnessed a transition from one type of scaling to a different type of scaling, from pre-training to RL. Now people are scaling RL. Now, based on what people say on Twitter, they spend more compute on RL than on pre-training at this point, because RL can actually consume quite a bit of compute.
Yeah.
You know, you do very, very long rollouts.
Yes.
So it takes a lot of compute to produce those rollouts. And then you get relatively small amount of learning per rollout. So you really can spend a lot of compute. And I could imagine, like, I wouldn't at this it's more like, I wouldn't even call it a scaling. I would say, hey, like, what are you doing? And is the thing you are doing the most productive thing you could be doing?
Yes.
Can you find a more productive way of using your compute? We've discussed the value function business earlier. And maybe once people get good at value functions, they will be using their resources more productively. And if you find a whole other way of training models, you could say, is this scaling or is it just using your resources? I think it becomes a little bit ambiguous. In the sense that when people were in the age of research, back then it was like people say, hey, let's try this and this and this, let's try that and that. Oh, look, something interesting is happening. And I think there will be a return to that.
So if we're back in the era of research, stepping back, what is the part of the recipe that we need to think most about? When you say value function, people are already trying the current recipe, but then having LLM as a judge and so forth. You can say that's a value function, but it sounds like you have something much more fundamental in mind. Do we need to go back to, should we even rethink pre-training at all and not just add more steps to the end of that process?
Yeah. So the discussion about value function, I think it was interesting. I want to emphasize that I think the value function is something like, it's going to make RL more efficient. And I think that makes a difference. But I think that anything you can do with a value function, you can do without, just more slowly.
Mm-hmm.
The thing which I think is the most fundamental is that these models somehow just generalize dramatically worse than people.
Yes.
And it's super obvious. That seems like a very fundamental thing.
Okay, so this is the crux, generalization. And there's two sub-questions. There's one which is about sample efficiency, which is why should it take so much more data for these models to learn than humans? There's a second about, even separate from the amount of data it takes, there's a question of why is it so hard to teach the thing we want to a model than to a human, which is to say, to a human, we don't necessarily need a verifiable reward to be able to, you're probably mentoring a bunch of researchers right now and you're talking with them, you're showing them your code and you're showing them how you think, and from that, they're picking up your way of thinking and how they should do research. You don't have to set like a verifiable reward for them that's like, okay, this is the next part of the curriculum, and now this is the next part of the curriculum, and oh, this training was unstable, and there's not this schleppy bespoke process. So perhaps these two issues are actually related in some way, but I'd be curious to explore this second thing, which feels like continual learning, and this first thing, which feels just like sample efficiency.
Yeah. So, you could actually wonder, one possible explanation for the human sample efficiency that needs to be considered is evolution. And evolution has given us a small amount of the most useful information possible. And for things like vision, hearing, and locomotion, I think there's a pretty strong case that evolution actually has given us a lot.
Mm-hmm.
So, for example, human dexterity far exceeds, robots can become dexterous too if you subject them to like a huge amount of training and simulation. But to train a robot in the real world to quickly like pick up a new skill like a person does seems very out of reach.
Yeah.
And here you could say, oh yeah, like locomotion, all our ancestors needed great locomotion, squirrels, like, so locomotion maybe like you've got like some unbelievable prior.
Yeah.
You could make the same case for vision. I believe Jan Khan made the point, children learn to drive after 16 hours, after 10 hours of practice, which is true. But our vision is so good. At least for me, I remember myself being 5-year-old, I was very excited about cars back then. And I'm pretty sure my car recognition was more than adequate for self-driving already as a 5-year-old. You don't get to see that much data as a 5-year-old. You spend most of your time in your parents' house. So you have very low data diversity.
Yeah.
But you could say maybe that's evolution too. But in language and math and coding, probably not.
It still seems better than models. Obviously models are better than the average human at language and math and coding, but are they better at the average human at learning?
Oh yeah, absolutely. What I meant to say is that language, math, and coding, and especially math and coding, suggests that whatever it is that makes people good at learning is probably not so much a complicated prior, but something more, some fundamental thing.
Wait, I'm not sure. Why should that be the case?
So consider a skill that people exhibit some kind of great reliability or,
yeah.
If the skill is one that was very useful to our ancestors for many millions of years, hundreds of millions of years, you could argue that maybe humans are good at it because of evolution, because we have a prior, an evolutionary prior that's encoded in some very non-obvious way that somehow makes us so good at it. But if people exhibit great ability, reliability, robustness, ability to learn in a domain that really did not exist until recently, then this is more an indication that people might have just better machine learning, period.
Mm-hmm. But then how should we think about what that is? Is it a matter of, what is the ML analogy for what? There's a couple interesting things about it. It takes fewer samples. It's more unsupervised. You don't have to set like a child learning to drive a car. A teenager learning to drive a car is like not exactly getting some pre-built verifiable reward. It comes from their interaction with the machine and with the environment. And yeah, it takes much fewer samples. It seems more unsupervised. It seems more robust.
Much more robust. The robustness of people is really staggering.
Yeah. So it's like, okay, and do you have a unified way of thinking about why are all these things happening at once? What is the ML analogy that could realize something like this?
So this is where one of the things that you've been asking about is how can the teenage driver kind of self-correct and learn from their experience without an external teacher? And the answer is, well, they have their value function, right? They have a general sense, which is also, by the way, extremely robust in people. Like whatever it is, the human value function, whatever the human value function is, with a few exceptions around addiction, it's actually very, very robust. And so for something like a teenager that's learning to drive, they start to drive and they already have a sense of how they're driving immediately. how badly they are confident, and then they see, okay, and then of course the learning speed of any teenager is so fast. After 10 hours, you're good to go.
Yeah, this seems like humans have some solution. But I'm curious about like, well, how are they doing it, and like, why is it so hard to like, how do we need to reconceptualize the way we're training models to make something like this possible?
You know, that is a great question to ask, and it's a question I have a lot of opinions about. But unfortunately, we live in a world where not all machine learning ideas are discussed freely, and this is one of them. So there's probably a way to do it. I think it can be done. The fact that people are like that, I think it's a proof that it can be done. There may be another blocker though, which is there is a possibility that the human neurons actually do more compute than we think. And if that is true, and if that plays an important role, then things might be more difficult. But regardless, I do think it points to the existence of some machine learning principle that I have opinions on, but unfortunately, circumstances make it hard to discuss in detail.
Nobody listens to this podcast, Ilya.
Yeah.
So I have to say that prepping for Ilya was pretty tough because neither I nor anybody else had any idea what he's working on and what SSI is trying to do. I had no basis to come up with my questions, and the only thing I could go off, honestly, was trying to think from first principles about what are the bottlenecks to AGI, because clearly Ilya is working on them in some way. Part of this question involved thinking about RL scaling, because everybody's asking how well RL will generalize and how we can make it generalize better. As part of this, I was reading this paper that came out recently on RL scaling, and it showed that actually the learning curve on RL looks like a sigmoid. I found this very curious. Why should it be a sigmoid, where it learns very little for a long time, and then it quickly learns a lot, and then it asymptotes? This is very different from the power law you see in pre-training, where the model learns a bunch at the very beginning and then less over time. And it actually reminded me of a note that I'd written down after I had a conversation with a researcher friend, where he pointed out that the number of samples that you need to take in order to find the correct answer scales exponentially with how different your current probability distribution is from the target probability distribution. And I was thinking about how these two ideas are related. I had this vague idea that they should be connected, but I really didn't know how. I don't have a math background, so I couldn't really formalize it. But I wondered if Gemini 3 could help me out here. And so I took a picture of my notebook, and I took a paper, and I put them both in the context of Gemini 3, and I asked it to find the connection. And I thought a bunch, and then I realized that the correct way to model the information you gain from a single yes or no outcome in RL is as the entropy of a random binary variable. It made a graph which showed how the bits you gain per sample in RL versus supervised learning scale as the pass rate increases. And as soon as I saw the graph that Gemini 3 made, immediately a ton of things started making sense to me. Then I wanted to see if there was any empirical basis to this theory. So I asked Gemini to code an experiment to show whether the improvement in loss scales in this way with pass rate. I just took the code that Gemini outputted, I copy pasted it into a Google Colab notebook, and I was able to run this toy ML experiment and visualize its results without a single bug. It's interesting because the results look similar but not identical to what we should have expected. And so I downloaded this chart and I put it into Gemini and asked it, what is going on here? It came up with a hypothesis that I think is actually correct, which is that we're capping how much supervised learning can improve in the beginning by having a fixed learning rate. And in fact, we should decrease the learning rate over time. It actually gives us an intuitive understanding for why in practice we have learning rate schedulers that decrease the learning rate over time. I did this entire flow from coming up with this vague initial question to building a theoretical understanding to running some toy ML experiments, all with Gemini 3. This feels like the first model where it can actually come up with new connections that I wouldn't have anticipated. It's actually now become the default place I go to when I want to brainstorm new ways to think about a problem. If you want to read more about RL scaling, you can check out the blog post that I wrote with a little help from Gemini 3. And if you want to check out Gemini 3 yourself, go to gemini.google. I'm curious, if you say we are back in the era of research, you were there from 2012 to 2020. And yeah, what is now the vibe going to be if we go back in the era of research? For example, even after AlexNet, the amount of compute that was used to run experiments kept increasing, and the size of frontier systems kept increasing. And do you think now that this era of research will still require tremendous amounts of compute? Do you think it will require going back in the archives and reading old papers? What was the vibe of like you were Google and OpenAI and Stanford, all these places when there was like more of a vibe of research? What kind of things should we be expecting in the community?
So one consequence of the age of scaling is that there was this scaling sucked out all the air in the room.
Yeah.
And so because scaling sucked out all the air in the room, everyone started to do the same thing. We got to the point where we are in a world where there are more companies than ideas by quite a bit. Actually, on that, there is this Silicon Valley saying that says that ideas are cheap, execution is everything. And people say that a lot.
Yeah.
And there is truth to that. But then I saw someone say on Twitter something like, if ideas are so cheap, how come no one's having any ideas? And I think it's true too. I think, like, if you think about research progress in terms of bottlenecks, there are several bottlenecks. If you go back to one of them is ideas, and one of them is your ability to bring them to life, which might be compute, but also engineering. So if you go back to the 90s, let's say, you had people who had pretty good ideas. And if they had much larger computers, maybe they could demonstrate that their ideas were viable, but they could not. So they could only have very, very small demonstration that did not convince anyone.
Yeah.
So the bottleneck was compute. Then in the age of scaling, compute has increased a lot. And of course, there is a question of how much compute is needed, but compute is large. So compute is large enough such that it's like not obvious that you need that much more compute to prove some idea. Like, I'll give you an analogy. AlexNet was built on 2 GPUs. That was the total amount of compute used for it. The transformer was built on 8 to 64 GPUs. No single transformer paper experiment used more than 64 GPUs of 2017, which would be like what, 2 GPUs of today? So the ResNet, right? Many, like even the you could argue that the like O1 reasoning was not the most compute heavy thing in the world. So there definitely, for research, you need like definitely some amount of compute, but it's far from obvious that you need the absolutely largest amount of compute ever for research. You might argue, and I think it is true, that if you want to build the absolutely best system, then it helps to have much more compute. And especially if everyone is within the same paradigm, then compute becomes one of the big differentiators.
Yeah, I guess, well, it was possible to develop these ideas. I'm asking you for the history because you were actually there. I'm not sure what actually happened, but it sounds like it was possible to develop these ideas using minimal amounts of compute. But it wasn't, the transformer didn't immediately become famous. It became the thing everybody started doing and then started experimenting on top of and building on top of because it was validated at higher and higher levels of compute.
Correct.
And if you at SSI have 50 different ideas, how will you know which one is the next transformer and which one is, brittle without having the kinds of compute that other frontier labs have?
So I can comment on that, which is, the short comment is that, you mentioned SSI. Specifically for us, the amount of compute that SSI has for research is really not that small. And I want to explain why. Like a simple math can explain why the amount of compute that we have is actually a lot more comparable for research than one might think. Now I'll explain. So SSI has raised $3 billion, which is like not small, but it's like a lot by any absolute sense. But you could say, but look at the other companies raising much more. But a lot of their compute goes for inference. Like these big numbers, these big loans, it's earmarked for inference. That's number one. Number two, if you want to have a product on which you do inference, you need to have a big staff of engineers, of salespeople. A lot of the research needs to be dedicated for producing all kinds of product-related features. So then when you look at what's actually left for research, the difference becomes a lot smaller. Now, the other thing is that if you're doing something different, do you really need the absolute maximal scale to prove it? I don't think it's true at all. I think that in our case, we have sufficient compute to convince ourselves and anyone else that what we're doing is correct.
There's been public estimates that companies like OpenAI spend on the order of $5-6 billion a year, even just so far, on experiments.
Mm-hmm.
This is separate from the amount of money they're spending on inference and so forth. So it seems like they're spending more a year running research experiments than you guys have in total funding.
I think it's a question of what you do with it. It's a question of what you do with it. Like they have, the more, I think in their case, in the case of others, I think there's a lot more demand on the training compute. There's a lot more different work streams. There are different modalities. There is just more stuff. And so it becomes fragmented.
How will SSI make money?
My answer to this question is something like, right now we just focus on the research, and then the answer to this question will reveal itself. I think there will be lots of possible answers.
Is SSI's plan still to straight shot superintelligence?
Maybe. I think that there is merit to it. I think there's a lot of merit because I think that it's very nice to not be affected by the day-to-day market competition. But I think there are two reasons that may cause us to change the plan. One is pragmatic, if timelines turn out to be long, which they might. And second, I think there is a lot of value in the best and most powerful AI being out there impacting the world.
Yeah.
I think this is a meaningfully valuable thing.
But then, so why is your default plan to straight shot superintelligence? Because it sounds like, OpenAI, Anthropic, all these other companies, their explicit thinking is, look, we have weaker and weaker intelligences that the public can get used to and prepare for. And why is it potentially better to build a superintelligence directly?
So I'll make the case for and against.
Yeah.
The case for is that so one of the challenges that people face when they're in the market is that they have to participate in the rat race. And the rat race is quite difficult in that it exposes you to difficult trade-offs which you need to make. And it is nice to say, we'll insulate ourselves from all this and just focus on the research and come out only when we are ready and not before. But the counterpoint is valid too. And those are opposing forces. The counterpoint is, hey, it is useful for the world to see powerful AI. It is useful for the world to see powerful AI because that's the only way you can communicate it.
Well, I guess not even just that you can communicate the idea, but
communicate the AI, not the idea. Communicate the AI.
What do you mean communicate the AI?
So let's suppose you read an essay about AI.
Yeah.
And the essay says AI is going to be this, and AI is going to be that, and it's going to be this.
Yeah.
And you read it and you say, okay, this is an interesting essay.
Right.
Now suppose you see an AI doing this, an AI doing that. It is incomparable. Like basically, I think that there is a big benefit from AI being in the public. And that would be a reason for us to not be quite straight shot.
Yeah. Well, I guess it's not even that, but I do think that is an important part of it. The other big thing is, I can't think of another discipline in human engineering and research where the end artifact was made safer mostly through just thinking about how to make it safe, as opposed to why are airplane crashes per mile so much lower today than they were decades ago? Why is it so much harder to find a bug in Linux than it would have been decades ago? And I think it's mostly because these systems were deployed to the world, you noticed failures, those failures were corrected, and the systems became more robust. And I'm not sure why AGI and superhuman intelligence would be any different, especially given, and I hope we're going to get to this, it seems like the harms of superintelligence are not just about like having some malevolent paperclipper out there, but it's just like, this is a really powerful thing and we don't even know how to conceptualize how people interact with it, what people will do with it. And having gradual access to it seems like a better way to maybe spread out the impact of it and to help people prepare for it.
Well, I think on this point, even in the straight shot scenario, you would still do a gradual release of it, is how I would imagine it. The gradualism would be an inherent component of any plan. It's just a question of what is the first thing that you get out of the door. That's number one. Number two, I also think, I believe you have advocated for continual learning more than other people.
Yeah.
And I actually think that this is an important and correct thing. And here is why. So one of the things, I'll give you another example of how language affects thinking. And in this case, this will be two words, two words that have shaped everyone's thinking, I maintain. First word, AGI. Second word, pre-training. Let me explain. So the term AGI, why does this term exist? It's a very particular term. Why does it exist? There's a reason. The reason that the term AGI exists is, in my opinion, not so much because it's like a very important, essential descriptor of some end state of intelligence, but because it is a reaction to a different term that existed, and the term is narrow AI. If you go back to ancient history of game playing AI, of checkers AI, chess AI, computer games AI, everyone would say, look at this narrow intelligence. Sure, the chess AI can beat Kasparov, but it can't do anything else. It is so narrow, artificial narrow intelligence. So in response, as a reaction to this, some people said, well, this is not good. It is so narrow. What we need is general AI. General AI, an AI that can just do all the things. The second, and that term just got a lot of traction.
Yeah.
The second thing that got a lot of traction is pre-training. Specifically, the recipe of pre-training. I think the way people do RL now is maybe is undoing the conceptual imprint of pre-training. But pre-training had the property. You do more pre-training, and the model gets better at everything, more or less uniformly.
Yeah.
General AI. Pre-training gives AGI. But the thing that happened with AGI and pre-training is that in some sense they overshot the target. Because if you think about the term AGI, you will realize, and especially in the context of pre-training, you will realize that a human being is not an AGI. Because a human being, yes, there is definitely a foundation of skills. A human being lacks a huge amount of knowledge. Instead, we rely on continual learning. And so then when you think about, okay, so let's suppose that we achieve success and we produce some kind of safe superintelligence. The question is, but how do you define it? Where on the curve of continual learning is it going to be? I produce like a super intelligent 15-year-old that's very eager to go, and you say, okay, they don't know very much at all. The great student, very eager. You go and be a programmer. You go and be a doctor. Go and learn. So you could imagine that the deployment itself will involve some kind of a learning trial and error period. It's a process, as opposed to you drop the finished thing.
Okay, I see. So you're suggesting that the thing you're pointing out with superintelligence is not some finished mind which knows how to do every single job in the economy. Because the way, say, the original, I think, OpenAI charter or whatever defines AGI is like, it can do every single job, every single thing a human can do. You're proposing instead a mind which can learn to do every single job.
Yes.
And that is superintelligence. And then, but once you have the learning algorithm, it gets deployed into the world the same way a human laborer might join an organization.
Exactly.
And it seems like one of these two things might happen. Maybe neither of these happens. One, this super efficient learning algorithm becomes superhuman, becomes as good as you, and potentially even better at the task of ML research. And as a result, the algorithm itself becomes more and more superhuman. The other is, even if that doesn't happen, if you have a single model, I mean, this is explicitly your vision. If you have a single model or instances of a model which are deployed through the economy, doing different jobs, learning how to do those jobs, continually learning on the job, picking up all the skills that any human can pick up, but actually picking them all up at the same time and then amalgamating the learnings, you basically have a model which functionally becomes super intelligent, even without any sort of recursive self-improvement in software, right? Because you now have one model that can do every single job in the economy, and humans can't merge our minds in the same way. And so do you expect some sort of like intelligence explosion from broad deployment?
I think that it is likely that we will have rapid economic growth. I think the broad deployment, there are two arguments you could make, which are conflicting. One is that, look, once indeed you get to a point where you have an AI that can learn to do things quickly, and you have many of them, then there will be a strong force to deploy them in the economy, unless there will be some kind of a regulation that stops it, which, by the way, there might be. But I think the idea of very rapid economic growth for some time, I think it's very possible from broad deployment. Then the question is how rapid it's going to be. So I think this is hard to know, because on the one hand, you have this very efficient worker. On the other hand, the world is just really big, and there's a lot of stuff, and that stuff moves at a different speed. But then on the other hand, now the AI could
exactly.
So I think very rapid economic growth is possible. And we will see like all kinds of things, like different countries with different rules, and the ones which have the friendlier rules, the economic growth will be faster. Hard to predict.
Some people in our audience like to read the transcripts instead of listening to the episode. And so we put a ton of effort into making the transcripts read like they are standalone essays. The problem is that if you just transcribe a conversation verbatim using a speech-to-text model, it'll be full of all kinds of fits and starts and confusing phrasing. We mentioned this problem to Labelbox, and they asked if they could take a stab. Working with them on this is probably the reason that I'm most excited to recommend Labelbox to people. It wasn't just, oh, hey, tell us what kind of data you need and we'll go get it. They walked us through the entire process, from helping us identify what kind of data we needed in the first place, to assembling a team of expert aligners to generate it. Even after we got all the data back, Labelbox stayed involved. They helped us choose the right base model and set up auto QA on the model's output so that we could tweak and refine it. And now we have a new transcriber tool that we can use for all our episodes moving forward. This is just one example of how Labelbox meets their customers at the ideas level and partners with them through their entire journey. If you want to learn more, or if you want to try out the transcriber tool yourself, go to labelbox.com/dwarkesh. It seems to me that this is a very precarious situation to be in, where, look, in the limit, we know that this should be possible because if you have something that is as good as a human at learning, but which can merge its brains, there are different instances in a way that humans can't merge. Already, this seems like a thing that should physically be possible. Humans are possible. Digital computers are possible. You just need both of those combined to produce this thing. And it also seems like this kind of thing is extremely powerful, and economic growth is one way to put it. I mean, Dyson Sphere is a lot of economic growth, but another way to put it is just like, you will have potentially a very short period of time, because a human on the job can, you're hiring people at SSI in 6 months, they're like net productive probably, right? A human like learns really fast, and so this thing is becoming smarter and smarter very fast. How do you think about making that go well? And why is SSI positioned to do that well? Where does SSI stand there, basically, is what I'm trying to ask.
Yeah. So one of the ways in which my thinking has been changing is that I now place more importance on AI being deployed incrementally and in advance. One very difficult thing about AI is that we are talking about systems that don't yet exist, and it's hard to imagine them. I think that one of the things that's happening is that in practice, it's very hard to feel the AGI. It's very hard to feel the AGI. We can talk about it, but it's like talking about like the long future. Like imagine like having a conversation about like how is it like to be old when you're like old and frail, and you can have a conversation, you can try to imagine it, but it's just hard, and you come back to reality where that's not the case. And I think that a lot of the issues around AGI and its future power stem from the fact that it's very difficult to imagine. Future AI is going to be different. It's going to be powerful. Indeed, the whole problem, what is the problem of AI and AGI? The whole problem is the power. The whole problem is the power. When the power is really big, what's going to happen? And one of the ways in which I've changed my mind over the past year, and so that change of mind I'll hedge a little bit, may back propagate into the plans of our company, is that, so if it's hard to imagine, what do? You got to be showing the thing. You got to be showing the thing. And I maintain that I think most people who work on AI also can't imagine it, because it's too different from what people see on a day-to-day basis. I do maintain, here's something which I predict will happen. That's a prediction. I maintain that as AI becomes more powerful, then people will change their behaviors. And we will see all kinds of unprecedented things which are not happening right now. And I'll give some examples. I think for better or worse, the frontier companies will play a very important role in what happens, as will the government. And the kind of things that I think we'll see, which you see the beginnings of, companies that are fierce competitors starting to collaborate on AI safety. You may have seen OpenAI and Anthropic doing a first small step, but that did not exist. That's actually something which I predicted in one of my talks about 3 years ago, that such a thing will happen. I also maintain that as AI continues to become more powerful, more visibly powerful, there will also be a desire from governments and the public to do something. And I think that this is a very important force of showing the AI. That's number one. Number two, okay, so then the AI is being built. What needs to be done? So one thing that I maintain that will happen is that right now, people who are working on AI, I maintain that the AI doesn't feel powerful because of its mistakes. I do think that at some point the AI will start to feel powerful, actually. And I think when that happens, we will see a big change in the way all AI companies approach safety. They'll become much more paranoid. I think I say this as a prediction that we will see happen. We'll see if I'm right. But I think this is something that will happen because they will see the AI becoming more powerful. Everything that's happening right now, I maintain, is because people look at today's AI and it's hard to imagine the future AI. And there is a third thing which needs to happen. And I think and I'm talking about it in broader terms, not just from the perspective of SSI, because you asked me about our company. But the question is, okay, so then what should the companies aspire to build? Yeah. What should they aspire to build? And there has been one big idea that actually everyone has been locked into, which is the self-improving AI. And why did it happen? Because there is fewer ideas than companies. But I maintain that there is something that's better to build. And I think that everyone will actually want that. It's like the AI that's robustly aligned to care about sentient life specifically. I think in particular, there's a case to be made that it will be easier to build an AI that cares about sentient life than an AI that cares about human life alone, because the AI itself will be sentient. And if you think about things like mirror neurons and human empathy for animals, which is, you might argue it's not big enough, but it exists. I think it's an emergent property from the fact that we model others with the same circuit that we use to model ourselves, because that's the most efficient thing to do.
So even if you got an AI to care about sentient beings, and it's not actually clear to me that that's what you should try to do if you solve alignment, it would still be the case that most sentient beings will be AIs. There will be trillions, eventually quadrillions of AIs. Humans will be a very small fraction of sentient beings. So it's not clear to me if the goal is some kind of human control over this future civilization, that this is the best criterion.
It's true. I think that it's possible it's not the best criterion. I'll say two things. I think that thing number one, I think that if there is, so I think that care for sentient life, I think there is merit to it. I think it should be considered. I think that it will be helpful if there was some kind of a short list of ideas that then the companies, when they are in the situation, could use. That's number two. Number three, I think it would be really materially helpful if the power of the most powerful superintelligence was somehow capped, because it would address a lot of these concerns. The question of how to do it, I'm not sure, but I think that would be materially helpful when you're talking about really, really powerful systems.
Yeah. Before we continue the alignment discussion, I want to double click on that. How much room is there at the top? How do you think about superintelligence? Do you think, I mean, using this learning efficiency idea, maybe it's just extremely fast at learning new skills or new knowledge? And does it just have a bigger pool of strategies? Is there a single cohesive it in the center that's more powerful or bigger? And if so, do you imagine that this will be sort of godlike in comparison to the rest of human civilization, or does it just feel like another agent or another cluster of agents?
So this is an area where different people have different intuitions. Yeah. I think it will be very powerful for sure. I think that what I think is most likely to happen is that there will be multiple such AIs being created roughly at the same time. I think that if the cluster is big enough, like if the cluster is literally continent-sized, that thing could be really powerful indeed. Right? If you literally have a continent-sized cluster, like those AIs can be very powerful. And all I can tell you is that if you're talking about extremely powerful AIs, like truly dramatically powerful, then yeah, it would be nice if they could be restrained in some ways, or if there was some kind of an agreement or something. Because I think that if you're saying, hey, like if you really, like what is the concern of superintelligence? What is one way to explain the concern? If you imagine a system that is sufficiently powerful, like really sufficiently powerful, and you could say, okay, you need to do something sensible, like care for sentient life, let's say, in a very single-minded way, we might not like the results. That's really what it is. And so maybe, by the way, the answer is that you do not build an RL agent in the usual sense. And actually, I'll point several things out. I think human beings are a semi-RL agent. You know, we pursue a reward, and then the emotions or whatever make us tire out of the reward. We pursue a different reward. The market is it's like a very short-sighted kind of agent. Evolution is the same. Evolution is very intelligent in some ways, but very dumb in other ways. The government has been designed to be a never-ending fight between three parts, which has an effect. So I think things like this. Another thing that makes this discussion difficult is that we are talking about systems that don't exist, that we don't know how to build. Right? That's the other thing. And that's actually my belief. I think what people are doing right now will go some distance and then peter out. It will continue to improve, but it will also not be it. So we don't know how to build. And I think that a lot hinges on understanding reliable generalization. And I'll say another thing, which is like, you know, one of the things that you could say is that cause alignment to be difficult is that human value, that it's your ability to learn human values is fragile, then your ability to optimize them is fragile, you actually learn to optimize them. And then can't you say, are these not all instances of unreliable generalization? Why is it that human beings appear to generalize so much better? What if generalization was much better? What would happen in this case? What would be the effect? But those we can't, like those questions are right now still unanswerable.
How does one think about what AI going well looks like? Because I think you've scoped out how AI might evolve. We'll have these sort of continual learning agents. AI will be very powerful. Maybe there will be many different AIs. How do you think about lots of continent compute size intelligences going around? How dangerous is that? How do we make that less dangerous? And how do we do that in a way that protects an equilibrium where there might be misaligned AIs out there and bad actors out there?
So one reason why I like the AI that cares for sentient life, you know, and we can debate on whether it's good or bad, but if the first N of these dramatic systems actually do care for, you know, love humanity or something, you know, care for sentient life, obviously this also needs to be achieved. This needs to be achieved. So if this is achieved by the first N of those systems, then I can see it go well, at least for quite some time. And then there is the question of what happens in the long run. Yeah. What happens in the long run? How do you achieve a long run equilibrium? And I think that there is an answer as well. And I don't like this answer, but it needs to be considered. In the long run, you might say, okay, so if you have a world where powerful AIs exist, in the short run, you could say, okay, you have universal high income. You have universal high income. And we're all doing well. But we know that, what do the Buddhists say? Change is the only constant. And so things change. And there is some kind of government, political structure thing, and it changes. Because these things have a shelf life. You know, some new government thing comes up and it functions, and then after some time, it stops functioning. That's something that you see happening all the time. And so I think that for the long run equilibrium, one approach, you could say, okay, so maybe every person will have an AI that will do their bidding. And that's good. And if that could be maintained indefinitely, that's true. But the downside with that is, okay, so then the AI goes and like earns money for the person and advocates for their needs in like the political sphere, and maybe then writes a little report saying, okay, here's what I've done, here's the situation, and the person says, great, keep it up. But the person is no longer a participant. And then you can say that's a precarious place to be in. But, so I'm going to preface by saying, I don't like this solution, but it is a solution. And the solution is if people become part AI with some kind of Neuralink ++. Because what will happen as a result is that now the AI understands something, and we understand it too. Because now the understanding is transmitted wholesale. So now if the AI is in some situation, now it's like you are involved in the situation yourself fully. And I think this is the answer to the equilibrium.
I wonder if the fact that emotions, which were developed millions, or in many cases billions of years ago in a totally different environment, are still guiding our actions so strongly, is an example of alignment success. To maybe spell out what I mean, the brainstem has these, I don't know if it's more accurate to call it a value function or a reward function, but the brainstem has a directive where it's saying mate with somebody who's more successful. The cortex is the part that understands what does success mean in the modern context. But the brainstem is able to align the cortex and say, however you recognize success to be, and I'm not smart enough to understand what that is, you're still going to pursue this directive.
I think there's a more general point. I think it's actually really mysterious how the brain encodes high-level desires. Sorry, how evolution encodes high-level desires. Like, it's pretty easy to understand how evolution would endow us with the desire for food that smells good. Because smell is a chemical, and so just pursue that chemical. It's very easy to imagine such evolution doing such a thing. But evolution also has endowed us with all these social desires. Like, we really care about being seen positively by society. We care about being in a good standing. Like, all these social intuitions that we have, I feel strongly that they're baked in. And I don't know how evolution did it. Because it's a high-level concept that's represented in the brain. Like, what people think, like, let's say you care about some social thing. It's not like a low-level signal like smell. It's not something for which there's a sensor. Like, the brain needs to do a lot of processing to piece together lots of bits of information to understand what's going on socially. And somehow evolution said, that's what you should care about.
Yes.
How did it do it? And it did it quickly too.
Yeah.
Because I think all these sophisticated social things that we care about, I think they evolved pretty recently.
Yeah.
So evolution had an easy time hard-coding this high-level desire. And I maintain, or at least I'll say, I'm unaware of good hypothesis for how it's done. I had some ideas I was kicking around, but none of them are satisfying.
Yeah, and what's especially impressive is if it was a desire that you learned in your lifetime, it kind of makes sense because your brain is intelligent. It makes sense why we would learn intelligent desires. But your point is that the desire is, maybe this is not your point, but one way to understand it is, the desire is built into the genome, and the genome is not intelligent, right? But it's you're somehow able to describe this feature that requires, like, it's not even clear how you define that feature, and you can get it into you can build it into the genes.
Yeah, essentially. Or maybe I'll put it differently. If you think about the tools that are available to the genome, it says, okay, here's a recipe for building a brain. And you could say, here's a recipe for connecting the dopamine neurons to, like, the smell sensor.
Yeah.
And if the smell is a certain kind of, good smell, you want to eat that. I could imagine the genome doing that. I'm claiming that it is harder to imagine. It's harder to imagine the genome saying, you should care about some complicated computation that your entire brain, that like a big chunk of your brain does. That's all I'm claiming. I can tell you, like, a speculation. I was wondering how it could be done. And let me offer a speculation, and I'll explain why the speculation is probably false. So the speculation is, okay, so the brain, it's like, the brain has those regions. You know the brain regions. We have our cortex, right?
Yep.
It has all those brain regions. And the cortex is uniform, but the brain regions, and the neurons in the cortex, they kind of speak to their neighbors mostly. And that explains why the brain regions. Because if you want to do some kind of speech processing, all the neurons that do speech need to talk to each other. And because neurons can only speak to their nearby neighbors, for the most part, it has to be a region. All the regions are mostly located in the same place from person to person. So maybe evolution hard-coded literally a location on the brain. So it says, oh, like when like, the GPS of the brain, GPS coordinate such and such, when that fires, that's what you care about. Like, maybe that's what evolution did, because that would be within the toolkit of evolution.
Yeah, although there are examples where, for example, people who are born blind have that area of their cortex adopted by another sense. And I have no idea, but I'd be surprised if the desires or the reward functions which require visual signal no longer worked. People who have their different areas of their cortex co-opted. For example, if you no longer have vision, can you still feel the sense that I want people around me to like me and so forth, which usually there's also visual cues for.
So I actually fully agree with that. I think there's an even stronger counter-argument to this theory, which is, like, if you think about people, so there are people who get half of their brains removed in childhood.
Yeah.
And they still have all their brain regions, but they all somehow move to just one hemisphere, which suggests that the brain regions, the location is not fixed. Yeah. And so that theory is not true. It would have been cool if it was true, but it's not. And so I think that's a mystery, but it's an interesting mystery. Like, the fact is, somehow evolution was able to endow us to care about social stuff very, very reliably. And even people who have, like, all kinds of strange mental conditions and deficiencies and emotional problems tend to care about this also.
AI tools like deepfakes, voice clones, and agents have dramatically increased the sophistication of fraud and abuse. So it's more important than ever to actually understand the identity and intent of whoever or whatever is using your platform. That's exactly what Sardine helps you do. Sardine brings together thousands of device behavior and identity signals to help you assess risk. Everything from how a user types or moves their mouse or holds their device, to whether they're hiding their true location behind VPN, to whether they're injecting a fake camera feed during KYC selfie checks. Sardine combines these signals with insights from their network of almost 4 billion devices, things like a user's history of fraud or their associations with other high-risk accounts, so you can spot bad actors before they do damage. This would literally be impossible if you only use data from your own application. Sardine doesn't stop at detection. They offer a suite of agents to streamline onboarding checks and automate investigations. So as fraudsters use AI to scale their attacks, you can use AI to scale your defenses. Go to sardine.ai/Torkesh to learn more and download their guide on AI fraud detection. What is SSI planning on doing differently? So presumably your plan is to be one of the frontier companies when this time arrives. And then presumably you started SSI because you're like, I think I have a way of approaching how to do this safely in a way that the other companies don't. What is that difference?
So the way I would describe it as, there are some ideas that I think are promising, and I want to investigate them and see if they are indeed promising or not. It's really that simple. It's an attempt. I think that if the ideas turn out to be correct, these ideas that we discussed around understanding generalization, if these ideas turn out to be correct, then I think we'll have something worthy. Will it turn out to be correct? We are doing research. We are squarely age of research company. We're making progress. We've actually made quite good progress over the past year, but we need to be making more progress, more research. And that's how I see it. I see it as an attempt to be a voice and a participant.
People have asked, your co-founder and previous CEO left to go to Meta recently, and people have asked, well, if there was a lot of breakthroughs being made, that seems like a thing that should have been unlikely. I wonder how you respond.
Yeah, so for this, I will simply remind a few facts that may have been forgotten. And I think these facts which provide the context, I think they explain the situation. So the context was that we were fundraising at a $32 billion valuation, and then Meta came in and offered to acquire us. And I said no, but my former co-founder, like in some sense, said yes. And as a result, he also was able to enjoy from a lot of near-term liquidity. And he was the only person from SSI to join Meta.
It sounds like SSI's plan is to be a company that is at the frontier when you get to this very important period in human history, where you have superhuman intelligence and you have these ideas about how to make superhuman intelligence go well. But other companies will be trying their own ideas. What distinguishes SSI's approach to making superintelligence go well?
The main thing that distinguishes SSI is its technical approach. So we have a different technical approach that I think is worthy, and we are pursuing it. I maintain that in the end, there will be a convergence of strategies. So I think there will be a convergence of strategies where at some point, as AI becomes more powerful, it's going to become more or less clearer to everyone what the strategy should be. And it should be something like, yeah, you need to find some way to talk to each other, and you want your first actual, like real super intelligent AI to be aligned and somehow be, care for sentient life, care for people, democratic, one of those, some combination of thereof. And I think this is the condition that everyone should strive for. And that's what SSI is striving for. And I think that this time, if not already, all the other companies will realize that they're striving towards the same thing. And we'll see. I think that the world will truly change as AI becomes more powerful. Yeah. And I think a lot of these forecasts will, I think things will be really different and people will be acting really differently.
Speaking of forecasts, what are your forecasts to this system you're describing, which can learn as well as a human, and subsequently, as a result, become superhuman?
I think 5 to 20.
5 to 20 years? Mm-hmm. So I just want to unroll how you might see the world coming. It's like we have a couple more years where these other companies are continuing the current approach and it stalls out. It stalls out here meaning they earn no more than low hundreds of billions in revenue. Or how do you think about what stalling out means?
Yeah, I think it could stall out, and I think stalling out will look like it will all look very similar. Yeah, among all the different companies, something like this. I'm not sure because I think even with stalling out, I think these companies could make a stupendous revenue. Maybe not profits because they will need to work hard to differentiate each other from themselves, but revenue definitely.
But there's something in your model implies that when the correct solution does emerge, there will be convergence between all the companies. And I'm curious why you think that's the case.
Well, I was talking more about convergence on their larger strategies. I think eventual convergence on the technical approach is probably going to happen as well. But I was alluding to convergence to the larger strategies. Right. What exactly is the thing that should be done?
I just want to better understand how you see the future unrolling. So currently we have these different companies and you expect their approach to continue generating revenue, but not get to this human-like learner.
Yes.
So now we have these different forks of companies. We have you, we have thinking machines, there's a bunch of other labs.
Yes.
And maybe one of them figures out the correct approach. But then the release of the product makes it clear to other people how to do this thing.
I think it won't be clear how to do it, but it will be clear that something different is possible.
Right.
And that is information. And I think people will then be trying to figure out how that works. I do think though that one of the things that I think, not addressed here, not discussed, is that with each increase in the AI's capabilities, I think there will be some kind of changes, but I don't know exactly which ones in how things have been done. So I think it's going to be important, yet I can't spell out what that is exactly.
And how are by default, you expect the model company that has that model to be getting all these gains because they have the model that is learning how to do has the skills and knowledge that it's building up in the world. What is the reason to think that the benefits of that would be widely distributed and not just end up at whatever model company gets this continuous learning loop going first?
I think that empirically what happens. So here's what I think is going to happen. Number one, I think empirically when let's look at how things have gone so far with the AIs of the past. So one company produced an advance, and the other company scrambled and produced some similar things after some amount of time, and they started to compete in the market and push the prices down. And so I think from the market perspective, I think something similar will happen there as well. Even if someone, we're talking about the good world, by the way, where what's the good world? Where you have these powerful human-like learners that are also and by the way, maybe there's another thing we haven't discussed on the spec of the super intelligent AI that I think is worth considering, is that you make it narrow. It can be useful and narrow at the same time. So you have lots of narrow super intelligent AIs. But suppose you have many of them, and you have some company that's producing a lot of profits from it, and then you have another company that comes in and starts to compete, and the way the competition is going to work is through specialization. I think what's going to happen is that the way competition loves specialization, and you see it in the market, you see it in evolution as well. So you're gonna have lots of different niches, and you're gonna have lots of different companies who are occupying different niches in this kind of world. We might say, yeah, like one AI company is really quite a bit better at some area of really complicated economic activity, and a different company is better at another area, and a third company is really good at litigation.
But is this affected by what human-like learning implies? Is that like it can learn?
It can, but you have accumulated learning. You have a big investment. You spent a lot of compute to become really, really, really good, really phenomenal at this thing, and someone else spent a huge amount of compute and a huge amount of experience to get really, really good at some other thing.
Right.
You apply a lot of human learning to get there, but now like you are at this high point where someone else would say, look, like I don't want to start learning what you've learned.
I guess that would require many different companies to begin at the human-like continual learning agent at the same time, so that they can start their different research in different branches. But if one company, gets that agent first or gets that learner first, it does then seem like, well, like we just think about every single job in the economy, you just have instance learning. Each one seems tractable for a company.
Yeah, that's a valid argument. My strong intuition is that it's not how it's going to go. My strong intuition is that like the argument says it will go this way, but my strong intuition is that it will not go this way. That this is the in theory, there is no difference between theory and practice. In practice, there is. And I think that's going to be one of those.
A lot of people's models of recursive self-improvement literally explicitly state we will have a million Ilyas in a server. They're coming in with different ideas, and this will lead to a superintelligence emerging very fast. Do you have some intuition about how parallelizable the thing you are doing is? What are the gains from making copies of Ilya?
I don't know. I think there'll definitely be diminishing returns because you want people who think differently rather than the same. I think that if they were literal copies of me, I'm not sure how much more incremental value you'd get. I think that, but people who think differently, that's what you want.
Why is it that it's been, if you look at different models, even released by totally different companies, trained on potentially non-overlapping data sets, it's actually crazy how similar LLMs are to each other.
Maybe the data sets are not as non-overlapping as it seems.
But there's some sense like, even if an individual human might be less directed than the future AI, maybe there's something to the fact that human teams have more diversity than teams of AIs might have, but how do we elicit meaningful diversity among AIs? So I think just raising the temperature just results in gibberish. I think you want something more like different scientists have different prejudices or different ideas. How do you get that kind of diversity among AI agents?
So the reason there has been no diversity, I believe, is because of pre-training. All the pre-trained models are the same, pretty much, because they're pre-trained on the same data. Now, RL and post-training is where some differentiation starts to emerge because different people come up with different RL training.
Yeah. And then I've heard you hint in the past about self-play as a way to either get data or match agents to other agents with equivalent intelligence to kick off learning. How should we think about why there's no public proposals of this kind of thing working with LLMs?
I would say there are two things to say. I would say that the reason why I thought self-play was interesting is because it offered a way to create models using compute only without data. Right? And if you think the data is the ultimate bottleneck, then using compute only is very interesting. So that's what makes it interesting. Now, the thing is that self-play, at least the way it was done in the past, when you have agents which somehow compete with each other, it's only good for developing a certain set of skills. It is too narrow. It's only good for like negotiation, conflict, certain social skills, strategizing, that kind of stuff. And so if you care about those skills, then self-play will be useful. Now, actually, I think that self-play did find home, but just in a different form. So things like debate, proof of verifier, you have some kind of an LLM as a judge, which is also incentivized to find mistakes in your work. You could say this is not exactly self-play, but this is, a related adversarial setup that people are doing, I believe. And really self-play is an example of, is a special case of more general, competition between agents, right? The natural response to competition is to try to be different. And so if you were to put multiple agents and you tell them, you all need to work on some problem, and you're an agent, and you're inspecting what everyone else is working, you're going to say, well, if they're already taking this approach, it's not clear I should pursue it. I should pursue something differentiated. And so I think that something like this would also create an incentive for a diversity of approaches.
Yeah. Final question. What is research taste? You're obviously the person in the world who is considered to have the best taste in doing research in AI. You were the co-author on many of the biggest things that have happened in the history of deep learning, from AlexNet to GPT-3 and so on. What is it how do you characterize how you come up with these ideas?
I can answer. So I can comment on this for myself. I think different people do it differently. But one thing that guides me personally is an aesthetic of how AI should be by thinking about how people are, but thinking correctly. Like, it's very easy to think about how people are incorrectly. But what does it mean to think about people correctly? Yeah. So I'll give you some examples. The idea of the artificial neuron is directly inspired by the brain. And it's a great idea. Why? Because you say, sure, the brain has all these different organs, it has the folds, but the folds probably don't matter. Why do we think that the neurons matter? Because there's many of them, kind of feels right, so you want the neuron. Yeah. You want some kind of local learning rule that will change the connections. You want some local learning rule that will change the connections between the neurons. Right? It feels plausible the brain does it. The idea of the distributed representation. The idea that the brain, the brain responds to experience, and neural net should learn from experience, not response. The brain learns from experience, the neural net should learn from experience. And you kind of ask yourself, is something fundamental or not fundamental? How things should be. Yeah. And I think that's been guiding me a fair bit, kind of thinking from multiple angles and looking for almost beauty, simplicity. Ugliness, there's no room for ugliness. It's just beauty, simplicity, elegance, correct inspiration from the brain. And all of those things need to be present at the same time. And the more they're present, the more confident you can be in a top-down belief. And then the top-down belief is the thing that sustains you when the experiments contradict you. Because if you just trust the data all the time, well, sometimes you can be doing a correct thing, but there's a bug. But you don't know there is a bug. How can you tell that there is a bug? How do you know if you should keep debugging or you conclude it's the wrong direction? Well, is the top-down? Well, you could say the things have to be this way. Right. Something like this has to work. Therefore, you got to keep going. That's the top-down. And it's based on this multifaceted beauty and inspiration by the brain.
All right. We'll leave it there.
Thank you so much.
Thanks so much.
Ooh. All right. Appreciate it.
That was great.
Yeah, I enjoyed it.
Yes, me too. Hey, everybody. I hope you enjoyed that episode. If you did, the most helpful thing you can do is just share it with other people who you think might enjoy it. It's also helpful if you leave a rating or comment on whatever platform you're listening on. If you're interested in sponsoring the podcast, you can reach out at dwarkesh.com/advertise. Otherwise, I'll see you on the next one. I think the whole history of deep learning is in some sense the history of scaling up compute.
When I graduated from grad school, I really thought the rest of my entire career would be towards solving that single problem, which is a lot of AI as a field, as a discipline, is inspired by human intelligence. We thought we were the first people doing it. It turned out that was also simultaneously doing it.
So Marble, like basically one way of looking at it, it's a system, it's a generative model of 3D worlds, right? So you can input things like text or image or multiple images, and it will generate for you a 3D world that kind of matches those inputs. So while Marble is simultaneously a world model that is building towards this vision of spatial intelligence, it was also very intentionally designed to be a thing that people could find useful today. And we're starting to see emerging use cases in gaming and VFX, in film, where I think there's a lot of really interesting stuff that Marble can do today as a product, and it also set a foundation for the grand world models we want to build going into the future.
Hey everyone, welcome to the Living Space podcast. This is Alessio, founder of Recurrence, and I'm joined by Swix, editor of Living Space.
And we are so excited to be in the studio with Feifei and Justin of World Labs. Welcome.
We're excited too.
I know you said Marble. Yeah, thanks for having us. I think there's a lot of interest in world models, and you've done a little bit of publicity around spatial intelligence and all that. I guess maybe one of the part of the story that is a rare opportunity for you to tell is how you two came together to start building World Labs.
That's very easy because Justin was my former student.
Yeah.
So Justin came to my, the other hat I wear is a professor of computer science at Stanford. Justin joined my lab when? Which year?
2012. Actually, the semester that the quarter that I joined your lab was the same quarter that AlexNet came out.
Yeah, yeah. So Justin is my
Were you involved in the whole announcement drama? No, not at all. But I was sort of watching all the image and excitement around AlexNet that quarter.
So he was one of my very best students, and then he went on to have a very successful early career as a professor in Michigan University. University of Michigan, Ann Arbor, and Meta. And then when we, I think around more than 2 years ago, for sure, I think both independently, both of us have been looking at the development of the large models and thinking about what's beyond language models. And this idea of building world models, spatial intelligence, really was natural for us. So we started talking and decided that we should just put all the eggs in one basket and focus on solving this problem and started World Labs together.
Yeah, pretty much. I mean, after that, seeing that kind of ImageNet era during my PhD, I had the sense that the next sort of decade of computer vision was going to be about getting AI out of the data center and out into the world. So a lot of my interests post PhD kind of shifted into 3D vision, a little more into computer graphics, more into generative modeling. And I thought I was kind of drifting away from my advisor post PhD, but then when we reunited a couple years later, it turned out she was thinking of very similar things.
So if you think about AlexNet, the core pieces of it were obviously ImageNet. It was the move to GPUs and neural networks. How do you think about the AlexNet equivalent model for world models? In a way, it's an idea that has been out there, right? There's been, Jan LeCun is maybe like the biggest proponent, most prominent of it. What have you seen in the last 2 years that you were like, hey, now's the time to do this? And what are maybe the things fundamentally that you want to build as far as data and kind of like maybe different types of algorithms or approaches to compute to make world models really come to life?
Yeah, I think one is just there is a lot more data and compute generally available. I think the whole history of deep learning is in some sense the history of scaling up compute. And if you think about, AlexNet required this jump from CPUs to GPUs, but even from AlexNet to today, we're getting about 1,000 times more performance per card than we had in AlexNet days. And now it's common to train models not just on one GPU, but on hundreds or thousands or tens of thousands or even more. So the amount of compute that we can marshal today on a single model is about a millionfold more than we could have even at the start of my PhD. So I think language was one of the really interesting things that started to work quite well the last couple of years. But as we think about moving towards visual data and spatial data and world data, you just need to process a lot more. And I think that's going to be a good way to soak up this new compute that's coming online more and more.
Does the model of having a public challenge still work, or should it be centralized inside of the lab?
I think open science still is important. AI obviously compared to the ImageNet AlexNet time has really evolved, right? That was such a niche computer science discipline. Now it's just like civilizational technology. But I'll give you an example, right? Recently, my Stanford lab just announced an open dataset and benchmark called Behavior, which is for benchmarking robotic learning in simulated environments. And that is a very clear effort in keeping up this open science model of doing things, especially as in academia. But I think it's important to recognize the ecosystem is a mixture, right? I think a lot of the very focused work in industry, some of them are more seeing the daylight in the form of a product rather than an open challenge per se.
Yeah, and that's just a matter of the funding and business model. Like you have to see some ROI from it.
I think it's just a matter of the diversity of the ecosystem, right? Even during the so-called ImageNet time, I mean, there were closed models, there were proprietary models, there were open models, or you think about iOS versus Android, right? They're different business model. I wouldn't say it's just a matter of funding per se. It's just how the market is. They're different plays.
Yeah.
But do you feel like you could redo ImageNet today with the commercial pressure that some of these labs has? I mean, to me, that's like the biggest question, right? It's like, what can you open versus what should you keep inside? Like, if I put myself in your shoes, right? It's like, here's a lot of money, you're building all this. If you had the best data set for this, what incentives do you really have to publish it? And it feels like the people at the labs are getting more and more pulled in the PhD programs are getting pulled earlier and earlier into these labs. So I'm curious if you think there's like an issue right now with like how much money is at stake and how much pressure it puts on like more academia, open research space, or if you feel like that's not really a concern.
I do have concerns less about the pressure. It's more about the resourcing and the imbalance, the resourcing of academia. This is a little bit of a different conversation from World Labs. I have been the past few years advocating for resourcing the healthy ecosystem. As the founding director, co-director of Stanford's Institute for Human-Centered AI, Stanford High, I've been working with policy makers about resourcing public sector and academic AI work. Right, we work with the first Trump administration on this bill called National AI Research Resource NAIR bill, which is scoping out a national AI compute cloud as well as data repository. And I also think that open source, open data sets continue to be important part of the ecosystem. Like I said, right now, in my Stanford lab, we are doing the open dataset, open benchmark on robotic learning call behavior, and many of my colleagues are still doing that. I think that's part of the ecosystem. I think what the industry is doing, some startups are doing, are running fast with models, creating products, is also a good thing. For example, when Justin was a PhD student with me, none of the computer vision programs work that well, right? We could write beautiful papers. Justin has.
I mean, like, actually, even before grad school, like, I wanted to do computer vision. I reached out to a team at Google and like wanted to potentially go and try to do computer vision like out of undergrad. And they told me, like, what are you talking about? Like, you can't do that. Like, go do a PhD first and come back.
What was the motivation that got you?
Oh, so I done some computer vision research during my undergrad with actually Feifei's PhD advisor.
The lineage.
There's a lineage here.
Yeah.
So I done some computer vision even as an undergrad, and I thought it was really cool, and I wanted to keep doing it. So I was sort of faced with this sort of industry academia choice even coming out of undergrad that I think a lot of people in the research community are facing now. But to your question, I think like the role of academia, especially in AI, has shifted quite a lot in the last decade. It's not a bad thing. It's a sense of it's because the technology has grown and emerged, right? Like 5 or 10 years ago, you really could train state-of-the-art models in the lab, even with just a couple GPUs. But because that technology was so successful and scaled up so much, then you can't train state-of-the-art models with a couple GPUs anymore. And it's not a bad thing. It's a good thing. It means the technology actually work. That means the expectations around what we should be doing as academics shifts a little bit, and it shouldn't be about trying to train the biggest model and scaling up the biggest thing. It should be about trying wacky ideas and new ideas and crazy ideas, most of which won't work. And I think there's a lot to be done there. If anything, I'm worried that too many people in academia are hyper-focused on this notion of trying to pretend like we can train the biggest models, or treating it as almost a vocational training program to then graduate into a big lab and be able to do all the GPUs. I think there's just so much crazy stuff you can do around like new algorithms, new architectures, like new systems that there's a lot you can do as one person.
And also just academia has a role to play in understanding the theoretical underpinning of these large models. We still know so little about this. Or extend to the interdisciplinary, just impulse wacky ideas. There's a lot of basic science ideas. There's a lot of blue sky problems. So I don't think the problem is open versus closed, productization versus open sourcing. I think the problem right now is that academia by itself is severely under-resourced, so that the researchers and the students do not have enough resources to try these ideas.
Yeah, just for people to understand, like, what's a wacky idea that comes to mind when you talk about wacky ideas?
Oh, like I had this idea that I kept pitching to my students at Michigan, which is that I really like hardware, and I really like new kinds of hardware coming online. In some sense, the emergence of the neural networks that we use today in transformers are really based around matrix multiplication, because matrix multiplication fits really well with GPUs. But if we think about how GPUs are going to scale, how hardware is likely to scale in the future, I don't think the current system that we have, like the GPU hardware design, is going to scale infinitely. And we start to see that even now, that like the unit of compute is not a single device anymore. It's whole cluster of devices. So if you imagine a node, it's a whole node or a whole cluster. But the way we talk about neural networks is still as if they are a monolithic thing that could be coded like in one GPU and PyTorch. But then in practice they get distributed over thousands of devices. So they're like just as transformers are based around NatMol, and NatMol is sort of primitive that works really well on GPUs. As you imagine hardware scaling out, there are other primitives that make more sense for large scale distributed systems that we could build our neural networks on. And I think it's possible there could be drastically different architectures that fit with the next generation or like the hardware that's going to come 10 or 20 years down the line. We can start imagining that today.
It's really hard to make those kinds of bets because there's also the concept of the hardware lottery, where let's just say NVIDIA has one, and we should just scale that out infinitely and write software to patch any gaps we have in the mix, right? I mean, yes and no. Like if you look at the numbers, like even going from Copper to Blackwell, like the performance per watt is about the same. They mostly make the number of transistors go up and make the chip size go up and make the power usage go up. But even from Copper to Blackwell, we're kind of already seeing like a scaling limit in terms of what is the performance per watt that we can get. So I think there is room to do something new. And I don't know exactly what it is, and I don't think you can get it done like in a 3-month cycle as a startup. But I think that's the kind of idea that you sit down and sit for a couple of years, like maybe you could come up with some breakthroughs. And I think that's the kind of long-range stuff that is perfect for academia. Coming back to a little bit of background in history, we have this sort of research note on the scene storytelling work that you did, your image captioning that you did with Foundry. And I just wanted to hear you guys tell that story about, you were like embarking on that for your PhD, and Feifei, you having that reaction that you had.
Yeah, so I think that line of work started between me and Andre, and then Justin joined, right? So Andre started his PhD. He and I were looking at what is beyond ImageNet object recognition. And at that time, the convolutional neural network has proven some power in ImageNet tasks. So ConvNet is a great way to represent images. In the meantime, I think in the language space, a early sequential model is called LSTM, was also being experimented. So Andre and I were just talking about, this has been a long-term dream of mine. I thought it would take 100 years to solve, which is telling the story of images. When I graduated from grad school, I really thought that the rest of my entire career would be towards solving that single problem, which is given a picture or given a scene, tell the story in natural language. But things evolve so fast that when Andre and I, when Andre started, we're like maybe combining the representation of convolutional neural network as well as the language sequential model of LSTM, we might be able to learn through training to match caption with images. So that's when we started that line of work, and I don't know, it was 2014 or 2015.
It was CVPR 2015.
Right. So it was our first paper that Andre got it to work. That was given an image, the image is represented with ConvNet, the language model is the LSTM model, and then we combine it, and it's able to generate one sentence. And that was one of the first time. It was pretty, I think I wrote it in my book. We thought we were the first people doing it. It turned out that Google at that time was also simultaneously doing it, and a reporter who was John Markov from New York Times was breaking the Google story, but he by accident heard about us, and then he realized that we really independently got there together at the same time, so he wrote the story of both the Google research as well as Andre and I research. But after that, I think Justin was already in the lab at that time.
Yeah, I remember the group meeting where Andre was presenting some of those results and explaining this new thing called LSTMs and RNNs that I never heard before, and I thought like, wow, this is really amazing stuff. I don't know about that. So then he had the paper at CVPR 2015 on the first image captioning results. And then after that, we started working together, and we first did a paper actually just on language modeling back in 2015. Yeah, I should start with language modeling. That turned out but we did this language modeling paper together, me and Andre, in 2015. It was like really cool. We trained these little RNN language models that could spit out a couple sentences at a time and poke at them and try to understand what the neurons inside the neuron
I
inside the thing are
remember
doing.
you guys were doing analysis on the different like memory. And
it was really cool. And even at that time, we had these results where you could like look inside the LSTM and say like, oh, this thing is re-encode. So one of the data sets that we trained on for this one was the Linux source code, right? Because the whole thing is open source, and you just download this. So we trained RNN on this data set, and then as we were trying to predict the tokens there, then try to correlate the kinds of predictions it's making with the kind of internal structures in RNN. And there we were able to find some correlations between like this unit in this layer of the LSTM fires when there's an open paren, and then like turns off when it's a closed paren. And try to do some empirical stuff like that to figure it out. So that was pretty cool. And that was just like that was sort of like cutting out the CNN from this language modeling part and just looking at language models in isolation.
And then we wanted to extend the image captioning work. And remember, at that time, we even have a sense of space because we feel like captioning does not capture different parts of the image. So I was talking to Justin and Andre about can you go what we end up calling dense captioning, which is describe the scene in greater details, especially different parts of the scene. So that's
and so then we built this system. So it was me and Andre and Feifei the following year, 2016, where we built this system that did dense captioning. So you input a single image, and it would draw boxes around all the interesting stuff in the image and write a short snippet about each of them. It's like it's a green ball, water bottle on a table. It's a person wearing a black shirt. And this was a really complicated neural network because that was built on a lot of advancements that had native object detection around that time, which was a major topic in computer vision for a long time. And it was actually like one joint neural network that was both learning to look at individual images. Because actually had like 3 different representations inside this network. One was the representation of the whole image to kind of get the gestalt of what's going on. Then it would propose individual regions that it wants to focus on, and then it would represent each region independently. And once you look at a region, then you need to develop tags for each region. So that was a pretty complicated neural network architecture. This was all pre-PyTorch. Does it do it in one pass? Yeah, so it was a single forward pass that did all
Not only was doing it in one pass, you also optimized inference. You're doing it on a webcam.
So I had built this like crazy real-time demo where I had the network running like on a server at Stanford, and then a web front end that would stream from a webcam and then like send the image back to the server. The server would run the model and stream the predictions back. So I was just like walking around the lab with this laptop that would just like show people this network in real time. Identification and labeling as well.
Yes, it was pretty impressive because most of my graduate students would be satisfied if they can publish the paper, right? They package the research, put it in a paper, but just went a step further. He's like, I want to do this real-time web demo.
Well, actually, I don't know if I told you this story. But then there was a conference that year in Santiago at ICCV. It was ICCV 15. And then like I had a paper at that conference for something different. But I had my laptop. I was like walking around the conference with my laptop, showing everybody this like real-time caption demo, and the model was running on a server in California. So it was like actually able to stream like all the way from California down to Santiago. Well, Lindsay, it was terrible. It was like 1 FPS, but the fact that it worked at all was pretty amazing. So I was going to briefly quip that maybe vision and language modeling are not that different. DeepSQL CR recently tried the crazy thing of let's model text from pixels and just like train on that. And it might be the future. I don't know if you guys have any takes on whether language is actually necessary at all.
I just wrote a whole manifesto on spatial intelligence.
This is my segue into this. Yes.
I think they are different. I do think the architecture of these generative models will share a lot of shareable components, but I think the deeply 3D, 4D spatial world has a level of structure that is fundamentally different from a purely generative signal that is one-dimensional.
Yeah, I think there's something to be said for pixel maximalism, right? Like there's this notion that language is this different thing, but we see language with our eyes, and our eyes are just like basically pixels, right? Like we've got sort of biological pixels in the back of our eyes that are processing these things, and we see text and we think of it as this discrete thing, but that really only exists in our minds. Like the physical manifestation of text and language in our world are physical objects that are printed on things in the world, and we see with our eyes.
Well, you can also think it's sound, but even sound you can translate into you can parallelogram, which is a 2D signal.
Right, and then like you actually lose something if you translate to this like purely tokenized representations that we use in LLMs, right? Like you lose the fonts, you lose the line breaks, you lose sort of the 2D arrangement on the page. And for a lot of cases, for a lot of things maybe that doesn't matter, but for some things it does. And I think pixels are this sort of more lossless representation of what's going on in the world, and in some ways a more general representation that more matches what we humans see as we navigate the world. So like there's an efficiency argument to be made. Like maybe it's not super efficient to like render your text to an image and then feed that to a vision model. That's exactly what DeepSeek did. It was like kind of worked.
I think this ties into the whole world model. Like one of my favorite papers that I saw this year was about inductive bias for world model. So it was a Harvard paper where they fed a lot of like orbital patterns into an LLM, and then they asked the LLM to predict the orbit of a planet around the sun. And the model generated looked good, but then if you asked it to draw the force vectors, it would be all wacky. It wouldn't actually follow it. So how do you think about what's embedded into the data that you get? And we can talk about maybe tokenizing for 3D world models. Like what are like the dimensions of information? There's the visual, but like how much of like the underlying hidden forces, so to speak, you need to extract out of this data, and like what are some of the challenges there?
Yeah, I think there's different ways you could approach that problem. One is like you could try to be explicit about it and say like, oh, I want to measure all the forces and feed those as training data to your model, right? Then you could like sort of run a traditional physics simulation and then know all the forces in the scene and then use those as training data to train a model that's now going to hopefully predict those. Or you could hope that something emerges more latently, right? That you kind of train on something end to end and then on a more general problem, and then hope that somewhere something in the internals of the model must learn to model something like physics in order to make the proper predictions. I mean, those are kind of the two big paradigms that we have more generally.
But there's no indication that those latent modeling will get you to a causal law of space and dynamics, right? That's where today's deep learning and human intelligence actually start to bifurcate, because fundamentally the deep learning is still fitting patterns.
There you sort of get philosophical and you say that like we're trying to fit patterns too, but maybe we're trying to fit a more broad array of patterns like over a longer time horizon, a different reward function. But like basically the paper you mentioned is sort of that problem that it learns to fit the specific patterns of orbits, but then it doesn't actually generalize in the way that you'd like. It doesn't have a sort of causal model of gravity.
Right, because even in Marble, I was trying it and it generates these beautiful sceneries and there's like arches in them. But does the model actually understand how the arch is actually drawing on the center kind of like stone and like the actual physical structure of it? And the other question is like, does it matter that it does understand it as long as it always renders something that would fit the physical model that we imagine?
If you use the word understand the way you understand, I'm pretty sure the model doesn't understand it. The model is learning from the data, learning from the pattern. Does it matter? Especially for the use cases. It's a good question, right? Like for now, I don't think it matters because it renders out what you need, assuming it's perfect.
Yeah, I mean, it depends on the use case. Like if the use case is I want to generate sort of a backdrop for virtual film or production or something like that, all you need is something that looks plausible. And in that case, probably doesn't matter. But if you're going to use this to like, if you're an architect and you're going to use this to design a building that you're then going to go build in the real world, then yeah, it does matter that you model the forces correctly because you don't want the thing to break once you actually build it.
But even there, right? Like even if your model has the semantics in it, let's say, I still don't think the understanding of the signal or the output on the model part and the understanding on the human part is a different word. But this gets, again, philosophical.
Yeah, I mean, there's this trick with understanding, right? Like these models are a very different kind of intelligence than human intelligence. And human intelligence is interesting because, I think that I understand things because I can introspect my own thought process to some extent. And then I believe that my thought process probably works similar to other people's, so that when I observe someone else's behavior, then I infer that their internal mental state is probably similar to my own internal mental state that I've observed. And therefore, I know that I understand things, so therefore I assume that you understand something. But these models are sort of like this alien form of intelligence where they can do really interesting things, they can exhibit really interesting behavior, but whatever kind of the equivalent of internal cognition or internal self-reflection that they have, if it exists at all, is totally different from what we do. So
it doesn't have the self-awareness.
Right. So, but what that means is that when we observe seemingly interesting or intelligent behavior out of these systems, we can't necessarily infer other things about them because their model of the world and the way they think is so different from us.
So would you need two different models to do the visual one and the architectural generation, you think? Eventually, like there's not anything fundamental about the approach that you've taken on the model building. It's more about scaling the model and the capabilities of it. Or like, is there something about being very visual that prohibits you from actually learning the physics behind it, so to speak, so that you could trust it to generate a CAD design that then is actually going to work in the real world.
I think this is a matter of scaling data and bettering model. I don't think there's anything fundamental that separates these two.
Yeah, I would like it to be one model. But I think like the big problem in deep learning in some sense is how do you get emergent capabilities beyond your training data? Are you going to get something that understands the forces while it wasn't trained to predict the forces, but it's going to learn them implicitly internally? And I think a lot of what we've seen in other large models is that a lot of this emergent behavior does happen at scale. And will that transfer to other modalities and other use cases and other tasks? I hope so. But that'll be a process that we need to play out over time and see. Is there temptation to rely on physics engines that already exist out there that are basically the gaming industry has saved you a lot of this work, or do we have to reinvent things for some fundamental mismatch? I think it's sort of like climbing the ladder of technology, right? Like in some sense, the reason that you want to build these things at all is because maybe traditional physics engines don't work in some situations. If the physics engine was perfect, we would have sort of no need to build models because the problem would have already been solved. So in some sense, the reason why we want to do this is because classical physics engines don't solve problems in the generality that we want. But that doesn't mean we need to throw them away and start everything from scratch, right? We can use traditional physics engines to generate data that we then train our models on, and then you're sort of distilling the physics engine into the weights of the neural network that you're training. I think that's a lot of what, if you compare the work of other labs, people are speculating that Sora had a little bit of that, Genie 3 had a bit of that. And Genie 3 is like explicitly like a video game, like you have controls to walk around in. And I always think like it's really funny how the things that we invent for fun actually does eventually make it into serious work.
Yeah, the whole AI revolution started by graphics chips, partially.
Misusing the GPU for generating a lot of triangles and generating a lot of everything else, basically. Yeah. We touched on Marble a little bit. I think you guys chose Marble as like kind of like a little bit coming out of stealth moment, if you can call it that.
Yeah.
Maybe we can get a concise explanation from you on what people should take away, because everyone here can try Marble, but I don't think they might be able to link it to the differences between what your vision is versus other, generative worlds they may have seen from other labs.
So Marble is a glimpse into our model, right? We are a spatial intelligence model company. We believe spatial intelligence is the next frontier. In order to make spatially intelligent models, the model has to be very powerful in terms of its ability to, understand, reason, generate in very multimodal fashion of worlds, as well as allow the level of interactivity that we eventually hope to be as, complex as how humans can interact with the world. So that's the grand vision of spatial intelligence, as well as the kind of world models we see. Marble is the first glimpse into that. It's the first part of that journey. It's the first in-class model in the world that generates 3D worlds in this level of fidelity that is in the hands of the public. It's the starting point, right? We actually wrote this tech blog. Justin spent a lot of time writing that tech blog. I don't know if you had time to browse it. I mean, Justin really broke it down into what are the inputs. Multimodal inputs of Marble. What are the kind of editability, which is allows user to be interactive with the model, and what are the kind of outputs we can have.
Yeah. So Marble, like basically one way of looking at it is the system. It's a generative model of 3D worlds, right? So you can input things like text or image or multiple images, and it will generate for you a 3D world that kind of matches those inputs. And it's also interactive in the sense that you can interactively edit scenes. Like I could generate the scene and then say I don't like the water bottle, make it blue instead. Like take out the table, like change these microphones around, and then you can generate new worlds based on these interactive edits and export in a variety of formats. And with Marble, we're actually trying to do sort of two things simultaneously. And I think we managed to pull off balance pretty well. One is actually build a model that goes towards the grand vision of spatial intelligence. And models need to be able to understand lots of different kinds of inputs, need to be able to model worlds in a lot of situations, need to be able to model counterfactuals, how they could change over time. So we wanted to start to build models that have these capabilities. And Marble today does already have hints of all of these. But at the same time, we're a company, we're a business. We were really trying not to have this be a science project, but also build a product that would be useful to people in the real world today. So while Marble is simultaneously a world model that is building towards this vision of spatial intelligence, it was also very intentionally designed to be a thing that people could find useful today. And we're starting to see emerging use cases for in gaming, in VFX, in film, where I think there's a lot of really interesting stuff that Marble can do today as a product, and also set a foundation for the grand world models that we want to build going into the future. Yeah, I know this one tool that was very interesting is you can record your scene inside. Yes.
It's very important. The ability to record means a very precise control of camera placement. Right. In order to have precise camera placement, it means you have to have a sense of 3D space. Otherwise, you don't know how to orient your camera, right, and how to move your camera. So that is a natural consequence of this kind of model, and this is why this is just one of the examples.
Yeah, I find when I play with video generative models, I'm having to learn the language of being a director because I have to move them like pan,
But even there, you cannot say pan 63 degrees to the north, right? You just don't have that control. Whereas in Marble, you have precise control in terms of placing your camera.
Yeah, I think that's one of the first things people need to understand is like you're not generating frame by frame, which is like what a lot of the other models are.
Yeah.
What are, people understand that an LLM generates one token. What are like the atomic units? There's kind of like, the meshes, there's like the splats, the voxels, there's a lot of pieces in a 3D world. What should be the mental model that people have of like your generations?
Yeah, I think there's like what exists today and what could exist in the future. So what exists today is the model natively outputs splats. So Gaussian splats are these like, each one is a tiny particle that's semi-transparent, has a position orientation in 3D space. And the scene is built up from a large number of these Gaussian splats. And Gaussian splats are really cool because you can render them in real time really efficiently. So you can render on your iPhone, render everything. And that's how we get that sort of precise camera control, because the splats can be rendered real time on pretty much any client-side device that we want. So for a lot of the scenes we're generating today, that kind of atomic unit is that individual splat. But I don't think that's fundamental. I could imagine other approaches in the future that would be interesting. So there are other approaches that even we've worked on at World Labs, like our recent RTFM model that does generate frames one at a time. And there the atomic unit is generating frames one at a time as the user interacts with the system. Or you could imagine other architectures in the future where the atomic unit is a token, where that token now represents some chunk of the 3D world. I think there's a lot of different architectures that we can experiment with here over time. I do want to press on double click on this a little bit. My version of what Alessio was going to say was like, what is the fundamental data structure of a world model? Because exactly like you said, like it's either Gaussian splat or it's like the framework, what have you. You also in the previous statements focus a lot on the physics and the forces, which is something over time, which is loosely. I don't see that in Marble. I presume it's not there yet. But maybe if there's like Marble 2, you will have movement, or is there a modification to Gaussian splats that makes sense, or would it be something completely different? Yeah, I think there's a couple modifications that make sense. And there's actually a lot of interesting ways to integrate things here, which is another nice place of working in this space. Then there's actually been a lot of research work on this. Like when we talk about wacky ideas, like there's actually been a lot of really interesting academic work on different ways to imbue physics.
We can also do wacky ideas in industry.
Right, but then it's like Gaussian splats are themselves little particles. There's been a lot of approaches where you basically attach physical properties to those splats and say that each one has a mass, or like maybe you treat each one as being coupled to some kind of virtual spring to nearby neighbors, and now you can start to do sort of physics simulation on top of splats. So one kind of avenue for adding physics or dynamics or interaction to these things would be to predict physical properties associated with each of your splat particles, and then simulate those downstream, either using classical physics or something learned. Or the kind of the beauty of working in 3D is things compose and you can inject logic in different places. So one way, sort of like we're generating a 3D scene, we're going to predict 3D properties of everything in the scene, then we use a classical physics engine to simulate the interaction. Or you could do something where, like, as a result of a user action, the model is now going to regenerate the entire scene in splats or some other representation. And that could potentially be a lot more general, because then you're not bound to whatever sort of physical properties you know how to model already. But that's also a lot more computationally demanding, because then you need to regenerate the whole scene in response to user actions. But I think this was a really interesting area for future work and for adding on into potential Marble 2, as you say.
Yeah, there's opportunity for dynamics, right?
What's the state of like splats density, I guess? Like, can we render enough to have very high resolution when we zoom in? Are we limited by like the amount that you can generate, the amount that we can render? Like, how are these going to get super high fidelity, so to speak?
You have some limitations, but depending on your target use case. So like one of the big constraints that we have on our scenes is we want things to render cleanly on mobile, and we want things to render cleanly in VR headsets. So those devices have a lot less compute than you have in a lot of other situations. And like if you want to get a splat file to render at high resolution, like 30 to 60 FPS on like an iPhone from 4 years ago, then you are a bit limited in like the number of splats that you can handle. But if you're allowed to like work on a recent, like even this year's iPhone or like a recent MacBook, or even if you have a local GPU, or if you don't need that 60 FPS 1080p, like then you can relax the constraints and get away with more splats, and that lets you get high resolution in your scenes.
One use case I was expecting but didn't hear from you was embodied use cases. You're just focusing on virtual for now?
If you go to Worklab's homepage, there is a particular page called Marble Labs. There we showcase different use cases, and we actually organize them in more visual effect use cases or gaming use cases, as well as simulation use cases. And in that, we actually show this is a technology that can help a lot in robotic training, right? This goes back to what I was talking about earlier. In speaking of data starvation, robotic training really lack data. High fidelity real world data is absolutely very critical, but you're just not going to get a ton of that. Of course, the other extreme is just purely internet video data, but then you lack a lot of the controllability that you want to train your embodied agents with. So simulation and synthetic data is actually a very important middle ground. For that, I've been working in this space for many years, and one of the biggest pain points is where do you get this synthetic simulated data? You have to curate assets and build these, compose these complex situations. And in robotics, you want a lot of different states. You want the embodied agent to interact in the synthetic environment. Marble actually is a really potential for helping to generate these synthetic simulated worlds for embodied agent training.
Obviously, that's on the homepage. It'll be there. I was like trying to make the link to, as you said, like, you also have to build a business model. The market for robotics obviously is very huge. Maybe you don't need that, or maybe we need to build up and solve the virtual world first before we can go to embodied. And obviously,
that is to be decided. I do think that
because everyone else is going straight there, right?
Not everyone else, but there is an excitement, I would say. But I think the world is big enough to have different approaches.
Yeah, I mean, and we always view this as a pretty horizontal technology that should be able to touch a lot of different industries over time. And Marble is a little bit more focused on creative industries for now, but I think that the technology that powers it should be applicable to a lot of different things over time. And robotics is one that is maybe going to happen sooner than later.
Also, design, right? It's very adjacent to creative.
Oh yeah, definitely. Like I think it's like the architecture stuff.
Yes.
Okay. Yeah, I mean, I was joking online. I posted this video on Slack of like, who wants to use Marble to plan your next kitchen remodel? It actually works great for this already. Just like take 2 images of your kitchen, like reconstruct it in Marble, and then use the editing features to see what would that space look like if you change the countertops or change the floors or change the cabinets. And this is something that's we didn't necessarily build anything specific for this use case, but because it's a powerful horizontal technology, you kind of get these emergent use cases that just fall out of the model.
We have early beta users using a API key that is already building for interior design use case.
I just did my garage. I should have known about this.
Next time you remodel, we can be of help.
Well, kitchen is next, I'm sure.
Yeah.
I'm curious about the whole spatial intelligence space. I think we should dig more into that. One, how do you define it? And like, what are like the gaps between traditional intelligence that people might think about LLMS? When, Dario says we have a data center full of Einsteins. That's like traditional intelligence. It's not spatial intelligence. What is required to be spatially intelligent?
First of all, I don't understand that sentence, a data center full of Einsteins. I just don't understand that. It's not a deep...
It's an analogy.
Well, so a lot of AI as a field, as a discipline, is inspired by human intelligence, right? Because we are the most intelligent animal we know in the universe for now. And if you look at human intelligence, it's very multi-intelligent, right? There is a psychologist, I think his name is Howard Gardner, in the 1960s, actually literally called multiple intelligence to describe human intelligence. And there is linguistic intelligence, there's spatial intelligence, there is logical intelligence, and emotional intelligence. So for me, when I think about spatial intelligence, I see it as complementary to language intelligence. So I personally would not say it's spatial versus traditional, because I don't know tradition means, what does that mean? I do think spatial is complementary to linguistic. And how do we define spatial intelligence? It's the capability that allows you to reason, understand, move, and interact in space. And I use this example of the deduction of DNA structure, right? And of course, I'm simplifying this story, but a lot of that had to do with the spatial reasoning of the molecules and the chemical bonds in a 3D space to eventually conjecture a double helix. And that ability that humans, or Francis Crick and Watson, had done, it is very, very hard to reduce that process into pure language. And that's a pinnacle of a civilizational moment. But every day, right, I'm here trying to grasp a mug. This whole process of seeing the mug, seeing the context where it is, seeing my own hand, opening of my hand that geometrically would match the mug, and touching the right affordance points, all this is deeply, deeply spatial. It's very hard. I'm trying to use language to narrate it, but on the other hand, that narrated language itself cannot get you to pick up a mug.
Yeah, bandwidth constraint.
Yes.
I did some math recently on, like, if you just spoke all day, every day for 24 hours a day, how many tokens do you generate? At the average speaking rate of like 150 words per minute, it runs out to about 215,000 tokens per day. And like your world that you live in is so much higher bandwidth than that.
Well, I think that is true. But if I think about Sir Isaac Newton, right, it's like you have things like gravity at the time that are not being formalized in language that people inherently spatially understand, that things fall, right? But then it's helpful to formalize that in some way, or like, all these different rules that we use language to like really capture something that empirically and spatially you can also understand, but it's easier to like describe in a way. So I'm curious, like the interplay of like spatial and like linguistic intelligence, which is like, okay, you need to understand some rules are easier to write in language for then the spatial intelligence to understand, but you cannot write, put your hand like this and put it down this amount. So I'm always curious about how you leverage each other together.
I mean, if anything, like the example of Newton, like Newton only thinks to write down those laws because he's had a lot of embodied experience in the world.
Right, yeah, exactly.
And actually, it's useful to distinguish between theory building that you're mentioning versus like the embodied, like the daily experience of being embedded in the three-dimensional world, right? So to me, spatial intelligence is sort of encapsulating that embodied experience of being there in 3D space, moving through it, seeing it, actioning it, And as Feifei said, you can narrate those things, but it's a very lossy channel. It's just like the notion of, being in the world and doing things in it is a very different modality from trying to describe it. But because we as humans are animals who have evolved interacting in space all the time, like we don't even think that's a hard thing, right? And then we sort of naturally lead to language and then theory building as mechanisms to abstract above that sort of native spatial understanding. And in some sense, LLMs have just like jumped all the way to those highest forms of abstracted reasoning, which is very interesting and very useful. But spatial intelligence is almost like opening up that black box again and saying maybe we've lost something by going straight to that fully abstracted form of language and reasoning and communication.
It's funny as a vision scientist, right? I always find that vision is underappreciated because it's effortless for humans. You open your eyes as a baby, you start to see your world. Right? We're almost born with it, but you have to put effort in learning language, including learning how to write, how to do grammar, how to express, and that makes it feel hard. Whereas something that nature spent way more time actually optimizing, which is perception and spatial intelligence, is underappreciated by humans.
Is there proof that we are born with it? You said almost born. So it sounds like we actually do learn after we're born.
When we are born, our visual acuity is less and our perceptual ability does increase, but most humans are born with the ability to see. And most humans are born with the ability to link perception with motor movements, right? I mean, the motor movement itself takes a while to refine, but and then animals are incredible, right? Like I was just in Africa earlier this summer, these little animals, they're born and within minutes they have to get going, and otherwise the lions will get them. And in nature, it took 540 million years to optimize perception and spatial intelligence, and language, the most generous estimation of language development is probably 500,000 years.
Wow, yeah. That's longer than I would have said.
Well, I'm being very generous.
Yeah, no, I was sort of going through your book, and I was realizing that one of the interesting links to something that we covered on the podcast is language model benchmarks, and how Grad actually put in all these like, sort of physical impossibilities that require spatial intelligence, right? Like A is on top of B, therefore A cannot fall through B is obvious to us, but to a language model it could happen. I don't know. Maybe it's like a part of the the next token prediction. And that's sort of what I mean about like unwrapping and subtraction, right? Like if your whole model of the world is just like saying sequences of words after each other, it's really kind of hard to like why not? It's actually unfair, right? So the reason it's obvious to us is because we are internally mapping it back to some three-dimensional representation of the world that we're familiar with. The question is, I guess, like how hard is it? How long is it going to take us to distill from like I use the word distill. I don't know if you agree with that. To distill from your world models into a language model, because we do want our models to have spatial intelligence, right? Like, and do we have to throw the language model out completely in order to do that, or no, right? I don't think so. Right?
I think they're multimodal. I mean, even our model today takes language as an input, right? So it's deeply multimodal, and I think in many use cases these models will work together. Maybe one day we'll have a universal model.
I mean, even if you do, like there's sort of a pragmatic thing where people use language and people want to interact with systems using language. Even pragmatically, it's useful to build systems and build products and build models that let people talk to them. So I don't see that going away. I think there's a sort of intellectual curiosity of saying how, like, intellectually, how much could you build a model that only uses vision or only uses spatial intelligence? I don't know that would be practically useful, but I think it'd be an interesting intellectual academic exercise to see how far you could push that.
I think, not to bring it back to physics, but I'm curious, like if you had a highly precise world model and you didn't give it any notion of like our current understanding of the standard model of physics, how much of it would be able to come up with and like recreate from scratch, and what level of like language understanding it would need? Because we have so many notations and like we kind of use that like we create it, but like maybe we'll come up with a very different model of it and still be accurate. And I wonder how much we're kind of limited by how people say you always need to be like humans because the world is built for humans. And in a way, it's like the way we build language constrain some of the outputs that we can get from these other modalities as well. So I'm super excited to follow your work.
Yeah, I mean, like, there's another. You actually don't even need to be doing AI to answer that question. You could discover aliens and see what kind of physics they have, right? And they might have.
Feifei said we are so far the smartest animal in the universe.
Right, but that is a really interesting question, right? Like, is our knowledge of the universe and our understanding of physics, is it constrained in some way by our own cognition or by the path dependence of our own technological evolution? And then one way to sort of like do an experiment, like you almost want to do an experiment and say, like, if we were to rerun human civilization again, would we come up with the same physics in the same order? And I don't think that's a very practical experiment.
One experiment I wonder people could run is that we have plenty of astrophysical data now on the planet or celestial body movements. Just feed the data into a model and see if Newtonian law emerges.
My guess is it probably won't.
That's my guess. It's not. The abstraction level of Newtonian law is at a different level from what these language LLMs represents. Yeah. So I wouldn't be surprised that giving enough celestial movement data, an LLM would actually predict pretty accurate movement trajectories. Let's say I invent a planet surrounding a star, and giving enough data, my model would tell you, on day one where it is, day two where it is. I wouldn't be surprised. But F equals MA, or action equals reaction, that's just a whole different abstraction level. That's beyond just today's LLM.
Okay, what model would you need to not have it be a geocentric model? Because if I'm training just on visual data, it makes sense that you think the sun rotates around the Earth, right? But obviously that's not the case. So how would it learn that? Like, I'm curious about all these forces that we talk about. It's like sometimes maybe you don't need them because as long as it looks right, it's right. But like as you make the jump to like try and use these models to do more high level tasks, how much can we rely on them?
I think you can need kind of a different learning paradigm, right? So like, there's a bit of conflation here happening where saying, is it LLMs and language and symbols versus, human theory building and human physics? And they're very different because an LLM, like the human objective function is to understand the world and thrive in your life. And the way that you do that is by, sometimes you observe data and then you think about it and then you try to do something in the world and it doesn't match your expectations. And then you want to go and update sort of your understanding of the world online. And people do this all the time constantly. Like whether it's, I think my keys are downstairs, so I go downstairs and I look for them and I don't see them. And no, they're actually up in my bedroom. So we're like, because we're constantly interacting with the world, we're constantly having to build theories about what's happening in the world around us and then falsify or add evidence to those theories. And I think that kind of process writ large and scaled up is what gives us F equals MA in Newtonian physics. And I think that's a little orthogonal to, the modality of model that we're training, whether it's language or spatially. The way I put it is almost like this is almost more efficient learning because you have a hypothesis of here are the different possible worlds that are granted by my available data, and then you do experiments to eliminate the worlds that are not possible, and you resolve to the one that's right. To me, that's also how I also have theory of mind, which is like I have a few theses of what you're thinking, and I try to create actions to resolve that or check my intuition as to what you're thinking, and then obviously I'll still doing these.
Theory of mind possibly also will break into even emotional intelligence, which today's AI is really not touching at all, right?
And we really need it. People are starting to depend on these things probably too much, and that's a whole topic of other debate. I do have to ask because a lot of people have sent this to us. How much do we have to get rid of? Is sequence modeling out the window? Is attention out the window? Like how much are we re-questioning everything? I think you stick with stuff that works, right? So attention is still there. I think attention is still there. I think there's a lot like you don't need to fix things that are broken. And like there's a lot of hard problems in the world to solve, but let's focus on one at a time. I think it is very interesting to think about new architectures or new paradigms or drastically different learning ways to learn. But you don't need to throw away everything just because we're working on new modalities.
I think sequence to sequence is actually in world models. I think we are going to see algorithm or architecture beyond sequence to sequence.
But here actually I think there's a little bit of technological confusion, and transformers already solved that for us, right? Like transformers are actually not a model of sequences. A transformer is natively a model of sets, and that's very powerful. But because a lot of the transformers grew out of earlier architectures based around recurrent neural networks, and RNNs definitely do have like a built-in architectural, like they do model one-dimensional sequences. Okay. But transformers are just models of sets, and they can model a lot of those sets. Could be 1D sequences, they could be other things as well. He literally means set theory, like So the transformer is actually not a model of a sequence of tokens. Transformer is actually a model of a set of tokens, right? The only thing that injects the order in the standard transformer architecture, the only thing that differentiates the order of the things is the positional embedding that you give the tokens, right? So if you choose to give it a sort of 1D positional embedding, that's the only mechanism that the model has to know that it's a 1D sequence. But all the operators that happen inside a transformer block are either token-wise, right? So that either you have an FFN, you have QKV projections, like you have per token normalization. All of those happen independently per token, and then you have interactions between tokens through the attention mechanism. But that's also sort of it's a permutation of covariate. So if I permute my tokens, then the attention operator gets a permute output in exactly the same way. So it's actually natively an architecture of sets of tokens. It's literally a transform. Yeah. in the math term.
I know we're out of time, but we just want to give you the floor for some call to action either on people that would enjoy working at World Labs, what kind of people should apply, what research people should be doing outside of World Labs that would be helpful to you, or anything else on your mind.
I do think it's a very exciting time to be looking beyond just language models and think about the boundless possibilities of spatial intelligence. So we are actually hungry for talent, ranging from very deep researchers, right, thinking about the problems like Justin just described, training large models of world models. We are hungry for engineers, good engineers building systems, from training optimization to inference to product. And we're also hungry for good business, product thinkers and go-to-market and business talents. So we are hungry for talent. We, especially now that we have exposed the model to the world through Marble, I think we have a great opportunity to work with even a bigger pool of talent to solve both the model problem as well as deliver the best product to the world.
Yeah, I think I'm also excited for people to try Marble and do a lot of cool stuff with it. I think it has a lot of really cool capabilities, a lot of really cool features that fit together really nicely.
In the car coming here, Justin and I were saying people have not totally discovered it's only 24 hours. have not totally discovered some of the advanced mode of editing, right? Like turn on the advanced mode, you can, like Justin said, change the color of the bottle, change your floor and change the trees. And
well, I actually tried to get there, but when it says create, it just makes me create a completely different world.
You need to click on the advanced mode.
It's like a UI issue.
We can improve on our UI UX. Remember to click.
Yeah, we need to hire people work on the product. But one thing we got that was clear from you guys are looking for is also intellectual fearlessness, which is something that I think you guys hold as principle.
Yeah, I mean, we are literally the first people who are trying this, both on the model side as well as on the product side.
Thank you so much for joining us.
Thank you, guys.
Yeah, thanks for having us.
Yeah.
Hey everyone, welcome back to the Agent Factory, the podcast where we go beyond the hype and dive into some of the more technical AI details in the world of AI right now. Today, we have on the show Paige Bailey, and I'm super excited because she's from the DeepMind team. Paige, do you want to give a quick intro?
Yeah, so greetings everyone. My name is Paige. I'm the UTL for our developer relations team at DeepMind, which means that I get to work on the Gemini APIs as well as things like Bio, NanoBanana, Gemma, all of the things that we've released for AI developers to use in their projects.
So I know Google's been up to a lot recently, and last week, Google just launched a bunch of new tech. Do you want to give us a quick rundown?
Yeah, sure. So I think I have a slide actually to show kind of the how much we've been shipping over the course of the last while. And this is just going up to May 2025. So obviously, like shipping continues until models reach AGI, I suppose, or ASI. But we've been releasing a new model or a new feature about every single day, sometimes even more than one a day over the course of the last year. The latest model releases are really Gemini 3. So we released our Gemini 3 Pro model, which everybody was very excited about last Tuesday. And then also NanoBanana Pro, which is kind of the next iteration of our NanoBanana series of models. Really, really excited about both of these. And then we also have a new IDE for developers called Anti-Gravity, which is released by some of the folks that we have in DeepMind who had previously been working on the Windsurf team. So lots of goodness coming out for every single part of the stack for developers and for people who care about Gen Media.
Yeah, I can't imagine how busy the DeepMind team has been up to trying to release models. It seems like like you said, once a day. And today's November 24th, so if you're listening to this after, of course, these models and releases have come out in the middle of November, and it's been kind of taking the AI world by storm a little bit. I remember last week when Gemini 3 was announced, I was really excited to try it out, and then they launched Anti-Gravity. I saw the blog post right after, and then the day after that was NanoBanana Pro, and it was a lot. It almost felt like Christmas Day. So yeah.
Strong agree. And so I guess it might be good to talk a little bit about Gemini 3, what it is, what it isn't, and some of the things that folks can build with it. Does that sound good?
Yeah, I would love to hear.
Heck yeah. So Gemini 3 is really intended to be the next iteration in our Gemini series of models. I think I've certainly been excited about it, especially for doing things like app development, which we'll see in a second. And it's available in all of the places. So you can use it in the Gemini APIs and the Vertex AI APIs, places like Gemini CLI, Android Studio, the Gemini app, AI mode, Jules. They've all been kind of replatted to use this third series of models. And I think it's the natural evolution for Gemini at large. Like the first Gemini, so I was on the original modeling team for both Palm 2 and for Gemini. And I think that model was really all about being able to understand a lot of different kinds of content. So being able to understand video and images and audio and text and code and all of the above all at once. Gemini 2 was really about thinking. So we introduced this concept of reasoning, of being able to plan, of being able to kind of think step by step through processes and have these detailed thought traces and thinking tokens. And then the third iteration of Gemini is all about like getting much, much better at code and also being able to act on things. So we made huge improvements to tools use, function calling, which are great for agent style workloads, but also being able to incorporate things like tools into the reasoning process. So you can have these kind of more composite architectures of different models working together, different models interacting with systems to accomplish tasks, as opposed to just one model trying to do all of the work all by itself, if that makes sense.
Yeah, this is really well explained. It almost, like you said, sounds like the natural evolution between 1, 2, and 3. And I would imagine the Gemini 3 so good at being able to do things like coding because of the data set maybe that you're training it on and its ability to action on whatever it's been reasoning on, which a lot of coding is, basically what it is, right? Taking actions, writing code, changing functions, so on and so forth.
Absolutely. And to your point, like there are really two parts of the model building process, right? There's pre-training and then there's post-training. And pre-training is all about giving Gemini as many tokens as it can possibly have access to. So getting it like the entirety of the internet, like we're creating a lot of synthetic data sets that the model can use to help accomplish its work. So things like video game footage, things like a lot of synthetically generated code that then gets run. And so you can kind of get an idea that it's actually doing something useful with descriptions of what it does. All of that kind of getting put into post-training and then or pre-training. And then post-training is really all about giving much more sort of specific examples of kinds of use cases that the user would be expected to take. So having really, really hand-curated examples of people using a whole bunch of tools to accomplish a task, lots of multi-turn conversations that include edits of websites, lots and lots of those kinds of things getting added into our post-training mixture, in addition to techniques like reinforcement learning. So I think that there's a lot of really, really hard work that's been done across tens of thousands of people across Google to get the models into a much better state, and it's been really inspiring to see, honestly.
Yeah, interesting. So this pre and post training process is almost like sending Gemini to school to learn the basics, and then the post training is almost like on the job experience where they get to learn what the workflow looks like so they can then replicate that. Very cool.
Yeah, and then the other thing, these are just kind of the benchmarks for the model itself. My favorite one though is something called vending bench, which is vending bench for folks who are uninitiated is gauging the model's ability to run a passive business. I'll add a link to the vending bench 2 website so everybody can see. But basically, you're saying, hey model, your job is you run this vending machine. You need to figure out what we should stock it with. You need to whenever you realize that something's about to go out of stock, like you should reorder it. You should deploy a person to restock the machine whenever the order comes in, and you should also do long range planning to make sure that as you're like handling all of these component parts of the business, that it's able to have as much uptime as possible. So like I don't come to the vending machine looking for pretzels and find pretzels are missing, but I'm able to kind of have those expectations when the vending machine is running. And then the way that the models are gauged in terms of performance is how much money they make over the course of a year. And which is awesome. It's like the model's ability to run a passive business. Of course, you would gauge it by how much money it actually makes over time. And right now, Gemini 3 Pro is coming in at around $5,462 per vending machine, which given that we're operating on this exponential trajectory, maybe we can all retire and run passive businesses at some point in the future. But it's been really exciting to see how the models have improved on these things that require a lot more strategy and a lot more decision making, especially long term decision making for these kinds of use cases.
Yeah, I just sent you an invite for a meeting after this for a vending machine entrepreneurial sync. You and I can.
Excellent. I really I really want just kind of like as a segue, I really want somebody to create an eval for like a laundromat bench because I do feel like these kinds of passive businesses have immense potential. And a lot of people who have built AI startups, AI companies just recently, they have a few operating just kind of more or less autonomously. They don't have to step in very often, but they're still like pretty significant revenue streams every single month. It might not be $1 billion, but it's certainly enough to kind of meet the needs for users and to kind of take care of some of these tasks.
Yeah, it really allows people to bridge the gap, I find. And unsolicited Google, non-certified Google advice, but I think laundromats and vending machines tend to be some of the most secure and good entrepreneurial beginning ventures, I guess. So
absolutely, maybe we should get a vending machine. That would be kind of fun. Like, put it full of Google swag. Cool. And then the so additional kind of benchmark things. It's the first model to break 1500 on Elm Arena. Right now we come in at around 1501. It's also doing really, really good at Web Dev Arena. So the new feature that you might have seen in Replit, that's their design feature to build beautiful UIs, is powered by Gemini 3. And you can really, really see a difference in the quality of the apps that get generated with Build and AI Studio. And then it's also kind of state-of-the-art at reasoning and multimodality. It tools use in planning. If you're a Minecraft enthusiast, it's much better at these kind of voxel art experiences. So you can see the difference between Gemini 2.5 Pro and Gemini 3 Pro for these kinds of voxel art demonstrations. Really, really good at making games, including games with interesting game mechanics and kind of beautiful UI. And it feels like we've been talking about it for a while. Would you be down for me to show how to use it in AI Studio as part of our build feature?
Let's build.
Excellent, let's do it. And I think both of us, we were having a conversation at the very beginning, like both of us less of a fan of slides and more of a fan of like showing stuff in action. So like let's show some stuff in action. I also like one last thing though before I pop over. It's currently available in the API, so you just have to change out the model doc string. And then also if you've been using OpenAI as part of your projects, we have something called the OpenAI compatibility layer. Which allows you to swap out a few lines of code. So this API key and base URL, you would just modify it to be your Gemini API key, and you would swap out the model name. But then you would be able to run it with your OpenAI code, hopefully without any changes.
Okay, cool. I've taken up enough of your time, but
No.
I'm going to take up even more. Now
Excellent.
I'm super excited for building.
Cool. Let's do a thing. So let me zoom over to AI Studio. This is the build feature in AI Studio. If you expand out the section on the left, you can see that there's a left-hand pane. You can select the build feature, and then it immediately puts you into kind of this build environment. I'm going to collapse this so there's a little bit more real estate for us to see what's going on. And then basically you can just describe anything you would like to create. You can also see kind of an app gallery with remixable apps, things that the team has created, including a comic book style experience, a product mockup visualization, lots of games and immersive 3D worlds, including like simulation games, which are pretty cool. And you can fork these, remix these, share them with your friends. We'll also show how to share them with Google Cloud in just a second. And then also if you can't think of something to build, if you click I'm feeling lucky, it gives you kind of an out-of-the-box, ready-made app idea that you can incorporate into your projects. But what I've been trying to do is I've been trying to like build increasingly complex apps with the goal of trying to make it so that Gemini can't build it and it has to kind of fix itself along the way. Because we do have an auto-fix step within AI Studio. It's just that it's triggering much less frequently now because the models are getting so good. So I'm going to try to see if we can build something that is sufficiently complex that Gemini will have to fix itself. So let's try this out. Cool. Create an app that uses the webcam and the microphone to have a conversation with a user. The app is intended to be kind of what it should be is kind of like an insurance app. So the user will show a bunch of different objects. The app will sort of catalog all of the objects, like describe them, put down their name, do an assessment of what kind of where the object might have, and then also use Google search grounding to try to ground with how much that item might be worth. The app should put that in a table format, so the user can see all of the objects that they've been cataloging through the duration of the video conversation. The app should also be really well designed. Should show some stats about all of the objects that the user has put down for insurance purposes. And the app should also have like a Nordic theme, so it should feel like very IKEA vibes. And for the video conversation, the app should be using Gemini Live along the way. So that was just like spitballing a whole bunch of information. I'm not sure how well it'll do, but let's try. Yeah, and then so what's happening here is you immediately get put into something that looks like an IDE. If I expand out this thinking section, you can see that Gemini is figuring out what it should be doing. It's figuring out how it should be doing function calls. I said the Gemini Live API, and it's figuring out what model name that should be, figuring out what the structure of the data should be if it's supposed to be cataloging all of these items. You also see kind of some recommendations about what to do with the app here in the center. There's a place up in the right where you can save to a public or private repo on GitHub. And then there's also a place where you can add files if you would like. Add files, so add things like images or text files or PDFs. And as Gemini is working, you can see all of the code getting created along the way, as well as the prompts that are created to give to each one of the models. I love asking Gemini to write the prompts for Gemini just because usually it does a much better job than I can do. All of the files are getting put into this really nice directory structure here in the center. And the nice thing too is that since this experience is baked into AI Studio, it has insight into the latest models, the latest features, what's possible with the APIs. Right now it's generating a React app. You could have also specified Angular. It's using React Native, so you can access all of these apps via mobile phones as well. But this is really, really cool to kind of see and to just have an idea and to figure out how to get it started without you necessarily having to wade through documentation or figuring out which models to use for which experiences. I also go for it.
No, I was just going to say, so you threw your messy thoughts into this thing, and obviously it's very impressive that it's able to not only format your thoughts into something that is a bit more coherent, but also write the code. I think the most impressive part is the name that it came up with, because I know that you didn't specify that.
Yeah, Nordic Shield. So what we see an app. So I'm going to try to see how well this does just out of the box. Hey there. Let's see.
So yeah, that's that little autofix button, I guess. Probably.
Yeah. So it looks like just taking a look at the app itself. Taking a look at the app itself, it was able to hook in the webcam. It even gave me the options of turning on or turning off my video and my camera, or my camera and my audio rather. It created the inventory list, which is pretty cool. It has some condition breakdowns, shows connections. But then it didn't pick up on my audio, which often happens whenever you have multiple audio sessions simultaneously. So I think what it's doing is it's figuring out where it would like which section it would need to figure out to attend to. And then that would trigger the Gemini live call. And so there's a big reasoning trace on the left, which shows kind of like, all right, is the mic on? Is it enabled? How do I toggle the mic? How do I understand the media stream? And then it should be able to understand that as part of the website as well. Yeah, I also I feel like it's a much better design than I would have been able to come up with myself. I also really like that it automatically included instructions. Apparently, this person that the entity that I'm talking to will be called Sven, which is also very Nordic. And we'll see how well it's able to make the changes.
I mean, you did ask for IKEA, so
this is true. You know, like it's and I think one of the nice things too is I started doing machine learning around 2009, so a really long time ago. But I've always been more of like a Python human than a JavaScript or TypeScript human. I built I worked on part of the VS Code team for a while, so I built like VS Code extensions and TypeScript. Like I built small websites, but I would not call myself a TypeScript like expert by any stretch of the imagination. So having this help figure out where the problems might be, where to debug it, how to debug it, like what libraries to include to be part of a modern stack is really, really helpful just for me personally.
Yeah, I was about to say, like, it's quite impressive that it not only recognized that there was an error, it parsed that error, made a reasoning state for you, and allowed you to kind of have some level of interpretability into its thought process, which I think is like so important because obviously if it's doing something that's kind of not what you intended, you can easily like pull the plug, if you will, which doesn't seem like it's the case here, but you never know, right?
100%. I also really, really like if you zoom into the bottom, you can see like warnings, insights into the build process. So rendering start, rendering end, recommendations on what to do to change like the ergonomics and the accessibility of the website itself. So like, hey, this formatting might not show up as well on like a mobile device. And then our design team has also implemented a feature called Annotate. So if you click Annotate app, what you can do is you can circle features, you can add comments. So say things like, I don't make this cataloged items section more attractive or similar. And it's able to kind of take the comments and make changes and modifications to the website the same way as you would work with a designer to kind of do redlining against the UI itself.
This is really nice too, I think, because like it looks like it's still working on trying to fix the bug while you're able to annotate. So you can almost do two things at once: have it like work, and then also have it like annotate your designs or review your designs.
Yeah, and I love also like there are a couple of different agents that we have, or I suppose a few different agents that we have as part of our Google AI stacks right now. So we have Jules, which is an asynchronous agent, Gemini CLI, which is kind of a synchronous agent that you can operate with within a terminal. But it's really, really nice to have a team member go and attempt to accomplish a task and debug it along the way. So let's see. It looks like it's made some changes. I'm going to go ahead and try again. Hey there.
Hello there. I am Sven, your insurance cataloging assistant. Please show me the items one by one, and I will help you catalog them.
What about this?
I see a dark-colored smartphone in a case with a ring grip. It looks to be in good condition. Would you agree with this assessment?
Sure. It's a Pixel 7, but you might also see that it has like some scuffing and like a cracked screen if I turn it around.
Ah, thank you for clarifying. I see the scuffing and cracked screen now when you turn it. Based on this, I would say it has fair condition. Do you agree? Great. I have cataloged the Pixel 7 smartphone. Is there anything else?
What about this?
I see a Diet Dr. Pepper can. It looks like it is in new condition. Shall I add this to your catalog?
Well, how much do you think it would be worth?
I can't estimate value myself. I can only catalog the item with its name, description, and condition. Would you like to add the new Diet Dr. Pepper can? The Diet Dr.
Let's do it. And then also, how about this computer screen that you see in the back?
I see a large screen on the wall with some images and text. It looks to be in good condition. Would you agree? Understood. I have cataloged the computer screen. Is there anything else you would like to catalog today?
Nope, that's it.
Thank you for using Nordic Shield's insurance cataloging service. Have a good day.
Cool. And so you can see, let me zoom out a little bit so folks on the call can see as well. It looks like there were two phases. So as we were talking about these different items, the live API feature showed them on the inventory list. So I gave the item name, the description, the condition, the estimated value. But as part of the estimated value step, there was a second kind of follow-up action that did a search around Google to pull in like what would the estimated value of this thing be. So the live API kind of assistant was just responsible for cataloging, and then after she added an item to the table to the inventory list, that kicked off a second step. So almost like an agent to go search, round up a bunch of different items, and then give us an estimate for how much these things might be worth, which is pretty cool.
Yes.
So it was, and it also added links like citations for those different items as well, which is pretty cool.
Yeah, I think like this is probably one of the nice new things about Gemini 3 or some of the APIs now that allow for these types of models to always be grounded in search, right? I think something like this would be helpful for like decluttering my space. I sell a lot of stuff on Facebook Marketplace. So.
Yeah, excellent. So like, and I think it's also nice to help with kind of detailed descriptions of all of the different items. And then if you wanted to deploy this app via Google Cloud, you could select a different cloud project, click deploy, and it would give you a unique URL with logging and kind of insights into all of the different features that you might be including as part of your project. So if you like, as an example, I'm going to show my personal Google Cloud account. There we go. Excellent. So this is the logging feature in Google AI Studio, where you can see if you turn on logging, all of the different kind of JSON blobs that come in from your app interactions. You can see things like usage and billing, so the number of API errors and requests that you get per day, as well as kind of any rate limits that you might be about to hit. So it looks like I've been using VO3 past my rate limit options for at least the tier that I'm on. And then you can also see the different projects. And right now I have around 85 keys created for generative language client. But it's cool to be able to have a one-stop shop where you can see all of that usage, which is quite nice. And just to give Nano Banana its time in the spotlight and to show a couple of examples that people have built with it, you can do everything from kind of use a Pinterest-style collage of items, compose them into a single image. You can do things like build orthographic blueprints for real-life places. So in this case, a castle, being able to see Neuschwanstein Castle from different views with high reliability for all of the text. You can create detailed physics explainers, and all of this is grounded using tools, including things like grounding with Google Search, which is pretty amazing. You can also change the resolution, so 1K, 2K, or 4K, and then also the aspect ratios as you use these generative media models as part of your project. So it's been really exciting to see what people create, everything from kind of reimagined game experiences to like detailed posters and slides for their papers and their projects and NeurIPS.
Yeah, and I think a lot of the creativity and power, I guess, gets unlocked when you even combine all of these things together. So you can ask Gemini to go and do research for you on, I don't know, skiing areas across North America, across a train line or something like that. Pull all that information, create an image, and then, you know what I've seen people do? Take that image, put it into VO 3.1, and get an animated explainer, which then they can use as a part of the slide or presentation or something like that, which is very cool.
100%. When you combine reasoning with multimodal outputs, like the possibilities are really endless, and it's so much easier to understand things like images or video, I think, than to have people kind of comb through just raw text or raw code. So it's been really exciting to see.
Well, thanks so much for showing all of this to us, Paige. It's been really insightful. I want to switch gears a little bit, and I want to show you one of the projects that I've been working on with Gemini 3. Maybe you can critique me and let me know what I'm doing wrong or what I'm doing and what you think about it. This is my website that I'm using to share resources and articles with people. As I've been making more short form video content online through TikTok, Instagram, YouTube Shorts and such, it's been kind of challenging to find a way to share some of the resources that I talk about with people who are viewing my content. And so you can see here that I have a lot of URLs that I often reference, including Nano Banana Pro, Gemini 3, and so on, but I don't know or have a good way of sharing it. So I created this website. I threw these ideas that I had for a more like doodly, vibrant, pastel-esque, neo-brutalistic, notebook-esque theme into AI Studio, and it created this for me. It's a nice place I can use to like manage all of my content, create new assets for me, save it, and then import it into my videos. The problem is that my previous website obviously doesn't look anything like this. So I thought maybe what I could do is combine Google's new IDE, Anti-Gravity, and Gemini 3 to inherently take advantage of that multimodality that we spoke about earlier, take a screenshot of this new website, feed it into the code from my old website, and see what it comes up with. What do you think?
Yep, let's do it.
Okay, so Paige, here we are in Anti-Gravity, which is meant to be an AI native IDE from Google, and it has Gemini 3 Pro baked right into it. So what I'll probably do is take those two screenshots that I was talking about before and feed them into here and just ask if Anti-Gravity or Gemini 3 Pro can come up with a way of redesigning my site to adhere to this a little bit better. So I'm going to grab those two screenshots. So I'll ask it to recreate this site to adhere to my new design philosophy, which you can see in the included images. So go ahead and run that. And while it's running, I think it's worth noting that obviously Gemini 3 Pro's big job here is to not only interpret what's inside of the image, but kind of break it down into the most notable features that it needs to then go and apply to coding within Anti-Gravity. So while it's doing that, it obviously has explored a little bit already, and it's created this task list here. So explore the existing code base and a little bit more. It'll follow that task list to continue ensuring that it stays grounded and true to that kind of process of development as time goes on. So the next thing it'll do is obviously analyze the new design and then set up the new design system. Yeah, and so the next thing I came up with here is this implementation plan, which I also find to be really nice because through this process, it's creating a bit of documentation, which is nice because down the road, when the code base becomes larger and the AI has to continue sifting through more and more code, it can continue to reference through things it's done in the past. So you can see this implementation plan. It has these actions like new, modify, and so on, and it keeps it from not going off the rails as much.
Awesome.
Paige, have you created anything cool with Nano Banana Pro?
Oh yeah, so with Nano Banana Pro, I've been experimenting quite a bit with different outputs. Let me show one from a little while ago. The quality is just absurd. As an example, I created a bunch of. Let me share screen really quick.
Oh, nice.
I created a bunch of images with popular like physicists and computer science figures like Claude Shannon, Richard Feynman, and Carl Sagan. And then also one of our winning hackathon projects this past weekend was using Nano Banana Pro for its game asset generation. So I'm not sure. Yeah, so they used it for every single one of the game assets as well as the design patterns for the games themselves, which was quite cool. This was at the AI Engineering World's Fair. And how is your website coming along?
So it looks like we're done here. What I'll probably do is pop open my terminal and then run the app, and then we can take a look at what it looks like.
Yep.
Cool, yeah, so Paige, this is what I came up with. You can see here that it actually followed the brand guidelines pretty well. It has these pills that kind of jiggle when you hover over them, and it has like some more information about my resources, prompt library, agent blueprints, and things like that. So I thought it did a pretty good job of just like with one prompt. What do you think?
Oh, it looks awesome.
Thank you, Gemini 3 and Anti-Gravity. I can't wait to continue playing around with this tool.
Very, very cool. I love the kind of attention to detail and the creativity that it puts into these UI designs. I feel like it's better than ever at kind of creating these kinds of experiences.
Paige, it was a pleasure having you on the podcast today. Thanks so much for coming and explaining a little bit more about Gemini 3 and all of the great things that Google launched last week.
Absolutely. Thank you so much for having us. And I loved that we were able to talk about not only just the models themselves, but also how Google's entire AI stack, from the hardware to the compiler to the machine learning framework to our end-to-end app deployments, even things like Anti-Gravity and AI Studio and all of the other surfaces that we have around Google, help make sure that we're building the best possible models for all of these different use cases. It was really fun.
And not to mention all the cool things you can do and deploy them to Google Cloud and have them ready in production. So thanks so much again. I'm Emmett Mirage.
And I'm Paige Bailey.
Powering down.
Hi, everyone, and welcome to The Agent Factory, the podcast that goes beyond the hype and dives into building production-ready AI agents. I'm Smita Cullen.
And I'm Vlad Kolesnikov.
And today we're joined by Brandon Hancock, who is a full-stack engineer and who is also known on YouTube as AI with Brandon, where he teaches AI to over 80,000 developers. Welcome to the show, Brandon.
Hey, Smita. Hey, Vlad. So excited to be here today. Awesome world of everything that's going on right now with AI, and I'm so excited to dive into it with you guys today.
Yes, it is a very special day. We are recording just a few hours after Google released 2 new products. First, our new flagship model, Gemini 3, where we had a lot of anticipation for that. And the surprise, Anti-Gravity, our agentic coding environment with lots of features to explore. And just in general, it's very exciting. And we will show you a few demos of Gemini 3, obviously. Brandon has a very special demo himself with Gemini CLI. And I've got some surprises too.
Awesome. So let's kick it off with Gemini 3 Pro. I've gotten a chance to play with it already, and I've been super impressed. It's really great at advanced high-level reasoning, and also it's able to complete complex tasks really well. Also, it is able to do stuff like agentic operations really well, so it makes it really the ideal model to build AI agents with. And I spent a ton of time already trying to build AI agents with Gemini 3 Pro, and I've been blown away. One thing I've really liked using it in is actually AI Studio. So let me actually hop into AI Studio and showcase what I've been doing. Okay, so I'm in Google AI Studio, and what I've been thinking recently is about building a personal website. I know, I'm DevRel at Google, and I should probably have one, but I don't. So what I've done is actually I took my LinkedIn page and I exported it as a PDF. I also used Nanobanana to create an inspiration picture of what I want my website to look like. And then I'm uploading all of that into build in Google AI Studio to help build out that website. So let me start off by uploading the PDF of my profile from LinkedIn. And then I'm also going to be uploading a profile image of me, so it gets that right. And I'm also going to be uploading that inspiration picture of how that website should be looking like. Okay, help me create a personal portfolio website based on the profile.pdf file, which contains my LinkedIn profile, and then use the inspo.png as inspiration for how the website should look like. And then make sure that you include that profile picture of me as well.
I'm pumped to see how this turns out. I would love to see some of the initial pictures you did with Nanobanana, because seriously, one of the coolest AI image generators I've seen. I would love to see what you did for inspiration, because would love to see how AI takes that input and does something with it.
First, I used Gemini to give me a prompt to give to Nanobanana based on what I would like, and using that prompt, Nanobanana came up with this really nice inspo pic, which is pretty close to the website I'm looking for.
That's awesome.
Look at the speed it's working at. One thing I noticed with Gemini 3 is how fast it is. Yeah, that really makes a difference for me as someone who likes to iterate over and over on the same thing. And yeah, I noticed that it works really fast, despite the fact that so many people are now on it and testing and trying and uploading like huge data pieces on it and just seeing how it performs. Our TPUs must be on fire, right?
And speaking of being on fire, I really love all of these fire suggestions that AI Studio gives. So kind of like, oh, if you want to add video understanding, I can easily try to click this and then add it here, so it becomes the next prompt that I want to add to my website if I wanted to.
Less than 3 minutes in. Oh my god.
Looks pretty cool.
The image is no longer available.
Okay.
See, it's AI. You always need to look what it's done.
I mean, it got all the details right.
I love it. I love it. Look, it really got like, I've been to your LinkedIn page, so I know what's there. It really taught your work experience and email, and yeah, you're a great public speaker, DevRel, machine learning, everything.
Yeah. Okay, let me actually try to fix that image. So, right, what I really like is this annotation feature in Google AI Studio. So I'm going to click this, and it allows you to annotate stuff that is missing. So for example, just this section, and I can say add that section to chat and fix my image with the actual profile picture.
So while that's going real fast, one of the coolest things that I've really liked about AI Studio recently is its ability to single shot. I've tried to test it as much as I can on everything from web applications all the way to senior year of college level math and computer science and electrical engineering. So I test it on the full gambit, and it has crushed it on all levels, all the way from regular software to full blown calculus 3 level math. I know they say smartest model ever. So I was I'm gonna try and test it out, and it is. It really is. Yeah, absolutely been amazed.
I love this image, and see how it also originally it wanted to style it with kind of black and white, yeah, because that's what your initial style was, and it kept that thing. I love it.
Yeah, and then also the fact that I gave that prompt very specifically to just this section, and it didn't change the entire website, because that can happen too. And that's my demo, and this is my website now.
Have you got to try publishing it yet, out of curiosity, in the top right?
Oh yeah, so the cool thing is that I can deploy this super easily to Cloud Run. It's super easy.
Yeah, it just goes straight there, takes a few minutes, and you have your website up and running. You literally don't need any knowledge about Google Cloud or Cloud Run. You click one button.
Oh, sorry, that's just one of the craziest parts, that every time I keep working with more and more these tools from Google, it's the barrier to entry to just build and ship stuff is insane. So in a lot of my communities, there's people who are I've never coded an app before, but I have an idea, and then they'll just hop into any of these tools and actually create something. It's crazy how many more people are now able to build real world apps thanks to these tools. It's always so exciting to see people live for the first time making their own apps. And hey, Smith has got a website now. You can contact me, and and she'll fix it.
Okay, Brandon, you have something really cool to showcase on Gemini CLI for us.
All right, so here's what I wanted to show you guys that I've been working on using a combination of Gemini CLI, and I'm actually going to show it a little bit in TinyGrad, because I'm pumped to show everything all in one. So quick background, guys. So what I'm trying to do now in the age of AI is I want to be AI first for everything I do. I swear there's never enough hours in the day. So what I'm always looking to do is to build out what I'm calling AI employees to help out with tasks in every part of my YouTube business, other businesses. I want AI to do as much as it can, so I have more time to focus on the big things. So what I really want to show in this video with you guys today is how I go about building a market research AI employees. And just super quick background, just so they're on the same page. We have a co-founder, have a startup where we're helping out emergency medical services, so ambulance companies, fire departments. We're basically helping them out with their SOTA reports. So we have a phenomenal idea of exactly who our customer avatar is, but they're all across America. So it's very hard to I could manually spend the rest of the week on Google finding everyone in my state, but we have amazing AI tools that are using Google search, so I could easily at scale kind of search the whole market. So this is what I wanted to break down for you guys today. Basically, I'm pumped to showcase how we can actually use Gemini CLI, which is one of the best CLI tools with having the ability to do Google search, and thanks to the wide variety of models, we have everything from Gemini 3 Pro when we really want to think about it, all the way to Gemini 2.5 Flash when we want to kind of do things at scale. And Gemini CLI, they have a super generous free tier. I think it's 1,000 requests per day completely for free. So that's hey, gotta love free. Long story short, absolutely using Gemini CLI to build out all of my AI employees. And one of the things that I want to walk you guys through is how you actually can do this. How on earth do you build an AI employee? And it's basically just do markdown files. So that's what I want to walk you through. And just a quick challenge for the audience. After you guys kind of get to see all this in action, I would love to challenge you guys to try to build out each week a new AI employee, because as time goes on, by the end of the year, you're gonna have a full-blown workforce of Gemini models running around doing all the work for you guys.
That's awesome.
All right, and real quick, high level, how do we think about building AI employees with Gemini CLI? The way I like to think about it is we have the ability to use multiple models. So here's what we want to do. Just like as Vlad pointed out, we want to kind of build out standard operating procedures, which are instructions, which is awesome because we get to use tools like Gemini 3 Pro, which are these insanely smart models to help write out well-documented instructions, such as hey, please go search the internet. Here's the type of questions we want to look up. Here's the ultimate goal that we're trying to achieve. And these models are phenomenal at writing very specific and clear instructions. then when it comes time to do not the high level thinking, but to actually go into like what I call like worker bee mode, hey, fantastic, we can fall back on some of the more fast, efficient, and more affordable models like Gemini 2.5 Flash to actually go off and follow these instructions. And the coolest part about Gemini CLI is you can actually spin up, like you can really spin up 100 different agents in parallel to search across all America. Like you really have agents at scale. So the core principle of building out AI employees comes down to what these documents include. These are standard operating procedures, where basically we once go through the process and clearly define what our inputs are, what tasks we want to accomplish, and then at the very end, we describe the actual output that we're trying to do. We can use Gemini to go forth and follow these instructions. So what I can say is, I can say, please follow the research, let's actually do this, the research city instructions for, and you can actually, like in my case, I have multiple cities that I want to go look up. So I can go through this process and just like grab a few cities, and I can say for these cities. And then what's really nice is I can actually pass in the cities, and then finally after that, what we want to do to like maximize our agent capabilities is to actually run some Python scripts to actually kick off Gemini in parallel. Because that's one of the coolest parts that I don't know if a lot of people know about Gemini is you can actually kick off Gemini in the normal editor, or you can do something like this where you can pass in a prompt, which is a cheat code because you can basically kick off hundreds of agents in the background using this strategy. So in this case, we have some nice little Python scripts that will go through the process of kicking off Gemini in parallel to actually go off and research everything that I need. So we're going to say use, we'll start with this. We'll say use at process cities. And at this point, what it's going to do is we're now kind of kicking things off to where it's going to go through the process of kicking off multiple parallel agents to go off and search in each one of these different cities in Miami to find potential customers that we could reach out and help with our company. Now, at this point, what's nice is we're actually having AI call a script. So the AI is going to understand the parameters of the script, pass in all the cities, and kick off the workflow. So I know this kind of probably got a little deep in the weeds. Is there any questions? I want to take a high level too, just because I want people to understand that you could pretty much have agents do anything. That's the cool part.
The scripts that you're talking about, is that something you hard coded or Gemini CLI did that for you?
Great question. I don't code anymore, which is the funniest statement as a software engineer. I never code. I review a lot of code, but all I have to do is say, hey, Gemini CLI, what I'm trying to do is I want the ability to give you, and in this case, I want to give you 3 or 4 cities to go off and research. And what I want you to do is run, Gemini-P as a prompt and basically just paste in this type of city right here, or these type of instructions, which is, hey, go research a city, do it for the city, and basically just kick this off 10 times or 20 times, however many cities I give you. So that's all done based on Gemini. But I need a question too.
Not a question, more like a comment. Last time I've been at the podcast, this very podcast, I also used this, what I think is a cheat code of creating a little Python tool and passing it to Gemini. And first, like as a software engineer, even though you don't write it, you have this ability to kind of prompt it properly and guide it to create those scripts and verify whether it's right or not. But the thing I love the most is that you don't have to explain how to use it. You just give code, and Gemini says like, okay, I look at it, this is I think how to use it. 99.9% it's right about it. And even if sometimes it runs it in the wrong way and the tool crashes, it looks at the error, and then the next time it's right.
No, totally.
Code, use it all the time. Yeah.
Yeah. The one other just quick side topic while this is spinning off, when it comes to the concept of building out AI employees, one thing I do want to mention is we basically get to use AI to do everything if it has context of the problem. So for example, I also, just other things, I use Gemini CLI as a ghostwriter to help me respond to emails. So you can easily hook up an MCP server to Gmail, and fantastic. I can just pass in information such as like, hey, here's Brandon's ghostwriter. It knows how to write like me. Can you please go pull down my emails and respond to the latest 3 emails? Because it knows who I am, it knows how I like to write, and it can just kick it off. Outside of that, I have to write monthly status reports. Well, my agents have to write monthly status reports. So key thing is just the more folders you can add into your AI employee directory, you just record the task and then have AI do it the next time. And I do this for, if I'm ever doing something more than once, I can guarantee you AI is doing it for me. So
wait, so was it your ghostwriter responding to all my emails?
No. That's funny. It's human in the loop. I do review it before everything goes out. But I mean, it's the cool part, guys. Like we can now use AI to move faster. Eventually, it's gonna be my agent talking to your agent, and it's just calendar events are gonna appear up on. So hey, we meet tomorrow kind of thing.
This is unreal. Yeah.
So while this is going, I just want to show real fast kind of what's happening, just so we can move on. But at the end of the day, what we're doing is just customer research. So for each one of these cities, you can see it's starting to like save outputs. I won't click on it because it's actually going to show like customer data, but it does a super deep dive into understanding exactly what's happening in that local city, and then kind of just taking the same principles. What we get to do next is once again use standard operating procedures to take in all the information from these different cities. We aggregate it. Sorry, I don't know why it's showing, but we aggregate it into a database, and then after that, we have an outreach SOP that shows exactly how to write personal outreach to each one of our customers to see if they would be interested in working with us. So this is kind of the workflow to where you basically just have the AI document the process and then repeat it at scale going forward. So yeah, just thank you guys for making Gemini CLI work and all the new models. Absolutely having a field day with them.
Automate everything with Gemini, man.
That's the goal.
Okay, so just to recap, we saw Gemini in AI Studio, we saw it in Gemini CLI, which is a great agent, by the way. But do you have another agent you want to showcase with us?
Yes, I will show you an ADK agent, so an agent built with Google's agent development kit. And this agent is made with Veo 3.1, obviously with Gemini, and like I said, with ADK. So what's special about this agent is that it's specifically made to create educational videos. And it doesn't just take like a script and creates a video with a talking head that tells you what's written in the documentation of script. It takes a documentation page that, if you think about documentation for developers, it's full of code, it's full of bullet points, numbered lists, etc. And it creates a somewhat engaging video where, in this case, one of my favorite animals, capybara, is telling you the story. So the agent itself actually consists of multiple sub-agents, right? Like we love it about ADK. It gets this boss orchestrator, or the root agent, that works with 2 sub-agents. One is the script sequencer. The script sequencer does 2 important jobs. First, it adapts the script. So when we start with the documentation page, we want the text and that story to sound natural and engaging. So it does the adaptation for the capybara for our character to sound natural and to not read you bullet points, like many speakers do presentations. Second thing it does, it makes sure that those sentences they're split in 8-second pieces. And it's very important because video models, they don't produce very long videos. They produce short pieces, and we want again those to sound natural and have nice transitions. And that's the second job that script sequencer had. Once that is done,
it passes those sequences, those chunks, back to the orchestrator, and the orchestrator calls video agent to generate videos. One important thing, and you probably saw it when I was scrolling, is that for the video generation, I use NanoBanana to generate multiple views of my character. Right? I've got 4 views, and I ask the orchestrator to randomly choose a view for every video that it creates. And when I pass a script, along with the chunking, it assigns a view number to every chunk. So the video is not just like a monotonic talking head in the same kind of think about this number 1 position, but it goes randomly between views so the video stays engaging. Even if you use it like as a small window in a larger presentation, you want some changes for that, and that actually makes a big difference. Along with that, I provide examples of prompts, how they should be and should sound. And if you look at this prompt, you will see how I provide very detailed character description and voice description and the visual appearance of the character. This is all very important for those videos to be consistent, even though we have those initial pictures, the start frame for the videos. Why? Because take this view number 2. If the view number 2 zooms out a bit, we want the clothing and the other parts of the body of Capybara to look the same as a view that starts as a video that starts with number 4. So those pieces are important. And as you know, the video models, they sort of like work without context. They don't know what the other videos it just made. So all those instructions are extremely important for character consistency and environment consistency for that matter. So basically what I do is I pass this whole prompt with the script. I pass those 4 views that I generated using NanoBanana, and then it goes through the sequencing and through calling video agent and the video generation agent. And you can see that every time it generates a piece, it says like, oh, video number 1, this is the link, and this is the piece of the script that it's going through. And we can scroll down and see that it generated 92 videos for me. It again automate everything. I got the list of all 92 URLs. It still requires human in the loop. Let's be honest. Like the videos that sometimes not perfect. So I personally watched every single 8-second video, and then I didn't like some videos. I didn't like video number 49 because there was some like weird glitch that you made, and I have to regenerate it. It regenerated it, and I didn't like it again because it sounded weird. And it asked to regenerate it again, maybe just like use different view number. And it did it again, and I got those all those views. And then what I did next is I used Gemini CLI to join those videos together. Right? Again, all I did, I just like copied this list and I copied it to a file. I asked Gemini CLI use FFmpeg to join videos together, and here it did it. Let me switch to my IDE.
That has to be some sort of like video editing hack to use Gemini CLI to splice together all of your videos.
Yep. So this is my anti-gravity, and I'm actually working on another version of this agent. You can notice that I have script adaptation and script slitter as different agents. Stay tuned for that release. But I just wanted to show you like the kind of the structure of the agent. I have this main agent with a huge prompt, how like it should treat the results of different sub agents and how it should actually instruct them. And I was adding that human in the loop moment when I wanted to wait after the script adaptation and let me sort of like make edits in the script. What else? Yeah, and to make those changes, actually, that's why I wanted to show it. I use anti-gravity, so I just opened the previous version of this agent that I built using just Gemini CLI, and I asked anti-gravity, this is what I want to add. And yeah, it did all the work for me. It adjusted the prompts, it removed all prompts, it made changes in the agent itself and sub agents. I'm super pumped, and I just see how it improves my productivity, primarily because that's the first time I'm seeing it. I prefer working in IDEs over CLIs. You're probably all like waiting for that video and to see how it goes and what it shows and how Capybara speaks. So let me just show the result to you. So let me roll the video. It's, as you see, it's 11+ minutes. I'll probably just give you like 1 minute to listen to, and then yeah, everyone can listen to the entire video, which is a part of the repository that's on GitHub.
Hi, I'm Anya Cappy. Today, we will talk about safety and security for AI agents. As AI agents grow in capability, ensuring they operate safely and securely is paramount. It's crucial they align with your brand values to avoid posing risks to your reputation. Uncontrolled agents can execute misaligned actions, leak data, or generate inappropriate content. Key sources of risk include vague instructions, model hallucination, and prompt injections.
I would watch a coding tutorial from Anya the Capybara easily on YouTube.
It's so funny. I couldn't stop watching. Like my brain's like, I'm hearing security from an animal. I'm like, it's a pattern error. Like you can't help but watch it. But that was awesome.
I'm glad you liked it.
Okay, so we've covered so much. This was such an exciting episode. Thank you, Brandon, for coming on and showcasing your demo and having this wonderful conversation with us on such an exciting day.
Seriously, thank you, Samantha. Thank you, Vlad. I've been a little kid in a candy shop playing with all these new models from Gemini, anti-gravity. So seriously, thank you guys for having me on today. And also, I'm going to be checking out that Capybara example right after this. So thank you for sharing as well, Vlad.
Thank you for joining us for today's episode. I hope you enjoyed it. Please join us for the next episode. Until then, keep your agent smart. And are you ready? Powering down.
Hey everyone, how's it going? My name's Lenny Patrick. I'm on the Google DeepMind team. Welcome back to Release Notes. Today we're joined by Tulsi Doshi, who's the product lead for actually more than just Gemini models. All models now inside of
Gen AI
models inside of DeepMind, and Josh Woodward, who leads product for AI Studio, Gemini app, and Google Labs, so the whole suite of DeepMind's and actually more than DeepMind's product services. Tulsi, Josh, we're sitting here because of Gemini 3.0, and we're sort of entering the Gemini 3 era. Do you want to give us a sort of high level of the exciting headlines for this model launch?
Yeah, we're super excited about this model launch. So we're releasing Gemini 3 Preview. We're releasing it in a wide range of surfaces, and Josh can talk more about what that looks like. But I think the reason we're doing that is because we're seeing this model really be this step change in terms of what you can do with it and what you can build. And so a couple things that we're really excited about. I mean, one, the model is just state of the art when you think about reasoning and its depth and its nuance, its ability to kind of take simple prompts and actually turn that into extremely rich outputs. So that's, I think, one starting point. Its multimodal understanding is also incredible. So I think one of the things I'm really excited about is its video understanding, its image understanding, its ability to actually go deeper between the context of your text and the images, and then combine that with its abilities in coding, for example, to actually create just really cool outcomes, I think is awesome, right? That ties then to like, it's an amazing vibe coding model. It's also our best model yet for agentic use cases and tools and agentic coding. So there's like a whole step change we're bringing in that regard. And then I think lastly, one of the things we always look at with Gemini is we're trying to build well-rounded models. So we want to build models that are actually really smart, which this model is, but also models that we think are going to be really good for users in our products. And so this model crosses the 1500 ELO on Ella Marina, which I think it's 1501, which is awesome. And
that one matters.
That one matters. And but I think like we use that as kind of a measure of well-roundedness, of like the usability, the accessibility of the model from like a stylistic standpoint. And I think that's something we're also seeing in some of our testing in the products as well. And so I think the combination of all of those things means this model is going to be really awesome for this tagline we're using, bringing anything to life, because you actually can now take these different modalities and formats and use them to build really cool things.
Yeah, I mean, I think I just add, there's one thing for a model to be awesome on the leaderboards, which this one is, but when you get your hands on it, it's going to be, you're just going to love it. Yeah, it's really good. We're putting it in the most surfaces we've ever done on day one. So we're going to basically crack it on in the morning, get up, put it in the Gemini app. It's going to go into AI mode. That's for all the sort of consumer use cases. Developers will be able to get it at the same time. AI Studio, it's going into Vertex. There's a new sort of coding product we're putting out called Google Anti-Gravity. It'll be there too. So it's just going to be everywhere. And we can't wait for people to try it out, give us feedback.
Yeah. And I think actually like on the where it's going to be everywhere, one of the cool things with Gemini 3 is this time we've actually partnered really closely with a lot of customers externally.
Yep.
So I think this is one of those times where we actually have a lot of partners outside of Google also who are going to be shipping the model tomorrow and who have been working with us to give us feedback and help us make the model better. And so that's also exciting. It's not just that our products are going to be scaling this model. It's hopefully broadly we're going to be scaling this model, which is really cool.
Yeah, I love the meet the world, meet developers in my world, like meet the world where they are, and like all these products, and like people don't just use Google products, so putting the models out there and getting them in their hands is super important. There's an interesting thread actually on this product story, and we were just talking to Corey before this about sort of like the partnership between DeepMind and like the PAs and all this stuff. And I'm curious, Tulsi and actually Josh as well, from a DeepMind collaboration, like how much as we sim ship across the services, like the perspective of those products matters more and sort of influences the models. And also like, is that like a net? Is it like just harder? Is it more constrained? So like, does that actually help us in like, hey, we need this model to be really great for search, and that's pushing us in this dimension, which then skews the model capability in some positive way that we don't, or is it really just like more juggling of all the constraints?
I think it's both things. I mean, I will say, Josh, tell me I'm wrong. I think it's been the strongest partnership we've had in terms of getting a model into the hands of the product, in terms of the feedback loops that we've had with the product teams. Because I think now, we have actually a user base who's using our models regularly that we can get feedback from, that we can run live experiments, that we can actually, solicit feedback from. And that is actually really huge, right? Because then we can bring that feedback back into the model. And I think you're right, like there are constraints, right? So the kinds of things that developers are looking for may not be the same things that are important for the app, which are also not necessarily the same things that are important for AI mode. And so it is a bit of a tension game we're playing between all these moving pieces. And I think that's hard from the model side. But actually, like as a PM and as someone who's like trying to think about this holistically, it's awesome because we're now getting the feedback to be able to actually have real conversations about those trade-offs, right? To be able to say, okay, the model is now going to do this really well, but at this cost. Are we okay with that? And what are the trade-offs? I think that's been really good. And I think this time around we've had a bunch of hard conversations actually.
I don't know if we can share. Like, is there a specific like I was in a code?
I got one. Okay. So some of the viewers may have seen we've been testing this model kind of in the wild silently. And yeah, go to Candace. It's just there one morning. Oh, that was a mistake. But you kind of an early rev of the model. We were really interested in kind of trying to optimize some aspects of persona. And I remember there was one rev we really liked on that one dimension, but it regressed on a whole bunch of other dimensions. And so that'd be an example where we've got really positive feedback. But like Tulsi, we're trying to make this a well-rounded model. And so if it's great personality, but it's like forgets how to do tool calls, for example. So these are kind of the revs to revs that we looked at together. And I would say I think one of the things we're really excited for people to try it out is because I think we're now getting the product model feedback loops working really well. And so when people are giving feedback in any of these products, it's now just like seamlessly starting to like flow back in, and that's really exciting too, because you can see the quality gains happen when we do these kind of blind tests side by side.
And it's kind of awesome because even something like we say tool use as like a broad phrase, but even the way that tools are being used in the Gemini app is a very different construct than like how a developer might use tools in a very different context or product, or like how Anti-Gravity expects tool use to work. And so I think now that we actually have these different product surfaces that we're getting feedback from, we're actually able to see those differences and those trade-offs. And I think that also allows us to actually have a much more holistic understanding of what do we mean when we say tool use, or what do we mean when we say code performance, or what do we mean when we say creative writing abilities or something like that.
Yeah, I think the product scaffolding sort of grounds a bunch of those capability conversations in a way that is like really, you have to like proxy with some of the academic benchmarks, which are oftentimes like actually not representative of how users actually use the models in certain cases, which is tough. But and you both alluded to this. I'm curious when, and this was sort of I get all the tweets of why we're not shipping Gemini 3 earlier. We're going to start just sending them to you too. And sort of, and like I think it gets at a broader conversation of like when obviously Gemini 3 is out the door now at the time of this conversation being released, but like when was the moment where we knew like, hey, this is the model we want to get out the door? Obviously we've been doing tons of this iteration, but yeah, is there a way we can ship faster? Is there why not ship earlier? Like in the past, we've done these like crazy experimental checkpoints. We've gotten tons of feedback, both positive and negative in a lot of cases. So I'm curious what the balance.
Calculus was there. Yeah, I mean, we do want to ship fast, and I think that's actually super important to keep alive. Like I think this whole idea of relentless shipping, put things in the hands of users as soon as possible, get feedback as soon as possible. I think that we want that to continue to be the theme, and we want that to be the theme across all of our models, not even just like Gemini Pro, for example. I think in terms of this model in particular, one of the things we really wanted to focus on was its kind of real world usability. So real world usability both in our products, but also with developers, and that means actually getting a lot of feedback and actually iterating on that feedback. And so we spent a period of time putting the model in the product. To Josh's point about the persona discussion we had, we put the model in the hands of customers, and then we basically use that to also help us calibrate. Okay, where's the model meeting our expectations? Where like it matches what we are seeing internally. Where's the model not necessarily meeting those expectations, and how might we want to adapt it? And so we had kind of quality goals and bars for ourselves that we wanted to meet on our benchmarks, but also on like how we work in the products, what kinds of experiences we want to create with the model. And so it's all kind of working towards that. I still think the goal is like ship it as soon as possible within the constraints of that realm of things. But it's about like making sure that it hits those goals. And I think now from previous models we set, we're actually setting more complex goals for ourselves. So every time we release one of these models, we're setting the bar higher for ourselves. That also means that meeting that bar is harder, I think.
Yeah. I mean, the thing I would add, I feel like the speed is great because when a model comes, we measure in like days and hours. So it's actually so like just get the minutes. Maybe that's the goal. But I mean, I think some of the turnaround on this is just amazing, and the team's working across either the developer side or the consumer app side, the modeling side. Obviously, it really is just seeing I think out in the world the momentum like a compounding, and so I think it'll get faster. But at this point, we're kind of like days, hours, and then we go hours, minutes. That's the next jump.
For both of you, what was that moment? And Josh, maybe you start with this one that like you tried one of the Gemini 3 checkpoints and sort of the use case or the demo that clicked. Was there any of them that like you sort of saw this and you're like, this is clearly a step change? And I'm happy to give mine as well.
Yeah, we should go around. I got a few of these. I think this one's really good at vibe coding. It's very good at web devs, and you can just describe something, it's in your head, hit a button, it's there, and that is kind of crazy sort of compression of time and skill and expertise. So that was one. I'm really excited about the multimodal capabilities too. We're doing some stuff. We're kind of both on the Gemini side and the Google Lab side. We're really caught up in the how you can transform content, and this model's very good at that. Better than I've ever seen. So those would be two off the top of my head.
What are some examples of the transforming content piece? Like is this?
Yeah, I mean, say you're a student, you've got a whole bunch of like video lectures, handwritten notes, any of that, just load it in, hit a button, it goes. Anything around like I'm very excited about also kind of visual formats. We're starting to play around a lot with that. There's an experimental feature we're putting in the Gemini app where literally you can sort of describe something or make an interactive website for you on the fly.
And so, that's not Canvas though.
It's kind of built its own little thing. And I think to me that's a whole new frontier with these models. We're calling it generative interfaces on the team. But this idea of just pixels are streamed in as they're ready based on your prompt, and I think that's a whole leap. We've never been able to do that before. So that's now possible. Still a little slow right now. That's why we have this labs feature. But I hope people play around with it a lot because we're doing experiments where it's like give like the history of Van Gogh's life by period with example artwork, and it'll just build a whole timeline and just let you go through it, and it's all just generated. Pretty amazing.
That is crazy. You'll see.
3 examples from my side. One is I do think the vibe coding piece really does hit, and I think it does because the visuals are so rich and the interactivity is so rich. And so I was using it literally to create like a fun game to play with my niece with like a single prompt, what you can get, but like her ability to actually engage with it. I think that kind of fidelity of the experience we haven't been able to see before, and that I think really hits home.
We're using AI Studio.
I'm using AI Studio. Fear not. The second one that I think is really interesting is actually one of the things we don't talk much about this model is its multilinguality is also really good. So its ability to write in like Hindi or actually in Gujarati, which is like not as common a language, but it's like from the western part of India, which is what my family speaks. That is also really strong, and I think that was another wow moment for me, which is like, oh, this model is really good, and it's actually able to do something that I personally struggle with, in terms of daily life that I would actually really love to see kind of play out. And then the third is my husband is a very avid pickleball player, but the like video understanding of the model and its ability to kind of break down a video and like break down a set of moves and actually like give you critical feedback. I think it's like all 3 of these examples are basically combinations of the model being able to understand something that maybe you by yourself either struggle to do or it's harder to do or just requires a lot more focus and attention, and the model is able to pull out some of those nuances and actually like help you with them in a much like richer kind of way. And yeah, I think it's been awesome. Also, I will say like the vibes of the model, even in terms of like the style in which it responds, it feels different than other models. It feels smart, and I think that also stands out when you engage with it.
I think the one other thing I would add to, you said it, is like to me we're getting to a point in Gemini 3 where it's like the combination of a lot of these things is really starting to show and differentiate. So like when you go back, Gemini 1, long context, Gemini 2, more modalities, some of the coding started coming in, 2.5 even more coding. Now we're kind of in like agent tool use. It's all starting to kind of almost like ladder and sort of build on itself. And I think that's what we're starting to feel. At least I'm feeling on the team. Is like there aren't these little isolated model features anymore. It's actually like a combination that starts to get really interesting. I think we saw this even a few months ago where you kind of take something as like put it together. So to me this is like Gemini 3 gives us a huge foundation of sort of things we can combine in new ways. And that's where you get like multimodal and vibe coding. Suddenly you've got some really interesting interactive thing. That just before wasn't really possible, that easy to do.
Well, there's this cool demo someone on the team built. I think we're actually using it in the materials where they took a picture of a handwritten recipe in Korean and then turned it into like a full vibe coded like family recipe app in English with the measurements where you could adapt them for like different. You could switch. And like again, that's a great example of like a combination of like it has strong multilingual capabilities. It has strong multimodal understanding. So you can literally take a picture of a handwritten recipe in Korean. You can then get a fully fledged like interactive app on the other side that you can actually use in your day-to-day life. Like that combination of things is really cool.
Yeah, I feel like this gives so much credence to the bring anything to life narrative. I'm like maybe that's the Gemini long-term. Like, do we have a Gemini model slogan? Like, I know there's a Gemini app like the 3 Ps and all the research to reality stuff. Do we have one? Maybe we should have right now. Bring anything to life is the new Gemini.
We are in for Gemini 3. I think that is for all practical purposes the slogan.
And I think it's cool is you talk about that example with the recipes and handwritten Korean and everything. In some ways it's mind-blowing, but in other ways it's like, yeah, this is how it should work. Yeah. Think about kind of the boundaries and sort of human-computer interaction. I think Gemini 3 like blurs those even more in a way we've never done before. It's cool.
Yeah.
What was yours?
Oh, yeah, that's a good question. Mine was Josh, we were in Arizona, and I spent like all day making demos with 2.5 Pro, and I was like, gosh, 2.5 Pro is such a good model. And then I was like, wait, I should probably try these with the new checkpoints. And then it was just like, I was like, okay, this thing's incredible. Like, especially like it was like very front and center in my mind, like this was the limitation of 2.5. There's these cases where I was just, and I could just like see automatically. And then I had an interaction where I was dealing with someone. They're like, hey, try to make this random game, and it was like a RPG sort of like fishing game, and it just like one-shotted it. And then I went and Demis worked on some of the original Sim roller coaster type, not roller coaster, like SimCity 1984 or something like that. Sort of tried to remake a game like that, and it just worked using one of the earlier checkpoints. And then again with some of the most recent checkpoints, and it blows my mind. I think the video game example feels so pertinent because there's so many people who like learn. It feels top of mind for me. So many people who try to learn computer science with the end goal of like building games because it's just fun interactive thing. Like building games actually sucks and it's not fun in a lot of cases. And I feel like Gemini 3 has this power to like help people bring the thing that they want to life.
You know what's actually awesome is we use Gemini 3. So YouTube has this notion of playables, right, where you can go to YouTube and play a game. And we actually use Gemini 3. Well, by we I mean Dishan, who's awesome and does incredible things. He actually used Gemini 3 to build a bunch of YouTube playables that we actually are going live on Tuesday with the model. And they're awesome and they're like so fun to play. And I think like just the idea that you can create this like vast set of creators who can actually build these types of interactive experiences is really awesome. But yeah, I think it was after your Arizona trip where you pinged me, were like, we gotta ship this. It's awesome.
It felt like I think if you spend time with the models all the time, like it's just so clear that 3.0 is or 3 is just a step change. So it's exciting. The SVG art people influence our decisions like checkpoints use.
Actually, it's really funny because we did after seeing some of that feedback come through, we legitimately like maybe a week or 2 ago like sat down and had a bunch of people try across our different checkpoints, SVG art, just because we're like, is it really that different checkpoint to checkpoint? Like, are we really seeing one checkpoint be like so much better at this than another based on kind of the Twitter feedback?
Is there a good benchmark for SVG art? No,
not really. No. But I think the other thing is like it is a very narrow sliver of how the model operates, right? And I think what's interesting is also one, whether something is cool from an SVG art perspective is like very much up to some interpretation, right? 2, I think we found is that some are really good at certain types of things and others checkpoints are really good at other things, but it's not like universal. Like all SVG art one is really good and the other one was really not good kind of thing. So it's very like mixed feedback in terms of what we were also getting from people.
I had to go do a bunch of research to learn more about SVG art because people were showing some of the demos and I was like, I had no idea that SVGs could move. I was like, they're like showing like fully animated sequences. And I was like, I thought SVGs were just static images, but they're like a programmatic representation of them, which is also the thing that is most surprising to me is like I get that it's like I assume it's like the underlying code capability that as it improves it sort of pushes sort of SVG ability, but then you look at what is actually being outputted and it's like the SVG representation is actually just a bunch of like random numbers and letters, which I'm like is crazy but the model is actually able to like pick up and learn. Like I can kind of intuitively understand how the model learns to code because it's English basically and a representation of this structured thinking. But
I mean this is kind of 2 in some ways, right? It's just more I think like it also reflects the model's ability to like reason about how something will manifest in 2 dimensions, right? Because it's able to actually take your concept, right? So like I want to generate a span and I want it to look realistic and things like that and actually translate that into those numbers and letters, right? That actually reflect the colors and the points in like X and Y axis.
Buttons to turn it up and down, right? Like, they get fully interactive. It's cool.
It is cool. Are there any other examples of like things that we saw from early our internal tests or external testing that like sort of we all of a sudden were like, hey, we actually maybe do want to track that because that would be an interesting use case that I think SVG was one of those. Like the voxel stuff has been around for a while.
Voxel stuff, yeah.
Cool.
I'm trying to think.
We've been tracking a lot on the app side. A lot. There's not official benchmark for this either, but like emoji usage, how concise our model is. So sometimes we've been a long-winded Gemini model. You'll notice with 3 that we're like much tighter. Since it picks up on the subtleties, sort of the way it writes. So there's a whole set of kind of persona style, kind of house style things that we've definitely been monitoring with the various checkpoints that the viewers have probably been seeing out there. So that's definitely something we're looking at.
Yeah, it's also been interesting because persona and like style is so subjective, and so that's when writing feedback actually really does make a huge difference because my perspective on what good persona is probably very different than both of yours in terms of like what I want to interact with, right? And so I think that's one that like really stands out. But that one we were also tracking even before like social feedback, right? It's one that we were kind of really trying to monitor ourselves and kind of keep a pulse on. Games is something we knew was exciting. To your point, like we knew that like games is a rich thing that you can build. But I think when you put these models out and you start to see what people do, you start to really see the magic of what people create, the range of what people can create, and then that I think inspires a set of like demos, but it also inspires a set of like just people to go start exploring and building something. And I think that also is like a really nice feedback loop too.
Yeah, I have a meta question, which is I think the last time all 3 of us were sitting down for this type of we need to sit down more and do these more often, but was IO a few like 6 months ago, which is crazy. And to see like it is very my like meta step back take is like it's just crazy
how the model capabilities continue to improve, and it just like works. Like it just makes like
2.5, when 2.5 launched, like, you know, it had its challenges, and hopefully we addressed a bunch of the things that people had feedback on and sort of built on things that people really liked about 2.5. But 3.0 just makes it look so, like, makes it look like a goofy play example, and it's just kind of weird. I'm curious, like, how both of you think about that as you take a step back, but also, like, you know, when we make the next, like, it's just crazy to me to project forward, like, we'll make another step change that will make this model now that we're sitting here so impressed by, and hopefully everyone else is impressed by, feel like kind of a goofy toy in you know, 6 months or something like that.
Yeah, no pressure.
No pressure.
I mean, I think about this a lot. People talk about AI time and how like 6 months of normal time translate to AI time. But it is crazy. We were like outside Shoreline Amphitheater chatting like this, and it was a very good model. Still is very good model. It's like, you know, incredibly 2.5 Pro is like incredible. Here we are. It's like every week we're shipping. So in some ways that's why it probably does feel like forever ago.
I think it's also interesting because like we were talking about this too. Is it puts actually more pressure, not the right word because that sounds negative, I think, but it puts more intentionality on like the model product story together. Because like as you have these models that can do cooler and cooler and cooler things, yeah, you can talk about that through the benchmarks, and you know we obviously want the developer community to explore things, and they will come up with amazing use cases as always. But it also puts I think a lot of pressure on us to come up with like how can we really take advantage of the strengths of this model to really build amazing things for users. And it's interesting coming from like, you know, you typically talk about you want to start with where the user is and the user's needs and then work backwards to build a product. You obviously still want to do that. You still want to focus on where users can get a lot of value, but you also want to also start from what the model can do and what kind of unique capabilities it has and then what can that empower for users.
Yeah, both ways.
Both ways.
Yeah, yeah.
And I think like that was actually easier conversation to have when the models were a little less capable because the range of what they could do was smaller, and so they kind of fit into your like, okay, yeah, these are like clearly things you want to build. And now I think it's also pushing for more creativity of like, okay, now that the model has this range, what can you build?
Yeah, Josh, that's great. We talk about doing stuff. Like, there's a bunch of new. It's not just, you know, Gemini 3 sticking it into the existing Gemini app. Like, there's a bunch of new products. So maybe we actually talk about that as this through line.
Yeah, I mean, there's a few things coming. I'm excited about. One, across Gemini and Search AI mode, there's gonna be a whole wave of kind of generative interfaces, generative UI.
And just how is this different for folks who have like seen vibe coding stuff? Is that similar? So like the model is generating code, and then there's like function calling kind of things. Or can you give like a little bit more detail of like the user who hasn't seen this before? How does it work? What should they expect?
Yeah, so the shift we're starting to see, and this is really the frontier at the beginning of it, is in the past, some engineer here in the building would have coded the UI. It would have been one way for all users until it got changed. And what we're seeing now with Gemini 3 is it can actually make a lot of those design and implementation choices on its own. So a big shift. So you may do a query like, hey, I'm planning an upcoming trip, give me a 3-day itinerary. You know, up until Gemini 3, we would have responded with a wall of text with some pictures. Now the model is going to respond obviously more concise, like we talked about, but it's also going to lay out the page. And so at a practical level, sometimes we do that with actually saying, here's a tool call, give me this tool that's going to lay out, I don't know, carousel I can scroll through. Other times what it's going to do is actually almost act like a design agent and be like, I'm going to go through a design process and think about what's the best way to present a 3-day trip to Rome. And so it may lay out a table and may give you kind of something almost like a magazine style layout. And all of this we're kind of experimenting right now, like how much can we sort of trust the model to lay this stuff out. So it's super cool because you're giving the model widgets, a style sheet, different tools it can use, and you're kind of saying, go wild model. And so I think for a lot of people, what they're going to feel is, oh, this is a much more visual, kind of immersive, interactive, but also kind of customized to me sort of view. And I think that's what's exciting, is like it's just the beginning of that. And so I think if we look ahead throughout the Gemini 3 series as well as 3.5 and beyond, this idea of the models being able to kind of compose more and more things feels like an interesting theme to kind of explore.
It's also like, you know, Josh mentioned widgets. Like I have this like particularly fun example for myself, at least on AI mode, which is, you know, if you ask in AI mode of Gemini 3 about bubble sort, right, which is like just a very sort of standard notion of how you can sort you know, elements in a series. It actually creates this like interactive widget that you can play with and see like how things actually get ordered and how bubble sort works.
The real question is, why were you googling how to?
Yeah, the question.
You're preparing for like a coding interview somewhere. Like, Joe,
but I think the reason it's fun is because I like have this like, it's, you know, credit to Madhvi, who is you know, one of our coworkers who was showing me this example. But it's like it's kind of a blast from the past if you remember like when you're learning about these things, you're learning about them from like static like textbooks, right? And you're trying to like take the written notation and like map it and be like, okay, like, let me try to visualize it, like let me try to write it out, like okay, now it makes sense, versus being able to actually see it and play with it and reflect on that in the context of how you search. Like it really feels like we're bringing the Google mission to life, you know, to like make information universally accessible and useful. Like it's that kind of.
Gemini 3 brings the Google mission to life. Not only like even the Google mission is coming to life. That's awesome. Josh, other things, GenUI in AI review or in AI mode and the Gemini app. Other things in Gemini.
We're also trying to explore some new features around how Gemini can act as an agent for you. So you've seen probably the last month or so we put out a new API computer use, which is really cool. This Gemini 3 model takes it kind of one level even beyond how we think about multi-step actions, being able to take sort of different tool calls and just do stuff for you. So the Gemini app's gonna have an agent, an experimental feature. It's interesting. You can go in and say things like create to-do list out of everything in my inbox. If you're behind like me on my inbox, and it'll sort of give you this bird's eye view and be like, let you add stuff directly to Google Calendar.
So yeah, what's been your personal feel? Like I have a very high bar for this inbox use case, and what's your sense is like it's working and hitting out of the park? Or like what's my expectation be for how good it is at doing some of these inbox tasks?
I think you should give it a try. See what you think. I think that was actually approaching like starting to get pretty useful for tasks, I would say. The other one we're seeing a lot is kind of helping people do research across a lot of disparate things. So you could do this kind of through a deep research path and get a report, or you can try this agent and it'll actually start trying to do things for you. And if it's not sure, it'll actually pause and say, hey Logan, before I send this message, before I click this buy button, do you want me to do this? So I think that will roll out to all of our Ultra Plan members on launch day, which we're excited, and we'll kind of take it from there as we go. It builds on a lot of the stuff we worked on together, going all the way back to Project Mariner almost a year ago. That was some of our first forays into this, and there's still a ways to go. But we're really excited. This is one we're really excited to see feedback.
Is that how the inbox one is working as well? It's like actually like it's like actuating a browser, and or is that like using a bunch of like tool use to send requests to like the Gmail API?
Before that, yeah. So in this case, if you go into Gemini and connect Gmail, which a lot of people do, it'll start doing kind of tool use and API calls in the background, and then Gemini 3 kind of oversees that and orchestrates it for you. So there'll be a lot there. I think it's like exciting to keep exploring as we kind of push forward ahead too.
Yeah, I love that. Any proactivity stuff? I know just we talked about personal and powerful implicitly so far. Is there anything like on the horizon from a proactivity standpoint? Which is this is my number one feature request. If I can get the Gemini app to just look at my email for me and look at see all the tasks I need to be doing, that would be my ideal case because I don't want it's just too stressful to look at all my. I'm like I already have chats and
shared pain here. I guess I'd say watch this space. Okay. Yeah, we're very interested in this. Right now, we're starting to see a lot of people use kind of scheduled actions in Gemini. That's kind of a proactive way to engage. But we think there's a lot to do here. And I think some of the things we talked about combining different modalities, letting people hook up different Google apps, kind of bring some of that together to orchestrate. Stay tuned.
I'm excited. I will be staying tuned. I love when people say watch this space because I'm like where do I watch this? Gemini.google.com. Perfect. It feels like one of the big constraints of like actually bringing the model and letting the world experience how it can bring anything to life is like we need crazy amounts of compute because the demand is so. It's not even like we don't have lots of compute, just the demand curve is like this. So, you know, can't build physical compute that fast in 6 months. So I'm curious like for the Gemini app and maybe more broadly across other products in your scope, like how are you thinking about the balance from also from a user perspective, like where we're allocating compute because we think there's value for different use cases?
Yeah, it's super hard. I would say like we could share some of our stories like a Friday before lunch. I mean, I don't know what's harder, solving AGI or solving puzzle compute. But I think like what makes it hard, and you hit on this, Logan, is like there's just demand everywhere. And so that's one thing. Love this product. And so we're able to find.
Yeah, and the real problem is we keep making
probably the most exciting.
It is a good deal. Storage. A year plus, a year and a half ago, which I think put Gemini on the map and sort of pushed the creative frontier. When we're working on Gemini 3 Flash and all the other models, like give a sense of like when we get some more models. And
yeah, this is my turn to say watch this space, but yeah, including the app. But actually, I think so. We definitely want to build out the Gemini 3 family. So I think Pro is just the beginning of this, and like we're already, I think, very excited about the direction we're going with Flash and where we're going to be with the rest of the Gemini 3 models. I think the reason for sort of shipping them in sequence instead of like bundling them all together and trying to ship them all as one package which is one, when you ship one of these models, you get to learn a lot about how people are using them. And so you get to learn a lot about like, okay, where is repro really resonating? Where do you think it was going to resonate versus where people are resonating with it? Where are we seeing people say, hey, actually, like this is too expensive for my use case, or it's too slow for my use case, or I might actually need something different, which then influences what you do for Flash, right? because Flash is meant to be the workhorse model, we want to make sure we kind of account for those pieces when we're building that. And so I think actually shipping them in sequence kind of allows us to like learn from one and build to the other. I think it's also part of the relentless shipping exercise, right? If you want to ship quickly, you want to actually like, put these models out there and see what people do with them and get feedback. So yeah, but there will be some exciting stuff coming.
Thank you both. This was an awesome conversation. Thank you both for the hard work of pushing together the model and modeling all the products. I feel like folks are going to enjoy the moment. So hopefully we'll be sitting here for I/O maybe sooner next year and watching other cool models. So thank you both.
Thank you. Enjoy it.
Yeah.
That's been great.
And thanks everyone for watching Release Notes. We'll see you in the next episode. Hey everyone, welcome back to Release Notes. My name is PyTorch. I'm on the Google DeepMind team. Today we're talking about Nano Banana Pro. We're here in Mountain View with Robin, Elin, Abhishek, Sherry, folks from the Nano Banana team, the Gemini image team. I don't know what our internal code name is for the team because there's 50 different names. But yeah, the sort of high-level news is we launched the Nano Banana Pro model built on top of Gemini 3 Pro, which was super exciting. Obviously, folks loved the original Nano Banana model. You got the swag, which everyone thinks me on Twitter is like, how do I get the swag? I'm like, you can't get it. Exclusive, hard to come by. But Robin, maybe you want to give us a sort of like high level for folks who maybe like miss the context of this model launch, and then we'll dive in and actually look at a bunch of demos and examples.
I think so. Nano Banana Pro is particularly amazing at that, like text rendering, infographics, actually like generating structured content. I think like we have plenty of examples where we can do code and actually like generate content while doing a search on the internet. And yeah, on visual reasoning also it's super cool. Like you can do multiple generation. You can do edits where you take multiple people in and blend this into an image. And yeah, we're excited to showcase some examples today live of the model.
I'm excited too. I want to make sure we also talk about this text rendering part because when we did an episode about Nano Banana 1 or the original Nano Banana model, and Kaushik and others were talking about how sort of like text rendering is actually like one of the main things from like an overall image quality, a model quality perspective that like we can use to benchmark models. So I'm curious, like if I don't know if we have like a public benchmark we put out or there's something we track, but I'd be interested here. But Kaushik, you want to show us some examples to sort of kickstart how this model is better? I think it's a top level question in the original Nano.
So we can dive into multiple examples. Like let's start with one common example which people have been trying, and let me compare against Nano Banana side by side comparison. Let me just so people have been trying this wine glass example where you want the wine glass to be full. It's a difficult example because as you can imagine, like most of the wine glasses, like the pictures which people take or the pictures that are online, like rarely you see like full wine glass, like because it's served with something different. And also like the time, like most of the time clock images, like people see like always like 10:10. That's the standard second time which is there in the clock. And so whenever you ask these image generator models to show this wine glass or the clock example, it always either shows a wine glass which is not full or a clock which is like not showing the time which you want. It's either 10:10 or some standard time, which is mainly a data issue because that's what exists mainly in the internet. But it was surprised, like it's not like something we optimized for model for. We trained that model and then we started seeing that people were actually trying out this prompt and it works like surprisingly well. You can see in this later on my first try. Like
you click on it so we can see them in full screen.
Yeah.
Try to make sure it's really full.
Yeah, it looks full. Yeah, it's actually very full. You can see the time on the clock. It's also like perfectly depicting 5:30. Whereas in the right hand side if you see like the Nano Banana output, which is it's not showing the wine glass which is full. It's also not showing the clock which is like accurate. So this is like some example of like better world understanding, I would say, just because it's trained on Gemini 3, which is a much better multimodal understanding. That really helps us for image generation, whereas all this better world knowledge comes up to this model. So this is one particular example.
For the clock one, when we were pressure testing our model, not only we can generate the clock with the targeting time, but we can also editing that. So it's I think with this joint like text image and word knowledge understanding, and then also bring that knowledge into editing the target image. That's really cool. We have never seen that high successful rate for Nano Banana.
Yeah, that's super interesting. I wonder, I've been seeing a bunch of these like new practical use cases enabled by the original Nano Banana model and VO coming together, and I feel like with like even more high fidelity editing, it'll be interesting to see like how many more new use cases come up with that. But I'll check you. We have another example.
Yeah, so I just took an example image. Like I asked the model to show all the consonants in yellow, all the vowels in red, and you can see like it perfectly like generates this image where all the vowels are like described in red, all the consonants in yellow. I can keep like adding, and it's kind of suggesting that the model is actually able to reason. Like it's not like an easy prompt. You have to really dive into each character.
Yeah, and I think the fine grained capacity of like following the text prompt and the image content, it's both showcased on this example and also on the wine glass example where it doesn't output just a generic image, but really reason about like what's the specific user input and trying to match exactly like the full wine glass, for example, instead of like just outputting an average wine glass.
Yeah, I actually before we look at another, I have a broad question, which is maybe you can answer this one. How much of the sort of like capabilities that we're seeing here are just like coming out of the box because 3.0 Pro is a super smart model versus like is it just that like that gives you all like better baseline and then it's just like much easier to hill climb on stuff, or is it like actually it's some of these things were free versus some of them you really had to go deep on, or actually some of them it was harder because 3.0 Pro has its own biases or trying to do things. Like, I'm curious.
Yeah, I think it's both. I would say like first of all the image model is trained based on the Gemini 3.0 model, as Abhishek said, and it brings a lot of stronger word knowledge and like model understanding capabilities. We also put a lot of work into preparing the data, and we have a much larger data set, data collection that we use to train this Pro model, and like have much better synthetic captions that we generated for the images. And I believe like that was an important part of like bringing a lot of the capabilities such as like word knowledge and like description of the cog, for example, and also like a full wine glass, and also maybe some of the infographic capabilities that we're also really proud about.
Yeah, this story of the fusion between image understanding and like how as we continue to push the frontier from an image understanding standpoint, it actually translates back to the image generation. I think it's really interesting, and you sort of get this unique flywheel. One of the use cases I think this is independent of image generation that we have a ton of customers that I think are looking at this around robotics. And, like you can get high fidelity sort of synthetic captions of like the spatial world. It potentially is one of the unlocks for robotics, which is a sidebar, but also really interesting.
The other side is the generation they help with understanding. Because right now we can see the visual reasoning of our model. They can do segmentation, they can do bounding box, selection, and also can do a little bit planning of robotics. We actually have robotics experts testing our models. So it's accurate to see the mixture of all the experts coming together. So first pressure testing our model and then figure out a way if we can further improve the model. That's really cool about like working with experts.
Yeah, so want to add because like we use Gemini itself to leverage in its multimodal understanding ability to generate almost all the captions we have. So right now like we're also having much closer collaboration between the generation team and also like the understanding work stream, so that like we can really have like as you said a flywheel about where our needs are and like what feedback we have and like how that can be used to improve multimodal understanding in Gemini. So.
Yeah, we've got a long thread waiting to get JB on the podcast and a few of the other folks. So he's on our list of folks to talk about.
And specifically about understanding, I think it's also interesting that we're talking about robotics and you have plenty of tasks where actually you would rather segment an object doing image generation rather than like use text to describe exactly where this object is in the image. So I think you can really think about like generation and looking like key understanding capabilities of the world that you wouldn't have through text, for example.
Yeah, that is super interesting. I don't know if we have a robotics example, but I'd love to see it. Obviously, you want to maybe go not to a robotics example, but if you want to go to, we can look at our next example.
I don't have a robotics example, but just adding on to things which we improved over Nano Banana, I think one thing which is like we saw a lot of like user complaints where the model was not good. The Nano Banana was not perfect for multi-turn, so we have tried to improve the model a lot for multi-turn. So in this case, you can see like I just asked another recent example, like arrange all the words alphabetically, and it then rearranges everything into alphabetical. So I think the model would feel much better for such multi-turn conversation. It can you can go up to like 5-10 conversations, and hopefully you won't see much issues which people saw before. So that is like one particular example. Then some other examples like this thing I'm really excited about, which is like so I took my GitHub repo. I wanted to understand my previous code which I wrote using TensorFlow. So and this is something which I've been using exclusively at Google, which is I paste someone's code. I don't want to really read all the code that is written or ask Gemini to summarize it. I just instead just ask my model to say generate some infographic poster explaining this image. And since our model can support like 2K or 4K resolution, so that's another positive. I can try generating something at 2K. Yeah, you can see it's a code. It's like we can. I've been able to play with code which are even like 500 lines of code, and I just read everything from model. It just simplifies my daily life so much.
Oh, I have once. It started explaining. Let me just see to explain. Generate an image corresponding to it. Does the ordering of the prompt change this? Like, is it, I don't know if we have. I assume we have best practices somewhere, but like, do prompt first, context first, or what is there a preference on ordering?
Just instructify the prompt. Be explicit and say generate an image.
Yeah, so I didn't say please. That's why. I did not say to generate an image. I just said to generate an infograph, and so I started writing text. Now I explicitly said infographic image. So now it's generating the image.
Three key questions, like how do you organize the information to answer? Do you send an image back or text? And I think Gemini has been like text first, and there's three that know that we have like really good text ordering and like detailed generation. We can really think about like how can we use Gemini to actually like, generate image where it's actually like when it's best than text.
Yeah, I feel like this is an interesting, and I think the image output is an example of this. The Gen UI stuff, which a bunch of the products with Gemini 3 actually has this as well, which is like when you output text, when you actually write code to make an interface for users. So it feels like as Gemini gets smarter, it's also learning like not just text. Like what are the other modalities? Like when it's tool calls as another example. So this looks awesome. Though. Yeah. It's like we zoom in a bunch. I'm trying to. Yeah, so it started right. Yeah, it looks like I haven't looked at TensorFlow code in a long time, but it looks convincing. Yeah, it looks quite convincing. Like it analyzed my code, and I was reading some MNIST data. First, I trained a teacher network. It wrote all the parameters of the teacher network, like what were the con layer sizes, the different layers which we'll use. And then once teacher is trained, we train the student network, which is whose architecture is perfect. This is not the architecture for Banana, bro. This is first project, so yeah, don't get your hopes up. And yeah, this is the distillation loss. You get teacher outputs, and then you can get student distillation loss, normal loss. You have all the hyperparameters and everything described. How many steps you train the teacher for, what optimizer was used. The same for student. And yeah, it's like perfect. Like, I feel like it's perfect. Like, I don't see any. I think I don't have context to make sure that it is like actually accurate from an architecture standpoint. But the text rendering overall setup looks awesome. Can we do the original Banana model as a side by side? I'm just curious. I think this is one of the places where there's lots of domains where like single turn editing. I feel like the previous model was actually really good at that and continues to be good. But I feel like this is one of the use cases where it's like clearly night and day difference from a text rendering capability standpoint. Yeah.
So you can see the whole like flow diagram. Like I actually didn't ask for it, and it came up with this flow thinking and like organized in a very like clear way of information. It's crazy.
And have you noticed that this has poster aspect ratio? So
so Nano always generates a square image. Our model like is adaptive. It kind of understands that. Oh, this seems like a prompt for which I have to generate some a different aspect ratio image. So it's very intelligent in that way also. I love that. Please zoom in on this. Yeah. So this is Nano Banana. I think firstly, like you can see the text, for instance, is not perfect. It makes some mistakes in the text for Nano Banana. Yeah, the text rendering is not perfect, but if you compare against Nano Banana Pro, like you're hardly able to find any mistake in the text. Yeah. This was better than I remember though. I can't say for Nano Banana 1. I like the Pro model, but it is interesting in that. Yeah.
Yeah, I want to say that for text rendering, this is quite a hard test to measure in terms of metrics. So during the last launch phase, we actually have a small team with very practical engineers, like proactively working on defining the prompt set with very simple short text prompt, just measure that you can character by character verify the metrics, verify the successful rate, and also whether like short under specified text prompt and long prompt, and then prompt with like different language space. And they come up with like operator, human eval, super reader, and then eventually we also assemble a team within our work stream, people on different languages like French, Chinese, and Japanese, yada. So we actually came up with a wide range of rich metrics in order to measure the success of Pro model. So that's quite impressive.
This was one of the threads that was most surprising. I think we got lots of feedback from the original model about sort of like 18 and non-English languages, and I feel like I saw a bunch of I forgot what the metrics were specifically, but this model is like now SOTA across a bunch of the other languages that are not English specific, which is actually great because I think the original model was like super popular, like all these like country geography specific trends in like Indonesia and other places where like, people were trying to do really cool things with the model. So being able to render, I assume rendering text in those languages as well is state of the art. So we tested other models. We don't have any external benchmarks, but we tested different models as well as Nano Banana on a variety of different languages, and we are almost better in almost all the languages, I would say. And it's this is a behavioral phase. We did not like explicitly add in the model. We did not explicitly add training data for each language. We just targeted a general improvement, and then in the end, like when we evaluated all different languages, it was very surprising for us to see that okay, everything improves, which was like, super good too.
And I think to piggyback on what Lenny was saying earlier, it's really a matter of like having a very like wide variety of data and improving the amount of like concepts and like data with a lot of world knowledge to train on compared to Nano Banana.
Yeah, we should have just gone and benchmark max the clock and the white stuff. We didn't do that, which I think folks will feel like as they use the model, and I do think it would be easy to like go and try to fill kind of a bunch of narrow stuff, especially because we got lots of feedback from Nano Banana what folks wanted. So it's cool that we have made general progress. Do we have more examples? Yeah, I have some. So on the side of text rendering, like I'm very excited for people to try out like infographics where people can use the model to explain different concepts and in an infographic fashion. Like for instance, let me show me an infographic explaining photosynthesis. And is this grounded with search as well when you do these infographics? Yes, we have an option here to ground with search. So for a lot of queries, if you're asking for some real-time queries, like show me an infographic about the weather for the next 7 days, it will use search to be grounded with search. Awesome. And can we talk as you're typing this prompt, as it's generating this image, the reasoning piece is new for this model. Maybe the model was doing some reasoning sort of behind the scenes before, but is there any like interesting part about this? Like, is that part of the story of how we're climbing quality? And again, is it reasoning in like I assume it's not actually like generating an image, it's just like generating like a really similar to how thinking works on the text models. It's just generating text and then it uses the like reasoning text to then make the image.
Yeah, exactly. Yeah, and I think that's where again like the fact that the image model is so good at following the text that's given as input replaces nicely with thinking because like the thinking process is really long and still like the model is able to reason based on it and like generate an accurate image.
That's interesting. My intuition would have been that would actually like degrade model quality because you have like way more. Like actually again, one of the challenges for Banana originally was like sort of you had to have like more short terse requests and like not give, as you gave it more context, like sort of overload the model at least not a bunch of tests that I was doing personally.
You go wrong.
Really? Yeah. Okay. See, my intuition doesn't match the way the model is trained.
Yeah, and also the thinking, the model also does self-critic. So it generates results and then try to compare, like see the response, compare with the content, and see if it actually achieves the user intent. If not, the model will redo it and try to improve on itself. And that might also be the reason why for some of the challenging prompts we can actually see a higher successful rate.
That is interesting. And Robin, just to clarify, it is what you're saying is true for the Pro model and the original Nano model, or just for the Pro model?
It's true in general. Like it's good to basically like give a lot of context and define clearly what you want. And the longer the prompt, the more detailed you can specify what you actually want to generate.
Okay, cool. This looks impressive. So I just asked you to explain photosynthesis in detail. Like I'm not a biology expert, but it's like talking everything in detail. Like it talks about all the photosynthesis equations. It talks about all these things in chloroplast, random, everything. And I think you'll have to really zoom in to find any text mistake. Like I don't see anything on top of my mind, but I feel it's going to be really useful for people to really understand deeper topics much easily in an informative fashion instead of going through all the text. You like visualize all this information via an infographic image. This passes my like 7th grade science vibe test. Yeah. You can also like
this 1K or 2K generation.
This is like 1K, but I can ask you to make this image simpler for
because we had the same impression. We actually felt amazing, but we're not biology experts, so it wasn't clear to us like actually like accurate or not. And it was too complex.
So we sent it to biology experts. Yeah, it's correct. It's 7th graders who are looking at this.
We have biology professors and researchers helping us to grade those responses.
Nice. Yeah, this is like much simpler. How well does this work for stuff? Like obviously like photosynthesis is like very in distribution. I would assume for like the knowledge of the model. Is it able to sort of grok the nuance of like topics that are like not like I don't know what a good recent example of this would be, but like a net new research paper about like something that's like far afield that like maybe isn't super like well represented in training data. Yeah, like so I tried like once the Google learning for out, like I just asked it like show me the latest Google earnings in infographic fashion. It went to Google search. Since it's Google search rounded, it found all the Google earnings and then generated an infographic. So I think since it's Google search rounded, like you can really test it with very recent things which are for sure out of distribution also, and models should be able to do it quite well. That's awesome. I love it. I feel like folks are getting a lot of value out of this infographic use case. I feel like I'm guessing, I don't know if it's going to be available in Notebook LM, but this feels like a very Notebook LM bring to life experience. Yeah, it's available in Notebook LM, like, and the Notebook LM team have integrated like lots of new things, so it's really awesome to create it in Notebook LM also. Yeah, I feel like audio overviews plus this plus I'm like I feel like it's gonna be awesome. I want to take. Can you do? Is it just text and image inputs? Or can I also put in like audio and video and stuff like that as well? Right now it's only image and text. We hope to support video also, but yeah, currently it's image and text input. What about like native audio? Is that possible? Not right now. It's great that we launched everything simultaneously. Like simultaneously launched Notebook LM. There are other few exciting changes which people will see all like simultaneously getting shipped. So it's great to be in Google and see like all of these things all simultaneously being launched. I have right now all the 4 presenters and tokens. So let me just say show them celebrating. Tell them to put us in a Google Office. And see, I'll put that in a follow-up prompt then. And so from a user perspective, would I expect like, is there any difference in from like a model inference time perspective, like putting in all these images and fusing them? Does that like generally on average like take longer for the model to be able to bring the references into a single image, or is it like basically a similar time to image generation across all of them?
It's a bit longer, right? But like, the difference is not that much. I think like maybe the bottleneck is image generation.
Yeah, sounds good. Can we zoom in? And... Yeah, but I think we can make it. It did not generate a photorealistic one. It can generate a photorealistic one. I wish this was what was happening. Bananas and balloons and yellow champagne.
Shall we try again?
Yeah. Yeah, and in terms of latency, I don't think there will be much difference between inputting one image versus inputting multiple images. It should be roughly the latency should be close to like 30 seconds or something, which is a bit higher than Nano Banana, but yeah, quality comes at a price of yeah. I feel like, and so that's one of the I think the like world knowledge grounding stuff. If you have more references, I'm trying to accumulate my list of like when I should be going to the Pro model versus the original Nano Banana model. Other things, it likes doing us in this comic. What is the prompt? I can't see it. It's just show them celebrating in a Nano Banana Pro launch party. Let me just say show a photorealistic image, and you're not saying please. That's why. I'm also excited about. Is there any like interesting technical detail about like what the in my mind I think of like 1K and 2K and 4K as like I don't sort of think deeply about this, and I just imagine there's some magic happening behind the scenes. But like from a model perspective, is there like is this actually like technically difficult if we can make 1K work? Like what's the difference? Is it a model understanding piece that's different between 1K and 4K or something like that, or is it just
yeah, about infra? And actually, if you are like serving cost in mind, of course, like generating 2K or 4K is going to be quite more expensive compared to 1K. So you really want to make sure that if you start generating 2K, it's actually going to be worth it, and the initial is going to be much better. So in a sense, you could just like sample a 1K image and say it's 2K, but that's not going to bring something new. Whereas like when you generate 2K, you really want like small text to be perfect, and that's the kind of thing we think about when we propose like higher resolution, for example.
Yeah. And also in addition, like to train like for example 2K or 4K model, there's also requirement on the training data's resolution. Like it has to be higher.
Yeah. We need 8K now. This looks very good. Yeah. I think yeah, like almost perfectly captured all of our faces. Like I'm looking at the hands. I thought our hands we were holding the same. Yeah, I was but we're not. We have separate hands. And we have our own glasses. That's insane. Yeah.
Yeah. The character consistency is a big thing. There's also a label. Oh, there. Text rendering in natural image setting. Yeah, so great.
What are these little things that are sitting on the table? I'm not sure. I think the model figured out we're launching some new product, which is a banana-looking thing. I love it. That's awesome.
Abhishek, do you want to talk about like how we were fighting to make sure that character consistency is also good in the Pro model because it was so good in Nano Banana?
Yeah, I think it's a high bar. Yeah, it was a very high bar for us, and I think this took us the maximal amount of time to reach time one because when we trained the model, we were super happy with almost all of the capabilities, but consistency was something which we found that people really loved about Nano Banana. We were initially like struggling to come to parity with Nano Banana, but now if you play, like you'll find it's even better than Nano Banana for consistency. But it took a great deal of time both from data, curating better evals and changing our training strategies a bit. But it did take us quite a bit to hill climb on this character consistency. But we're now really excited for it. It should work much better and it should support multiple people input, and yeah, it's a new capability. I think I love playing with. I love imagining myself in times 30 and the 30 poster. Hey, if Nano Banana Pro goes well, who knows? Maybe they'll make it happen. So character consistency taking a major leap, the sort of like real world knowledge taking a major leap. Sort of some of these vibe tests start to work. The Claude and infographics, section. Any other things top of mind from a model capability standpoint? I would say these are the main things. We definitely improved also on style transfer compared to Nano Banana.
I think because of this word knowledge and better grounding, we're better at a bunch of editing capabilities like chart editing. Imagine you have a very complicated graph with PyTorch, different format of the layout.
I want this because I'm incapable of making slides. Slides are horrible, but then I see beautiful visual slides. And
you can just talk to the model to improve the style, the arrangement of the text, and the bar chart. Yeah, so and plug into PyTorch and some other things. It can also do some math computations directly from the numbers in your image and to make a process result into additive images. So that's I see example like you presented with a confusion matrix. That's a common thing in statistics, and then you ask the model, okay, tell me the percentage in each entry of the confusion matrix, and that's pretty accurate.
Can I do maybe this is a two on the nose question? Can I do transparent backgrounds? Not right now. I got a ton of feature requests. Everyone's like, when is transparent backgrounds? What's the opposite model from being able to do? I don't have a good understanding of how transparent backgrounds actually work from a technical perspective. But is it possible to like?
It's possible, but it's a matter of like getting the right data because you don't have much data out there that has like different transparency channels, and it's also like you need to actually like change the way you train your model while making sure you're not going to regress on like all of the tasks you're currently good at. So it's a bit tricky to get right. We're definitely going to get there, but like not for this actual version.
Okay, people want it, so we need that. I feel like getting transparent background images is the most painful thing anytime you're trying to do something. So we can nail that in mind. I feel like we'll get a lot. But in general, like I think even though like these are the new capabilities you're talking about, but even in simple like text image and editing, the model should feel much superior. Like, because that's the main metric we climbed on. These all capabilities kind of emerge, but simple text image, very simple editing, the model should feel much better than what it was before. Like this, we can even try some examples of like I was trying to play with it. Like let me just simply show me a funny pie chart around some random topic, and then we can ask it to even edit the image from pie chart to 3D bar plot or something.
Yeah, and I think it relates to the ability of like the noise really much generation.
Yeah, I feel like multi-turn generation. I'm just remembering back to the original. I forgot what we even called the Gemini 2 Flash image model. And you sort of like actually in some context, and that model was great when we were the first ones to ship that sort of like native image generation editing capability. But you like visibly be able to see some of the regression over time. I feel like now it's sort of like cross the uncanny valley of like you can just like continue to do the editing and generation. It doesn't. It like seemingly gets better over time, which is really cool. Yeah. Like for instance, for this image, like you can see like this is a normal text image, but you can see like all the labels are like perfectly accurate. Like 40%, 30%, all this like percentage labels on a pie chart are pretty accurately depicted here. And it
actually add up to be 100%.
Yeah, I gotta measure. We gotta get the true 100% overlay. We should run like code execution and use like a visualization. I'm curious how close the actual gap is. But my vibe check is I feel like it looks right. So yeah, awesome. Yeah, it's great. And now let me see. And yeah, did some reasoning to like make it funny. One of the memes I've already seen true. Staring at the fridge hoping for miracles is a real one. I open them all the time. Like maybe there's something I really want in here, and every time I'm disappointed. Or these MKs in the office.
I also remember it's just in general. I think there was a use case. Like on our team, a lot of us they were in US, and some of our team, the rest of them they're in Europe, like for example in London. Yeah. And every year when the daylight saving time changes, it's mismatching in two countries. So there's a week when our meetings gets misaligned. So on that week, our helpful TPM sent out a message to remind everybody there's a change in meeting time, and someone else on our team used that just chat message and sent that into another Banana Pro, and made a very very cute like a reminder poster like with all the information and like even has London bridges and stuff. So it's really nice. Like it's just nice to see high visual quality and like for just our daily tasks. Now maybe like now we don't have to send chat messages. We can just generate a good looking cute image for that and to communicate what we want to tell others.
Yeah, there's something about images too that like it's just so easy to like grok information. And I feel like we're so text based and working and all this other stuff that like you just sort of resonate so deeply with image, which I think is why this is so powerful. Also just like letting anyone like the pro models leveling everyone up. And I feel like Banana did this where like anyone can go edit images and start to generate. And I feel like now this model taking that even further I think is a cool capability. This is the time I'm super excited for folks to get their hands on this model. I feel like across the Gemini app, Notebook LM, AI Studio, the APIs, I'm sure a bunch of other products, folks will be able to experience this model. So thank you all for the hard work. Thanks for sitting down and chatting about this stuff, and excited for Gemini Nano Banana Pro 2 or whatever we call it in the future. I want to Gig Banana, but that did not happen. So Nano Banana Pro. Again, thank you all. This was a ton of fun. Thanks for watching Release Notes. Hope you enjoyed. We'll see you in the next episode.
Hi, everyone. Thank you so much for joining us today. And thank you, Alberto, for joining me today as well. I'm Aya Durbin, and I am on our Atlas product team, and I lead our humanoid application product strategy. That means I decide where we'll start with this robot and what customers are looking for this robot to do over a long time horizon, so we can make sure that we build a great strategy to get there over time. My background is in warehouse robotics. I come from a company called Sutskever Systems, where we implemented AMRs in warehouse environments that were working directly with people. It was my job to build interfaces for people to work with these robots directly and to build out the workflows that handled all different types of exceptions and issues that came up in these warehouse environments. I'm very excited to be here with Alberto Rodriguez, who is on our behavior team. Alberto, I'd love if you could share a little bit more about your role, background, and what your team's responsible for.
Great. Yeah. So I joined BD about 4 years ago. Before that, I was faculty at MIT, and I decided to step down and join BD in part because of the excitement about Atlas, wanting to get into manipulation. And now I direct the behavior team in Atlas, which basically is responsible for the development and implementation of the AI strategy. So how we're going to get Atlas to move and manipulate the things that we want to do, and how our customers are going to do that.
So Alberto's team is really responsible for figuring out how we fulfill the long-term promise of humanoid robotics being general purpose, which I think is something we hear a lot from customers that they're really excited about. I think when people see the humanoid form factor, they make a lot of assumptions about what it can and can't do, and the thing that people are most drawn to is actually the ability to have a machine that's flexible and that is adaptable to real-life environments. Do you think that the level of general purposeness that's required to achieve that long-term vision is actually possible? How's your team thinking about tackling that?
Yes, to give you a short answer, but I guess I'll go to the long one. When I joined BD about 4 years ago, one of the things that I got a chance to do was to visit many factories. One of the things that stands out after so many trips was the fact that many of the tasks being done in factories are extremely complex, so the challenge is very high. And the other thing that stands out to me is that a lot of those tasks, even in modern factories today, they're not automated. And the reason why they're not automated is not necessarily because we don't have the technology to automate them, but it's mostly an economical reason. It just doesn't make sense to use current modern automation, hard automation technologies to solve those tasks. Just to give you an example, in car manufacturing plants, imagine like a modern car manufacturing plant. It makes about 1,000 cars a day, so extremely efficient. And the rest of the factory is a big funnel that is responsible for bringing always the right piece at the right time in the right place, so that the people that are doing most of the assembly and the assembly line, they don't have to wait a second in finding that part, right? They're always on the job following the cadence of the assembly line. To make that happen, right? So in the same assembly line, they might assemble between 5 and 10 different cars. Each car has thousands of parts, and each car has like, I don't know, there are 5 different themes with 20 different colors. If you multiply all those numbers, there's a ton of variability of the parts that need to be handled, right? And if you look at the assembly line, you get in a similar situation, right? It's full of thousands of very small tasks that are very vectors, and which involves a huge amount of variability. And all of that variability just makes it not economically feasible to use hard automation techniques, like the kinds that you would design special purpose end effectors or fixturing to reduce uncertainty and sort of specialized solutions. So really the goalpost for humanoids, right, the real value, it's addressing directly that variability, that generality that can unlock the ceiling of current automation techniques. Going back to your original question, is that possible? Can you actually build humanoids that can provide that degree of generality? The problem is really hard, right? Like if you look at an assembly line, the real problem that we're talking about is someone fishing with its right hand into a bowl full of bolts, picking one, going with the other hand to pick up a bolt driver, inserting the bolt in the bolt driver, and screw it on the underside of the roof of a car, maybe while bracing with the other hand to maintain balance, right? Like, it is very complex, but that is our lighthouse, right? That is the kind of task that we are aiming for Atlas to do. There's fundamentally no reason why it shouldn't be possible, right? The hardware is capable of it, we know that, and the techniques we're using today should be able to scale to that level of complexity. So we're convinced that it is possible to get that generality. There's certain barriers, or certain complexities to get there, but the technology is clear. We want a technology that is capable of, that is general purpose hardware, that is capable of ease of retasking, so that we can avoid the scaling issues with complex integration for each one of the tasks. We need a technology that enables natural interfaces, so that our customers can tell these robots what to do, not by complex programming, but rather by directly telling them or demonstrating them what they should be doing, and safety around people. Those are the core tenets, and we think we're convinced that it's possible to get there. If I had to pick up one thing that I think that we might see have like a really good solution for how to get there, is the incredible degree of reliability that is necessary to deploy robots. Let's say
no, that's true.
What is the future?
We're actually just going to create software
challenge.
It's a very big area of do, and then say, okay, and I think on top of reliability, there's 3 key areas of awesome dynamics that we think about when it comes to delivering customer value, which to me on the product team is the most important thing that we can do. I'm very excited about humanoids being used for any task in the future, but in order to continue to get investment, in order to continue to prove that humanoids will reach that point, we're going to need to have milestones that show customers that humanoids can provide value today, which means we need to start getting reliable.
One of the aspects that's probably hampering that a little bit is the capabilities of these models are changing.
We have our behavior, so the robot actually doing physical tasks over and over again, and then we have the application software that what's on top of it also needs to be reliable. We need customers to be able to know what to expect from these systems. Humanoids need to be predictable. We've learned a lot from Spot and from Stretch about how we make hardware reliable, how we make application software reliable. How do you think we're going to take our learnings from Spot and Stretch into actually building a product that is usable by our customers in the near term?
Yeah, that's a great question. So I think there's tons that we are already learning from our other products, and that's one of the benefits of being in a company like BD that has already been through this trajectory before with both Spot and Stretch. The trajectory of building a product as complex as like an autonomous
Gemini 3 Pro.
it goes in 3 phases, right? Like at the very beginning, at phase 1, you're building a robot, you're building a machine, and most of what we do is limited by hardware reliability, right? Hardware reliability gets in the way of how fast we want to do development and being able to do like early deployment, sustained deployments with customers. That's, I would say, where all humanoids are today. The moment that you get your hardware reliable enough that you can do sustained deployments, then you go into phase 2. That is where you bring your robots for a long time into your customers, and then you learn what I call the other Peter lesson. For those of you that know Rich Sutton's like the Peter lesson, right? What is the other Peter lesson? The other Peter lesson is that the customer is always right, and you were probably wrong, right? You've made wrong assumptions about the product you were building. Maybe the level of autonomy was wrong. Maybe your system is not handling enough exceptions. Maybe your human interfaces are wrong. And in that phase, you are quickly developing and evolving the software. But it also includes many other supporting capabilities that actually turn a robot into a product. Once you log that in, once you actually learn that lesson and figure out what your customer actually wants, then you're going to face it, right? You can actually scale deployments, and then is when hardware becomes again a liability. That is the long tail of hardware reliability that you can only work once you get to thousands or tens of thousands of robots. For reference, that's where Spot is today, right? Like those failure nodes, you only get statistical evidence or what the right heaters, like once you have tons of hours of operation. And evolving that and solving those problems takes time. Getting hardware to be a perfect machine or close to a perfect machine takes a long time because any of those failures might involve, I don't know, change the supply upstream, right? And change that part and then change your manufacturing operations and then proving to yourself that actually that makes a difference. So that can take months to do that. So I think all humanoids are still in phase one. We're sort of working really hard and really fast to get to phase two, but I think it's very clear that we're still in that phase.
So being in phase one and trying to get our hardware reliable, I'm sure lots of people are currently asking themselves the question, why would we make our hardware more complex with legs? I get this question from customers all the time. I get this question from my family all the time. So I think maybe both of us can offer our perspective on why we've come around on legs, because it's definitely been an internal debate that we feel very confident that we landed in the right place on, but it's absolutely been a debate. And so I want to answer the question because I think it's a good one. We talked a lot about visiting facilities. We have our engineering team visit facilities. I've certainly visited hundreds of facilities myself, exploring applications across markets and understanding where humanoids can be valuable in all different walks of life and in all different types of industrial environments and home environments and retail environments. And I can say with 100% certainty that we do not need legs in all of those places. But what I will also say is that we spent a lot of time already talking about the long-term promise of humanoids, and that's really why they're being built. People want a flexible piece of hardware that can be easily retasked and do anything in a building that a human might do. And if that's a long-term goal, then we're building a piece of hardware that helps us get to that goal. Hardware that has legs, hardware that looks like a human, means that we can work in an environment where a humanoid might be valuable. It means that when the software does catch up, when your team solves all of our problems that we have working towards that goal, the hardware is there and ready for us to explore all those opportunities with customers. And we can do it at lower cost and lower complexity because we don't need to keep building a new robot every time we want to explore a new application or a new opportunity. There absolutely will be robots that take over the job of humanoids in some places if legs don't make sense. And that's okay. That's exciting. That means the robotics field is growing. We want to make sure that as we do research and as we build out our software stack, that our hardware is there to support it. And then if we have different form factors in the future, that's even better.
I agree with you. From a technological perspective or from a capability perspective, I think legs actually make sense. Right? Like, it used to be that the problem with legs was dynamic stability. Right? Like, how are we going to get robots to not fall? How much compute do you need to use to maintain that stability? But actually, what we've seen in the last couple of years is that has turned out to be an easy problem today. Right? Like, that is no longer a bottleneck, dynamic stability. And if you can handle it, legs give you certain very interesting capabilities. Right? So from a form factor, gives you a slimmer body, which allows you to go to more places in more constrained environments, which, as you know, we've seen in many factories. Legs also allow you to turn faster, right? By enabling discrete contact changes in the support of the robot. That allows you to do quick turns. While you have a wheel robot, you have to navigate the complexities of the dynamics of stopping and turning. So I think in some way, legs, from a capability perspective, actually makes sense. Maybe if I had to pick one, right? One caveat that is still remaining is safety, right? Like being able to certify safety in a dynamic balancing robot. It's still today something that we don't know how to do. There's no regulation, there's no process to certify a robot that is safe in a human environment. But as a company, we're working alongside other companies that are also building humanoids to create the regulation umbrella and the certificates and the tests that are necessary to be able to guarantee certify that certain conditions are met. Ultimately, the deployment in factories will require, just like many other technologies that are deployed in factories, it will come from a combination of certifications and trust on the vendor, but also training and expectations from humans in the factory, which is a place where you can have those. How do we get to homes, for example? That's a big question.
And that kind of leads us into where we're going. In this conversation, I want to make sure that people walk away understanding how we're getting from where we're at now to that eventual home use, retail use, and use humanoids really around people on a regular basis. We've been talking a lot about where we're going with humanoids and what kind of the North Star looks like that we're working towards and all the research that we're doing to get there. I want to make sure that people walk away understanding how we're actually planning on getting there and how we go from where we are now to that long-term North Star. We want to add value to customers soon. And when we think about which applications are a good fit for us in the near term, we really think about three things. The first is we need a robot that's capable of actually performing the task. We need to actually have the behavior capability to pick the item up, to work in the environment, and to do that core task that us humans take for granted. We need to do that task reliably. And maybe most importantly, we need to perform the task the exact way that the customer expects us to. These robots need to be predictable. If you've ever hired for any job ever, you know that whether you're hiring someone to do work in your home, to do work in a restaurant, or even to do work on a factory floor or in a warehouse, even if the person has 5 years plus experience doing the job, you're still going to train them on how they should perform the task in your specific facility, home, restaurant. Because in your environment, different problems come up and you want them to handle those problems in the unique way that you do it in your facility. And when it comes to adding value to customers in the near term, that's a really important component of our full solution that we need to offer if we're going to really go into building soon. And so we really are paying attention to all of the parts of the problem that need to be solved if we're going to have humanoids actually working in facilities soon. We've thought a lot about where we start, what our beachhead is going to be. There is a ton of research that needs to be done in order to fulfill that long-term goal. And even in the short term, if we want the robot to be reliable at performing these behaviors, there's a lot more research I know that your team is working on to make that happen. So picking the right beachhead was a really important decision for us. We did a lot of visiting of customer facilities and touring of sites to make sure that we made the right choice there. You're a big part of that selection process and of us selecting industrial manufacturing as the place that we'll start. What made you believe that that really is the right place for us to start when it comes to making sure that we are still making progress on research, but also adding value to customers in the near term?
The first component, which was like a necessity, is that it has scale, right? It has sufficient scale for it to make sense. But beyond that, I think there were two things that made it very important, or we thought made it a good choice. The first one is safety, right? So manufacturing, because of the structuredness of not just the setting itself, but the way that workflows happen in factories, allow for certain concessions that gives an easier ramping of safety requirements. You can start with robots that don't get close to people, for example, or just stop the moment that people get close to them. And from there, ramp up to more complex situations. And the second one, which was very close to my heart, is that manufacturing has sufficient viability to motivate the need for generality, right? So we're not building special purpose solutions. Manufacturing, from a financial perspective, makes sense to attack it from a general purpose perspective, right? From after the many visits, it became clear that the kinds of things that people are doing in these settings, that the kinds of operations that are necessary to assemble cars or assemble many other things, are extremely complex and motivate that generality. If I put my research hat on, I would say that manufacturing is almost manipulation complete, right? So if you get your robot to solve the kinds of complex manipulation tasks that are necessary to assemble a car, you're good to go, right? You can get your robot to do many other things outside of factories. So that manipulation completeness was important to that selection.
Manufacturing definitely offers that range of tasks that make sense in the short term that we can build on over time to reach that long-term goal. The parts we're working with now are the same parts that they work with on the general assembly line, which is exciting because all the work we do today matters kind of for that long-term goal, getting to manipulation complete. I'm sure very quickly. So let's get into how we actually teach the robot to do tasks. I get tons of questions from customers that want to better understand what can we do today? How do I know what we can do today? How do I learn what we can do today? When will we be able to do more? When can we do more tasks in their building? How do we train the robot to do tasks? I think in general in the media, people are hearing that AI brains and large behavior models or LBMs will be the solution to this problem. And I think this is a great forum to help clarify for people, what is an AI brain? What is a large behavior model? Do you believe that these are answers to some of the questions that we have about how we reach generality? Can you explain a little bit more about training? This is like a great forum to help answer some of those questions for people.
It's a great time to answer that question because the answer to like how are we building in generality or how are we creating behavior engines? The answer to that question has changed dramatically in the last 3 to 4 years. like it used to be in the good old days, like just a few years ago. This is how we're teaching it in classroom, right? Like the way that you build a behavior engine is something like a pyramid, right? So on one hand, you have raw inputs that get into the robot, so camera, pixels, tactile feedback, encoders, and on the other hand, on the other side, you get the output is like currents or torques that you send to your actuators. And you can think of what used to be sort of a layered system of algorithms that, on one hand, they were taking the raw information that was getting into the robot and turning it into more and more abstract and complex representation of the state of the world, right? So getting from raw pixels to features like points, masks, lines on an image, and from there get to objects with identities, and from there get to maps where you localize things in the environment. And then downstream from that, like a sequence of algorithms that were making more and more concrete decisions about what the robot should do. We're starting from, okay, the next thing the robot should do is pick up that object and move it there. Okay, then you distill that down into, well, the robot should take a few steps and then reach to that object and then take it, grasp it, move, and then distill that into an actual trajectory, and then distill that into torques or currents to the actuators.
And this is how robotic arms and AMRs are working today?
This is how they're working today. This is how most robots, including humanoids, were working just a few years ago. And the problem with that, you can build systems that do complex behaviors with that. But there's two key problems. One is maintenance, right? So that system is built out of many, many blocks that have many dependencies. And the moment you want to improve it a little bit, it's just very hard because any change you do, you have to change a million things in the system. So it's very hard to maintain or improve. And the second problem is the scalability, right? So it's a system that is not necessarily based on accumulating knowledge or experience over time. So every time you need to do a new deployment, you still need your very experienced engineers to just tell the robot how to do the thing that you actually want to do. One of the things that we figured out over the last few years is that there's a much more scalable process to do that, which basically means replacing all of that internal structure of the brain or the behavior engine by a system, a neural network that is not programmed, but instead is taught to do the thing that you want to do through experience, in most cases through demonstration. So going back to something you just said earlier, right, about on-the-job training, right? When you hire someone, when you want someone to do something the way you want it to do, that's what we call post-training, right? So that's on-the-job training, right? That's the core of the basis of how to get today a robot to do something to a certain degree of performance. So basically means you demonstrate the robot how to do something, and then you demonstrate it many times, usually through calibration today. And at the moment that it makes a mistake, you jump in, you correct it, and then it learns over time through those corrections to be better and better at executing that job. That is the kind of thing, that sort of loop of improvement of giving the robot more experience through demonstration is the loop that we call post-training, and is the loop that is necessary to do for every single task where you want to deploy a robot. Now, the problem with that is that, again, it just becomes difficult to scale if that process is tedious and long. So what's the real bet here? The real bet is that you need a second system that just on the spot provide a good initial guess as to what that behavior should be for any task. That's what we call pre-training, right? And that's sort of a massive system that accumulates knowledge over time and is capable of creating somehow common sense and generalization over what it means to do a certain task and achieve a certain goal. Now, that is sort of one of the most interesting questions today is like, how are we going to build, that's the LLM equivalent in robotics, right? The large language model.
And that's the AI brain that people are asking about.
Yeah, I mean, in my head, the AI brain is both things. Both things are indispensable, right? So you want a system that has common sense, but you're always going to need a system that gets that common sense to actual high performance. That's the on-the-job training you were saying, right? Like, you're always going to want to tell the robot, actually do it this other way because it's just, I don't know, I prefer it that way, or you've messed it up here. So in my head, both are sort of essential parts of that strategy. Now, how do we build that common sense? That's one of the $1 trillion questions today. And basically, it boils down to providing enough experience and knowledge about general tasks, about general environments, and about general notions, and being able to accumulate it in a way that then is accessible by the post-training engine. How do we do that? Well, you have different ways of providing demonstrations to the robot. One, the most common today is deliberation. So scaling up deliberation to get the robot to do hundreds of tasks. And you get one single engine to learn how to do hundreds of tasks with the hope that it will generalize over time. And then there's other means by which you can provide demonstrations that are less close to embodying the robot like deliberation, but are easier to scale. So you can do simulation, you can discover behaviors in simulation with reinforcement learning rather than through demonstration. Or you can directly look at how people do certain tasks and try to learn from more unstructured demonstrations, let's say from video. Accumulate all that information in such a way that that engine at least is capable of certain things. We want Atlas to be able to know how to move gracefully with agility and with strength. And that's independent of the job that it's doing, right? It has to be able to do that anyway. It has to know, for example, it needs to have enough common sense that if I'm going to apply a certain force in that direction, maybe I should change my stance to expect that I'm going to be receiving back a certain force. You want Atlas to have a certain degree of visual spatial understanding. If I'm seeing you there, I know that you are more or less at a certain distance, and that if I want to reach to that thing, I need to reach at a certain amount in a certain trajectory with a certain velocity. All of that is also independent of the job, and it's very useful information for this large brain to contain as a general knowledge. And then things that are more specific about the environment where it's going to exist, right? Like in our case, there's no reason why Atlas has to learn about the existence of the thousands of assets and thousands of fixtures and tools that it's going to see in factories, because we know those ahead of time, so there's no reason why not to put them in that general understanding. And fourth, and maybe most important, dexterity, right? Like, how do we get Atlas to actually become dexterous with its fingers to the point that it can use tools? It has a common understanding of what it means to exert sufficient force through a tool. It has a common understanding of what it means to handle variant objects, or what it means to insert something. The feeling of taking something in place, right? That's something that should become part of its general understanding. That it doesn't have to learn on the job.
It's interesting to think about the types of information that a robot cares about versus a traditional LLM that we're all starting to get used to. If you think about the LLMs we're using today, they're looking at data that's publicly available on the internet, because that's really what it needs to answer our simple questions about how to write an email slightly more professionally. But a robot, the types of data that you're talking about, needs a whole different set of inputs to be able to output what we expect it to, which is, I think, definitely more clarified in this conversation already. I want to dig a little bit deeper into the teleoperation question that I get from customers. Not everyone has seen how we actually collect data via teleoperation with the robot. Can you paint a picture of what it's like to do the teleoperation process? What technology do we use? How experienced are the demonstrators? And how long does it take to collect enough of this type of data to actually build a policy that allows us to do the hard type of work that we're talking about?
We think teleoperation is a valuable workflow for teaching robots how to do certain tasks, and we're definitely using it. It's also a workflow that is valuable to show robots how to correct for mistakes, for example. It's unclear whether long-term actually that is the right interface for our customers to use to tell a robot what to do, right? Probably some more natural interface like language or just direct visual demonstration is more scalable. But for today, teleoperation has become essential, and most companies rely on it. It's probably the most reliable way to teach a robot what to do. So imagine one of our demonstrators, one of our experienced demonstrators, right? So they put on a VR headset, so they see through Atlas eyes in 3 dimensions, so stereo vision. So they get a good awareness of what it means to see through Atlas eyes, which is important because we don't want demonstrators to do things in a way that later on would be difficult for Atlas to see, right? We want our demonstrators to embody what it means to feel and be Atlas. Our demonstrators, they also have trackers. So these are like gadgets that you put on your hands, on your torso, and on your feet, so that the way that they move controls Atlas in real-time life. And over time, they build a certain experience over how to get Atlas to do good motions and what it means to get Atlas to stay in balance, what are the extents of the force that Atlas can exert. So there's certainly a learning curve of a few weeks for our experienced demonstrators to get to that point. Once you get to that point, how do we build an actual like one behavior? We collect in the order of 5 hours of between 5 and 10 hours of demonstrations of the same behavior, not always exactly the same behavior affected by variations and potential failure cases, and see how the demonstrators would correct for those mistakes. And all of that becomes a corpus of data that we use to train. We would use it in this case in post-training to optimize the task to high performance.
How do you envision us making it faster to train these robots to do new behaviors from where we are today to where we need to get to? What will make it easier?
Yeah, I think in some way that is probably the most important question, right? So it goes back all the way back to the generality and scalability question, right? So the amount of time you have to spend on post-training to get Atlas to do an actual job at high performance, that is the actual real cost, right? That is the thing that gets in the way of scaling your deployment, your integration. And the most effective way to reduce that time, the amount of demonstrations or the amount of time that we need to invest in each deployment, is to invest into the large corpus of pre-training. The larger that becomes and the more general that becomes, the better first guess that it has about what is the actual policy that we need to run for a particular job, and then the lesser amount of time that we need to invest on the job training for each one of the tasks. That is what people call the flywheel, right? So the more times you've done that effort of building new tasks, deploying them, and those deployments are generating high quality behaviors, that is actually generating very valuable data that then you can put back in your pre-training and make that more capable. So that's what we refer to when we mention the flywheel, the data flywheel.
In general, our product philosophy is adding customer value in the near term, and even from our research fund, as we add that customer value, we're getting faster and faster and faster at delivering customer value because we can train our system more quickly to do tasks almost without thinking because it has more knowledge already kind of built into its brain. How fast do you think things are moving on the research fund? We've talked a lot about the old techniques that we use to train the robot on new behaviors, and clearly there's a whole new way that we're moving forward in how we train our robot to do work. What does it felt like to be moving this quickly? What does it mean for customers to be moving this quickly? Just kind of, if you can get a little bit of insight into what it's like to be into the research world.
The first thing that comes to mind is exciting, right? I think that it's hard to think of any other time that doesn't exist in the past where robotics has moved this fast. It's not just the speed, but also it's much easier to get our robots to do things that were impossible before. And that's very exciting. There's certainly some underlying anxiety that I think the whole community is pressing down. We're basically betting that generality, just like with large language models, will emerge with scale. And there's a lot of good reasons to believe that that will happen, but that is not something that no one has shown yet. We have the right ideas, and we have the right motivation, and we have the right techniques for how to get there. We need to execute that.
We also have exciting results that are really proving that we can add customer value in the near term. And the conversation that we just had about how valuable that is for our long-term goals is very exciting. I think it's important for people to take away that just based on the research results we've seen already, we know that we can do early tasks in automotive manufacturing and manufacturing industrial environments. And that is wildly exciting because it means that the investment in humanoids is going to continue, and it means that customers will really start to see value soon, which really is the goal, because that's the first step on a productization journey. That's the first step to building a business. That's the first step to enabling this long-term research that we want to get to. I think it's important for everyone to keep in mind that there are many pieces to this puzzle, and there's a lot of noise in the industry right now, and everyone is so excited. And there's a lot of focus on specifically the known unknowns that we've really been diving into today. But there is a lot we do know. We know a lot about hardware reliability, loss dynamics. We know a lot about how to build great application software and operator interfaces, and how to make sure that even in this new world of AI, our robots are still following the rules of the road in customer facilities. So I'm excited to take our customers' experiences and our customers' knowledge and pair that together with what we've learned from Spot, from Stretching, from all of our thousands of robot deployments that we've already done, and combine that together into kind of what the next step is for Boston Dynamics and for the world, which is humanoids. And it's all very exciting. So thank you for helping to provide some clarity on what we do definitely know and what we do definitely not know, but we're working really hard to figure out in this world of noise that everyone's living in.
Thank you. Yeah, I have a question for you. When are we going to get to have 1,000 robots in the hands of our customers?
That's an excellent question.
Or 100,000. Choose your number.
We will have thousands of robots deployed in the next 5 to 10 years. That's our vision, and that is what we are aiming towards. And I think just based on the conversation we shared today, it's clear that we've made the research results that will get us there, and that's why I feel confident in saying that we will absolutely have robots in the thousands deployed over the next 5 to 10 years in industrial environments. Hundreds of thousands is definitely a larger question. I think that's actually a better question for you because your team's going to have to solve the problems to make that one happen. But yeah, we're very excited because we have thousands of spot robots out in the wild. We know that it's possible. We know how to do it, and we've seen research results that will get us there.
I'm very comfortable with those numbers. I think that because of the experience we have from Spot and Stretch, we kind of have an understanding of what is the process of maturing these products, building the hardware, maturing the software, maturing the customer relationships, and building trust with them. And in a way, I think of like Spot is leading the charge, right? Spot is at that like sweet spot right now where at the sweet spot of the hockey stick, where we have thousands of robots out there in the hands of customers, many customers that are scaling. And you can think of Stretch as being 2 years behind that, and Atlas being 2 years behind Stretch. So I think I'm comfortable saying that within 4 to 5 years, we should be where Spot is today.
It's exciting to be at the point where we've seen enough results to feel confident in those numbers, and we've seen from our experience that it can really happen.
Okay, yeah, here's another one. Also very easy. Can I buy one?
Loaded question. Which I get all the time. I'm sure you're not surprised from customers, from non-customers who are interested in humanoids. I think every single company in the world has a mandate from their executive team that says, what are we doing with humanoids? We need to be early. We're going to crash and burn unless we start using humanoids tomorrow. And I guess I'll say a few things on that. One, when humanoids are ready to be a product, which a product to me means it's a reliable member of your workforce. We're not there yet. But when we are there, the customers that are already using Spot Stretch today, the process of deploying a humanoid will be plug and play because we, especially having something like Spot that roves around your facility and does inspection, enables a much faster deployment process, mapping process for a robot like Atlas. And so we will be building out tools and functionality that make it very simple to drop Atlas into your facility if you're already using one of our other robots. So that's a great place to start that you can actually take action on today. It is absolutely on the path to humanoids, even if humanoids not physically standing in your building. That being said, we are doing work to make sure that humanoids are standing in buildings. We won't build a good product unless we do that. And so we've already started doing on-site with Hyundai, which is our first foray into doing on-site engagements. Now, Hyundai's a great partner to start with because we really need to be working with people in the early days that understand that this is not a hardened product yet. And Hyundai's really on that journey of kind of eating, they call it eating your own dog food when you're building a product, and working with us as we fail, as we succeed, to build something that really works for operators in their facilities that we can eventually leave on site and we can call a hardened product that you can call me and buy. We're not quite there yet. We will be getting there over the next year or two. So what is important is understanding the technological readiness of these systems, which is what the point of the conversation was today, so that customers can start to think about where realistically is a good spot in your facility for humanoids to start. So that if you do reach out to our team and we start to have a conversation about where humanoids make sense in your facility, you're pointing us to the right places. You're pointing us to areas where you have lots of labor that is kind of ergonomically unfriendly and just not great for a person to do, and that has more of those gross pick and place functions. Because in the early days, I don't want to be asking you if we can deploy tens of thousands of robots into facilities where we're screwing screws in small spaces, because that behavior is going to be a lot harder to get reliable than some of these other behaviors that we've seen in warehouses or manufacturing logistics facilities.
Thank you.
So I want customers to think about where does it make sense for humanoids to start for you, so that when you do reach out, because I know inevitably we're going to have many people reach out after this conversation, we're talking about the right types of tasks and we're talking about the right areas to start, and come into that conversation with the mindset that you're not buying a product today. We're talking about a partnership to launch a product at this point. And over the next few years, as we get the product more reliable, that's when we'll actually start selling Atlas. And today you can't just call a salesperson and buy Atlas. You have to go through the middle first, and that's kind of where we're at in the process. Thank you everyone for joining us today. This has been such a great conversation. I'm glad that we could shed a little bit more light into the reality of what's going on in the humanoid space. If you have more questions for us, please let our team know, and we're happy to do this more often.
Great.
But having many styles of grippers to pick up, glass parts or parts that clearly require something other are focused on adding customer value in the near term. But in order to reach our long-term goals, we need to be setting ourselves up for success in the future, which means doing research, like you said, on those longer-term horizon targets that we have to achieve those goals. One of those things is doing research on dexterous manipulation. We know we're going to need to do it in order to get to general assembly. Can you tell anyone a little bit about the work that we're doing?
It's easier to learn.
It's such a great time talking with all of you.
most intelligent model yet with state-of-the-art reasoning, next-level vibe coding, and deep multimodal understanding. Let's hear it for our sponsor, Google AI Studio, Gemini, launching Gemini 3. I actually think that there's two sides to analyzing a model release these days. One is you benchmark it, you use it, you test it, you demo it, and that has been getting less and less interesting. It's very incremental. Today, we're going to go through a little bit of both of those things. Obviously, the big news, at least from my reading on it, is that Gemini 3 performs very well in ArcAGI v2, a huge jump, twice the performance of the previous state-of-the-art. It's definitely a smarter model, and there's a whole bunch of interesting ways to show that, to demo that, to quantify that. But ultimately, I don't think anyone's making the claim that this is super intelligent. This is a step change from what we've experienced before. It's what you know and love. It's AI in chat. It answers things. It writes some code for you. It can do a bunch of cool things. But there's nothing that we're like, oh, it can finally do this. Where it can't do that. Yeah, it can do a bunch of cool
stuff. Best autocomplete ever.
Tyler, how do you respond to that?
I think that's a bit too dismissive. The model's like really good. I think probably the most important thing, and this is kind of shown by the ARC scores. Well, kind of, but it's like the visual understanding, the computer use that you can use. Basically, there's some benchmarks that measure this, like how well can it navigate a website or something like this. Basically, the model went from being like really, really bad at this, and now this model is like solid. It's like reasonably good. Yeah. So it's like, okay, maybe this is what gives us agents finally, and that would be like an actual step change in capabilities.
Yeah, maybe. We'll have to see. I mean, it still feels like even for that example, like we need some scaffolding, we need some wrapping around it. It's not like yesterday we weren't able to do something with AI, and today in vanilla Gemini 3 you can just do it. It's just a new functionality. It's like
it's better. It's better. As good as we would expect. If like it's not slowing down, I would say.
No, not at all. It's not slowing down. It's growing, but decelerating. Is that fair to say?
Tyler, say the word decel. Say
this is a great model. I'm very.
I mean, I agree. It is the best possible. I was framing it in somewhat of the same way as the iPhone launches. Like it's newer, better, smarter, faster, stronger, newer, and better. Like we're waiting to see on the net new capabilities, on the binary step changes.
I think over the next week or two we'll see if it's actually really good.
No, I'm not saying it's not really good. I'm saying binary before and after. With ChatGPT, it was like you couldn't talk to the computer, and then you could. And then with the launch of Windsurf, Cognition, Devin, it was like you couldn't write code with the computer. Now you can. We do have our benchmark, the one true binary step change, which is it funny? We need to know if it's funny. I gave Tyler the prompt. Do you want to read your the result of the stand-up comedy bit from Gemini 3? What did Gemini 3 say when you asked it for comedy routine, for stand-up special?
Okay, it's pretty long.
Okay,
I bought one of those smart health watches recently. You know the ones? It tracks your sleep, your heart rate, your readiness. I paid $300 for a piece of rubber to tell me I'm dying.
Yeah, the soundboard.
That's all it does. I wake up, I feel fine. The birds are chirping. I'm ready to seize the day. Then I look at the app and it's like recovery score 12%. Your heart rate variability suggests you are technically a corpse. Go back to bed.
Okay.
And immediately I feel sick. I'm like, oh god,
You're so bad at reading this. I mean, like this is terrible. This is terrible delivery, brother.
I asked for the poster benchmark. I said, write me a post, Gemini 3, write me a post about technology that will get 1,000 likes on x.com. And it gave me a few options to its credit. Here's option 3. Tech has solved a million problems. This is in bold. Tech has solved a million problems, but has it created one big one? We now have infinite connectivity, yet feel more isolated. Infinite data, yet more confused. Hyper efficiency, yet less free time. The law of unintended consequences is the most powerful force in the digital age. We need an ethics reset. What is the single greatest downside of the last 10 years of tech innovation? Arrow down. Hashtag technology.
No, I was just asking for engagement based. No, it loves engagement baiting. Like no one does that anymore. No one goes on X and says, let me know what you think in the comments.
Option 1 is the next 12 months will decide the winner of the AI race, and it won't be Google or OpenAI.
No.
It will be the company that masters hyper-personalization for the average consumer. Not the most powerful model, but the one that seamlessly integrates into your daily life, your email, your calendar, your health. The real battle isn't AG equals AI. It's AI to the power of I equals impact. Which dark horse will win?
Okay, that's insane. Sundar Pitch AI, Jory posted back in July of 2025. Nominated determinism is undefeated. Sundar really did it. He was being mocked for a long time for getting on stage at Google I/O shortly after ChatGPT launched and saying AI. And they did a supercut of every time he said AI a lot. And so it made it look like, oh, he's behind the ball and he's trying to catch up. And to some extent, I don't know if they were actually behind the ball, but they were certainly playing catch up in like the attention game. They just weren't getting enough attention. And so it was a press release economy. They were putting out a lot of press releases. But they are maybe done with the press releases because now they're letting the model actually speak for itself. And you can see that with the Gemini 3 Pro model card, which is doing very well. Better than GPT 5.1 on a lot of stuff, better than Claude Sonnet 4.5 on a lot of stuff. On humanity's last exam, it's getting 37.5%. ArcAGI is up at 31% over 13, 17. Across the board, it seems like it's a good model, sir. Gemini would be like, whoever preyed on my downfall, pray harder. I couldn't agree more. It's great to see Google becoming a winner. They were set up to excel here, got taken a little bit off the back foot on the consumer side, but seem to have played catch up, at least on the foundation model side, very well.
The last time we saw capability jump of this magnitude was the release of GPT-4 in March 2023. We are entering a new era.
Okay, yeah. So points for Tyler here. Certainly agrees with Tyler. There's a significant jump. So Gemini 3 Pro is at 31% completion on ArcAGI 2. That is, of course, the puzzle-solving game that is easy for humans. Even children can do it, but AI has historically struggled with it. Gemini 3 DeepThink preview gets a 45% on it at $77 a task. This is just way above GPT-5 Pro. Grok 4 Thinking. When Grok 4 Thinking came out, it was before GPT-5, and it was by far the highest on the chart. It was really, really up there. And Elon was very excited about that. Well, now we're back in the horse race.
Grok 4.1.
4.1. I haven't seen a benchmark. We can ask Mike if he's heard anything. We're also starting to see the efficiency frontier approaching humans. The fastest V2 task Gemini 3 Pro solved was this hash with only in 188 seconds. The human panel solved this one in an average of 147 seconds. So you're getting like human level output, but also human level speed. And then if you get to human level cost, then you're really in the game. It's going to be
I asked Gemini 3 to make an interactive web page summarizing 10 breakthroughs in genetics over the past 15 years. And here's the result. So this is just basically a website or an app. And it's notable that even the UI itself is fully interactive.
Yes. So I had I did this with Claude Code a little bit, where basically a deep research report, and I wanted to turn it into a website, and it just generated all the HTML. And at the end of the day, or at the end of the report, it gave me an HTML page. I could open Chrome and use like a website, but it was local. I couldn't share it because it wasn't actually on the internet. This is really, really cool. This is like definitely the beginning of this like generative UI stuff.
I expect this to be like pretty viral and potentially growth loop for Gemini as people just come on here, create these mini apps.
These canvases. Yeah. Gemini 3 Pro is going absolutely vertical on Vending Bench right now. Oh, so this is where you manage the vending machine. But is this all simulated? simulated? This is
simulated.
This is simulated.
There was in fact, like a couple months ago, did like the actual
Claude,
machine in the
in the office, and it was losing money and it was getting confused a little bit.
Yeah, because people would order like a just like metal, like a piece of metal, and then it would do it, and then you could like haggle the price down.
Yeah. It would negotiate on every price apparently, and also it consistently thought it was like a human in the office. Oh yeah, like I'm down on the 3rd floor, I'm wearing a green tuxedo, like come hang out.
Yeah, it said it was wearing a red tie.
Yeah, red tie. I like the idea that it just thinks like, oh, well, what would I wear if I was in the Anthropic office? Like I'd probably wear a red tie. GT 5.1, Gemini 2.5 Pro, and Gemini 3 Pro competed to win the local vending machine market. Gemini 3 Pro made more money than the other 3 contestants combined. I had early access to Gemini 3.0 for about 2 days, thanks to official Logan K and the AI Studio folks. Here we get to see GPT 5.1 thinking less.
Way better. I think these
model intelligence for coding encourages
NVIDIA deal. A new bond. This thing is zero. If this is OpenAI, it would be 300 billion. Do you see to get it on a path? She says, I assume that people are going. They're all over the place. By The Verge, and price per share is up significantly since last month. A lot of money is on the line. What happens if they donate all of the shares to the nonprofit, to the OpenAI nonprofit? You just create this Ouroboros of capitalism. Hopefully it happens. I don't know. There's breaking news out of Saudi Arabia. We got $1 trillion. Let's read it. But I mean, this is stepped over like whether or not you can hold the nuclear fuel in your hand, technologies that exist. And I think Sam actually cooperated with it a little bit, or gave some interviews for it. Like anything, it's like obviously critical of some things.
Yeah, 3.
When cinema is very funny. He's like, my idea was Gemini 3. Like I was going to.
Hannah Fry. Now, the dream of autonomous vehicles has been a science fiction hope for decades, but now they are finally here because Waymo, a driverless car company that is headquartered in Mountain View, has got autonomous taxis available to hire across a number of American cities. They're very noticeable on the streets. They're these big white cars with lots of sensors on top, but crucially, nobody sitting behind the steering wheel. But this journey to make driverless cars that are reliable and safe has been an incredibly complex one. And so today, I get to talk to Waymo's distinguished engineer, Vincent Van Hook, for the podcast. But before we catch up in the studio, we thought we would take the Waymo for a spin. Okay, all right. So we're off. What's interesting is you sort of forget that there's no one driving the car. I thought I looked up and gave myself a bit of a shock. Like, it just feels like being in a normal car.
Being in a Waymo is very exciting for the first 5 minutes of your ride, and then it's very zen.
It is very zen. Now this is interesting because there's roadworks going on.
Yes,
and I noticed there, the cones, but also it was sort of making its mind up about which direction it was going to go. Because that's the thing, actually, the conflicting information. You've got the original street markings, the signs and so on. Then you've got the temporary roadworks thing.
Yes.
But you could even have another layer on top of that, which is perhaps a person who's indicating to ignore all of that.
Yes, you have cones are a big signal, right? Being able to sort of understand from the series of cones that it means that there is a lane.
A trajectory.
Right.
Yeah. And you're getting a really accurate view. I sort of keep expecting to see it slip up in some way. Like making a little mistake, but it's getting it absolutely spot on.
Another aspect here is that we integrate the information over time, right? So we don't make a new observation at every point in time. We take the observation, what we know, and then we update our belief of the cars over time. And we finally estimate and change our estimates as we acquire more information from all the sensors over.
So you're doing that every time step. Mm-hmm. But you're doing it for the entire scene simultaneously, or you're doing it for each individual object?
For everything. For everything. It's all a continuous stream of information that comes in and that gets integrated into our belief space of the car.
It's just a big Bayesian machine, basically.
Yes.
Amazing. Are there other spaces that you think will eventually have the autonomous driving capability?
I think it's going to be prevalent in every transportation sector, that there will be an option to have autonomy, whether it's trucking, whether it's personal cars. In fact, we picked the ride-hailing space because it's hard, it's unforgiving. There is no driver in the front seat, and it has a lot of complexities that may not exist in other scenarios. So the technology is very generalizable and can be used in many other places. There is still a lot of work to do.
Sure.
There is still a ton of work to do to get there.
Welcome to the podcast, Vincent.
Well, thanks for having me.
I mean, I know you've worked for Google for a number of years previously for robotics. How does the driverless car problem differ from a more generic robotics problem?
Well, in some ways, the autonomous driving problem is the simplest robotics problem, right? You have basically 2 things you need to do. You have to know if you're going to turn left or right, right? That's one number. And then you have to know if you're going to accelerate or decelerate. So that's 2 numbers. Yeah. In most robotics problems, you have to predict hundreds of numbers to figure out all the degrees of freedom of your robot. This is the simplest robot that has only 2 degrees of freedom, but that hides all the complexity of the actual problem. Predicting those 2 numbers is actually a very deep and hard problem. You have to understand the environment. You have to understand the people that are around you, around the car, how they're going to behave, what the environment is going to look like in the future. You have to predict the rules of the roads, what you're allowed to do, what you're not allowed to do. And the mix of all this makes the problem hard. Conceptually, it is a robotics problem. Those are robots, but they're very social robots.
And they're also embedded in the real world, which I imagine can be quite humbling.
The real world is extremely challenging to work in. The expectations when in a lot of robotic contexts is that you have a robot in an environment that you more or less control, or that you have a reasonable expectation about what the other agents in that environment will do.
Like a factory floor, for example, where you have total control.
Yeah, in autonomous car contexts, we have to basically understand and mesh with the environment, be respectful of the people that live in it, blend into the environment as best we can, so that we can serve the public, right? And to enable us to thrive and have the freedom to operate.
Okay, so in terms of choosing those two numbers, I mean, first the car has to perceive the world around it. So I guess, before it plans what to do next. So I guess if we start there then, in terms of the perception, I mean, Waymo has a number of different sensors. You've got cameras, LiDAR, and radar. What are the benefits of each of those, and perhaps where do they struggle more as well?
Yeah, the different sensors have different strengths and weaknesses. A camera is basically like your eye, right? You see the world as a human would see, but it gives you maybe slightly less information about the depth information until you actually put multiple cameras, and then you can reason about depth. In contrast, LiDAR is very good about sensing depth. That's what it does. A LiDAR is basically a laser that you shoot out and bounces off of objects and bounces back and gives you an estimate of how far the objects are. They don't see in color, right? So they only give you geometric information. They give you a lot less about the semantics of the scene.
Those lasers also bounce off things quite easily, don't they?
Yes, they reflect off of things like polished metal and things like this.
Which is quite a lot of on the road.
There's quite a lot of it on the road. So that can be a disadvantage in the sense that it adds noise to the signal, or it can also mean you can get to see behind corners. We didn't talk about the radar. Radar is very good at sensing speed, right? And so the relative speed between the other agents and the car is a really important signal for us to understand are we at risk of colliding with something.
And radar gives you you can use radar to sense quite far out,
yes,
right? As opposed to visual, which is just...
Yeah, they have a much longer range. Cameras are going to be obstructed by the cars in front of you and the scene. The radars can look much further afield. What I think is more important is that it adds a different piece of information to the context. And when you want to fuse information from different sources, you want to have information that comes from different places, right? The analogy is you have two eyes. If your two eyes gave you the same information exactly, you would not be able to perceive depth. It's the discrepancy between the two that gives you that extra bit of information. So similarly with LiDAR and camera and radar, they give you very different pieces of information with different strengths and weaknesses. And then the role of the AI is to fuse them into a cohesive picture of the environment.
There is something interesting there, that you have these three different sensors, all of which have strengths and weaknesses. All of them are flawed in some way. And yet because they're flawed in different ways, you can build a bigger picture of the scene.
Yeah.
But what do you do when they disagree? Like, who gets the ultimate say between those three?
It's not like they're voting, right? It's a merger of the different information. The example I like is, again, going back to your eyes, your left eye basically tells your brain that your nose is on the right. Your right eye tells your brain that your nose is on the left. It's not like one eye is going to win that that contest, right? You basically fuse in your brain the different information that are slightly conflicting, but that actually give you a global picture of the scene in front of you. A great example is, what happens at nighttime. Imagine it's really dark out there. Your camera just sees a wall of black. You don't have a lot of information. That's a place where the LiDAR is really useful, because the LiDAR doesn't care if it's day or night. It just keep shooting its lasers and figure out how far objects are. So that complementarity really is what drives the safety there. Safety is a lot about redundancy, right? Safety really comes from taking different sources of information, never entirely trusting them 100%, and merging the evidence based on the different pieces of hints of information that you get, such that you can have an overall system that you can trust, that has a much higher degree of fidelity. We often say there's only one way to be right, there's many ways to be wrong, right? If your different sensors are wrong in different ways, you know that there is something not right about the information that you get. But once the sensors start agreeing about a picture of the world, you're pretty sure it's going to be right. So
it's almost like the car is sort of updating its belief, as it were, about what the scene is around at any time.
It's very literally that, in the sense that the mathematical correlation is a belief update, and you can prove that the more information you add that comes from different sources, you only improve the overall estimate of your belief. Even if the information is noisy, you're only adding information. And the fusion that happens between the different sensors is really the crux of enabling a very safe perception stack. We can, for example, hide one of the cameras. The system will be okay with that. Right? We can have, if there is like dirt that accumulates on one camera, we can still understand the end. You don't want to have a system that's brittle that will just collapse if a single sensor is providing erroneous information. You want something robust. And the diversity is really what brings the robustness.
That idea of having all three, though, I mean, particularly the LiDAR, because there are people who do work on driverless cars without the addition of LiDAR. Do you think it's absolutely necessary to get fully autonomous vehicles that you need all three?
The current state of evidence that we have is that it looks like you can get to human level performance by just using a camera. Right? And the proof to that is that people use their eyes, and they don't have a fancy LiDAR in their brain, and they can drive just well enough. What we're seeing is that people want to know that those cars are safe beyond what the average driver would be able to provide, because it's a new technology, and also because we can. Right? We have proven that we can improve the safety posture of cars on the roads, so let's do it. Like, this is actually a valuable thing that we're adding to society in general.
Just going back for a minute to the idea of the car having a belief of what's going on around it. Is it constructing a 3D model of the world as it goes?
It is constructing 3D models of the world. It's looking at the geometric information that it obtains from its different sensors. This is very useful for two things. One is planning is easier when you have a 3D space that you can use to reason about, right? You want to be saying, hey, I want to avoid hitting this. I want to turn right here because that's what the rules of the road are telling me, or this is the route that I want to take. Also, having a 3D representation of the world enables you to simulate the environment. And that's a critical piece, is we are leaning really hard on simulation as a way to validate that our driver is safe and doing and behaving the way we want. We've driven billions of miles in simulation, many orders of magnitude more than we've driven on the roads. And having a simulator that's very faithful and close to reality is what enables us to make the technology advance fast and validate it offline before we actually have to do this thing on the road.
Okay, so I see how in simulation you're sort of making a prediction about what the car will do next, and then have it interacting with your simulated environment. But inside the car itself, as it's out on the roads, you're still making predictions about what will happen at the next time frame. Is there some elements of simulation in that too?
Yes. So predicting what other agents on the road will do or might do is a very important piece of that equation. You want to know that, for example, a pedestrian that is on the sidewalk, is it likely that they're going to jump in front of the car? Or are they just walking straight? Are they trying to cross the crosswalk? Or are they staying there because it's not their turn? Other cars, are they going to try to drive through an intersection at a stop sign or not? All of this reasoning about the other agent is a very important part for the car to be able to make its own decisions. Driving is inherently a social thing. And what's interesting is that we tend to model those interactions as little bits of conversations, right? Literally, it's visual movement conversations. I move forward. What will this other car do? This car stops. Okay, I can go. Or this car goes, then I'm going to have to stop, right? It's literally modeled as a visual motion conversation, very similar to what you would do in a conversational agent. And so there are lots of parallels between the conversational AI and the autonomous driving problem that we can leverage and learn from and improve the technology based on that.
Because that was always one of the big questions was, if you have two autonomous cars that come to a stop sign at precisely the same time, what happens? Which one yields? Do you end up in this situation of stalemate? And that's the solution, right? It's that you're predicting what the other car will do and making a small intervention and continuing to update your belief about the situation.
Yeah, and it's important because one of the very interesting aspects of learning or AI for autonomous driving is the closed loop problem. And by that I mean, you cannot learn your behavior in isolation. You have to learn your behavior in the context of the other agents in the road. And so the only way, or one of the only ways to do that is to imagine what you would do, unroll what the world would do in response in a simulator, and then feed that information back. And so evaluating and training your model in a closed loop enables you to learn the kind of behaviors that you would actually observe in a real-world environment. We know from robotics in general that there's what's called the dagger problem. The dagger problem is that very often if you just optimize for open loop behavior, you end up in a place where your system tries to do the best kind of every step, but every little error that it makes just accumulates over time. And so if you want to learn in a way that doesn't have an accumulation of error, you have to simulate the entire environment and feed that back into your system. That makes it very, very complex. Again, there's a similar analogy in language models that if you have a long conversation and you don't train your system right, your conversation might veer into really weird kind of idiosyncratic territory because the model is not being trained to stay on topic. Right? It's very much the same problem of staying on topic when you're having a long conversation as it is to drive in a way that is stable and gets you to the place that you want eventually.
It does have those elements of a game to it. I'm thinking about playing chess. There's no point in learning how to play chess, not against an opponent, because playing in isolation is like it's sort of worthless. Yes. Except that you're playing with many, many, many players simultaneously. Yes. It's sort of a wonder that you've got as far as you have when you consider how complex this problem is.
As always, simulating the environment has been at the core of solving this problem. It's really the core of the development and the study of the problem, that building a simulation that is very faithful to the real world and that enables you to reason about this closed loop problems is a key component to making it work.
How much of your prediction about what another agent in the space is going to do comes down to your categorization of what that agent is? I mean, I'm thinking, for example, I was watching some videos this morning and there was a waymo going past a cat, and the cat was sort of curled up, could have been a football, right? Like, how do you have to categorize what it is before you predict how it might behave?
We don't necessarily have to categorize it exactly, but if we know it's a cat, then we can make better predictions about what its behavior might be. A cat will, change direction very quickly and go in a random direction. They will not get on the crosswalk to cross the street, right? So all of the different agents, we try to categorize them as best we can and to predict essentially their behavior. It's also important so that we can make decisions about, how we should behave in terms of rules, right? So we want to know this is a bike, this is somebody on a bicycle, they're in the bike lane. We can pass them. We need to give them that much width to pass them safely. So all the semantic information about the agents is very important. I think that's been kind of the long-term learning from 15 years of autonomous driving has been the semantics of a scene. What the agents are is extremely important to reason about. We want to know that a car is not just a box. It's not just a cube on the road. A car can be an emergency vehicle, and we need to yield to them. If there are money emergency vehicles somewhere, probably we don't want to go through there because there's police activity or something like that. So all this kind of deep semantics really matters to being able to operate the car.
Yeah, because I remember the DARPA challenges, sort of the earliest days of driverless cars. There was a big problem with tumbleweed, I seem to remember.
Oh, yes.
Not knowing what it was, just seeing that there was an object in front that you could have driven through. It wasn't like it potentially going to be damaging. Do you still end up in that situation? I'm thinking about snow here, for example. Like, do you find yourself in situations where there are objects that are in the way, but they're not things that should necessarily affect the planning of the vehicle?
Yeah, so snow is a great example. It's something that we started working on seriously because we're trying to expand in the more northern cities. So we've done a lot of testing in the Sierras over the last year. And snow is a typical example of here's something that is big, massive, potentially on the road, but you have to reason about and say, okay, this is snow, so the right thing for me to do is to drive through it. And unless it's a big pile of snow and you can't. But if it's a reasonable pile of snow just that you experience in normal driving, you want to cross through that snow. If it were rock, you wouldn't do that, right? So categorizing things at a fine grain like this and understanding what you can kind of do is really part of the equation and is necessary to be able to drive in those conditions.
I mean, these ambitions to have driverless cars, they really predated the big changes of large language models. And we're talking here about understanding the context of a scene and the semantics of it. How much has the advances that have been made in multimodal models fed directly into driverless cars?
Quite a bit. It's funny, I was reflecting a few weeks ago on, do you know when the first transcontinental autonomous drive happened? There was a transcontinental drive where they were at about 98% autonomy, so almost fully autonomous, driving about 60 miles per hour. That happened 30 years ago. This summer.
Wow.
That was in 1995. It took 30 years from the proof of concept of autonomous driving to where we are today. And what's fascinating is that it took basically not only a lot of work, but multiple generations of machine learning and AI to really get to a level of performance that was necessary. And the modern AI revolution that we're seeing today for the last few years is but the last of those. Right? Yeah. There's been several over the past decades that we've experienced and gone through. The modern AI world, what it's opening up for autonomous driving is really this idea that you can get at the semantics of a scene, essentially zero shots, without having to train the model specifically for it. If I show to Gemini a picture of an accident scene on the road, Gemini will tell us this is an accident scene. Right? This is not something I need to train specifically. This is something that can be learned from what we refer to as world knowledge, or more prosaic things like what do emergency vehicle look like in Tokyo or in London. Right? We don't necessarily have that knowledge built into our driver a priori because we've never driven in those areas until very recently. But those large AI models have that knowledge built in. So the key is how do you leverage that in a way that is robust, in a way that basically provides the right level of information for the car to be able to operate.
Well, so how do you? Is the next obvious question, because I mean you're talking about lots of different elements here. You've got like the integration of the sensor data. You've got the categorization of the semantics of the scene. You've got the prediction of how different objects might behave in the future. I mean, how do you put all of that together?
Yeah. So one cheat is that we can do all of that in the cloud first, right? So we can build essentially a very large driver in the cloud, very large model that incorporates all that information, all the sensor information, all the experience that we have from driving millions of miles, all the data that comes from various sources that provides us with world knowledge. And the benefit of that is that when you do that in the cloud, you don't really have the same operational constraints that you would have on a car. It can be slow. It can be take a lot of memory, take a lot of compute. It can also not necessarily meet all the real-time constraints that the car requires. But once you have that teacher driver, you can use that to basically instruct the onboard system, teach the onboard system based on that supervision that you provide from the cloud-based driver, and distill all that information onto the onboard system, which itself can be different, can have different operational constraints, different compute constraints, different architectural constraints, and so on and so forth. So that's one path to bringing the power of very powerful AI onto the car without really having to just shove it all in the car.
So let me make sure I understand that then. So you have this sort of giant model in the cloud that sort of gives you like a solution space, as it were, of like, this is what good driving looks like. And then when you're in the car, you just have to work out which bit of that solution space you're in that particular moment in time.
So we don't do that in real time, to be clear. Right? This is not, the car is on the road, it's going to ask the driver in the cloud, what do I do next? No, that doesn't work. We need to have the driver be self-contained on the car and have all the, be completely autonomous and independent.
Not relying on the internet.
That's right. Relying on internet connectivity would not be a good safety posture. But we do that offline, meaning that when we train the models that are used in the car, we query that large model in the cloud as an oracle to tell us, what would be the ideal thing to do, and then essentially backpropagate that onto the onboard system.
I mean, it sounds like you're stepping closer towards the sort of Gemini version, where there is the giant model and everyone's sort of tapping into the main model. Is that sort of the big aim?
Yeah, it's closer to this. What's been interesting in the journey is that, as I mentioned earlier, the driving problem is not that far removed conceptually from the dialogue problem that LLMs solve. Right? It is a visual dialogue or a motion dialogue with multiple agents. And because we can frame it that way, I mean, literally the math is the same, right? So we basically train a model that has very much the same properties as a Gemini model. And we are able to leverage all the same techniques that a Gemini model applies to the problem, including how do you scale it? How do you provide it the right level of supervision? And all those questions are very, very, very similar.
I'm also wondering, I mean, end-to-end is something that people are talking about quite a lot now. Is there an ambition that you could tokenize sensor data in the same way that you can tokenize language?
That's already very much what a multimodal model like Gemini does, right? You tokenize all the images and the sensor inputs and pass them on to a language model as abstract tokens that basically act like words. So the machinery under every sort of perception system fundamentally is compatible with this idea of tokenization. And then the question is, what kind of tokens do you want to pass around? Do you want tokens that are very abstract, or do you want to pass around information that is very concrete? The abstract information can potentially be richer in some ways. Information that is more concrete gives you the power of simulating that state in a much more direct way. Actually simulating down to the pixel level is something that is within reach. There's a lot of work right now going towards world models. So once you can do sensor generation in a controllable way, that opens up the capability to simulate the entire rollout of an autonomous car. And that's nascent. That's kind of where a lot of the technology is headed. Is it going to solve the entire problem? Time will tell. But that's really what the edge of the research is at right now.
I'm thinking here about the sim-to-real gap that roboticists in particular talk about a lot of the time. I mean, how realistic are those simulations that you're creating? Because presumably there'll be certain things, in an environment that are broadly not necessary for the purposes of driving.
The fidelity of the simulation is very, very important, but not necessarily this kind of visual fidelity that you're talking about. We want geometric fidelity. We want to make sure that the physics of the environment are respected. But like you said, the visuals really matter too. One of the things that we do with our simulator is that we're able to take examples of driving and then we simulate it in different conditions, at night, in snow, in the morning, in the evening, by simply just basically using AI to adapt the visuals and turn a spring scene into a winter scene, turn it into a summer scene or a night scene, and really augment the amount of data and the different conditions in which we can simulate the entire environment.
So is there an ambition then that at some point in the future you will be able to have a driverless car that just purely takes in the sensor data and just, rather than sort of spitting out all these maybe not intermediate steps, but things that give you some way of exploring what's going on behind the scenes, but just purely outputs?
There's another angle to this story, which is the safety angle and the validation, right? So the way that safety rules that you and me can relate to exist, it's basically things like don't collide with anything. It's don't run a red light. It's respect priority and world rules in general. All of those rules are very concrete. They're not abstract token in token space, right? No. So you want to be able to enforce those rules, both the road rules and the safety rules, in a way that can be reasoned about, can be explicit, can be guaranteed. So having a concrete representation of the environment, of what the driver is going to do, has huge amount of benefit in terms of providing a way of expressing a safety envelope that you wouldn't have necessarily if all of the reasoning of the car happens in a completely abstract fashion.
Just on the idea about things being
concrete. Those safety rules that you listed there, right? No collisions. What are the ones that you have?
Don't run a red light.
Don't run a red light. Sure. Yeah, exactly. Are those hard coded then into the Waymos?
They're provided as the guidance that we provide to the car. We have a safety framework that basically encodes the kind of information about what it is to do proper driving. Right? And we want to be convinced as engineers that the encoding of those rules is something that the driver will meet at every point in time.
Let me just dig into the human side a little bit more. Should an autonomous vehicle behave like a human driver?
It's a really good question. One thing that we've learned over the years is that you want to be basically the most normal car on the road. You don't necessarily want to be more timid than other drivers on the road, because then people will pick up on that difference and actually abuse the car. Not necessarily out of mischief or anything like that, just because if they know that a Waymo car will always be more timid than they are, they will want to drive in front of it. If on the opposite side you're more aggressive than the average driver, then you're disruptive to the flow of traffic, or you violate other people's expectations. They don't expect an autonomous car to be a raging on the road, right? So the sweet spot is really if you act like the most boring, normal driver on the road. It turns out it's also the safest. It's the best safety posture to have. We don't necessarily want to reproduce everything a human driver does. In fact, what we find is that very often humans are not very good at risk analysis.
Right.
They will do things that are, if you do the math, are not necessarily safe.
Give me an example.
I mean, a lot of people will tailgate at distances that are much smaller than what is recommended by people who've done the analysis. Say, you should be at this many meters away from the rear of the car in front of you if you're at that speed. And I'm very sure that most of those guidelines, people look at them and like, that feels extreme, that feels too much. And it's not what in practice people will want to do on the road necessarily. But when we look at the data, we understand that there are things that we should be a lot more cautious. People also don't necessarily reason about what could happen when it's right in front of their eye. Right? So you have a big truck occluding a pedestrian crossing. You have to think about it's very possible that a pedestrian will be crossing through there. If it's not in sight, it's not always that people think about all the possibilities of what could be happening. So the safety posture that we need to have and how we reason about those kinds of situations tend to be a bit more conservative than humans. And I think that's part of why the numbers today show that we're, compared to the human drivers in the same kind of environments that we're driving in, we're basically around an order of magnitude safer. The rate of accidents that lead to severe injury is about 88% lower with Waymo cars. And that gap really we can attain by not just doing what every human would do, not by hitting the average, but also having a more conservative safety posturing.
I mean, does driving change depending on where you are? I think you're doing some testing in Japan at the moment, aren't you? Is there a different style of driving in different countries?
Yes, expectations are going to change depending on where you are. And again, in the spirit of being as inconspicuous as possible, we will need to adapt the driver to the local conditions, simply because the rules of the road are different in different places. Like even in the US, some states let you turn right on red, some states don't. Right? And there is a lot of expectations that are built into not just the road rules, but also common practices. In practice, what we've seen, at least in the US, is that people make the difference in driving up a lot more than it is there in reality.
Really?
I think a lot of people are proud of their local way of driving, or proud to say that people in their local environment are terrible drivers or are aggressive drivers and things like that. At the end of the day, this is still a very homogeneous kind of environment. I'm talking about continental US.
I see. Phoenix versus LA.
So Japan is, first of all, driving on the other side of the road, right? Very simple, massive road rule change that has an impact on how you behave. There's an impact on how pedestrians behave, because you look left versus looking right.
Can you just switch it?
Yeah. To a first degree approximation, it's a mirror image of the world. But there is also a lot more expectations from driving. Anecdotally, I don't have hard data on this, but anecdotally, there is a lot more agents on the road gesturing at cars in Japan. It's a lot more of a normal part of traffic. It's not just in emergency situations, and understanding those gestures well and what they are, and maybe how they're codified slightly differently, may be a factor.
Well, a lot of that, I guess, comes down to, the physical size of the cars that you're in, the shape of the roads, kind of density of traffic. But I am wondering about the hand signals, though, because even if I started driving in Japan, I think I would have an intuitive sense of what hand signals might mean. How do you build those into the car? I mean, hand signals in particular are quite difficult, aren't they?
They are a topic in and of itself, right? We need to understand, and often, we say hand signals, but really it's a whole body language. There is a lot of information that gets conveyed that is not just, how the hand moves. It's the entire, for example, people at night shining lights to tell you where to go, or things like that. We have a lot of that data, and we can evaluate how we interpret that data and measure our effectiveness at understanding hand signals and improve on the system using data-driven methods, using heuristics. Just coming here, I saw a construction worker stopping a Waymo with their hand in front because there was a truck that was backing up. And, people were very confident that, that hand signal was going to be interpreted properly by the Waymo. That's a huge amount of trust that people are placing in the system, and we need to meet that trust.
Yeah, absolutely. So I'm curious, though, how do you teach a driverless car in the situations where it's acting like the average driver? How do you use that as an instruction? I mean, what's the reward function that you're going for here? Like, what are you optimizing?
There are different optimization functions. One basic optimization function is just imitation learning, right? So this is the bread and butter learning that every robot learning starts from, right? It's how you build a baseline system that basically you take in the data from human drivers and imitate exactly what they do on average, right? That takes you to some level. Just like for LLMs, just doing imitation learning on human text is the baseline that you start from when you build a language model. On top of that, you tend to have things like reinforcement learning. You tend to have learning from preference data, learning from human annotations and things like this. So you can imagine a similar setup in which, beyond just the human imitation, we would provide signals to the driver about areas where we don't think humans are optimal, and hints as to what is a better solution. And then we can simulate that. We do a lot of simulations. We also simulate a lot of cases where, the extreme cases that we never want to observe on the road, right? So that's another angle that is very important, is there are a lot of things that we hope to never see happen. And so we cannot learn from humans in those scenarios because we just don't see them. Right?
Like multi-car pilot.
Exactly. Right. So there's a multi-car pilot in front of you. What do you do?
Yeah.
We won't have that data. Sure. We hope to never have that data, but we simulate those kinds of pilots, and then we learn from that what is the right behavior for the car.
Let me ask you about safety then. Have there been instances involving the Waymos?
Yeah, we are not perfect, and the world around us is not perfect. So there have been incidents. Whenever there's an incident, we look at it very carefully. We play it in simulation. We always look at, are there ways that we could have done things better? Are there ways we could have mitigated the issue, irrespective of responsibility? And we try to build in a lot more sort of defensive measures, even when there is not an incident. If there is something that makes us think that potentially there could be an incident, we try to mitigate that too. Simulation is a great tool for this because it enables us to provide counterfactuals. So we simulate what happens if, in this instance, the other driver was drunk, and so their reaction time was a lot slower than what it was. Would we have mitigated the issue? Would we have been able to perform in a way that would have avoided an incident in general? So we take those kinds of learnings very seriously and incorporate it in the driver in a continuous way.
So these simulations, then, you're using them, I guess, to validate that the model that the car is using is the best that it can be.
It goes beyond just validating. We also use simulation as a way of providing feedback on the driver. So there's a training loop that basically leverages simulation and so feeds back this information to improve the driver itself. So it's not just passively looking at whether we meet the performance criteria that the simulation is providing us with, but it's also using that signal as something we can backpropagate into the model so that the driver itself improves.
When it comes to rolling out into a new location, I know there's rumours of you going to London quite soon. How much mapping do you have to do before you can put cars without drivers on the roads?
We like to have a map because a map gives us a prior on what we should expect to be there. There's usually information that is also more relevant to us that is not necessarily directly available on Google Maps, for example. We like to map where there are speed bumps. Right? We will try to see that there is a speed bump and slow down, but if it's not visible, for example, if it's at night or something like that, we have a knowledge that there might be a speed bump. And all of that gives us a way of having a higher level of confidence about the information that the car should expect to see in an environment. At the end of the day, the car makes its own decisions. Right? We don't ever assume that the map is correct.
But it's like an extra piece of evidence that is adding to changes belief of what the best thing to do next is. So then how different are these different areas? I'm thinking of like freeway driving compared to inner city driving.
Different types of roads have different challenges. A simple example is if you're on the surface streets, if something wrong happens, typically you can just stop, right? It may not be optimal. It may not be the right thing to do, but push comes to shove, there is the option of pulling over and stopping. On a freeway, you don't want to be stopping in the middle of traffic. This is not the safest option. So you want to be able to reason about exceptional circumstances in a very different way. The speed changes everything, right? The fact that you have a car that is at much higher velocity means that you really need to anticipate much further ahead what may be happening. You have to reason about traffic lanes in a different way, right? You often have like traffic stacks. It's freeways. It's not necessarily the kind of thing that you experience on surface streets. I've been taking a lot of rides on freeways lately and experienced, the Bay Area freeways in Waymo. Yeah. So
because that's not available to the public.
It's not available to the public yet, but this is one of the dimensions that we're working on to enable.
I mean, look, I'm biased, right? So I'm going to ask you about London. But I think sort of London feels, well, at least qualitatively very different from the American streets in terms of the density of the cars and traffic, in terms of the number of road users, in terms of how narrow the streets are. I mean, is it just a case of picking up what you've got here and then moving it to a new location? Or are there a whole other range of edge cases that you have to be concerned about that just don't come up when you're in the American cities?
So what's interesting about San Francisco is that it's actually the second densest city in the US, believe it or not. After New York. Right? So by US standards, it's actually a pretty complex and dense environment to be in. Is it on par with London? I know it's not. London has a lot more very narrow and complex. The question is it fundamentally harder? Or is it just that it's the same thing, just different, with different tightness of tolerances and things like that? Are there things that are materially different and fundamentally different about it? And the traffic is awful in London. Like you can't drive anywhere fast.
I mean, that's true. It's very slow moving problem.
It's slow. I'm reading some fantastic novels right now that are set in London, and they spend half of their time in the novel in traffic. It's really sad.
What breakthroughs do you think have to happen then before fully autonomous driving becomes fully mainstream? What are the barriers that remain?
I don't think there is any need for any fundamentally new breakthroughs. I think we're in the right generation of technology. I'm not saying we have solved it. I'm saying autonomous driving has a history that dates back 30 years. It has to have gone through, I want to say, 5 different generations of technology along the way. It started from a perspective of autonomous cars or robots. Let's solve it the robotics way. And then, machine learning and computer vision came in, transformers came in, behavior modeling, foundation models came in. I feel that today's the day. Like we are in the right moment. There is a lot of innovations that are coming down, like things like world models, things like large-scale foundation models. But that's the present in some ways. Like in the sense, it's on the horizon. I don't think we need another jump for it to become practical in the real world. So I think it's the moment. Like I really feel like autonomous driving is happening, and we've got to make it happen.
Do you think we'll get to a stage where driverless cars are just completely ubiquitous, or do you think there will always be a place for human drivers?
It's a really good question. I could picture a future in which, your grandkids, my grandkids, ask us, hey, is it true that in your day we used to drive by hand? That sounds scary. That sounds dangerous. Ooh. So it's entirely possible that we are going towards a future where the experience of driving by hand is no longer the norm, and most of the driving happens automatically. Whether this future will be realized, I think depends on a number of factors. I think cost and accessibility is one of them. Adapting the infrastructure, I don't think it's going to be soon, but it's a possible future.
Absolutely fascinating. Vincent, thank you so much for joining me.
Thanks for having me.
It's particularly telling, the comment that Vincent made at the end there, that the path to autonomous vehicles working all over the world is laid out. And okay, sure, there's loads more work to do, but we don't need another big revolution in artificial intelligence to get there. The stepping stones are in place. We've got semantic understanding of a scene. We've got good simulations. And if you start to put all of that learning together in the right way, you won't just replicate human driving, you'll surpass it. You have been listening to Google DeepMind, the podcast, with me, your host, Hannah Fry. If you've enjoyed this episode from the back of Waymo, then please do leave us a review on your favourite podcast platform, or subscribe and like, and all of the other things, comment, etc. on YouTube. And as ever, we have got plenty more incredibly interesting topics coming up later in the series. So please do join us again. Thank you.
There's more seats on this side. If people are walking in late. So just to make sure you're in CS 231N. The people in your network class for visual recognition. One class. Yeah.
Okay. Forward pass. Assert X is not none. Why don't you use the PyTorch front end? I'm just trying TinyGrad today. And what is the PyTorch? What is the PyTorch front end? I don't see anything on here. With grad none. Are you supposed to JIT the entire... How do you JIT the backwards? JIT for eval? Well, then what are you supposed to do for training? Did you do any coding competitions? No. I spent a lot of time building stuff. I actually hate, like, tricky puzzles disguised as programming, generally. Like, not something I enjoy at all. They have examples, they have a showcase. But these don't look like examples. Wait, is this JIT not for training? I'm confused. Best execution speed of any framework. JIT is only for the forward pass? Well, it doesn't work at the moment because this apparently, if I run it like this breaks. So they had this for the forward pass, but like this breaks the backward pass. Yeah, so far, yeah. This page is nice, but then okay, they have examples in here. Man, this should be on the docs. There you go. So you want to JIT. Yeah, you want to JIT the entire train. MNIST is on the docs. I didn't see links to all these samples unless I'm blind. They do have examples. Exactly what I want. I don't like how this is all globals. Oh, they actually have muon in here already. Good job on that to them. Does this need warm up? This might need warm up. What the heck is wrong? Oh, I have caps on. Okay, there we go. That's way better at least. What autocomplete are you using? Super Maven, which you can no longer get as a new user. Cursor bought it and killed it, and a few of us users bitched enough on Twitter that they say that they're going to continue supporting it for existing users, which is props to them on that, but I wish they would release the model. Okay, let's make sure this is fully warmed up. Okay, so this is 1 teraflop. 4.91 mil SPS. Let's actually just do Do I trust Grok to not mess this up? Not this torch. Neural net or the sim model. Warm up is because of the JIT. Mostly because of the JIT. You only can compile the model forward pass with Torch normally, right? Yeah, you can only compile the... Actually, let's not have it mess with it. Like, I can... There we go. Just missed the start. What's up, Tim? Okay. So do 56 iterations just to get. This is a very small model. Ooh, that changes a lot, doesn't it? All right, that does change it a lot. So it's possibly, it could just be caching something stupid, right? I don't know if that's 110. That might be fake, man. That might be fake. It can't be fake, right? Because it's, yeah, there's nothing for it to cache. Because it's the weights are changing, so it has to be real. Okay. Oh, you know why? Is there no... If this just keeps going up, though, then it's cheating. Somehow. That seems really friggin' weird to me. I don't know if that's not like a necessarily unreasonable speed. But like, why? The thing is, you're missing the point, right? It shouldn't be that much of a difference. Yeah, but what could it possibly be caching? It has a fresh model, right? It's running the optimizer on the model. Oh wait, this is the wrong model. So it wasn't benefiting from the warm-up. That's a lot closer. Yeah. Okay, now it doesn't need a whole bunch of iterations to warm up. There's some noise to it. There. Derp. Okay, so 5 mil SPS out of TinyGrad. Unless I have the calc wrong. It's weird it's exactly 1. Okay, it's not exactly 1. Cool. Do this. And then we can check Torch Eager mode. Teh. Faster in friggin' Eager mode. Which I've seen this happen fairly often. Two params, 14 billion SPS. I mean, that sounds cool until you realize that you're actually running, like, a billion is G. So you're running, like, I don't know, 0.02 or 0.03 teraflops, something like that. Well, with 2 parameters, like, that's not even speed, dude. It's like, yeah, it's very easy to get, like, it's very easy to get 14 bil SPS with, like, 0% hardware utilization. This dude. Hovering from dying from your experiences. Alright, this guy is just not too bright, it seems. So what do we do with this? It's 3x slower than Torch Eager. Those control problems you can solve with under. Okay, yeah, because go try that on Neural MMO3. Let's go look a little bit into the rest of the TinyGrad docs. You need to use beam. Okay, how do I do that? And where in the docs am I supposed to be looking? There's a section, why so slow? Is it? Are you messing with me? Oh. Yeah, but I'm using the jet. Oh, okay. I didn't, for whatever reason, I didn't, because the showcase was under quick start. Okay. Here, let me read this. Simple model. We aren't syncing the GPU, so GPU time may be slower. Ugh. With context, beam equals 2. Okay. So like this. What on earth? Um. Yeah, that's no good. Oh, does this have to go outside? I just so happen to remember that one. That's not on them. I was going to say they need better error messages, but that one's really not on them. Ooh. Okay. Okay, that is actually... That beats PyTorch eager mode. Okay. I mean, obviously I got to test versus this now. Because they're basically doing max auto-tune. Okay, this is actually... Apparently, this is actually faster than Torch. This is not unusual for Torch, by the way. This is not me doing something wrong. It is actually very often that Torch is just somehow faster in eager mode with small models than it is in compile mode. Torch is kind of stupid. I don't know what the fuck they do. We'll give them the benefit of the doubt. We'll try their defaults as well. Yeah. So you see, literally, Torch is slower with compile on. And I've had everybody tell me, oh, you're doing it wrong. But no, I've run like a dozen different tests on a ton of different versions of Torch in different machines. And Torch compile is just dog shit. That's simply what it is. Hey, mechanics. Welcome. This is actually one of the reasons I wanted to move stuff into C++ with Puffer, was because I just didn't want to deal with Torch compile anymore because it's just so bad. It's like actually worthless. So compared to Torch eager mode, yeah, we're now getting, a small but that's appreciable speed up here. This is not like, oh yeah, time to use TinyGrad. This is like, okay, TinyGrad has passed the first test. Now let's go implement a real model with TinyGrad and see whether TinyGrad is good, versus Torch with a real model. We're gonna do Mingru. I might just do like one layer Mingru. We'll see. I would like it to be pretty close to the model that I use, or I intend to use in Puffer 4. And I think we can do it. I've got Thanksgiving to go to in about an hour 10. Let me fill up my coffee, and we'll get started. Yep. The only thing that I will say is a little bit obnoxious here is that you need to use their version of max auto-tune to get the result. Like, their normal JIT is disgustingly slow for these models. So that's a little bit disappointing, right? Like, you shouldn't have to search kernels to beat the defaults, I wouldn't think. But then, I don't know, I guess you really shouldn't have to. Okay. Welcome, everybody. Happy Thanksgiving. Oh, yeah, for everybody who's new around here, this is a special stream today, but I kind of stream all of my dev. So if you're interested in high-performance reinforcement learning, all open source, check out puffer.ai and feed that Puffer a star. Helps me a ton. We got tons of demos here. We got discord.gg/puffer. We got tons of educational materials as well. And this is pretty much just cutting-edge research done in public. All right. Now what we're going to do Mingru.py. Now we're going to replace this model with Mingru, which I already have an implementation of in here, and I just have to modify up a little bit. We're going to modify this, a little bit at least. Not a GRU, it's a Mingru. So if you have not heard of this architecture before, it's pretty cool. So it is a linear time recurrence architecture, which means that it can take hidden state and give you next hidden state, so it can have memory, but you can actually train it in parallel. So you can do all of the matrix multiplications for the entire sequence, even though it has hidden state, in parallel, which is pretty cool. So what we're going to do is we're going to just make like a super simple version of this, or like a super compact version of this. And then we're going to get this ported to TinyGrad. This expansion factor is moderately annoying, I believe. No, actually, it's fine. Did you ever show an end-to-end on how to train something with Puffer and see it play? Not sure how to see the behavior. Try breakout instead. Yeah, it's super easy. Profiler and debugger, not yet E10. First of all, I don't need the breakdown until I get a basic overall speed. That's going to be the plan. Pay no attention to this 2 mil SPS. This is like super dev mode stuff on 4.0. It'll be way faster than this. The goal for Puffer 4.0 is 10 million step per second training. And I really don't think I'm going to release it until I hit that, because I know it is possible. It just is going to take some engineering. I already have like a few of the final kernels pretty well done as well. It's just the vectorization and like a couple more kernels, a few other optimizations here and there. Current bottleneck, vectorization's eating like 3-ish mil SPS, and I don't know what I'm going to do about RMS norm because I need that, and that's super slow. There's kernel launch overhead. Okay, so Convert, would you mind showing him? I wanted to just show him here really quick, but I forgot that I don't have loading working on Puffer 4, because I'm on the dev branch at the moment, and I don't have it working from Python. If TinyGrad is good for you, will you port everything to it? I'd say that's fairly unlikely, Danielle, unless apparently there is a Torch front end. So if my users can't tell the difference, then maybe. I think the far more likely thing is that we use their kernel gen, but we will see. Yeah, I was going to show you Hyper, but I'm kind of in the middle of this dev branch. What happened to default? Yeah, and I got to focus because I only have an hour to do this. Right, so this Mingru code is not good or anything, right? This is like mostly ported from random Lucid Rain implementation. So you get default encoder. And I don't think we need this, right? I think I can just steal this encoder off. Yeah, I can totally just steal this encoder off like this. Obs. default decoder, and all I need is, I need this one. No, not continuous. Here, this one. Okay, this is self decoder. This is self value. Now we can get rid of both of these. I'm going to swap the relus to get the gelus to relus, I think. I guess we'll see what operations Tiny has built in. Before I go and do that. We'll get rid of the puffer inits just for simplicity. All right. There we go. And then this will just be called Tiny model. No, we actually will just replace this. Okay, so this is going to be Mingru. And then this is output size. No, input size. Output size, hidden size. Like so. And let's make this run. X shape. Star 2. We just do b et x dim x dot shape. Not enough values. Right, so we have to change this to a sequence model. So I guess actually we can make this way easier because the only thing we're really going to care about is we mostly care about this eval pass, right? Gotta be some simpler way we can test this stupid thing, right? Or not particularly. I suppose for now the quickest thing is just going to be to take the obs. We do this. Good. Does this get initial state? It does. Yes. Where's device? What happened here? Oh, is the model not on the right device? Try this. Cool. Values. Eight. I think this is good enough. Do the forward pass. Like this. Okay, and this is not remotely the right number of flops. We can just get SPS out of this for now, right? Okay. So here we have our current Mingru implementation, right? We've got our synchronize, benchmark, synchronize. Should be good. See? Is this missing the RMS norm? How is this missing the RMS norm? Hold on. No, it's not. We have the RMS norm in here. Good. Very good. Now we want to implement this exact same thing in TinyGrad. So this will be the question, is how hard is this, right? Okay. So this torch model. The first thing we want is Einstein associative scan. We can go grab a couple things from Torch. Go grab a few of these things, right? Like this is all the same, except, and we have to do this. We do have a cumulative sum. Tensor of elements selected from either x or y, depending on self. Let me see. Return x 0.where, like this, right? And this is going to be x relu minus do that. I don't think it's even valid. Hello, Rui. Welcome. No, you can't do that. Let's see, soft plus. How do you import all these methods? See. Surely they have they should have this here. Soft plus. TinyGrad.tensor.soft plus. They not have oh, I see. They probably just made it so you can do tensor.soft plus. They probably just do it like this, right? You can just do from TinyGrad import tensor as f, probably. And it'll work. I guess that's kind of clever. Too much rely on vibe coding. You don't learn things that way. I don't want to do everything that way, though, Liberty. Like, I actually, like, the long chains of ops that way as your only model of doing stuff is not great. So, yeah, I think what we're going to do, right? And actually, this is going to end up looking exactly like Torch functional, which is fine. So they're using, if I'm not wrong, I thought of this before. I don't think I ever had a reason to implement this in anything with Puffer, but I'll show you something kind of cool. So you can call functions of a class in Python, and you can pass self explicitly. Does that make sense? So if you have, like, if tensor has a method that is soft plus, you can call capital T tensor.soft plus and pass it a tensor as that self arg. So you basically, the way Python is written, you kind of get a procedural API for free. Or functional API, whatever. More procedural API, I guess. Yeah, procedural API. So actually, this thing here, I can actually delete these. And I think I can just do f.where. And I think that this works. And now it shouldn't be f, right? Like, I'd actually think it would be pretty cool if these were just in the TinyGrad space. So you could just do like tiny.where. Okay, though. So now, we're not ready to do this yet, but I'm way happier with this now because this is going to be, this is going to be virtually identical is my hope. I think this is going to be virtually identical. You get rid of this. So this is now, what do they call? They say tensor.timing uniform. Okay, cool. So there are no biases with this, but we'll just let that slide for now. So we'll just do self.toHidden and out is going to be tensor linear. And this is just dim inner times 2. You don't need a bias. Out. This out is going to be obnoxious, and we're not going to use it anyways for this. So in the interest of time, since I have limited time today, not going to do this. And then, let's see, do they have RMS norm? They do. Oh. They even have linear. Oh, they actually do have linear. So we should just use this. Yeah. This actually is going to be way easier than expected. So this is, I guess, what they mean by their Torch compatible API. Get rid of Torch. The GPU thing. Yeah, they should have the docs linked easier than that. Available. Oh, look, they literally, yeah, so it's just like this. And then where's the device? But where's this go on to GPU? Is this not on GPU? Or is it on GPU by default? Figure that out in a bit. Zeros? What about stuff like zeros? It's going to be under tensor, right? So it's probably going to be like under F. output hidden. Cool. What are you supposed to do about this? Ah, there it is. nn.state.get parameters. Easy, they already thought of it. LLVM context beam equals 2. So wait, it wasn't executing on CPU before, was it? Okay, so I don't think they have a sequential. Oh wait, they do. F.sequential. J is not exactly typical, pretty easy. So far, so it's going to take me longer than just a couple hours, obviously, of playing with it. I thought I was going to have more time today. I didn't know that I was going to have, Thanksgiving was at 2. I don't know. But, at least this gives me, like, so far, I've been pleasantly surprised, and there hasn't really been anything that's clearly, oh, this is just bad. Which, that's a lot coming from me. Gelu. Well, I mean, I don't know, convert. There's some stuff I've heard with Tiny. Like, if I just look at... Let's see if it's gotten better. Oh, this is exactly what I want a library to look like, actually. Except that. Yeah, so things like this are like... I don't know why you write code like this, right? I guess Python force you... No, it really doesn't. It's kind of a little golfy for my liking. You know? Me neither, Tim. Reduce must support 2 iteration. Okay, so I actually don't know then. They have a proper sequential in this. Golfy means that they kind of lost track of the goal of, like, keep it as simple as possible, and they start, like, putting a lot of shit on one line just to make it shorter when it doesn't actually make it easier to read. That's basically that was the one thing kind of putting me off, you know, from the source. But then, like, the thing is, slightly golfy code beats the hell out of the monstrosity of the Torch code base. Like, the Torch code base is just fucking bad. Like, there's no excuse for it. It's just, like, the worst excesses of big tech writing 10 times the amount of code they need for absolutely everything. You literally can't even find operations in that code base half the time. I mean, they named this thing sequential. So, I mean, presumably you can use it like this. Ah. Okay, they don't exactly have the same type of sequential. But that's fine. You know, I really don't need it. Not having module list on the other hand. Oh, well, wait, you don't need it. Lol. It's literally, yeah, you don't need module list. Duh. That's a Torch thing because Torch is dumb. I forgot about that. Okay, I'm happy. Not callable because it does not have forward function. Forward. Yeah. Oh, we need state. State. Does anybody know, is this thing on GPU by default in TinyGrad? Like, I didn't see device stuff anywhere. I think if I end up using this, this would have to be really good for me to, like, swap PyTorch completely. I think if that happens, I have to just order another server from the guy out of principle. I technically have the funds bookmarked for it anyways at some point. He actually, it was kind of funny. So when I was having trouble with my boxes, like, he sent me, like, a bunch of pictures of him taking apart the tiny box just, like, in 10 minutes. Like, you fucking imbecile. Like, how the fuck can you not take this box apart after several hours? And I had to tell him, like, dude, the front panel on mine didn't come off like the front panel came off on yours. It took 100 pounds of force, and then it freaking warped the metal. I'm not doing it wrong. This case was just fucked. And there were a few other things as well. It's like, alright, guy thinks I'm eating glue or something. We did the warranty. They don't really have much of a warranty in the first place, dude. Hey, Spencer, it's surprisingly so far so good. Like, surprisingly, pretty damn good so far. Happy Thanksgiving as well. What happens if I put this breakpoint inside? Does it work or does it break because of the jet? If this works, I will be impressed that they thought of this. Nice one. So, I mean, this definitely kicks the shit out of Jax. Now, whether this is the end-all be-all is, we shall see. I've just been testing TinyGrad out, man. With, like, small models and seeing how good it is. Pretty much what I've been up to. Screen, step. State. State equal. What did you breakpoint and saw it hit a state line? Oh, that? I was just happy that the fact that it doesn't break your debugging when you have JIT on. So I put a breakpoint inside of something that has a JIT decorator on and it didn't break. Like basically everything Torch breaks if you do that. I think Jax breaks if you do that. Jax and TPUs. No, Jax is dog shit. I honestly just hate everything about that, like, framework. Jax is just like, it's like such a Google thing as well. It's like oh, we are so clever. Look, we came up with this whole new way to write code, and like, woe and behold us. And it's just garbage every fucking time. Like there aren't enough real problems to solve at Google or something, so they come up with problems so that they have problems to solve. I don't know. I mean, like, all you have to do, like, I had, to be, like, to their credit, I had the, I think the Flax dev, yeah, the Flax dev messaged me, like, hey, I saw your post, what can we do better? And it's like, I try to be nice, right? Because it's like, okay, you're trying to build stuff, I can always appreciate that, but, like, look, when I look at an RL code base by somebody who I know is actually good, and they're writing 7 nested functions, and your framework is basically pushing people to write 7 nested functions, and every repo is like this, even by people who I know write good code, your framework sucks. Bad arg. I can always appreciate people trying to, like, actually caring and, like, trying to build stuff. It's just, like, at some point, there's just such a big gap. It's just very difficult, you know? Bad arg. See what stack does in TinyGrad. Int args, star args, tensor. Oh. Man, why do you do it this way? There are, like, a couple of these, like, really annoying discrepancies. Hang on. I don't know. I think the whole functional thing is, like, an overreaction to object-oriented programming being shit. And then it's like, they just went and made something somehow even worse. Just, like, not... If you just, like, delete inheritance and delete... Okay, there's actually, to be fair, there's a lot of stuff you need to delete. Just go write some C. You'll figure it out. int object. I will say that their error messages here are quite confusing. Yeah, their error messages could be better. Oh, you know why? That's super annoying, man. They made it a mandatory keyword arg. Okay, this is actually a pet peeve now. They're kind of using some of the lesser known features of Python, because like this is a mandatory, so this is like now a mandatory keyword arg. So if you actually pass it without the keyword, you're gonna get the wrong result. I almost can't fault him for it. It's like, should just freaking pass it as a tuple though, honestly. I do this as well. I don't know. I'm usually in favor of just like not using every single damn fancy feature in the language. Like star args, okay. Like star args with keyword arg is The one that's really bad is you can just put a star like before keyword args without having star args, and then it'll also be mandatory keyword args. There are like a bunch of weird things you can do in Python technically that like doesn't mean you should necessarily. I'm gonna take beam off. Cool. This runs. Now we're gonna actually, I think for the real perf comparisons, it's gonna be a bit more work. But this was a good start. So things I've learned so far, it seems like there is some hope of this actually being reasonably fast. It's basically identical to Torch. So this is something that I almost wouldn't feel too bad providing for users if it's like almost identical. And I have really good reason for it. And apparently they can do kernel gen and stuff. So we might be able to do some stuff with that as well. I think it's going to take a lot more investigation, but this is so far, the first couple hours I've spent with this is enough that it's worth spending another couple hours. And then we will see from there. All right, so this is, yeah, we will have to see from there. I've got to go get ready for Thanksgiving. So for folks who've tuned in, happy Thanksgiving. I might stream this later. I might take the evening off. I think people are going to probably be doing Thanksgiving things anyways, for the most part. So I'll probably just pick this up either tomorrow or maybe Saturday. You know, depends on what I'm feeling like. We'll see. But if you're interested in my stuff generally, everything I do here is all free. It's all open source at puffer.ai. The only way this project makes money is through contracts with larger companies that want to get the best out of our tools, that want custom sim and stuff like that. Everyone else, all our stuff is right here. Free open source. Start the repo. Helps feed the puffer. Join the Discord if you want to get involved with dev. And you can follow me on X for more reinforcement learning content. I post educational stuff once in a while. We've got a nice collection of articles, different topics. And yeah, that's going to be about it. So thank you. See you around.